leaping into the weekend light, basically has data of 1,000 candidates. Now you can see the influencer being generated. Look at the quality of that. You can select the color that you want. You don't want the user to see this. This would be very hard to generate. Your content is safe, probability is 0.14%. It will show me the images of cats. This is the modified image. This is the story that it generated. It will start writing the blog, a blur effect. There you go. The best thing about this is it's actually streaming. All of the cars, they are very similar at a deepfake software. Hi there. Welcome to AI for Everyone, a course developed by CV Zone and sponsored by NVIDIA. Whether you are a 10-year-old trying to cheat on an assignment, or even a 24-year-old engineer who has forgotten everything their degree had to teach them, or even a 50-year-old HR manager who has a million CVs to sort, AI can help you. But isn't AI for nerds? Well, not anymore. Back in 2013, when I created my first AI model, it was all about creating, but now it's about using them. You see, AI is now a tool that will help you solve your problems. Like a drill machine, it is a tool that will help you. You don't have to make the drill machine to use it. The smart people build the AI, and we will just use it as a tool. But I don't know any programming. I can't do AI. Well, that's not true either. In fact, 50% of this course is aimed towards no coding, which means you will learn to run AI and even automate it to some extent without coding. Then what about the other half that is for programmers? Surely it is for the top 1% geniuses, right? No, that's not true either. You only need to know the basics of Python to get started. In fact, here is a litmus test for you. If you know all the words listed here, you can easily complete this entire course. Are you convinced, or do you need some motivation? Well, we have the answer just for you. We have created this course checklist so you can print this on an A4 paper and place it on your desk to check out each part as you progress through the course. But what exactly is in this course? Good question. Let me show you. We will start by understanding the basics of AI using some awesome animations. Then we will learn prompt engineering, the study of how effectively you can talk to AI. Because if you can't explain what you need, guess what? You will not get it. After understanding the basics, we will install everything from scratch as if you bought a brand new PC. Then comes the no-code examples. Here we will start with text generation, where we will learn to generate text, get explanations of images like graphs, and even upload our own document like an Excel sheet to extract information from it. Then we will learn to generate images by giving prompts like a fire-breathing dragon or a portrait of an Instagram model. We will learn to do this both online with some services like ChatGPT and offline on your own computer so you don't have to pay a penny. From there, we will start our coding journey. First, we will learn the basics of creating simple front-end apps. Then we will start by learning how to use AI models that are either available online or the ones that you can download and use on your own PC. Here we will create our modules so that we can write the code once and use it in many projects. Now we will put everything to test and create some amazing apps, including an AI meal planner that generates a meal plan based on your weight loss requirements, a logo generator that produces unique and amazing logo designs, a caption generator that can create extremely creative Instagram captions like this one, just a perfectly timed jump over the fence. Yes, this was actually created by this app. A PDF sorter that can skim through your PDF files and organize them automatically, an adult content detector, an app that can filter inappropriate content, Google Photos replica, create a similar app to Google Photos that can use AI to find the relevant images from your gallery. Clothes changer that will change your outfit with just a single prompt. Storybook generator that will generate an amazing storybook for kids with just a single prompt. A YouTube blog, this app will convert any YouTube video to a blog in just a few seconds. We will create a total of 15 amazing apps. And that's not all. This is not just a course, it's a community. We have created Facebook and Discord channels so you can share your progress, your ideas, and even your achievements within this channel. So you can get motivated and inspire others. And don't worry, you are in safe hands. This is not our first course. We have previously created courses such as Learn OpenCV, drone programming, and computer vision web development that not only rank #1 on YouTube, but on Google as well. So without further ado, let's get started. Hey everyone, welcome to the course, and officially we are about to start. But before we begin, I want you to do something that will maximize the potential of this course, and it will maximize what exactly you learn from this. Now, you might have seen this meme that me and my Udemy courses, I'm also a culprit of this. I buy the courses and I just take a bite of it and I just leave it for good. So this is a bunch of courses. You just take a bite and it's gone. So I don't want you to go through with this course in a similar manner. So that's why what we have done is we have created a checklist. So this, if you can see here, this is a checklist of the complete course. It basically tells you what exactly is in this course. And whenever you complete some of the tasks, you can basically tick out all of these boxes. So this is a very useful method to keep you motivated. And the biggest thing that you will get from this is motivation along with the bigger picture. The bigger picture will tell you where you are in the course and how much is left and what exactly you are doing. If you don't know the bigger picture, you might not go through with the complete course. So that's why we have created this. You can download this from our website. I will show you now how to download this. But when you do it, the first thing you will do, you are going to go ahead and write your name, and then you are going to write today's date. So whatever date you are starting this on, you are going to write that date so that you feel committed to this, that you have done something, you are committed to it, and you are going to follow through the complete course. And I want you to take a picture of this and upload it on your social media platforms. Now, you would say, oh, this guy is trying to promote his course. Yes, that is true. I want to promote this course. First of all, it's free. A course like this takes a lot of time. I have been working on this for about 3 months, and AI keeps changing and it's very difficult to keep generating newer content. So this complete course, which you can see from our other courses that are paid, that are not that cheap as Udemy courses, you will see that this course is actually of the same quality and caliber and even more, but it is for free. So I want you to promote this course as well as get motivated. Yes, it will be a promotion for our course that you are doing this, but it will motivate you as well, that you are showing other people that I'm committed to this, so that you can go back and check, and people can also push you that you are doing something good and you will complete this. Now, upload that picture and use the hashtag AI for everyone and upload it on your social media, and also upload it on our Facebook and Discord channels so that we can see that people are actually going through with the course and how they are progressing. So of course, 90% of the people will still not do this, and this is only a request that you go ahead and do this. It's for your own good, and of course it will help us promote this course as well. So upload it on social media and put it on your workbench, paste it with a tape so that you can look at it and you can see that this is my progress, this is what I've been doing so far, and people walking around will also see and what you are doing and how you are progressing through this course. So how can you get access to this? So here you will go to our website, computervision.zone. You can also write CV Zone on Google and that will give you this link, or you can follow the link in the description and directly go to the course page. So here you will go and click on login/register. If you already have registered, you will write your credentials here and log in, or you can register your account, and you can register with Google as well. Once that is done, you will open up the courses page. Now you will get my account and my courses when you log in. So these will be all the courses you are taking, and this will be the account settings and so on. And here you will go to your courses, and you will click on the courses and you will go down and you will see that AI for everyone is for free, and you can click on that. Once you click on that, it will take you to this page. Here, if you try to access the checklist, it will not allow you because you haven't enrolled yet. So to get started, you will simply click on enroll now. And once you do that, it will simply enroll and it will give you that this is how much you have completed. And then you will simply go to download checklist. You will click on this and it will take you to the download page, and you will simply save it as a file, or you can download it and print it out. Once you print it out and once you do any of these tasks, take a marker and tick that task like this. So if I can show you, it will be difficult to show. Yeah, so here you can see I have ticked those tasks. So do it with a marker. Don't do it with a pen or a pencil, because with a pen and pencil, it's like, yeah, I did it. It's not that, solid. But with a marker, it's like, yeah, I did it. There is some energy behind it. And when you do it, it's very satisfying. And you might think that this is not a very big deal. But in fact, let me show you, I actually created a lot of different prototypes of this model and this checklist. So you can see there's a lot of work that went behind this so that it is satisfying and useful at the same time. So earlier, the very first design we did was this, but this was not very functional, or it didn't give the overview as good as the other ones. So anyways, the point is print it and paste it somewhere so that you get motivated, and you help us promote this course as well, which is free for everyone. And make sure you add the hashtag AI for everyone. So if you look at this, AI for everyone, can I focus here? Yeah, hashtag AI for everyone. This is the tag that I want you to add in each of your posts. So if you're posting progress, if you're posting a picture, whatever you're posting, make sure you add that hashtag. And then whenever you come up with new ideas and whenever you create some new apps that are not shown here, or the ones that you complete here, make sure to upload their video on our Facebook and Discord channels. That way you can discuss about them, you can improve them, and you can create something really functional and useful and get benefit from these communities. Now, don't forget that this course is sponsored by NVIDIA, and they have graciously provided us with a 4090 to give away. So that is a big deal, because that is the best graphic card for programming and for AI. So what you can do is, all you have to do is you have to click on the link below, and that will take you to a registration page. So once you open up that registration page, go ahead and click on register now and register for the AI conference. And that will allow you to enter the pool of people from which we will select one of the winners who will get the 4090 graphic card, which is 24 GBs of VRAM, which is amazing. People don't even have that kind of normal RAM, but think about the VRAM, which is 24 GB. So it's amazing graphic card, and that will give you very fast responses. So make sure to go ahead and sign up and register for the GTC conference and attend one of the conferences, and you will get in the lucky draw. So now that we have everything ready, all the course content will be within this course page. You will be able to access all the codes over here, and you will be able to access anything that is downloadable that we mentioned in the course will be available here to download. So make sure to have access to this page, print the checklist, and then let's go ahead and get started. Intelligence is an attribute associated with humans. When we actually try to mimic this intelligence in a machine, we call this artificial intelligence. By definition, any method that mimics human behavior is artificial intelligence. The machines that we program them using code. And in coding, we have different methods such as if statements or while loops or for loops and so on. Using these methods, if we can replicate human behavior, this would be artificial intelligence as well. However, it would not actually perform well because this method is an explicit way of programming, which means we are defining each and every possible scenario and what to do if that scenario actually occurs. For example, in a self-driving car, we would define every possibility that could happen on the road while driving, like stopping for a human in front, or slowing down if there is water on the road, or driving when the light is actually green. Individually, these scenarios, they seem very simple. But what if the human is in the front and the road is wet and the traffic light is green, all at the same time? In theory, there are infinite possible scenarios. So writing all of these scenarios would not be possible. This is where machine learning comes to the rescue. Machine learning is a part of artificial intelligence. Unlike the previous methods, it is not based on explicit programming. Instead of us defining the rules, the machine itself will learn the rules. For instance, to teach a machine the difference between cats and dogs, we would define some features of each of them separately. These features are numbers rather than just saying dogs have bigger ears than cats. Even with machine learning, the process is not fully intelligent, as humans are providing the features for it to learn, because extracting features can be difficult and a time-consuming task. This leads to deep learning, a subset of machine learning that is inspired by human brain. Here we just show the machine different images of cats and dogs, and it finds the relevant features by itself and trains itself to differentiate between them. This method is closest to the human intelligence and has shown promising results in various fields. For example, in a self-driving car, using deep learning, we collect images from a camera and record the steering angle, acceleration, and braking values to train the machine. When a new image is shown, the machine decides by itself how much to accelerate, brake, and steer. In this example, we did not define any features such as road lanes, bumps, or even obstacles. It observed and learned by itself which features are relevant for driving. The backbone of deep learning is the concept of neural networks. Just like our brain, there are millions and billions of neurons that make up a deep learning model. To understand this, let's start from the very basics. For any given problem, we have an input, an AI model, and an output. Let's say we want to classify images of apples and oranges. We will input an image of an apple or orange. The AI model will do some logical processing and then tell us whether it's an apple or an orange. As humans, we can easily understand images, but the computer only understands numbers. It does not matter what your input form is, whether we input audio, images, or even text. All of these have to be converted into numbers before we can do any processing. Coming back to our apple and orange example, we can convert the images to pixel color values. So if we have an image of, let's say, 32 by 32 pixels, then we will have a total of about 1000 pixels that will be the input for the AI model. In the simplest method, we can use if statements to find out if it's an apple or an orange based on the color values. But this approach is not very reliable, as the color might change due to its lighting conditions or other external factors. So instead, we will use the method that comes directly from our brain. In our brain, we have billions of neurons. When we see the images of an orange or an apple, then different set of neurons light up in our brain and give us the final result as orange or apple. Using this method, we can create an AI model that we will call neural network. Like our brain, it consists of neurons that turn on and off when different images are shown to it. Let's have a closer look at how this works internally. First, we will convert the image to pixel values. Now that we have our 1000 values, each value will be an input for the neural network. This is called the first layer, which is the input layer. In the second layer of the network, we have the neurons that will turn on and off when different images are shown. And in the output layer, we have only two neurons, where one will trigger if it's an apple and the other one will trigger if it's an orange. But the question here is, how does a network understand which neurons to turn on and off based on these images? So here comes the training part. Like humans, when a baby is trained, we show them lots of apples and oranges, and each time we show them a fruit, we tell them its name with it. This is repeated again and again until they correctly classify the fruits by themselves. Similarly, we can train the AI model by showing it images of apples and oranges and giving them the correct answer. Using this method, the model trains itself so that it can classify correctly. But what does the training actually mean in terms of a network? Each neuron in a network is connected to other neurons in the next layer. Each of these connections has a weight. When the network is training, it changes the values of these weights to see if it can get better results or not. So in other words, these connections or weights can be thought of as knobs that can be rotated to give different results. Given our input of 1000 values and a hidden layer of, let's say, 100 neurons and an output layer of 2, we will have a total of 100,200 weights, are knobs to train. As you can see, that's quite complicated for such a simple task. That's why these trainings can take a lot of power and time. Now, you might have seen the ChatGPT model or the Facebook Llama models that have a number in front of them. For example, 70B, 13B, or 7B, and so on. These numbers represent the total number of weights that the model was trained on. So in the case of 70B, the total parameters were 70 billion. So imagine rotating 70 billion knobs to journalize a machine to give accurate results. Not an easy task, is it? That's why we need lots of power and time to train large models. But don't worry, now there are clever methods of training existing models to cater to your specific needs without needing to start from scratch. So this means that you can take existing models like Llama from Facebook and you can retrain it with your own flavor. We will look into those methods later in this course. We can split the deep learning further into two parts: discriminative and generative. Discriminative AI focuses on classifying or predicting outcomes based on input data. For example, we can ask the AI whether this image is of a person or not. Techniques like object detection, where we find where is the object located in an image, or even segmentation, where we create a mask of the object, fall in the discriminative AI category. On the other hand, generative AI creates completely new content that did not exist previously. It can generate text, images, or other outputs based on the input patterns that it has learned. In the example of human, instead of asking if the image is of a person, it will generate an image of a new person. In this course, we will create apps using both generative and discriminative AI methods. But most of our focus will be on the generative AI, as it is the newer field and has a lot of potential. Let's have a look at some of the generative AI models. First comes the generative adversarial networks, also known as GANs. These involve two neural networks competing against each other. One generates new content while the other one evaluates how well did it create the new content. This competition improves the quality of the generated output. Second, we have the variational autoencoders, also known as VAEs. These are used for generating new instances that are similar to the input data. They are great for tasks like enhancing image resolution or generating new face images. Then we have diffusion models. Diffusion models are a newer class of generative models. They work by gradually transforming a distribution of random noise into images over many steps. The process involves repeatedly adding noise and then denoising the data. This approach has shown impressive results in generating high quality and diverse images. Then we have recurrent neural networks, also known as RNNs. These models are a type of a neural network that is well suited for processing sequential data, like text. But RNN were slow as they processed one word at a time. So replacing them, now we have a newer method by the name transformers. These are used primarily in the natural language processing. They can generate human-like text, and this is basically what power today's chatbots and text generators, because they are able to leverage the power of parallelized computing rather than sequential, which we saw in RNNs. So now we will go ahead and look at some of the common terms that will be used within our course and after in many different cases of AI. So the first one is the training data. So imagine that you want to train an AI model that needs or that will classify the different images of cats and dogs. Then you will be needing a lot of images of cats and dogs. So if you were to classify, for example, humans or detect humans, you will need a lot of images of humans. So that collection of images is basically your training data. And that is what you feed to the AI model to train the model itself. Now, these can be images, these can be text, it can be audio, it can be video. So anything that you provide as the input for the training, that is basically your training data. So once the training has been completed, then you have a process that you can run your inference with your AI model. So what does that mean? It means that you give it an input and it will provide you with an output. That whole process is basically an inference. So here you will give an input to the AI model and the AI model will give you an output. So that is referred as the inference. Now, normally we don't refer to input as input. We call it a prompt. Especially when you are inputting a text, we call it prompt. So you might see this term used a lot. Sometimes it's input prompt, sometimes it's just a prompt. So mostly it's for text-based inputs, but it can be used with others as well. Now, once we get the output, that is usually referred as the response of the AI model. So the input is the prompt and the output is your response. Then we have tokens. So we have discussed this earlier that when you have an AI model, you don't actually send raw data to it. For example, if I say, what is the weather? I will not just send the text to the AI model. I will convert it into numbers and then I will send it to AI. So even if it's an image, it's an audio, it's a video, whatever it is, it needs to be converted into numbers before you can send it to the AI. So that numbering part is basically tokenization. So you convert it into tokens. So for example, in this case, we will use this example, what is the weather and question mark. So it will be converted into tokens and then we will convert them into token IDs. So each of these words is basically a token and then we convert that into token IDs. So these numbers, they are token IDs. So for example, a question mark has the token ID of 30. So we will take these token IDs and these will be fed into your actual AI model. So that's the basic idea of tokens. Now, this is very important because when you are actually purchasing an online service like ChatGPT, then you will definitely need to know what exactly are the input tokens and what are the output, so you understand what exactly are you paying for. Now, it's not always the case that every word is basically one token. Every word can also be split into two tokens. So it depends on the word itself. So it can be split up into multiple tokens. So for a general rule of thumb, you can say that 1,000 tokens are equivalent to 750 words. So you will have more tokens than the actual words. So let's take an example of an AI model that says that you can input 16,000 tokens and it will output 4,000 tokens. So what does that mean? It means that with 16,000 tokens, you can input around 12,000 words, and then it can generate the output words to be almost around 3,000. So that is your input and your output. So we also call it the input context window and the output context window. So this is very important because it will be used later on when we are referring to which model has how much big of a output or input context. So for example, if you go to the OpenAI website, which is basically ChatGPT, you will find that they mention it here that this is the context window. So what is the context window? They are talking about tokens. So here they are saying, so you have 128,000 tokens. This means that you will have around 100,000 words that you can input into the model. And this is for the input. For the output, they mention it separately. So here you can see the output context is 4,000 tokens, or you can say around 3,000 words. So each of these models, they will have a different number of tokens. For example, this one can input 8,000, this one can input 32,000. Now, you might not be able to grasp how big these numbers are. So for reference, let me tell you that the Harry Potter and the Sorcerer's Stone, the book, the first book, is equivalent to almost 77,000 words. So with your ChatGPT 4 model, you can input the complete book in one go, and you can ask it questions, you can ask it to summarize, you can ask any questions that you want within that book. And nowadays, there are models like the Gemini, they claim to have an input token of 1,000,000 tokens. So 1,000,000 tokens means that you can have all the 7 books of Harry Potter fed into the model all at once. So imagine the context window, how big these things are getting. But in most cases, the output window is still very low. So here you can see it's 4,000, and most of these are still 4,000. And even when they say it's 4,000, it doesn't really generate 4,000 tokens. It generates maybe 1,000 or 1,500 or 2,000 at once. So there are ways to increase that, and we will discuss how we do that later on. But understanding the tokens and the context window is very important. That's why we are putting some effort to actually understand this so that we can read these documents later when we are running our models or choosing our model. So then we have the word temperature. So what exactly is this and where is it used? Now, when we are sending an input to the AI model, the model itself has a parameter that you can change. That parameter is temperature. There are many parameters. One of them is temperature. So the temperature value can be from 0 to 1. So if the value is 0, the model will not be creative at all. It will not try new things. If it is at the value of 1, it will be very creative and it will try to be very artistic or creative to generate the output. So in the context of, let's say, create an image of a man or create an image of a burger, then it will depend on how much creativity do you want. So the temperature value can range from 0 to 1, and it can be 0.2, it can be 0.3, depending on how much do you want the answer to be creative. Now, this is valid for text and for images as well. So when there are AI models that can generate images, it will have a temperature knob. If there are text AI that produces text, it will also have a temperature, so that when, for example, you say write a sick leave to my boss, now how much creativity do you want there? So I would say very little, because you want to be formal and straightforward. But if you were writing a fictional story, then you would increase the temperature to increase the creativity of the written words. Then we also have a guidance scale. This is similar to temperature, but this is mostly used with images. Now, this is how much to follow the input prompt. So for example, if we say a burger on a plate with fries on the side, now how much exactly do you want it to be like that? So do you want the model to be creative and put a table next to it, put some things in the background, or do you want to focus only on that part and generate that specific scenario only? So that's basically the guidance scale. These values can vary depending on the model, but we will look into that later on. Then we have embeddings. Now, this is an interesting one because it's a little bit harder to understand what embeddings are. Now, imagine this, the word dog and the word puppy. So as I mentioned, if you are giving an AI model some text to understand, it needs to understand the semantics or the meaning behind the words, not just compare dog and puppy. So for example, if I were to say dog and puppy, they are relatable, right? They are very close to each other when it comes to meaning, right? But in terms of words, not even a single letter is the same, right? There is no single letter that is same. So if you tell the AI, compare these two, how will it compare? That's the basic idea of comparison. How can you compare two different things? Right now, we can compare word to word. It has three characters. It has 5. It has a P. It has a D. It has an O. It has a P. But this is nothing comparable. This is meaningless. For AI models, and even for us, it is meaningless. We need to learn the meaning behind it so we can actually compare it to each other. So when we convert our input to tokens, we convert it into numbers, right? So now maybe we can compare the numbers. But if you look at the numbers right now, how do you compare this number? This is the token for a puppy, and this is the token for a dog. How do you compare these? How can you say that this actually has a closer meaning to a dog than to, let's say, a car? How can you do that? You cannot do it with tokens. But you can do it with embeddings. embeddings are basically vectorization of your values. So these numbers, they are further converted into tokens. So not tokens, embeddings. So this is a vector. A vector is just a bunch of numbers put together. It's a fancy word for all these different numbers put together. So here you have 6 numbers and they represent the word dog. Let's say these are random values I generated, but let's say, by the way, these are actual values. The dog and the puppy, the tokens are actual, but these vectors, they are not real values. These are fake. But let's say this represents the value of dog and the puppy will represent this value. Now if you compare these two, they are quite close to each other, and only difference is here. 0.15 is here and 0.1 is here. So they are very close to each other. But if we look at compare with a car, then the car and the puppy is completely different, and the car and the dog is completely different. So that's why we can compare these, and these are basically embeddings. So embeddings are like tokens, but tokens plus the semantics, the meaning of the actual word, so that when we actually search, then we get the correct answers. For example, if you were to save an image of a person and you write the name person in it, but what if we write a man? Should that image appear or not, right? And then if we write a human, should that refer to this image or not? It should, right? Because human, person, man, woman, they are in the same context. They are close to each other. So if we create embeddings of these and then we search it, then everything will make more sense. So that's what embeddings are. Embeddings are vectors that allow us to have meaning of the actual words. Very important and revolutionary in terms of transformers and in terms of large language models. Then we have the memory. What exactly is the memory? Let's say we have this input. What is the weather in London? It's not is, but it's in. But let's say it's is, it's in. What is the weather in London? We send it to the AI and the AI gives the value of 50 degrees Celsius. Then the next question we ask, what about tomorrow? And the AI will be, what tomorrow? What are you referring to? Give me more context. What do you want? Why? Because when you send this question, it answers it and that's it, gone, bye-bye. The AI has shut down. Then the next question comes in. It does not know what did you ask before. So it has no context of what happened before or what were the conversations that happened before, right? Imagine if you just randomly went to the street and said, what about tomorrow to a person? What will they say? What will they answer? Nothing, right? So they will not have any context. But if you say, what is the weather in London and what about tomorrow? Then they will know what to answer. So the same way, the way you can give AI memory is that instead of giving only the question, you will give it the previous conversations as well. So in this case, when we ask what about tomorrow, we will give in the question, the previous question, what is the weather in London? And then the answer was 10 degrees Celsius. So this will be packed up and sent to the AI with the next question. So then it will look at the whole thing. It will understand, oh, first it asked the question about weather, and then now it's asking about tomorrow. So what will be the weather tomorrow? It will give you the answer, 12 degrees Celsius. So that's basically your memory. You are basically giving in the history of conversations along with the new ones. But there is a big problem here. If you keep doing that with every question, after 10 questions, you will have a long list of questions trailing a big way, right? So one way to fix this is that whenever you are sending, first summarize the text and then attach it as the chat, the previous chat or the history. So you can have less words that go in. The other way is you limit it. For example, you are going to save only 5 questions 5 previous questions, and then when the new one comes in, when the 6th one comes in, the first one goes away. So you pop out the first one. So you can try different things on that. Then we have the fine tuning. Fine tuning is basically, let's say that we have an AI model that can differentiate between oranges and apples, and it is trained very well. It took, let's say, 10 days to finish this AI model. And now it's amazing. It can do this very efficiently. But now we have a question. We have another task, training dogs and cats, the difference between dogs and cats. Now we have an option. We can get all the images of dogs and cats, like hundreds and thousands of images of cats and dogs, and then we can train the model like we did before, which took 10 days. Or we can fine tune it by giving a small number of images of cats and dogs, and then it will create a new AI model that is able to differentiate not between oranges and apples, but between cats and dogs. So that's basically fine tuning. So with less numbers of images, you will be able to get the same functionality that you had previously gained because of lots of training, but now you will have to train it for only 1 day instead of training it for 10 days, and you will need a lot less images. So this is a very, very heavy and very, very powerful method of using your AI models to your benefit. And normally these very big models, they are trained by big companies on their big servers that are very expensive, and it costs hundreds of thousands and millions of dollars. Once they train that model and they give it to you, for example, Facebook, they give it to you for free. Stable AI, they give it to you for free, their models. But then I want to train it for my own self, right? I want to train something that has my face using this model. How can I do that? I can fine tune it on my local PC without spending millions and billions of dollars, and I can do it at home in a few hours. That's the power of fine tuning. And that is exactly what we are going to learn in the training part of this course. That will come at the end, but make sure you don't skip the rest. Go and stepwise finish everything before you go on to the training part. So these were some of the common terms. They are very important for you to understand. If you did not understand any of these, go back and try to understand what exactly did I say or what exactly it is. Try to research it. If you still don't get it, go to our Facebook or Discord channels and ask their questions. What exactly are these? Or if you have a specific case, then you can go and ask questions about that as well. So let's say that you are a tourist and you have traveled to Japan. Now, the only language you actually know is English, so you have a bit of a communication gap when you want to do something within the country. So what happens is that you get hungry and you want to eat some food. So in this scenario, you find a local person, and what you do is you ask them about food. But the issue here is that you don't know how to communicate. You don't know their language. So the only thing you know is the word for food, which is tabimono. So you go to the person and you just say tabimono. And what they do instead of having a proper communication, what they do is they just point you to the nearest restaurant, or they give you directions, go left, go right, and there you will find a restaurant just by hand gestures. So that is not really a good way of communication, because technically you could have said a lot more about your preference of food, but you were not able to communicate properly. So would you say that this is a good way of communication? Definitely not. Because let's say you wanted to eat or you wanted to try out the local pasta, and it had to be non-spicy and it had to be vegetarian. So all of these details you were not able to effectively communicate to the person because your lack of understanding of their language. So this way we would definitely say that it is not a very good way of communication. So the same way when we talk about AI, you have to understand how exactly the AI model understands. So how do you communicate with the AI model? Because if you give in bad data, it will output bad data as well. So we have a saying that garbage in equals garbage out. And that is true in this instance as well, that if you give in bad information, it will output bad information as well. And that is effectively all comes down to your communication part. So if you understand how to communicate with the AI model, then you can effectively tell it to give you the desired output. Now, keeping this in mind, we have an effectively new field that has emerged because of this AI revolution, and that is your prompt engineering. So what exactly is prompt engineering? If you think about prompt, it's basically just an input. So whatever you give the input to the AI model, that is basically your prompt. So effectively, if we summarize it in a nutshell, we can say how to efficiently talk to an AI. That is basically your prompt engineering. So here the highlight is efficiently talking to the AI. So if you are able to communicate effectively, then you will get the desired output that you are looking for. So prompt engineering is tweaking your way around this problem so that you can get good results or good output from the same model. Remember that the AI model is not as dumb as you think. So getting the correct answer is not only solely upon the AI, it's upon you as well. If you give in good prompts, if you give in good question, if you ask the question in the right manner, then you will have a better chance of getting the desired results. So this is what exactly is our prompt engineering, and we will look into the details of this. Now, if you wanted to go into the details, we can have a complete course on this as well. But what I've effectively done is I've gathered all the different topics from this and summarized it into 6 parts. And we are going to discuss these very important 6 parts that will help us in our upcoming projects, whether they are using code or whether they are using without code. It will be very important how well you communicate and how do you ask the question to the AI models. So the first one we have is the persona. So what exactly is persona? Persona is, you can say it's a personality. You are basically giving a personality before you are actually asking the question or you are giving the prompt. For example, if I wanted to learn about gravity, I can simply ask my AI model, explain gravity. So here I have given the AI model question of explain gravity. Now this is using ChatGPT. Right now, you don't have to worry about how to get it up and running and how to run this. I will explain that in the later parts. But for now, try to understand the concept of what exactly is happening. So we said explain gravity. That's all that we gave. So here it is explaining gravity is a fundamental force of nature that attracts two bodies towards each other. It's one of the 4 fundamental forces in the universe, blah, blah, blah. The understanding of gravity has evolved over centuries. Then it gave us the Newton law of universal gravitational force. It gave us the equation. Then it explained all of that. So I would say this is a good bookish explanation for gravity. But let's say I wanted it in a different way. I am a high school teacher and I wanted to explain it to high school students. So what I will do is I will give in the persona. So in this instance, my persona will be, you are talking to the AI. You are saying you are a high school teacher who uses simple and clear language to explain. No fancy words, no big words, simple and clear language to explain. You like to add real world examples while explaining the concepts. And you also don't shy away from using humor. So something funny in between here and there. Then, after giving this persona, this personality of a person, then you tell it to explain gravity. Now let's see what the AI has to respond. So here you can see we have given the persona. This is the complete persona. And then we have explain gravity here. So here you can see right away, the language has changed. Let's dive deep into the world of gravity, the invisible force that keeps your feet on the ground and not floating off into space like balloons at birthday party, right? Now look at the way it's trying to explain in very simple language. It's saying, imagine gravity as the universe way of saying, hey, stay where you are. Now let's break this down. And if you go down and read, it's actually quite good and it's well explained for high school students. And if you look below here, it also says the moon keeps circling around us because of gravity. Earth tells the moon, you can't leave, you are in my gravitational friend zone. So I would say that's quite humorous as well. So it's trying to take that personality, it's extracting those features, those traits, and based on that, it's giving you a good output. So persona actually helps you deliver based on your own personality. So try to explain to the AI what do you do and what kind of responses do you usually give, and that will allow it to align more with your personality. So that's why persona can be very useful. So the second point we have is the detail. You might have heard that the devil is in the details, and that is pretty much true. So if we look at an example, we will have a better understanding of this. So let's say I wanted to ask the weather from the AI. So what I can do is I can say, what is the weather? So let's see what exactly does it respond. So there you have it. What is the weather like? Now, the answer is to provide you with the current weather conditions. I need to know your specific location or the location you are interested in. Weather varies greatly by region. Having specific location will allow me to give the most accurate information. Could you please provide that? So there you go. The AI directly tells you that what you are referring to is not enough information. So you need to provide more details to get a better response. So what can be a better response? Let's go ahead and look at that. So here is a better example where you are saying, what is the current weather forecast for Lahore? Lahore is a city that you are specifically specifying for the weather for the next 3 days. Then you are even specifying it more that I want the weather for 3 days and include the temperature ranges, chances of rain, and wind speeds. So these are the four things that you have added. One is Lahore, 3 days, ranges, change of rain, and wind speed. So one is the main element, the detail of where you want the weather to be, and the other four are basically the details of what exactly are you trying to achieve. So let's go ahead and look at what the AI responds. So there you have it. We have written what is the current weather forecast for Lahore, blah, blah, blah. And then at the bottom, you can see the weather forecast for Lahore over the next 3 days is as follows. Now it's giving you the dates, it's giving you all the information, it's giving you the range as well. It can be from 11 to 22 in the afternoon, then in the evening it can be 16 degrees. Then the speeds are also given in meter per second, and that information is organized in the correct structure where we have 3 different days. So we actually mentioned that we want it for 3 days and for the upcoming days. And then it also gives you a conclusion. Overall, the weather in Lahore will feature mostly clear to partly clouded skies. So all of these things, they are because we gave in the correct details. If we don't provide the details, the AI will not understand what exactly do you want, and it will not give you the correct output. So the next one is steps. Now, this is one of my favorite ones because it allows you to get a much better response. So a lot of the times, if you have already played around with an AI model, it doesn't actually give you very long answers. For example, if you ask it to give you an article, so write down an article on creating a good video. So what it will do is it will give you output based on its maximum size of output, right? But what if I don't want that? What if I want it longer? Or what if my task is very complicated? So in that case, it's always good to break it down. So let's take an example of writing an article on creating a good video. So what I will do is, instead of just saying that, I will break it down into steps. But before we do this, I will show you what the response of this is, and then I will break it down, and then I will show you the response. But let's say I want the article to be 2000 words. But when I write an article on creating a good video, it only gives me 500 words. Then I keep trying it, it gives me 550. Even with the details, I tell it that, okay, I want 2000 words as my output. Or at least 2000 words, or I give a range from 2000 to 3000 words. Whatever I do, it doesn't give me more than that because there are limitations to AI models as well. So let's go ahead and look at how we can increase that number and how we can get a better response. So here we have given the command, write an article on creating a good video. So here you can see that it is giving us the direct answers. You can see that it's saying define our objective, know your audience, craft compelling story, focus on high quality production. And you can see we have a total of 8 different topics, and then we have a conclusion. So that is all well and good. And if we look at the word count, it's not a lot. I would say it's less than 1,000 for sure. Then if you look at each of the paragraphs as well, it's only 2-3 lines, and it's not looking as a big article. It's a very small, very precise article. But what if we wanted a bigger perspective? What if we wanted a more long article with more words? So what can you do? You can break it down into steps. So how can you do that? So instead of giving it the direct creating a good video article, what we will say is we will say create a table of content for an article creating a good video. So first, create a table of content, create all the topic names. Then we will say write in detail the first 3 topics of the article. And we will keep repeating this by writing write in detail the next 3 topics of the article. So every time we want to generate, we will keep telling it write 3 more, but in detail. So this way, the answers will be much longer and they will have a much better quality in terms of writing. So let's go ahead and look at the results. So here we have given create a table of content for an article, creating a good video as our prompt. So what happens is that it provides us with the table of contents, and there you go. So right away, you can see there's a lot more detail here because we have a total of 13 topics now. Earlier we had 8 or 9, but now we have 13. But that's not the biggest difference. The biggest difference will come in the detail of each of these topics. Now, not only did it mention the topic, it also mentioned the subtopics. So it might actually expand with that. So let's go ahead and look at that. So once that is done, we will write in detail the first 3 topics of the article. So we didn't even write the names of the topic. So we didn't say write introduction, understanding your audience, and conceptualizing your video. We didn't write that. We just said write the first 3 topics. That's it. So it started writing, and right away you can see the difference. So introduction, you can see a much bigger paragraph. And then within understanding your audience, it has categorized it further, and we have more categories. We have subtopics as well. Identifying your target audience, tailoring content to audience preferences. Then in conceptualizing your video, you can see we also have subtopics, and you can see all of this is probably the same word count as our complete article that we saw earlier. So only 3 topics versus the complete article. So then what we will do is we will write in detail the next 3 topics of the article. And then it is writing the next 3. And again, we are not defining the exact names or the titles of these paragraphs. We are just saying the next 3. It's so easy for us to do that. Then we are again saying write the next 3. So it keeps writing the next 3. And then I believe when it's about to finish, we just said finalize the remaining. That's it. So sometimes you don't have to give a lot of detail. Sometimes when things are clear, you can just tell it to continue next or something like that. You can give as the input as well. So there you go. So now look at this. Now this is much more than 2000 words for sure, but you can see you can create much better responses, much longer responses if you know how to categorize it, how to organize it, and break it down into steps. And stepwise, you give your questions to the AI model. So don't expect it to give you the output all at once. Give it step by step. So sometimes you are having a hard time even organizing it, then you can even ask it to organize it for you. So that's what we did here. We didn't actually tell it that these are the titles and we need the paragraph for these. We just told it to create a table of content, and based on that, create everything else. So that is very convenient, and it is one of the best ways to get some quality output. Because it is summarizing a few steps at a time, it is actually giving you more detailed and more dense information rather than just creating one article in one single go. The next topic is basically reference. This is very simple. Sometimes what you do is, instead of trying to explain what is happening, you actually copy some text and paste there and just tell it that, okay, I need information from this. For example, if you were watching a YouTube video, you would copy the transcript of the video, paste it there and say, oh, I want to know what are the views of this person about this topic. So it will explain that. So in this case, we have summarized the following article. So you copy the complete article. So that is your reference material. So you copy the complete article, you paste it, and you ask questions about it, or you tell it to summarize and do all sorts of different things. For example, if you're a teacher, copy all of the chapters, paste them, and ask the AI to create question answers, MCQs, and stuff like that. So it becomes very easy when you are using reference text, and it makes your life a lot much easier. Now, when you are using reference material, what happens is that sometimes it becomes confusing for the AI model to understand what is the reference material and what exactly is your question. So to avoid this, to differentiate between that, we have delimiters. So what exactly is a delimiter? Here, for example, you can see we have written the text, summarize the article, introduction, the art of video creation has evolved dramatically with the advent of digital media. Now, even for a human, it's a bit confusing. Wait, what happened there? Where is the question? Where is the text? So in reality, what we are doing is we are saying summarize the article, and that's it. That's the question. And then the article begins. Introduction, the art of video creation has blah, 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 blah. So that is not very evident in this example. So what we need to do is we need to split it up. We need to emphasize that this part is the article. So how can we do that? We can do that using delimiters. So for example, here we have triple quotations. That is one type of a delimiter. So instead of writing the whole thing once, we are saying summarize the article. Then we have the delimiter. And here you can see it starts, and here you can see it ends. So that part is basically my article. So it's easy for a human to understand as well. And it is easy for the AI to understand as well that, okay, there is where you started and there is where you are ending it. So we have a lot of different types of delimiters. Let's have a look at some of them. So we have triple quotes. So you can add triple quotes, and in between you can write the article and then end it. Then you can also use XML tags. So for example, you were referring to an article. So inside you will write article starting here and then ending here, like you write HTML tags if you are familiar with HTML. So, and in between you write the article. So if you were referring to an essay, you will write essay here, and in between you will write the complete essay, the reference material. And another way of doing that is line breaks. So you can add line breaks like you do it in HTML. My preference method is the triple quotes. I use them a lot, and I would recommend that you use that as well. The last concept here we are going to learn is the output format. This is very crucial if you are automating some tasks. For example, if you were to create a calculator and every time you want a very specific response. So let's say that you have the input. Let's say the person is asking, what is 2 plus 2? Now, the calculator should not answer randomly. It should answer based on a specific format. So by default, it will answer the result of 2 plus 2 is 4. But I don't want that much English. What I want my result to be that result equals 4. That is what I want. I don't want to write the result of 2 plus 2 is 4 or anything else. I exactly want result equals 4. So what can I do? I can give it an output format. So when I'm writing what is 2 plus 2, this is by the user. What I will do is in my code, I will add use the following output format, and you can see we have added the delimiter, result equals answer. So now the output format that we will get will be result equals 4. So that is what we wanted. So let's go ahead and look at that in action. So here you can see if we write what is 2 plus 2, it will give me the result. The result of 2 plus 2 is 4. So as I said, this is not what we want. So what we did instead is we said what is 2 plus 2. Then we use the following format. We added the delimiter and then we wrote result equals answer. And then it gave us this result equals 4. So now you can see that sometimes it is very crucial that you have a very specific type of output because you have to do some post-processing after you get the answer. So in that case, this formatting is very helpful. And we will be using this a lot in our coding examples. Now, we have discussed quite a bit about prompt engineering, but we haven't covered everything. If you want to know more about this, I would highly recommend you to check out the prompt engineering article given by OpenAI. This is a very good article, and I would recommend that you do some examples, you create some apps, and then come back and read the full article. Because if you keep getting into theory without actually doing any practical implementation, then it becomes harder to understand the theory as well. So I would recommend stick with those 6 principles, make some apps. When you start getting stuck or you are not getting the desired response, then come back and read this further and read some more articles about what exactly can you do or improve in prompt engineering. So there's a lot more here. So I would highly recommend that once you create some apps, come back to this and read it, because at that point, this will be more interesting because you will have a larger concept and you will have a bigger perspective on the building app part and the prompt engineering part. So definitely recommend this. Check it out after you're done with some apps. Do you want to implement your computer vision ideas to solve real-world problems? Or upgrade your resume by enhancing your computer vision skills? Then the computervision.zone is the perfect platform for you. CVZone is a one-stop computer vision platform with over 100,000 users with courses sold in over 80 different countries. If you want to commercialize your computer vision ideas, then the Computer Vision Web Development course is the perfect course for you. Here you will learn the basics of web development and computer vision, as well as how to integrate them to solve real-world problems like customer engagement, car counter, face attendance, shirt size measurement, and a lot more. Advanced Drone Programming is another great course that focuses on the practical implementation. Here you will learn the basics of drone programming as well as advanced concepts like face following, body following, gesture control, and a lot more. If developing mobile apps is your thing, then check out our Computer Vision Mobile Apps course. Here you will learn the basics and create several apps including object detection, augmented reality, face detection, document scanner, and a lot more. The best part is that you will create a single app that will work both on iOS and Android. If you are passionate about integrating hardware with software, then check out our Computer Vision Arduino course. Here you will learn the basics along with amazing projects such as conveyor belt assembly, face tracking, lamp gesture control, face door lock, and a lot more. The Computer Vision Game Development is another great course where fun meets programming. Here you will learn to create games such as Fruit Ninja, Balloon Pop, Squid Game, Cookie Cutter, all using the latest computer vision techniques. Not only that, you will learn to compile your awesome game to an exe file to make it accessible to all. You can also learn to implement computer vision on embedded devices with our Computer Vision with Jetson Nano course. Here you will learn the basics of Jetson Nano and computer vision along with creating exciting projects like lane following robot, eye tracking, object following, and a lot more. All these courses have a clear path from basics to advanced with maximum knowledge in a short amount of time. So check out the links in the description to get started with your computer vision journey today. So now we are going to have a look at what exactly is the difference between GPUs and CPUs. CPU stands for Central Processing Unit, whereas GPU stands for Graphics Processing Unit. So in AI, you can both use CPU and GPU as well. So the question comes, which one do you actually should use? Now to understand this, I like to refer to the brick problem. So what exactly is the brick problem? Let's have a look. So let's say that we have a task in hand and we can hire either Einstein or 100 average people. So when it comes to intelligence, you can definitely say that Einstein is much better than an average person. He has one of the highest IQs. And the average people, they might not have that much intelligence, but they have a big labor force. So you can ask them to do some labor intensive tasks. So for example, if we were to give them some bricks to lay from one position to another, then which one would you hire? So the task is to go from the left side to the right side. And let's say we had 100 bricks. So would you hire Einstein or would you hire the 100 people? So if Einstein were to do this, what he would do is he would pick one brick and he would lay it on the right hand side, and then he would go back and forth while laying bricks. So this type of computation is basically series. What he is doing is he is performing one task at a time. So while he's performing one task, he cannot move on to the next task. He has to complete one task and then he can go ahead and lay the second brick. So he cannot lay the bricks all at the same time. On the other hand, if you were to hire 100 people, each of them would pick up one brick and all of them simultaneously would lay the bricks on the right hand side. So this means that for Einstein, if he were to do this, he would have to do it in series and it would take a lot more time compared to when 100 people do this. What does this have to do with our CPU and GPU? So in our case, CPU is basically Einstein who can do good things using the series method. And GPU is basically 100 people who can do the computation in parallel. So in our case, if we were to lay the bricks, which is a very simple task to do, it does not require a lot of intelligence, then in that case, we would prefer that we would do it with 100 people rather than using Einstein. So for example, in my computer, I have a 16 core CPU and my GPU is 10,000 cores. So if each of these cores were to run and do some processing, then you can say that the 10,000 can do a lot more than the 16 cores. But that is not always the case. If you compare these cores together, there is a big problem. The problem is that the CPU cores are built differently and the GPU cores are built differently. So the GPU cores, they are built for simple tasks. For example, laying bricks. But the CPU cores, they are capable of processing logical tasks that require series computational, and they can do much more complicated tasks compared to the GPU. Because otherwise we will have to ask the question, why exactly do we need the CPU? If GPU is so good and it's so much faster, then why should we need this CPU at all? Another way to look at the GPU and CPU comparison is using the Mythbuster example. A few years ago, they gave a very excellent demonstration with paintball guns. So if you had one paintball gun, then it had to draw an image. So this is how it will draw and it will be very slow. But if you had a GPU, it is like having lots of paintball guns that shoot all of it at the same time. And all of a sudden you have this Mona Lisa painting drawn right away. So that's the difference between GPU and CPU. But again, the question comes then, why should we use CPU at all? Why don't we just throw away all the CPUs? The answer is that CPU are good for series computation. So in our example, if we had a very complicated math problem, we would not give it to 100 people. We would actually give it to Einstein to solve that problem, because Einstein has much more intelligence than those average 100 people. So it depends on what kind of task do we have in hand. Are we laying bricks or are we having a difficult mathematical problem? So we need to categorize in order to understand this. So where does AI land in this? Now, you might say that AI is the next big thing and it is very complicated, but that is not the reality when it comes to computational power. In computational power, video games and machine learning algorithms, they are considered to be easy tasks. So for example, if you were to do any machine learning or if you were to do any video games, they are simple trigonometric functions that can be parallelized. So the main idea is that even if you have a complicated task in AI, it usually can be broken down into independent pieces and then fed it to the GPU, and the GPU can process all those independent pieces at the same time. So that's why it can be broken down into individual pieces, and these pieces, they can be processed all at the same time instead of processing them one at a time. So this gives us a very big advantage when we are using machine learning models or when we are playing video games. Then the GPU comes in very handy because the GPU is dumb, but it can do a lot more. There are 100 people that can do a lot more compared to Einstein, who can only do the bricklaying in series. So if it's a computationally heavy task, then we give it to Einstein, we give it to CPU. If the task is heavy, but it can be broken down, or if the task is easy, then we give it to the GPU and it can do it at a much faster rate. So in AI, we will be using GPU for most cases because it will give us 5x, 10x, 20x faster responses, and it will be much, much faster. For example, if you were to process an image, let's say on CPU, it might take you, let's say 30 minutes, and then the same image might take you around 1 to 2 minutes using a GPU. So that's how big of a difference it can be. And if you were to process, let's say 100 images, then instead of days, you can do it in minutes. So that's the big difference that it can make. So we are going to have a look at how we can use the CPU and GPU both, but mostly we are going to use GPU. Now, if you are on Windows, we are going to learn a very simple trick that will make you an expert right away. What you have to do is you have to press Control, Shift, and Escape. I will repeat, you have to press Control, Shift, and Escape, and that will open up this task manager. So once this task manager opens up, you can click on more details and you will go to performance. When you go to performance, there onwards, you will see all the details and the specs of your hardware. So here, for example, you can see my CPU is running, which is 12th generation i9, and you can see the cores of that are 16. As I mentioned earlier, I have a CPU that has 16 cores. Then you can see the memory here. It is around 64 GBs. Then you have a few hard disks. And here at the end, you can see the GPU. So here I have a 3080 Ti graphic card, and you can see it has a dedicated memory of 12 GBs. So the more graphical capability you have, the better it will be for you. Now, the cores are a different story when it comes to GPU. You can find the cores of these graphic cards online on their website. They are not really mentioned over here. So what you can do is you can always use RTX graphic cards, NVIDIA graphic cards, because nowadays you have to use these because they are most optimized for AI capabilities. So my recommendation is the 4090 graphic card, which has double the graphical capability, which is 24 GBs of VRAM. So that will give you a lot more capability than the 3080 Ti. Now the 3080 Ti is also very good, but if you were to go for the best, then I would recommend that you go for the 4090 right away and get the best performance. Now, if you have an earlier version, if it's 2070, 2060, 2080, it's not a big deal. You can always check their compute capability. How well will they perform with AI models? So how can you check that? You can go to NVIDIA's website. So if you go to NVIDIA's website here, developer.nvidia.com/CUDA-GPUs, here you can find all the GPUs. So if we go to GeForce and Titan, you will see here 4090 is at the top, which has the compute capability of 8.9. And if you go down, the 3080 Ti that I'm using is at 8.6, which is not bad at all. Then of course you can check your versions here. Even a 2070 has 7.5, even a 1080 has 6.1. So it's not that bad. You can use older versions as well. So you can see all of these that have these capabilities, and you can also compare the Jetson Nano products, and you can also compare the data center products. So these are the high-end products, usually for companies and big servers. And the ones that are here are usually for laptops and notebooks. And the ones over here are for desktop. You can see these are the compute capabilities. So or you can always go and compare your capabilities here of your GPU. So now we are going to go ahead and have a look at the difference between online and offline AI models. Nowadays, we have the option of running both on our local PC and using a cloud service like ChatGPT. So what exactly is the difference between them, and which one should we pick will depend on the pros and cons of this. So that's why we are going to go ahead and have a look at these. So when it comes to offline, it's basically a computer that you have on your home, and you are running it using a local GPU that you have within your computer. And you can say that it is running AI at home. And the online version is basically on the server of a different company that actually gives you access to run the commands or run the model using their API. So the online model, basically you will write, for example, what is the weather today, and it will send the command to the server. The server will process, the AI model will process, and it will send the command back that today the weather is 26 degrees Celsius. So that is the basic model. In the offline model, what you will have is basically you will ask your AI model within your home. So your data is not going outside, it is staying within your home. Now, in order to actually understand the pros and cons of this, I like to give an example of a hungry man. Let's say there is a man and he gets hungry, and now he wants to eat a burger. So when he wants to eat a burger, he has two options. The first option is the offline model, and the second one is the online model. The offline model, he can go ahead and cook at home. Then the online model, he can pick up his phone and he can call up the restaurant and ask them to send him a burger. So this is very similar to running AI models. So this is how we will take this analogy and compare using our AI online and offline models. Offline models, first of all, they are cheaper. So if you have your own kitchen, you can go ahead and cook your meal, and it will be cheaper for you instead of ordering online, right? The same way AI models will run cheaper if you use your own computer. Then, even though it is cheaper, there is a big upfront cost. For example, you need to have the kitchen ready. You need to have all the cooking ware. You need to have all the appropriate utensils to actually cook. Same way, you need to have a good PC with a good GPU in order to run. So all of that is upfront cost for the offline model. But if you are ordering online, then you don't need any upfront cost. You just pick up your phone and you order. Even if you don't have a kitchen or you don't have a PC to run, you can simply ask the AI model to run on someone else's computer, and they will send you the data. And it can come to your phone, it can come to your cheap PC, wherever you want. Then there is the issue of maintenance. So if you have your own kitchen and you're cooking again and again, you will have to maintain it. Same way you will have to maintain your PC. If there are any installations, if there are any issues with interruptions with the electricity, you will have to manage all of that locally within your home. But if you are ordering online, or if you are using an AI of a different server, then you don't have to worry about that. It's their problem. If they don't have, let's say, a stove, if their stove broke down, then it's the problem of the restaurant. They need to fix that, and they will get it done, and they will deliver you the order based on your timing. So that's the difference. And then we have the security issue. So offline model, you are not sending any data to any other computer. You're not sending anything to the cloud. So that gives you security. For example, I have an image of myself and I am asking what is inside this image. Give me the semantics of this image. For example, it will say a man sitting in front of a computer talking to a camera. Okay, that's the semantics of my image right now. But I don't want to share my image. Maybe it's confidential. Maybe I am a hospital that has confidential files of all the patients. So I don't want to share that online. Someone can hack it and they can get access to the data. They can leak it. So in that case, if you run it offline, it's better because it will be more secure. On the other hand, online, the data is being transferred to a third-party server and it's processed and coming back. So there is a communication between, so it can be intercepted. So you can have security issues there. So you have to think about whether you want offline model or you want to run online model. If you are confused between them, then go ahead and think of the restaurant example, the analogy where you are hungry. Can you order online? Or do you want to cook it at home? So that's the basic idea of online and offline models. And we will be learning all of them. We will be learning offline coding examples, no coding examples, and online coding examples and no coding examples. So when it comes to installations, we have a lot of different options that we are going to go ahead and move on towards. So before we go ahead and start writing the code or using our AI models, we need to understand what do we need to install. So I will assume that you have a completely new PC, a Windows PC that you have not used before. This is the first time you are turning it on, and then what do you need? Now, later on, we will have examples of no coding and coding. So when you are using no coding, then you have the option of not installing anything, only in the case of online. For example, if you are using ChatGPT or Gemini from Google, then you don't need to install anything. You can just go online and you can write the commands and it will give you the output. So in that case, you don't need any installations. You can simply go ahead and start running. But if you want to take the most out of this course, and I would say 99% of the people should, then you should install pretty much everything. So you should install Python, you should install the IDE that we will write the code on, you should install the GPU requirements so that you can run very fast models. So all of that I will go step by step and explain. Even when you are doing no code examples, you will need the GPU when you are running offline. For example, I want to create an image using a command. I will say a child playing in the park and it will generate an image. So that image generation is done on your computer. It's offline, but it needs a GPU. So that's why I would say go ahead and install everything I recommend, and that will make it very easy for us to go ahead and complete these tutorials. Now, of course, if you are doing coding, then you have to install everything. You have to install Python, PyCharm, you have to install all the GPU dependencies and everything. But if you are running a GPU offline, then you might skip a few things. But in my recommendation, install everything so everything goes smooth from here onwards and you don't have to go back and start again. So let's go ahead and start with all the installations. So now we are going to go ahead and start with our installations. The first thing we have to install is the Python, and then we are going to install an IDE, which is an integrated development environment, which allows us to write the code for our Python. So what we will do is we will go to python.org, and here we are going to go to downloads and we will download. Now, I do not recommend downloading the latest version because it might have some bugs that need to be fixed. So what I recommend is that you go to the full list and over here you look for a more stable version. So right now it's 3.12. So I would say 3.10 is a good bet to download. So let's say we go to 3.10.10. Let's click on that, and there you go. We go down, and in Windows you can see we have the installer. So, and that is the recommended one, so we can go ahead and install that. Now, versions, they can cause a lot of problems. So make sure that you know when you are installing some of the Python versions or some of the libraries later on, whether they are compatible with each other or not. I will try to explain as we go along. But for now, let's go ahead and download this. And then for the IDE, we will go to PyCharm. We will just Google PyCharm and it will take us to this website. We will go to downloads. And over here, we have the PyCharm Professional. Now, this is a paid version. We don't want to download this. What we want is the PyCharm Community Edition. So we are going to download and install that. So we will go ahead and download this. Again, this is for the coding part. It will not be required as much in the no coding part. You might need, if you are running specific programs, you might not need to write the code, but you might need this to actually run the code. So that's why it is a good bet to have this installed as well. We will wait for it to download, and once it downloads, we are going to first install Python and then we will install PyCharm. So here we are going to go ahead and install Python. So make sure you add python.exe to path, and then we will click on install now. You can go ahead into the details of which directory you want to install it, but I do not recommend you do that. Just go for the default settings and install everything as it is. So there we have it. Setup was successful. So now we can close this and we can move on to PyCharm. So now we will start the installation of PyCharm. We'll just hit next, next, next. And I recommend you click these. Actually, they help out later on. So we will click all of them and we will install in the default location, which is C. So once the installation is complete, you want to reboot your PC so that everything runs smoothly. Now, in order to test our installations, what we have to do is we have to click on PyCharm, and here we will go ahead and create a new project just to see if everything is working fine. We'll hit on continue. I don't want to send anything, and there we have it. So now what we can do is we can click on new project, and here instead of Python project, we are going to call it AI 0 to hero. So this will be the name of our project. And then as you can see here, we have an option of Python 3.12. It is asking that, do you want to download and install? No, we don't want to do that. Instead, we should have already our Python installed, which was Python 3.10. So this is the one that we are going to select. So what it's doing is that it's giving you options of downloading it and automatically installing it. In the previous PyCharm versions, we did not have this option, but now they added this. But I would recommend you go with Python 3.10 that we installed earlier, and then we can simply go ahead and create. So right now it's saying that it's creating a virtual environment. What does that mean? The virtual environment is a safe place where you can install all the libraries for your project. Now, there is a Python that is working globally, and there is a Python that is working only for your project. So when you install anything to your project, it will be installed only for the project. It will not be installed globally for the complete PC. So that's a very good point, because when you are using different projects, you don't want to mix different library packages. For example, for this AI 0 to hero course, we have, let's say, Python 3.1, and the library we use for that, let's say we are using CVZone, and it runs with 1.6. But in the later course or in another project, we have to use the CVZone package 1.2. It is a compulsory, or maybe 2.0. Then we do not want to mix these two things together. So we have one project here, and it will have all the libraries installed here. So we don't have to worry about mixing with the global packages. So that's why we have this virtual environment. So here what we will do is we will right click and we will create a new file, and we will create a Python file. We will call it main, and that will create our main.py file. Now, if we open this up, at the bottom here, it says Python 3.10. So if you had multiple Pythons, then you can have the option to switch here 3.1, 3.12, 2.9, whatever it is, you can switch it from here. So right now it's 3.1, so it will remain 3.1 here. Just to test if everything is working, we can simply write print, and we can write hello world. There you go. So that will allow us to check whether it's working properly or not. And what we can do is we can right click and click on run main. So if we click on that, there you go, you get the output hello world. It means our Python is working and our IDE is working as well. So that's pretty good. Now we can go ahead and move on to the more complicated GPU installations. If you have a GPU, then I highly recommend you go ahead and install the GPU parts as well. Now, before we move on to the NVIDIA driver and all the dependencies of those drivers, we are going to go ahead and install two things that are mostly required for a lot of different computational AI models. So one of them is FFmpeg. This is basically a video converter, and the other one is a C++ compiler. So we can download the C++ compiler easily by downloading Visual Studio, and FFmpeg we can also download from their website. So let's go ahead and look at Visual Studio first. We will go to visualstudio.microsoft.com. You can of course Google this as well. And here you will see that we have Visual Studio, and we will again download the community version because that will be free. So we will click on that, and then we can simply wait for it to download. So now it's actually downloading the files. So now it has started downloading the installer. So first of all, it will download the installer, and then we will have the option to select what exactly do we want to download. Now Visual Studio is again an IDE in which you can write code, but what we need from it is the C++ compiler, because a lot of libraries, they depend on that. So here you can see now we have the option of selecting. So what we have to do is we have to select desktop development with C++. So that was the main thing that we required. So we will select this, and then we will hit install. So this is the total space required, and all of the selections, they are automatically done. You don't need anything else. That's the only thing that you need. Again, desktop development with C++, and we will hit install. So this will take a while to install. While this is doing the installation, let's go ahead and install FFmpeg. So here we will go to their website, we will click on download, and here we will have the option of downloading Linux, Windows, or Mac. We will select Windows, and we will go to gyan.dev, and over here we will go down, and then we have the FFmpeg release essentials.zip. So we are going to go ahead and download this. So now you can see that the installation is complete. We can hit OK, and you can launch and try it out, but we don't need to do anything for now. We can close this, and now if we go to our FFmpeg, if we open that up, this is what we get. So the idea of this is very simple. You just have to copy and paste this, and you have to add the link to the essentials. So you can paste this anywhere you want. So I have it in the C folder, and I have a folder by the name archive. So I'm going to go ahead and paste it here. So we can simply drag and drop. So now we will open this up, and we will go into the bin folder, and you will see this is your main file FFmpeg. So we need to copy this link, and then we are going to paste it in our environmental variables. So we will click on Windows, and we will go to the environment variables. We will write en, and this will appear. Edit the system environment variables. We will click on environment variables here, and here you can see the top part here is for only this account, and the one below is for all of the accounts. So it's up to you where you want to add it. So in our path, we can double click it, and we can add new, and over here we are going to paste this. So that's pretty much it. And now what you have to do is you have to go ahead and restart your PC, and then we can go ahead to our NVIDIA drivers. We also have to install Git. This is basically a platform to do version control. So we have to install this. You can simply go to Git. You can Google that, and you can click on Git, and here you can go to the download part. We are going to click on download for Windows, and here we will download the Windows 64 setup. Once the download is complete, we will simply go ahead and install, and now we can finish. So now we are going to go ahead and look at how can we install our GPU so that it works with our artificial intelligence models. So we first need to install NVIDIA driver, then we have to install the library for our NVIDIA, which is CUDA. And then we also have a deep neural network library, which is known as cuDNN. We need to install that as well. Now, this might seem a lot, but it's very simple. It's very easy. All you need is a little bit of patience and we should be good to go. So first of all, you will go to official drivers for NVIDIA. Just Google it and you will find NVIDIA driver downloads. And here, what you have to do is you have to select which one you are using. So right now I'm using a laptop because I didn't want to uninstall everything on my main PC. That's why I'm using a laptop which has, I believe, 2080. So in order to check that, you can of course press Control, Shift and Escape. That will open up the task manager and it will be like this. So what you can do is you can click on more details and you can go to performance. And in performance, you can see all the specs. You can see here it's i7 and it has 6 cores. And then if you go to the GPU, then you can see it is a 2080 with max Q design. So this is the GPU that I am using at the moment. So what you have to do is you have to, based on this information, you have to go ahead and select that. So it's GeForce. Notebooks is for laptops. So that's why we have 20 series. So notebooks 20 series. And then we have the 2080 Super. That is basically the max Q design. Then I'm using Windows 10 64-bit. If you're not sure about your bits, you can always go ahead to your PC, right click and go to properties, and there you go, you have 64-bit operating system. Most of them are 64 nowadays, so you don't have to worry much about that. Okay, so you have 64-bit and then you need the studio driver. So that's what we are going to download. So you will go ahead and click on search and this will give you your exact driver and you can simply download it. So while that is downloading, we are going to go ahead and download CUDA and cuDNN as well. So we will go ahead and write CUDA. So if we do that, what will happen is it will give us the latest link for the CUDA. So right now it's 12.3. But the problem is that sometimes a few of the softwares, they are not as up to date. That's why they don't run with the latest CUDA version. So that is a big problem when it comes to AI models. So what I have seen so far in my experience, CUDA 11.8 is the best up till now, which runs most of the softwares. So what we can do is we can actually download the exact model 11.8, this exact version. So it will be easier for us to use our different packages. Now, later on, if you are watching this video far ahead, then I recommend go ahead and look for a more stable version. Probably the softwares now, they are more compatible. So make sure to try the latest ones, but not the latest one, a stable version of the latest one. So here we have 11.8. So we will click on that. We are using Windows, so we will click on that. Architecture is x86-64. Then we are using version 10 and installer type. We will do local. You can do network as well. It's up to you. Local will download the actual file. So there you go. The download has started and we are going to wait for it to download. The next thing we need is the CUDA DNN, which is deep neural network. So we will write cuDNN. So here you can see we have the deep neural network. Install CUDA and cuDNN on Windows, Linux. So we have all these documentations. So we need to check which cuDNN for CUDA 11.8. There you go. So if we write that, for best performance, the recommended configuration of GPUs is CUDA 9.0 with CUDA 12.3. Now this is for the latest one. We are not talking about the latest one. So let's go ahead and move on to the archive. This is the cuDNN archive. Now we saw that in CUDA they were giving us 12.3. So probably if we just write CUDA DNN, then it will give us the latest CUDA DNN, and that's not what we want. So here is the latest one, which is working with 11.x. So we have 11.8, so it means we can use it with this. Or if you want to go a little bit back and use a previous version, you can also install any of these, the ones that are before this. Okay, let's go ahead and install this, which was in November. So let's click on that. So here we have the option for local installer for Windows. So we will click on that. Now, this is one thing that you do have to provide your NVIDIA credentials to actually download this. So you have to log in to actually do that. So I will go ahead and log in now. So here it has redirected us back to the downloads. So we will go ahead and download it again. So the local installer for Windows. And as you can see, the download has started. So let's wait for it to finish and then we will come back. So now we are going to go ahead and install the driver. So we will install the graphic driver and the G4 experience. And we will go for the Express, which is recommended. So once the NVIDIA driver is installed, we are going to go ahead and install CUDA. So we will hit OK. First of all, it will extract the CUDA toolkit and then it will start the installation. So now we will hit agree and continue, and we will do the Express installation. Now we will go ahead and install cuDNN. So to do that, you will go to the installation folder of CUDA, which is in C and then program files. Here you will see NVIDIA GPU Computing Toolkit. We will open that up. Here we have 11.8, and then we will open up our cuDNN. So here you will see that the files are pretty much similar. We have a bin folder. We have a bin folder here, then we have include, and then we have a lib and a lib. So what we have to do is we have to copy these over. So here we will go to the bin and we will select all and drag them. Then we will go back and we will do the same with include. So we will copy over everything. Then we will go to lib. Inside lib, you will see we have x64. We have x64. We will copy everything here. Now our installations have completed. So now we are going to go ahead and move on to our no-code examples. So we are going to learn how to use AI models without using any code. So this is for an average user who wants to automate their things, who wants some guidance from the AI. So the idea is very simple. You can do this online, and all you need is an internet connection with a laptop or a mobile phone or even an old computer you can use. It doesn't matter how good your computer or mobile phone is, because the processing is done online. It's being done on a different computer, someone else's computer. Their server is being used to do the processing of AI, and then they send back the data. For example, I can say, what is the weather in Lahore today, and it will send the command and it will process it and it will send it back to me, and it will be just raw text. The answer, let's say, is 26 degrees Celsius. So that's the basic idea of how you can use these online AI models. And this is very powerful because it gives the ability for normal people to use it. By normal, I mean the ones who do not use coding or programming. Even they can use this and really have full benefits of the AI models without having any external sources. So we can actually generate some text, we can generate images, and we can generate audio from this. We are going to look at all of these. What we will be looking at are the different AI models. And the ones that we are looking at are the OpenAI, Gemini, and Copilot. Copilot is from Microsoft, Gemini is from Google, and OpenAI is independent by itself. Now, the thing is that these are AI models that are popular right now. Later on, there might be other AI models that are popular, and you might not have these at all. But the main idea is that how do you actually interact with them? What are the key principles that you need to keep in mind to actually communicate with them? So this is the basics of what we are going to do. Now, the thing is that you might say that, oh, I have a little bit of experience with ChatGPT, or I have done Gemini a little bit, but I would highly recommend that you go through all of these processes, because I will share different types of techniques on how an average person can actually use it at home, whether you are an accountant or you are a marketing agent, whoever you are a high school student or even a high school teacher. Whatever your qualification is, whatever area or field you are in, you can definitely get benefit from this. And even if you are good with any of these technologies, you will get some insights that you might not have seen before. So let's move ahead. Now, before we continue, there's a little bit of debate going on that should you be actually creating the AI models, or should you be actually using it? Now, I like to simplify this with a very simple example of a drill machine. A drill machine is simply a tool that you use to, for example, drill a hole in wood or in a wall, or you tighten some screws and so on. So my question to you is, how many people actually design this tool compared to how many people actually utilize this tool? So when we talk about designers, there will be very few designers who actually created the tool, right? So who are the ones who designed the drill machine in the company? They did all the research and development, and they did all the processing to make it nice, neat and clean and ergonomic and all of that, right? But these are the people who know what kind of motor is used, what is the power efficiency of the motor, how many switches are inside that motor, and so on. Now, for average user, they do not need any of this information. They just need to know whether this drill machine would work with wood or with concrete or with metal, or what type of drill bits can I use with this. So it's a different set of knowledge that is required to use the tool when compared to designing the tool. So there will be maybe a million people who will use the tool out of one who is actually designing the tool. So what we are doing now is we are utilizing the tool. So we are not building ChatGPT. ChatGPT or Gemini is being built by Google. They have lots of data, they have lots of computational power, they have lots of money to invest in this stuff. So they are at this position that they can do this. But we as users, if I even create an AI model in my home and I try to replicate that and compare it with, let's say, ChatGPT, I will be far, far off, because it is not simply possible to put that much effort, money, and data in your home to create something like that. So our goal is to utilize the AI models. Now, what we will be doing is that we will be taking those AI models. Maybe we have one AI model from here, another one from here. We merge them together and we automate these tasks. Now, it might seem a little bit difficult to understand this, but I will be giving a very good example in the text part, and I will show you how an HR manager can actually automate these tasks, for example, of simplifying their candidates who actually apply for the job, and it will make their life so much easier. So that will be an example of how an average person can use AI actually in their workflow. The online text, that's the first thing that we are going to start off with. We will write an email. We will start with the very basic email and summarization. We will summarize a YouTube video. I will show you how you can do that. Then we have graphs. We will input a graph and we will ask the AI model to explain that. Then we will also do for documentation. So that's the main part that I was referring to earlier. That is the fun part, where we will provide a document. And because this is something that a lot of companies, they do right now, they want to automate their processes. So this is very useful if you want to automate it for a company, or you are a company that wants to automate it yourself. Then you can input your documents and it will automate and it will give you the output that you directly want. So keep an eye for that. And then the last part is that you can automate this even without writing a single line of code. So I will show you that as well, how you can do that using ChatGPT. You can automate these tasks, but of course that automation is limited compared to when you compare it with coding examples. So if you have the power of coding, you can automate pretty much anything. But if you don't want to code and you want to automate something online as well, there are still some use cases, some tools out there that will help you do that. So let's go ahead and move on to our examples. We will first go ahead and open up our AI models. So in order to open your AI models, what you have to do is you can simply write OpenAI on Google, and then over here we have Google Gemini, and here we have Microsoft Copilot. So we will be using Google Gemini, and we will be using OpenAI, which is ChatGPT, and I will show you the comparison between these two. Now, the main task is not to compare these two or these three. The idea is to understand how generic AI works. So this is not really a comparison because these things, they keep changing. Right now, you are watching this video, maybe 1 month later, 2 months later, it will be completely different. One is better than the other and so on. So don't get into the fight of that. Now, I don't own OpenAI, I don't own Google. I have no investment of any sort in any of these two. So I'm simply sharing how to use AI rather than explaining which one is better or comparing any one of these. So what you have to do is you have to go to OpenAI, and here you can click on try ChatGPT, and over here it will ask you to sign up. You will click on sign up, and then you will have the option of using Google, or you can use your email and so on. The same thing will go to Google Gemini. Gemini, I believe, will start right away because we are already logged in on Google Chrome. So if we click on that, we will accept. You do have to accept their terms and policies, continue, and I believe, yeah, there. So that's the idea. And then for Microsoft Copilot, again, you can go and start writing here right away because probably it's linked, so you don't have to log in. But if you do, then you can always sign up. All of these are free to use. Now, Gemini and OpenAI, they have their paid models as well. We are going to look at both of these and what they are capable of. So here we have opened up the interface of ChatGPT and Gemini. So here you can see, first of all, that you have the option of selecting which model do you want to use. Now, ChatGPT 4 is paid version, and ChatGPT 3.5 till now is free. So 3.5 we are going to use over here. And then the same thing goes with Gemini. Gemini has an advanced version and a free version. Now, the main difference here is that Gemini can actually generate image, and we can upload image to it on the free version as well. So if you want to do something with images, you can do it for free on Gemini. Whereas in ChatGPT, you cannot upload or ask it to generate images if you are using 3.5. You have to use the paid version. Okay, so let's start with the interface first. So here on the left hand side, you have the ChatGPT. If you open up this bar, these are all the different queries. I have listed down all the chats. They have listed down today, yesterday, previous 7 days, and so on. And then you also have something known as the custom chat GPTs. So this is the automation part I was referring to. And this is unfortunately only available for the paid version, but this is very powerful. And if you don't want to code, this is the way to automate. So I will show you how you can do that as well. If you already opened up one of these chats and you wanted to open up a new one, you will simply click on here, which is new chat, and it will open up a new chat. The same thing goes over here. You have the interface and you have some options here. There you go. So these are again all the chats, the recent chats we have done, and you can create a new chat. So right off the bat, when you start talking with AI, think of it as a person with limited capabilities. So think of it that you have to think a little bit about it before you actually say something, but you don't have to go too much into detail that everything needs to be perfect before I send it, right? And I will share some examples of that as well as we go along. So now the first thing we want to do is we want to start off with a very simple example. I want to write a sick leave. So I want to write a sick leave for 3 days because I am not well. So I'm going to simply write here sick leave. So I will simply write here, write a sick leave and mention that I will not be able to continue for the next 2 days. So the idea is that we are providing the information that we need a sick leave, but we are also giving some details that, okay, for the next 2 days, I will not be available. Now you can keep adding the name of the company, name of the manager, and you can edit that later on, or you can just mention it here. So let's put it here and let's enter it here as well. And let's see. So ChatGPT 3.5 is very fast. So as you can see, it's the turbo version and it just flies out. Okay, sick leave, your name, position, company name, blah, 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 supervisor name. Dear supervisor, I'm writing to inform you that I'm unable to report to work due to illness. I have been experiencing blah, blah, blah. And after consulting with my healthcare provider, it has been advised that I take some time off and rest and recover, and so on. And you can see it's written like this. And then unfortunately, I can't write a complete sick leave for you without information. Now, this is a trend that I've seen in Gemini, that it doesn't actually give you something unless you provide it with some information. Same goes for images, same goes for documentation and stuff like that. So it needs a lot more information. I think it's trying to be more protective, that it will not give you wrong information or misleading information or something like that. So it wants to be more precise. Sometimes that's not really what you want, because I can just copy this and make some changes on this and move on with my life. But here I have to answer some questions. It's like I'm being interrogated, right? But again, I'm not saying Gemini is bad, so don't quote me on that. Okay, who are you addressing the leave to? Do you have a specific reason? Would you like to share? It's like I'm giving an HR interview, they are interrogating me. Why are you taking this leave? Have you completed any urgent tasks before leaving? I mean, come on. Will you be reachable during the leave? Urgent matters. Okay, let's see. I don't want to answer any of these. Just write a generic sick leave. Ah, come on. There you go. Let's see what it says. Okay, so now it says that it understands that you want privacy, and it will actually generate that for us. And you can see it is actually okay, please accept this email as a notification that I'm unable to come to work today, tomorrow, the illness and this and that. So now if I wanted to go a step further, what I can do is, okay, write, or I can say add the following info. So what is the following info? As I mentioned earlier, it's always good to organize your things and send it to the AI model so that it's easier for you to understand and for the AI as well. Okay, what are the things that we want to add? We want to add that sickness is, let's say, cold, flu, and then we can say that I did obtain a sick leave from the hospital, or obtain, or is it or did they stamp it, or whatever, something like that, right? I also want to mention that I have informed my clients already, which is not a good thing, but I would say you should get the leave first and then tell them, but whatever, we are adding as an example. And let's see. So there you go. It's very fast. And as you can see, I'm writing to inform you that I'm unable to report to work due to bout of cold, flu. Following a consultation with my healthcare provider, I obtain a sick leave from the hospital that I take off and rest. As per the doctor's advice, I need to take 2 days leave. Absence, I have arranged any pending tasks beforehand. I understand the responsibility, apologize, and blah, blah, blah. So yeah, and of course you can change the tone as well. For example, you can write, make the tone more informal, which is not a good thing to do for a sick leave, but you can do that. Just wanted to drop you a quick note. I mean, yeah, that's informal. And let you know that I'm feeling under the weather with a nasty cold flu. I swung by the hospital and got a sick leave. One thing I like to do is sometimes, let's say, make it formal again and make it sophisticated. sophisticated. Now, when it makes it sophisticated, it adds very big words, right? So for example, I trust this correspondence finds you well with amidst your endeavor, blah, blah, blah. Okay, that's too much for me. So what I like to do is, this is something I like to use, and I like to add that don't use big words. I like to say that every now and then. So then it will be a little bit informal, and it will try to restrain from using big words and making the explanation a bit more simpler for everyday user, right? I hope this message finds you well. I regret to inform you that I won't be able to attend the work. So as you can see, it's already changed, and that's the basic idea. Now, if your manager, let's say, was your friend, right? Or let's say you are a co-founder and you wanted to send an official email to your friend, which is also a co-founder, then you can give the persona, as we discussed in prompt engineering, you can give a persona that I am a co-founder and I'm sending an email to my co-founder who is also my best friend from 20 years and blah, blah, blah. And we talk in informal but formal, blah, blah, blah. You can add all these details, specific details in the persona as well. And then you can ask it to generate a very specific kind of sick leave. So that's the basic idea of generating any text. Now let's move on to the second part, which is YouTube summarization. Okay, so what I will do is I will go to my YouTube channel, and here you can see these are all the different videos that I've posted. And what we will do is we'll pick one of these. For example, we will pick this waste classifier. And what I want to do is I want to write a blog about this. So in order to write this blog, I will ask ChatGPT or Gemini to actually create the blog for me. And what I will do is I will give the persona as well. So if we go down and we click on the description, we have the option to show transcript. So if I click on that, this is where the transcript will come in. Now you can see it's a long transcript. Now, one thing you can do is you can actually copy this with the timestamps, or you can toggle it off, toggle timestamp off, and then you can copy that. So when you want to use only for summarization or writing a blog, then yes, only the text might be useful. But what if you wanted to add screenshots based on timings, right? Then in that case, the timestamps will actually be very useful. So that is something a bit more complicated, but I just wanted to mention that you could do that as well. So what we will do is we will copy all of this. Now here you might see a limitation when you are using the free versions. So let's copy that and let's try it out. I'm not sure if it will accept it or not. So now we will go and start a new one. Every time we do, we will start a new one so that it does not have the previous memory. So this is something that you need to understand. When ChatGPT or Gemini, they are creating, or when you are asking them new questions, the previous one is already in their memory. So there is a limit to that, but they will keep it in the memory. And whenever you ask a new question, it will copy all of the text from the previous one and put it in the new one. So it will get complicated if you are not asking the same questions of the same field or area. So I highly recommend that you use a new window whenever you are using or whenever you are creating something new. Okay, so what we will do is, first of all, we will write the persona. We are going to write that I am a YouTuber, or let's say you are a YouTuber. You are a YouTuber who provides or creates computer vision tutorials. Okay, and you need to write a blog of your, or blog or some, let's say summary. Write a summary of your latest YouTube video below. Okay, let's give it some characteristics. First of all, write table of contents, then give catchy titles. Then we can say add links where required. Then we can say add an FAQ session section at the end, right? So yeah, and then below is the transcript. And if you remember delimiters, we said that we are going to add delimiters. So 3 and then 3, and that's how I like to do. So in between, I will go here and I will just paste the text. That's it. So that's a long text. We are going to copy all of that because we need to paste it here. And if we go down, hopefully it will be able to accept. No, it's too long. Okay, let's pick a shorter video because I don't want to use the paid one right now. We will use the paid one later on, but for now I want to use a simpler one. The problem is most of my tutorials, they are very long. Yeah, maybe this one, it's 20 minutes. Come on, ads. Okay, so we will go down, we'll click on show transcript, and hopefully this should be fine. Copy that, and instead of, we can, by the way, edit this, and we can remove all of that. There you go. We are back to square one, and then we just paste it. All right. That is actually long as well. I'm not sure if it will accept. Let's save and submit. Oh, it did work. There you go. That's your ChatGPT answer, creating a face blur filter with computer vision, table of contents, introduction, project setup, face detection, blur image, FAQ. I don't see the links. I don't see this being clickable. So not very great, but you can see that it is actually able to summarize. And the same thing we are going to do with Gemini. And let's see what it does. While we are doing that, let's do for ChatGPT 4, which is the paid version. And let's see how well does that give us. Okay, so yeah, we have YouTube summary, face filter, table of contents. This is better organized, I would say, and it does have timestamps. Now this is very important. Even though we didn't actually give them the timestamps, I'm not sure how they got it. Yeah, maybe they got it from YouTube. I'm not sure about that. So what are the prerequisites for this project? How can I adjust the blur level? So yeah, they have given the questions as well. The links are not there, but the funny thing is, the summary is not there at all. It's just table of contents. So I think by summarization, it meant that you just create a bullet points. So I think that is what it thought. But we were looking for a paragraph. Nevertheless, if we look at ChatGPT 4, introduction, overview, FAQ, conclusion. So I think both of them, they did not understand that part where you do have to summarize it, and the table of content is a bit different. I guess table of content would be better in a blog than in a summary. You would not need table of content. Maybe that's the confusion here. I should have thought of that earlier, but I didn't. Okay, that's okay. Now, that's the basic idea of how you can create summaries and blog posts and stuff like that. Now, one important thing to note here is that ChatGPT trains the data and it does not use the latest data that is available online. On the other hand, Google and Microsoft, they actually use real world data. So you can ask them questions related to anything that is happening right now, current affairs as well. So let's see if this video can be found by ChatGPT and Gemini. Let's see. So if we go to 3.5 and we go to our previous, where did it go? Yeah. So we are going to write here, find the link of this video from YouTube. There you go. And we'll paste it here, and there you go. Let's see if either one of them could find it or not. Okay, so both of them are not able to find. Is it possible titled different or something like that? Okay, I'll give you a hint. The channel name is Murtaza's Workshop. Let's see. So it's giving us the channel link directly, but it's not giving us the specifics of this video. So that's okay, I guess. But here we do have to mention that ChatGPT does not use the latest information, whereas Gemini uses that. In order to showcase that, what we can do is we can say, find a flight from Lahore to, let's say, London in the next 3 days. And we will ask the same thing to Gemini, and let's see what they give us. So that's what I was referring to earlier, that ChatGPT cannot access real-time information. So it will not be able to give you that. On the other hand, we have Google Flights that is actually giving us all the options, and it is also giving us the price and the timing and the flight time and so on. Now let's go ahead and try it with ChatGPT 4. Does it give me more information? Let's find out. There you go. Now you might say, wait, what happened? How is ChatGPT 4 able to give me that information? The thing is, ChatGPT 4 actually has a lot of plugins that you can use to find relevant information. So if you go to their plugins, you can find these different plugins for Canva, for making logos, for checking documentation, for CapCut, and even for finding these flights. I believe this is one of the companies that actually finds these flights. So that's the idea. So you need to have a plugin to actually make it work. But I would say the answer of Gemini was better, and you get a lot more detail there. So that's the idea of how you can generate some text. So now we are going to go ahead and look at how we can explain, how can we get an explanation of a graph from ChatGPT and Gemini, or from these AI models. So the first thing is, if you note, you go to 3.5 and you do not have any option of uploading an image here. So that's a bummer. You have to use ChatGPT 4, which is the paid version, to get any image output or image explanation. On the other hand, Gemini does not have this limitation. So here we have State of AI in 10 charts. This is by Stanford, and they have provided this graph. They have multiple graphs. You can check any one of these, but we are going to check out this one. AI jobs posting, Singapore dominates while US sees a first dip. This is from year 2013 to 2021. So let's go ahead and see how well it performs in explanation of this. So we will try to drag and drop, nothing will happen. But if we go to ChatGPT 4, we drag and drop, and there you go. It accepts. The same thing we will do, we will drag and drop, and there you go, nothing happens because we have to drag it here. No, it didn't work. It seems that the drag and drop is not working, so we can simply copy image, and we can come here and paste the image, and that should work. So now both of them are ready to go. And what we can do is we can write, explain this graph in detail. And the same thing we will do over here, and enter and enter. By the way, ChatGPT 4 is slower than ChatGPT 3.5. So as you can see here, it's not like before. So as you can see, it is actually giving you a lot of information. The first thing it says that the years are from 2013 to 21, and it is about artificial intelligence job posting. So even if you have very little small text here and there, it is able to understand that, and it is able to get a bigger understanding of the whole structure. So that is what humans are able to do, right? Earlier, we used to use discriminative models where we will extract text from here and there and then try to make sense of this together. But now these generative models, they can take one glimpse and they can actually manage to understand what's going on very intuitively. Here you can see the vertical axis represents AI job posting from 0 to 2.5%. Is that correct? 0 to 2.5, that is correct. And the horizontal axis shows year from 2013 to 21. That is correct. Each represents a different country. That's correct. Countries are shown: Singapore, United States, United Kingdom, Canada, Australia, New Zealand. Is that true? I'm not sure. Let me check. Yes, that is true as well. Then if we go down, the US line indicates a percentage of 0.9 in 21. Okay, let's see that. 0.9 in 21, United States. Yeah, kind of. 0.9 in 21, which is marked a dip because it's going down. Yeah, that's good. The line of United Kingdom, Canada are relatively close each other, ending at this. New Zealand has the lowest. Upward trend for all countries, larger share, and this and this and this. The data source is cited as Burning Glass. The graph is index AI 21 and all of that. But I would say that it didn't actually mention anything about Singapore in detail, because the idea is that Singapore is dominating. That was the main concept. On the other hand, here we can see something. Singapore has the highest percentage. Yes, 2.4%. Then United States, second highest, but it has seen a dip. That's good. Then all of these are similar and they are close to each other. That's good. And then it's also giving us more additional insights. So I would say that's a very good. And by the way, we are not using the paid version of Gemini. We are using the free version of Gemini. So that's a very good plus. Then the relatively stable percentages of job AI posting in countries may suggest that these countries are keeping up pace with the growth of AI, but they are not yet leaders in the field. So yeah, and the slight dip might be because of COVID-19. So it's actually giving you some insights as well. So that's very good. And as you can see, it is able to give you all this information. Now, for the fun part, what we will do is we will tell it to create an Excel file with this graph, but in pie chart format. There you go. So let's see what it does there. Again, we are using ChatGPT 4, which is the paid version. So if you're not using paid version, you won't be able to do any of these. You can't create files, you can't upload files using ChatGPT 3 or 3.5. So now let's see. Unfortunately, I cannot directly create Excel files. However, I can guide you through the steps. That's not good. Okay, instead of a file, create an image of the new pie charts. Let's see if that works. So this, by the way, whenever ChatGPT says analyzing, it's actually writing code and it is trying to perform some task. And you can see that by clicking here at the back end, what exactly is it trying to do. So if you're a coder, you can actually relate to that and see what happens at the back end. And it has finished analyzing. I have created the Excel file and it has given me the download link to that Excel files as well. So let's open that up. So there we have it. Oh, I mean, come on. That's pretty impressive. So you have Singapore 2.4, United States, Canada, Australia, New Zealand, and all that. And then in Gemini as well, you have the same thing. They even gave you the percentages as well. And it is kind of interactive, this chart. It's not just an image. So what exactly is that? It's an image, edit the chart. So you can actually edit the chart as well. So it is very a unique way of giving the information. And it looks pretty good. It is kind of interactive graph, you can say. By the way, there is another thing that you might want to see, which is drafts in Gemini. So in Gemini, you will see you have different drafts here. So it generates multiple answers and it gives you the best one it thinks it is. So you can always go and check the drafts for different answers. So not for all of them, but for some of them you will get. So here you can see this is draft number 2 and here is draft number 3. So these charts, you can see they are in JSON format. So it will be easy to upload it on a website and so on. And it is also giving us the code behind it. So that's how it has written this Python code and basically given us the answer. By the way, we could ask it to generate the code as well. We could ask ChatGPT to give us the code as well, or you can copy it from here as well that it has already created. So this is the idea behind how you can utilize graphs when using ChatGPT. So you can really take advantage of the insights of an AI model, how it perceives images, how it perceives graphs, and gives you the output. Okay, so now we are going to move on to a very exciting part. I think this is one of the best things about AI, which is automation. So actually, we will go to automation, don't worry. But before we go there, I want to show you the manual process, and then we will go to the automation process as well. So this is a very fun part. I really enjoyed creating this demo as well. So what is the idea behind this? We have an Excel sheet, which basically has data of 1,000 candidates. So who are these candidates? Random people, right? So the scenario is that you are an HR manager, right? And you listed a job and you said you can apply using a Google form. Now, 1,000 or maybe a lot more people applied to this job posting using this Google form. And in this Google form, you had listings for example, the candidate name, their salary, expected salary, their age. So they had to fill out this information. They had to provide their CV. They had to provide their portfolio and so on. So these are the different titles, the different parts that they had to fill out. So what happens is that once you are done with the Google form, you can download the data in an Excel sheet, right? So this is that Excel sheet. Now, of course, I have created this dummy Excel sheet. It's not of real people, but let's say it was. So how exactly can an HR manager get help in sorting out all the candidates? So let's go ahead and look at that. Now, one thing to note here is that we have to use ChatGPT 4 in order to do this. We cannot use Gemini, or even the advanced Gemini we cannot use, because it is not able to accept any files. So that's a big no-no in terms of Gemini. But in terms of ChatGPT 4, you can upload different file formats. So we are going to open up ChatGPT 4 for now, and then let's start with how exactly are we going to run this. So what you have to do is you have to simply drag and drop your file, whatever file you have. So we have dummy data, 1,000 people. So these are the applicants who applied. Now I am an HR manager. I want to know more about what kind of people applied, how many applicants were there, and then I need help in filtering out. Now, let's go ahead and filter it. So first of all, how many candidates applied? So it is going to analyze the file. The good thing is once it analyzes this file, it might take a while to analyze this, but then later on, it will not take as long as it took the first time. So that's a big advantage, that once it analyzes, it can help you later on get faster responses. There you go. The file contains data of 1,000 candidates. So, okay, that's good. Now, let's say we want to filter them. So let's open the file. And here you can see we have some empty spaces. So this is very unprofessional. For example, you left out the email or you left out your name. So that's not very good. So what we will do is filter out all the candidates that left any of the fields empty and give me the number. So now it's analyzing again, and there you go. So as you saw, it's much faster than before. So it is saying after filtering out all the candidates who left any fields empty, there are 521 candidates. Okay, that's good. Now what we need to do is, let's say we want to filter it more. What we have here is, let's say we have an age group. So we want to hire people, let's say from between 30 to 40. So filter for age 30 to 40. So again, now I'm talking to the AI as if I were talking to a person. I did not go very formal, filter the age of 30 to 40 people, and then give me the output and tell me the number and keep the remaining blah, blah, blah. No, I just said 30 to 40 age, and it casually gave me the answer. Applying the filter within the range 30 to 40 years, there are 140 candidates remaining. Okay, so that's our filtration process. Now, let's say we want experience of at least 5 to 10 years. Okay, or we need that range, let's say. Experience range 5 to 10. Now, I am not writing years. I am not writing filter this. I'm just saying experience range 5 to 10. And it will understand that, okay, I actually want to filter and I want to get the output based on that. So there you go. It's very quick now. And then years who also have 5 to 10 years of experience, there are 21 candidates remaining, right? So we have only 21 candidates. Now, let's say we filter furthermore Or let's just write one word. Let's see if it does or not. Masters. Let's see. So what we're trying to say is that we need a master's degree. And that's pretty much it. No PhD, no bachelor's, no nothing else, just masters. 30 to 40 who have 5-10 years of experience and hold a master's degree. There are only 5 candidates remaining. So that's how good this is, right? So you can experiment with this and you can get a lot more out of this. Now from 1,000, we shrank it down to 5 candidates. Now we are lazy. We want to go further. So what we will do is write an email to these candidates, ask them to come for an interview. We have 2 time slots, one in the morning at 9 and one in the afternoon at 3. Adjust them accordingly. Do this for the next week. So it's like I'm giving the complete task. So right now it's creating the draft. So it will be interesting to see if it gives us all 5 emails. My guess is not, because it might give you some fillers that you have to fill, because 5 emails would be, first, it will be repetitive. Second, it will be a lot of text. It tries to avoid providing a lot of output. Oh, it does. That's great. So right now I can see, oh, it is giving for all 5 of them. So I guess if the applicants were like 10, 20, probably it won't give that. And it has written very short email, so that's okay. So now you can see like how lazy do you have to be. Actually, it's smart work. Like you can say that, you can argue that this is smart work. And imagine that if you were to automate this, right? So you had already a filtration process. You didn't have to write questions again and again. And then you just press a button and it will filter all of them, write the emails and ask you, do you want to send the email? Yes or no? So that could be another thing. Okay, so let's read one of these. Dear Christopher, we are pleased to inform you that your application has been shortlisted for the position you applied for at our company. Now that's a bad thing. The position you applied for the company, you should actually tell, because we didn't tell anything. That's why it doesn't know, and that's why it didn't write. We would like to invite you for an interview to discuss your application further. Interview details. Please confirm your availability for this interview by replying to this email. If you have any questions or need further information, feel free to contact us and this and this and that. So yeah, so that's the basic idea. You can even go further and provide this information. Your name is, let's say, Murtaza Hassan, and your position is let's say HR manager, and your contact information is 1 2 3 4 5 6. So add these, and we can also write the job position is of a back end developer. So it will revise all the emails and it will be pretty much ready to go. Now the only automation you can't do here is that you can't just send it from here. But if you were to write code, definitely you can easily have a button. After verifying everything, you just press email, goes to the email provider, sends out all the emails, and yeah, that's the idea. So as you can see, it's giving us all the information, but again, it is using ChatGPT 4. It is not using the free version. You have to have the paid version. So there you go. Now we have all the emails ready. So now we are going to go ahead and create some images from text. So the idea is that you give a prompt and it will generate an image for you. So there are a lot of models out there that you can use. There are a lot of websites that you can use, and most of them are paid. And some of them, they might give you some credits to do this. Now, if you wanted to create realistic images, I would highly recommend you do it offline. You do it on your own computer, because now models are getting very good and very fast as well. You can create a very realistic image in just 10 to 15 seconds if you have a 4090 or even a 30 graphic card. So that is highly recommended. But if you don't have that option, and by the way, you don't have to code anything to create these images. I will show you in the next steps how you can do it without any coding. But if you don't even have that option, and if you have to do it online, then you can use ChatGPT 4, or you can use Gemini. By the way, Gemini creates images as well. Gemini Advanced creates images as well, which is paid. Gemini is free, but ChatGPT 4 will create images only. ChatGPT 3.5 will not create images. So if you want to create images, you have to pay for the model for ChatGPT, not for Gemini. So let's go ahead and look at how well it performs. So let's go ahead and just type in create an image of a child playing in a park. Let's see what it does. And we will do the same thing for advanced. And we will hit enter and let's see what we get. So right now it's creating an image. It is loading. Let's see, and it's loading here as well. Okay, so we have a bad news. I can't generate images of that. Try asking me to generate images of something else. Let's see the drafts. Did it create anything, or it's just text? So here, on the other hand, in ChatGPT, we have an image. A kid is running in a playground and it's not realistic. Maybe we can write realistic. I don't think it will make it realistic. These Dolly models, they don't really give you realistic, especially in ChatGPT. So it can't generate. Why can't you generate? Spellings are all wrong. That's okay, as long as it understands. It seems like you might be asking, why can't you generate something? There are common reasons, scenarios apply, physical law, blah, blah, blah. The reason it's not generating child playing in a park because it has the word child in it. So it's restraining from that. So it avoids creating people. Google has been not very good with creating people images. So that's why. So let's write here, portrait of a woman influencer, and yeah, let's just keep it that way. And Instagram. I'm pretty sure this will not run. It seems that they don't want to create. Oh no, it did run. So this time around it actually ran. Okay, so now it's so initially it felt like it's going to create it and then it didn't create it, and it's all weird because they are still not able to generate people images. So here you can see it's very weird, and it's not fantasy, it's just out of proportions, I would say. Okay, let's try out the other methods. Generate a logo for a flower shop. The same thing here. Let's see how well does that perform. So far, ChatGPT is creating good images, but Gemini, it's just giving excuses that it can't. So sure, here is a logo of a flower shop. I would say this can be a logo, which is not bad. This and this and this, no, not. These are just images of flowers. Yeah, now this is more like an image of or a logo of a flower shop. So it's done much better here. Then let's try something awkward. Car flying on the moon with a horse on the car. You see, you have to be imaginative to check the real potential of AI. So let's see what it does here. And there we have it. It's a horse on the car and the moon is at the background. And it's like a balloon. Okay, so the flying balloons. Oh, this is futuristic. And the horse, is it animatronic? Kind of. And the car, is it forward or backwards? It's hard to tell. But anyways, it did a good job. It's a good image. Here it's not bad as well. It's more creative. Yeah, I would say both of them, they did well. Here, the horse and the moon, it's more, I think, towards the realism, I guess. Anyways, so let's try another one, social media post for computer vision course. So let's say I was creating a course and I wanted to create a social media post. Now, of course, I didn't mention any details. So let's see what it does. So here it's creating an image, and here it's saying, it's giving me options. Option 1, eye-catching visual focus, highlighting practical applications, the wow factor, course specifics. Oh, okay. Let's say the wow factor, 3. So it's asking me which direction do you want to move into. So, okay, so this is what I've seen in ChatGPT, that when it creates something which has to be a bit creative, it just adds a lot of icons together and just creates something weird. And it looks really weird. If you look at the custom models, the Storybook Weaver, Clipcraft, all of these, they are very, very densely designed, I would say. So there is a pattern there. It's again asking more questions. A list of 3 things. What's going on? Okay, let's pick the second one. So it's asking a lot of questions, which might be good in a sense that it needs more information before it can actually create something relevant, but it can be really annoying as well. Like in this case, at least it gave me something to work with. See, again, it's giving options upon options upon options, creates an image already. Come on, do it. Okay, so finally it did understand it needs a image. So let's see. Oh, well, I would say that is better than this. Bit futuristic, not bad. So let's try another one. Create a meme on AI. Let's copy that. Let's copy that. And let's see what it does. So whether they are able to create memes or not, let's see if it works. Oh, come on. It's giving us ideas, which is okay, but when you want to test it out, that's not a good thing to have. Meme idea 2, AI versus reality, the overly optimistic, the never-ending learning curve. Okay, let's go with 2 again. Humorous meme about AI capturing the playful challenge of understanding. When AI tries to understand, emotions do not compute. Well, when AI tries to understand, do not. Okay, okay, pun intended. I get it. But the text is not that great, and the image itself is not that great. Visual ideas, expectation side, reality side. Again, it's just creates the meme already. Oh, okay. So it cannot create a direct meme for me, and it can guide you through the process. And oh, okay. Fair enough. So it cannot create. So it said I cannot do that. But you can see ChatGPT actually is able to do all of that. And Google, it seems that they still have a lot of things to figure out. But of course, there's a lot of improvement required in this arena as well. Now, again, if you wanted to create memes, the best idea would be to add a couple of AI models, automate them together, and create the meme. And the same thing goes for stories and other images that you wanted to create. For example, if I wanted to create, let's say, a YouTube vlog. So I have the YouTube video. Now I want to create a blog out of it. I can take specific keywords from that YouTube video, and then I can generate some images of that and put it in the blog itself. So that's kind of a creative way to do this. So of course, all of that can be automated in our coding sections. So make sure you go ahead and go through all that, and we will create some really good apps, and I will see you in there. So now we are going to have a look at ChatGPT's new functionality, which allows us to automate our tasks without actually coding. So whenever you want to automate something, you might think of coding as the first choice, but in this instance, to some extent, we can actually do some automation as well. So how can we do that? Now, one thing, it is paid because you have to use ChatGPT 4 for this. So, and we don't have any other option yet. Maybe later on, someone else will come with the same idea. But for now, you have to use the paid version. So we can open up our sidebar, and here you can see some of my previous ChatGPTs that I've created or configured, you might say, or automated. So what we are going to do is we are going to explore GPTs. And here you will find all the different GPTs that people have created, companies have created related to writing, productivity, research and analysis. So there's a lot of things you can do. For example, you can automate the task of citations and stuff like that. So there's a lot to explore here. Now, what we will do is we will click on create, and we will create our own GPT. And the idea of this one is that we are going to create a GPT that allows us to create a book for children of 5 pages. So this AI model will create a storybook for children that has 5 pages, each page 5 pages. That's the first thing. Then each page will have one sentence. So when you open this up, you will see that on the left hand side we have a create and configure, and on the right hand side we have a preview of the actual GPT that we are creating. So in this instance, we are going to create a storybook creator. So the idea will be that we will give it a title, or we will give it a scene or scenario, and it will create a storybook of 5 pages, with each of these pages having a one sentence story. So one sentence for each page, and that will have a total of 5 to complete the story. So now what you have to do is you have to give instructions to this chat GPT, and it will configure it and put it in instructions. And then every time we don't have to explain it again and again. Now, if I were to create this story using normal chat GPT, then I would say write a story for 5 pages, then create the first image, then create the second image, then create the third image, and so on. So what we are doing is we are basically reducing the repetition. So that's what we are trying to do. So here, first of all, we are going to give it the context. This will be a story creator for children. Let's say storybook creator for children. The book will contain 5 pages. Each page will have an image. Each page will have a sentence or two at max. Okay. And the user will mention the topic of the story. So that's the basic idea. So let's go ahead and enter this, and let's see what it tells us, what exactly is happening. So right now it's saying that it is updating the GPT, which means it is running this instructions. It is trying to optimize this, and it will paste it here. So we will go back, updating, and there you go. Good timing. So creates children's storybooks based on a topic, is designed as a storybook creator. So whatever we mentioned, it just optimized it and wrote it here as instructions. So that's the basic idea. So how about we call it Storybook Weaver? The name should be Kids Book Creator, let's say. There you go. It has updated it. And you can see now, if you go to configure, it should come here. It didn't? Why is that? Maybe it is. Oh, it's generating a profile picture. So let's see what it does. So basically it will replace it here. Okay, I like it. Good. So Kids Book Creator. So that's the idea. And if you go to configure, you can see you have the name, description, instructions, and these are the conversation starters that you can click here. If you wanted to change, you can change these as well. And here is the knowledge part. So if you had a specific patterns, specific design or something, you can upload some files here that these are the reference materials, do something similar to this, and so on. But we don't need that in this instance. And then you can also add code using this part, but this is a bit more advanced, and we will cover that in the coding part, where we will actually automate using our own models. So now what we can do is, so it is asking, let's refine the behavior a bit more. What kind of stories should it emphasize or avoid? So let's forget about that. Right now, let's go ahead and test the Storybook creator. So tell me a story about space. So let's start from there. Now you can of course write your own topic, for example, a kid playing in a park or a dragon flying through a mountain, whatever you want to call it. So right now what it will do is, first of all, it is going to create the actual story. And for each page, it is creating an image description which will be used to create the image. So that is a very important point. So here it has done for all 5 pages. And now it is asking us to whether to continue with this or not. So this is the title, The Little Astronaut's Big Adventure. So here we will write continue with the images. There you go. So now it should generate all the 5 images for all the 5 pages. So let's see what it does. So there we have it. This is the first image that it has created. So let's see what it was. It says, in a small town where the night sky glittered with stars, there lived a curious child named Alex. Alex dreamed of exploring the vast twinkling universe above. A cozy little town at night with a child looking up the star-filled sky from their backyard, wide-eyed with wonder. So that is pretty good. And I would say that's a very good image for this purpose. Then in the second one, oh, it went realistic all of a sudden. So one night, a shiny silver spaceship landed in Alex's backyard. Out stepped a friendly robot, inviting Alex on a space adventure. So spaceship and this and that. So I would say that the image 1, 3, 4, it's good. Like it's keeping up with the theme. But image 2 is not. So it is realistic. So this is what we can discuss with the GPT, and we can retrain it. So here we will say the model is good, but sometimes it does not keep up with the theme of image, or not the theme, the style of images. So the style of the images should always be cartoonic for children. It should not be realistic. Right? Is it cartoonist or cartoonic? I'm not sure. Let's just send it and see what happens. So now it should update. So it is updating the GPT. So here it is going to change the configuration. Now that we have refined the image style to always be cartoonish for children, avoiding realistic, is there anything else? So, okay, now let's go ahead and try a different one. Create a book about create a book about underwater adventure, generate a book about day at the zoo, make a story featuring a magical forest. I would be interested to see that personally. So let's figure that out. So now it's creating an image. So interestingly, why is it creating an image first? Let's see. Maybe it will create an image and then it will write the story and then create an image, then the rest of it. Let's see. So it's directly creating the image. It's a bit more cartoonish this time, I would say. Yeah. Or maybe instead of cartoonish, we can say fantasy type of thing. Okay, so now you can see the problem is it's not actually giving the text. So first, right now, it's only giving the images. First, it should give the story text and then generate the images. Instead of the images being cartoonish, make them fantasy. Let's see what it does now. Regenerate. By the way, there is a limit to ChatGPT 4. You can send only 40 messages every 3 hours, I believe. So it doesn't seem very limited, but when you are asking questions back and forth, it can finish very quickly. Yeah, so especially when you're generating an AI model like this. Tell me a story about space featuring magical forest. So I will go again with the magical forest and let's see what it gives us now. So it should give us the story first, but it's again creating the image first. So that's not good. It is still creating the images first. Follow these steps. Okay, first one, create the story for all 5 pages along with the image descriptions. Create the images using the descriptions created earlier. Maybe now it will get it. Sometimes you have to repeat things. So as long as it optimizes it over here, creator designed to craft storybooks for children, generate 5-page story based on a user topic. Each page will first present. It seems fine to me. To spark imagination, fitting fantasy theme with blah blah blah. After establishing story, yeah, book creator will proceed to generate images based on that. Yeah, makes sense. Okay, create a story book for the topic beautiful day at the forest. Let's see what it does. There you go. Now it's giving us the text first. That's good. A beautiful day at the forest, page 1. The story is this. The good thing is it didn't go above 2 sentences. If it had gone, I would have been very mad and frustrated. But no, it's not going. But it is quite lengthy, actually. We can keep telling it to increase the size, decrease the size, change the image style, this and that. So that's the basic idea behind this, that what you are doing is you are automating this process that otherwise you would have to write in maybe 5 different lines or 10 different queries. This, you just wrote one query and it will do everything for you. Now, this can be even more optimized or automated while you are actually coding, but for something that is online, it is very good. So right now, we just gave one query. We just said write a story, and it already has the criteria that it should be 5 pages. It should have text that has sentences, not more than 2. Then it should create images. They should be kind of fantasy images. Oh, and there is an error. Error loading image. So maybe we'll try to run that again, but let's see if it creates the other image. So again, this is a new thing that is coming up. So there will be some problems here and there, but don't worry. Hopefully it will get better. Okay, in the heart of lush green forest, where the sun danced through the leaves, lived a cheerful little squirrel named Sammy. Oh, they even named it. But it's Bella here. What's that? Anyway, so that's the basic idea of how you can automate stuff. You can basically add all the configurations here. You can keep going back and forth. Oh no, you did this mistake. You should do this, you should do that, and so on. And you can even give some reference things, some files to actually automate this. But of course, it is limited. It's not that great. But if you wanted real automation, then I would highly recommend you go for the coding examples. And we will be building a lot of apps in our upcoming parts. So make sure you go through all of them and see how it works. And by the way, we are going to create a storybook creator as well, 5-page storybook, which will be maybe 10 times better than this because we will be using some coding examples and coding automations with it. So I will see you there. So now we are going to go ahead and learn how to run our models offline, which means that we will use our own computer to run the AI models. So we don't have to send any data to any cloud, or we don't have to share our data. We can do it right from our own computer. So how exactly can we do this without coding? That is what we are going to look at. So there are a few softwares that allow you to do this. So we are going to use the LM Studio, which is one of the best ones out there to get started, and it's very easy to run this and install. And the good thing is that it has all the different models already that you can actually search for and download it within the software. So you don't have to worry about exporting or importing different models. Now, one thing to note here is that the models that we used earlier, ChatGPT or the Gemini model or the Copilot, they are not available to public. So they are private models. But what we are using, what we will be using are open source models that are available online for free to download. So they might have their own licenses where you can use them or not. But a model like, for example, that has been provided by Facebook is Llama. Now, Llama actually gives you full access to use in your commercial projects and research projects and whatever you want to do it with. Now, of course, there are limitations. You have to read about them, but it is very good to see that such big companies like Facebook are moving towards the open source arena as well. So that allows us to easily create our apps and even build commercial apps with this AI revolution, with this AI models. So what we will do is we'll go to lmstudio.ai and simply you can download it for Mac, Windows or Linux. You will simply click on download and you will download and simply install it. Once you install it, this is what you will have. So the good thing about this is that it even tells you which of the models will work well with your computer. So that is a good thing. So here it says supports any Llama model, Mistral, Falcon, GPT Neo, and all of those. It also gives you these models that have been released recently, so you can check those out as well. Or you can always go to search, and over here you can search for any models. For example, we will write Llama. That is the model provided by Facebook. So it has different versions. Like we saw in our introduction video, it had 7 billion parameters, it had 70 billion parameters. So depending on what type of computer you have, how much can it process, you can actually select those. Okay. Now, one thing to note here is that when you are running an inference for any query, it goes to the server and then it comes back when you are using online, for example, ChatGPT. So your computer is not being utilized. You are sending the data, the process is done in a server and it comes back. Now that server costs millions of dollars, right? So it can process a lot of data very quickly and give you good results. But even the best of computers that are locally available, they are not as good as those servers. So we need something to actually easily convert our big models to smaller models so that we can run it on our computer. Because especially the text part, the language models, they are very big. So they can be lots of GBs and we will not be able to run them without actually having a lot of memory. So you need a lot of RAM just to run one inference out of these. So without having a big server, it's not possible to do that. So what is the solution for this? The solution is quantization. So here you can see, for example, when we wrote Llama, we have these quantized models. So here the biggest one is 7 GB and the small one is 2 GBs. So what's the difference here? How is it going from 7 to 2 GB? What's the difference? So that is using quantization. So we will go ahead and look at what exactly is quantization. So I don't want to get into too much detail of quantization and going in deep into the maths, but the idea of quantization is that you take a very big model and you convert it into a smaller model so that you can run it on your computer, on mobile phone, on your watch, or whatever it is. So how can you do that? For example, you have a 50 GB model and you convert it into 5 GB so you can run it on your phone or on your computer. So how can you do that? You can do that by reducing the bits. So for example, you had weights that were 32 bits and now you convert them into 8 bits. So later on, I will show you the different levels of quantization. So sometimes it's 2 bits, 3 bits, 4 bits, 5 bits, and so on. So you don't have to go into too much detail on exactly how bits work and how the conversion happens, but let me give you a very high level overview of this. So for example, When we are talking about numbers, we are talking about weights of the neural network, right? So for example, when the model is training, it is training these weights, it's changing these weights. So when the model is trained, it stores these weights. So each one of these connection basically has a weight for it. So for example, the value of this weight is 3.2. The value of this weight is 1.2. Now, what quantization does is it simplifies it, right? So this 3.2 becomes 3. Now, you lost some information, you lost zero point 0.2, but it's close to the actual value. Then 1.2 becomes 1. 0.24 becomes 0.2. Now, this is a very vague value, a very vague example, but it's very simple to understand. That's why we are giving it with actual numbers. So it's very simple to understand that we are basically reducing the size by reducing the resolution, right? So here it will be more accurate. Here it will be less accurate, right? So that's the basic idea of quantization. Now, if we go to the model card of this model, for example, here it says model card. If we click on that, it will take us to a website called Hugging Face, which is like the YouTube of AI models. You can find everything there, pretty much. Whatever is open source, you will find it there. So here, this is the model card of this AI model, right? So it is Llama 2 7B, which means 7 billion values it has, 7 billion parameters. And what is the size of this? Now we have to check here. So this is the quantization method. Here it says it's 2 bits. So the size will be 2.8 GBs. But it says it is the smallest and there is a significant quality loss, not recommended for most purposes. So it's not good to use this, right? Similarly, we have 4-bit. So 4-bit legacy, small, very high quality loss, prefer using Q3. So they are giving you suggestions. For example, this 4-bit is medium balanced quality recommended. So they recommend using this because it is a good balance between accuracy and size. And here the biggest one is 7 GBs. And here it's very large, extremely low quality loss, not recommended because quantization is not really doing anything there, right? And it is also giving you how much RAM is required for each one of these. So here you can see how much RAM is required and you can make a decision based on that. So now what happens is that when we go here, you can of course select any of these. So the one I selected was Llama 2 7B chat Q4. And this is GGUF. GGUF is the format when it is quantized, it will give you the format GGUF. So that is the model that we will be using. So it is around 4.8 and it tells you that it should work on your computer. If it says it doesn't work on your computer here, then you should not download it. You should try a different one. Okay, so how do you download? You simply go here and you click on download. So it will start the download process. And what it does is if you click on this part here, it will show you the download process. So it's starting to download now. And I believe in the latest model, they actually added the option of pause and cancel. I thought they did, but it's not showing here. Maybe in the next one, they will add something of that sort. But anyways, so how do you run this? To run this, you go to AI chat and here you select the model. So for example, you can see here, I tried the Q8, which was 50 GBs and it didn't work on my computer. So even though it said it would, but it didn't work. Anyways, so let's try this and we will accept. And right now it is loading the model. To make sure it has loaded or not, we will press Control, Shift and Escape and it will take us to the GPU. And right away you can see the GPU starts working. So now we know the model has been loaded and whatever we ask questions, it will be based on the GPU. So what we can do is here in the GPU offload, you have to give a number if you want to use GPU, right? So they recommend that start from 10, 20, something like that, or you can just go 99 or 9,000 or whatever number you want. So there is an explanation for that. You can go and see help. If it's running slow, you can of course try faster or reduce. And here you can have the context length. This is the context length, which means how much input can you give. And it actually supports up to 4,000, which means you can give 4,000 tokens. So how can you chat? To chat, you will simply close this, and here it says reload model. So again, we will apply reload, and here you can see there is a bump, and there you go, it went up. Now you can see the GPU is being utilized, right? Earlier, the GPU was not being utilized completely. Now it bumped up, and now it's using it. So what do we want to ask? Let's say write an email to tell my boss that I am sick. And it tells you it's 12 tokens. And you can see it's quite fast. It's not bad at all when compared to, for example, ChatGPT. And yeah, so we can ask, for example, make it more formal. So I'm writing to inform you that I'll be taking a sick leave today. I'm currently blah, blah, blah. Make it longer. There you go. Now, if you were to use a different model that is not quantized, it will take a lot more time, and it probably will crash as well. So without quantization, it will be very difficult to work with that. So there you go. We are getting some output as well. So this is the basic idea of how you can run your model. Now you can go to Hugging Face to check out all the different models that are available for you to use offline. You can, later on, we will be learning how to code with these as well, but you can do it within this as well. So you can go to search, and you can search for the latest ones, the most popular ones, and there are different sorting mechanisms that you can use here. For example, you can go to home and check. You can see here right now Google Gemma 2B Instruct was released. So it is small and fast. So you will find a lot of different variations, and it will be very helpful to you to keep an eye on these different models that come up, and you can download them and run it for your own local machine, and you can create your own data. Now, the best thing is that you will not have to send it anywhere. It will be running through your computer. Now, one more thing, when you are running this, it is quite intensive. And as you can see right now, it is using 9.8 GBs of memory. So what you want to do is, if you don't want to use it, and if you want to keep it open, you will go to AI chat and you will eject the model. When you eject the model, you can see right away it dips down and it removes the model. And then if you want to completely remove it, of course, you will hit close, and then you will see a further dip in the GPU usage. So right now it's at 2.3. So now we are going to go have a look at how exactly can we generate images, good quality images, using our local hardware. Now, this might look like a difficult task, but it is very simple, and the quality that we get is extremely good. So we have multiple softwares that allow us to do this. The most famous one is Automatic 1111. Now, if you go here, this is the Stable Diffusion Web UI. This is the most famous one, but it is for advanced users. So right off the bat, you will not get good results unless you tweak it, unless you make some changes, you know what you are doing, and you need to know which models to use and so on. So I recommend this if you have some experience with AI models, but for average users, I would definitely recommend going with Focus. Now, if it is Focus or it is Focus, I'm not sure, but it is very good. So Focus, you have to write Focus GitHub on Google, and it will take you to the GitHub page. And this is the software that we'll be using. It is in the GPL 3.0 license. And you can see this is the result that you get. I mean, that's amazing. Right off the bat, you don't have to do anything, and this is what you will get. And the author actually mentioned that this is not cherry picked, which means they didn't try like 100 of these and then pick the best one. It is an actual random sample. And I can vouch for that actually it is that good. So how exactly can you get started with this? It's very simple. You can use Windows, Linux, or Mac, whichever one you have. All of the information is given here. So whichever one you want to use, you have also the option of AMD. So all of this information is given here. So if you are using CPU only, it will be 17 times slower than RTX 30 series. If you are using Windows or Linux, you can get very good performance. The fastest one will be again with the 4090 that I highly recommend that you get for the AI purposes. Now, how exactly can you download this? It's very simple. We will do it for Windows. You simply click on download and you will get a zip file. You extract all the zip file contents and this is what you will get. And all you have to do is you have to run .bat. You have to click on that. Once you click on it for the very first time, it will take some time to download all the models. Not all the models, the one that is required to get you started with. Now, once you do some other operations, then it will download other models. So for example, here it will start with the Juggernaut model. I believe it is actually using Stable Diffusion XL and it is using Stable Diffusion XL Refiner. So the refiner actually refines the image after the model has generated it. So it even becomes better in terms of realism. So let's go ahead and look at how this works. Once you run it and everything is downloaded, then it will open up something like this. So right off the start, you can see it's a very simple UI. All you have to do is you have to write the prompt. For example, I can write burger and I can hit generate. So just to make sure, we can open up our task manager and here we can go to performance and see if GPU is working. And there you go, the GPU is working. It's not using the CPU. Now, this is because we have done all the installations in the installation chapter. That's why it's running that. And there you go. So right off the bat, you can see how realistic this is. You didn't do anything. You just downloaded and gave the prompt burger. That's it. This is the second one it's generating. And I will tell you why it's generating too. By the way, funny thing, I wrote the spelling wrong and it still gave me the correct burgers. So yeah, that's funny. Anyway, so yeah, this is the idea. And then if you go to advanced, here you will have the option of how many images do you want to use output. So 1 image, 2 images. Right now it's 2. So every time it will generate 2. Then you can optimize for performance. So for example, we want quality rather than speed. So we can specify that. What is the size you want? You can specify here. And you can add something here that you don't want. So for example, if you don't want red color in it, you can define, I don't want red color. If you want a person, there should be no fingers, right here fingers. So it will try to avoid fingers and things like that. Then we also have style. In style, there are 3 styles already applied, which make it so much better than the base model of Stable Diffusion. That's why you are getting such good results right from the start. Then you also have these anime style, pixel art style, low poly, and all of these. So for example, if I remove these and I generate, so now it should give me anime style burger. And let's see how it looks like. And here you can see it is sampling now 60 frames, so 60 iterations. So earlier we said that we wanted speed. That's why it was doing 30, but now it will be doing 60 for each one of these. So 60 might be a little bit too high because it's taking how much? It's taking around 20 seconds, I believe, to do one. Let me check the exact value. So here it is, yeah, around 30 seconds to do one, 25-30 seconds. So this is the anime style burger. Looks very yummy. And of course you can create people, you can have sceneries, you can have any style that you want here. There's lots of styles here that you can try out. So let's try out. A lot of people, they like to create influencers, and so let's try out and create an influencer and see how well that performs. And I will show you the more advanced features when you can use input image as well. So let's start with influencer, Instagram, portrait. All the spellings are wrong, so let's fix those. Portrait, influencer, Instagram, portrait, realistic, no makeup, rough hair. You can basically come up with whatever you want. And yeah, let's try it out. Let's generate. What do we get? Did we change the setting? No, the quality is 60, so it will take a while to start. So now you can see the influencer being generated, and you can see the hairs, they are rough, yes, and it is a portrait. At the back we have jungle, I believe. What is that? So it is almost done, and there we have it. So look at the quality of this image, like how realistic that is. I mean, that is pretty amazing. So that's the idea of how you can create. And what you can do next is, if you wanted to create the same person in a different environment, you can say, you can go to input image, and here, whenever you are going to use input image or a different model, then it will download that model first, and then it will be able to run it. Now, I have already downloaded all of these, so it will not take a lot of time. So, but let me, I'm telling you so that you'll have to wait a little bit before it runs. Now, if I wanted to upscale this, if I wanted to make it 2 times, 3 times, I can do it here. Upscale 1.5, upscale 2, and so on. And then I can also, by the way, I can simply drag and drop, so that will work. And then what I can do is I can use the image prompt to generate the same person, kind of the same person, in a different environment. So let's say in a mall shopping. So let's generate that. So now it will take this image as the reference image, and it will try to embed this with that. So she is in a shopping mall doing some shopping. So probably the portrait will be the same because it is a portrait image. It will try to replicate the same thing, but the background will probably be, yeah, mall. There you go. So you can see now it's more like a mall rather than a jungle at the background. So we are almost about done. There you go. So is it the same person? Well, you can argue, like you can say yes and no. It is debatable. See, that's the beauty of it. As AI gets better, you will have access to that as well, and you can keep downloading newer models. So here in the model, you will see this is the version of the Juggernaut, and probably I think version 8 has been released as well, so you can use that. And then this is the refiner. This is the LoRA actually, and the LoRA, basically I will explain this a little bit more in detail in the later videos, but for now just think of it at it that it helps creating a better image. Then in the advanced, you have guidance scale. So guidance scale basically is how much do you want to follow your command. So if it is a higher value, if the guidance scale is high, then it will try its best to replicate what you have said in the command, in the prompt. If it's lower, it will try to be more unique, more creative, and things like that. Image sharpness, of course, image sharpness, if you want to increase, you can increase it here. So yeah, there you go. It's in the mall, and you can see it's a quite good image. And then let's say that the mall is there, everything is there, or should we go to the previous one? Let's do a burger again, or let's do one more thing. Fire breathing dragon. That will be fun to watch. Let me change that to speed so that we can do this quicker. You don't have to wait as long. So, oh, my bad. Stop. So we have to remove the input image because we don't want a fire breathing dragon with that image. We just want a fire breathing dragon. So the reason I'm doing this is I want to add something. Ooh, that's scary. So now we have 30 iterations, as you can see. So there we have it. Look at the quality of that image. I mean, it looks like it's right off a movie, and it's very cinematic and all that good stuff. What we can do is we can actually change some things of this. So for example, if I wanted the dragon to wear a hat, right? So then I can go to input image. I can go to in paint or out paint, and then I can just drag this image here, and then it says start drawing. So here I can change the size of this brush, and here I will put something like this, and I will say fire breathing dragon wearing a funny hat. Or let's not put funny. Let's see if it tries to make it realistic, right? Now again, if you do that, it will load different models. So if you haven't done this before, it will first download those, and then it will start processing the image. So you will have to wait a while before it gets started. Now it is moving to GPU. Let's see what is going on with GPU. There you go. GPU is bumping up. There you go. So it's trying to generate a hat, and it looks good so far, hopefully. Yeah, so you can pick places that you want to add or remove stuff. So that's the idea of InPaint. So there you go, fire breathing dragon. Look at the reflections. They are very good. So if you look at the left hand side, it's bluish, and the right hand side is reddish, orangish. So that is also reflected here. So bluish hat on the left hand side, and on the right you have orangish. I mean, it is very, very good. And of course it's generating two of these. So I think the first one is better than the second one. The second one is looking like a magician. Nevertheless, and what you can also do is you can add to left, right, bottom. Like if you wanted to increase the size of the image, you can basically do that. Or let's just do one. Let's increase on the left and let's increase on the bottom. So let's generate that and let's see what it does. Again, it will be a different model that does this. So make sure you wait for it to download and then it will start working. So there you go. On the left and on the bottom, it's trying to generate more of the image, trying to get the essence of the scene and putting it all on its beautiful canvas. So far it's looking good. I believe it is up to par and it is amazing. I mean, come on. So all of this, you are doing it within a few seconds. I'm not pausing or anything. You are looking at this in real time, and it is quite amazing to see what AI is able to produce with such small amount of times. So this was done in 16 seconds. The other one is how much? Pretty much the same. Yeah. So there you go. Two variations. You can see that's pretty amazing. So that's the basic idea of how you can use this AI generation tool. And of course, when newer models come in, you can add newer models here as well. You can go to the appropriate folder of the models and you can paste a newer model there. And when you come and refresh here, it will show the newer model over here. And if you add a refiner, the refiner is not required for this model. But if you wanted to add your own LoRa's, you can actually add these here. And then when you refresh it, it will show you over here the LoRa's as well. So that's the basic idea of how you can generate images using your own local hardware. So now we are going to have a look at a deepfake software that is using these AI models at the backend, and we are going to have a look at how we can use this. Now, I was not going to initially add this to the program, to the actual course, but because it's a lot of fun and it's so easy to use, I wanted to add this on as well. So I actually tested it out and I posted a few of my videos, and one of them even went viral. If you look at this video, it actually went viral. It had 2 million views in a few weeks, and people were debating whether it is actually true or not, it's real or not, whether it's me. I actually uploaded this as a joke because I wrote, haters will say it's Will Smith. And it's obvious that it's Will Smith. But if you look closely, there is some resemblance. And at times, for example, here, it can become difficult. If you have seen me before, it can become difficult that maybe it's me, maybe it's not. So that's quite fun to watch. So how exactly can we do this? Let's go ahead and look at that. So this software is by the name Face Fusion. You simply Google that. And then this is the GitHub. Actually, this is the GitHub. So if we click on that, this is the repository for that Face Fusion. So Face Fusion and Face Fusion. And thanks to all the contributors who have done all of the hard work and provided this for free. So thanks to Henry, Russ, and all the contributors who actually made this possible. Now, what you have to do is you simply download it and run it. You have to write 1 or 2 lines of code. Like, it's not logical code, it's just running the command. So don't worry, there is nothing too fancy about this. So all you have to do is you have to go to the code and you can download zip. Now, if you are a programmer, if you are familiar with GitHub and Git, then you can simply copy the URL from here and you can clone using Git. But for average users who don't know about this, you can simply download the zip file and this is what you will get. So what we will do is we are going to go ahead and copy that in our PyCharm project. So for the PyCharm project, we are going to create a new project. Let me bring that here. So this will be our new project. We will call it Face Fusion Deep Fake. And we are again using Python 3.10. We will create that and this will open up our window. And what we can do is, in order to drag and drop, you can right click and open in Explorer. Once you open that up, make sure you are in the folder. .idea .environment is there, right? And then you simply drag and drop. So you simply drag and drop. And then I would recommend that you rename this to Face Fusion. There you go. So now you will see we have Face Fusion over here. We can make this a little bit bigger. And the idea is that you have to install all the softwares, all the packages that are required for this software to run. So all of them are available in requirements.txt. So you don't have to do anything fancy. Just right click on Face Fusion, open in terminal, and that will give you the virtual environment. And over here, you are simply going to write pip-r install -r and then requirements.txt. Did I write it correct? Requirements.txt, hopefully. So if we run that, it will start collecting the packages. Basically, what it does is it makes it easier for us. The requirements file has all of these packages names with their versions, which one to install. So it collects all of them and it starts installing them. So when you are actually installing any software in Windows or Mac or something like that, then it's actually doing the same thing at the back end. It's not doing anything fancy. It's doing the same thing. It's collecting all the requirements, it's installing them and putting them in different folders and wherever it's required. So that's pretty much what is happening here. Right now, our folder is this virtual environment, and inside that we have our library folder in which we will have all the libraries and everything that will be for this project. So we are going to wait for it to finish. Once it finishes, then we will continue. So now that the installations are done, what we can do is, if we go to Face Fusion, we see there is a run.py file here. So all we have to do is we have to run this. So we have to make sure we are in this folder. So you can see it's Fusion, Face Fusion Deepfake, and inside that we are in Face Fusion. If you are not, you can simply right click and open in terminal. And then you will simply write Python run.py. And that's pretty much it. So you didn't have to write any code. It's the only thing you had to do was run this. Now, when you run it for the very first time, it will download the AI models that are required to run this software, because they are not coming with the package, not coming with the software itself. So it will download these and it might take a while. So once it is done, then it will open up the actual software. So now that the download is complete, this will give us a local URL. We can simply click on that and it will take us to the actual software. And here you can see we have the face swapper selected and we are using CPU. So we didn't do anything related to GPU yet. I will explain how you can add the GPU part as well. But for now, let's say that our target image, and let me bring my source image. So just drag and drop, and then I have Googled here Iron Man, and I will simply drag and drop this over here. In a few seconds, you will have the result. There you go. So it did face swap, but it's not very realistic and it's not very clear. So in order to clear it, we are going to use the face enhancer. So if we click on that, it will start the download again, because it needs to download another model to do the face enhancing and another model to do the face swapping. So there are two different models. So that's the beauty of this software, that it will bring different models together and it will make them compatible with each other. Otherwise, you will have to write the own code and it will take a long time to make them communicate with each other. So right now we are using CPU. So of course it will take longer, but I will explain how you will do the GPU as well. So let's wait for it to download and then we will look at the final result. So now the download is complete and now you can see it's better than before. Again, it's not the best result, but it is better than what we saw earlier. Now the same thing you can do with videos. So basically you can simply drag and drop For example, I have this video lying around, and what you can do is you can move the frames to see the preview as well. So right now, if you look at this, there will be no face swapping because there's no face there. But if we move it around, it will actually show you the result based on that frame. So right now it's very weird. Something is off. There you go. So this is the face, the actual face, and we need to swap it with this. So what we can do is we can select the reference face and it will swap it. Sometimes you have multiple faces, and in that instance you can select which face do you want to do, or do you want to do it only on one, or do you want to do it on all of them. So that is the option here as well. So that's why this is a very good software, because it makes it very easy for us to do. And now if you wanted to convert this complete video, you can simply press the start button, and using this reference face, it will do the complete video with this face swapping. But if you want to do videos, I highly recommend that you use GPU rather than CPU. So how can you do GPU? In order to do that, we have to do a few more steps. The first thing we have to install is PyTorch. So what you do is you go to PyTorch locally. So you can Google PyTorch locally, and that will allow us to download this. So here we are using pip, Windows, Python, and then CUDA 11.8. If you remember, we installed 11.8. So we are going to copy this command, and we will go to our code. Here you can see we have some errors. That's fine, no problem. Just go to the terminal and we will press Ctrl C. It will exit the software, and then we will make sure that we are in the virtual environment. Okay, make sure we are in virtual environment and we are here in our Face Fusion. So what we will do is we will simply paste, and we will hit enter. So what it will say is that PyTorch has already been installed and it is not really installing something new. If that is the case, then what you can do is you can go to File, Settings, and you can go to Projects, Python Interpreter, and over here you will see we have Torch and Torch Vision. These are the CPU versions. You can uninstall them by clicking here, uninstall, and then you can install this again. So this will allow you to run it again and install it again if it says that all the requirements are already satisfied. But right now it didn't say that. So it is recognizing this as a different version. So that's why it's installing this. So let's wait for it to finish and then we'll come back. Now to install the GPU version, first of all, we need to uninstall the CPU version. So we have to write pip uninstall torch and torch vision. So that's pretty much it. Install spellings are wrong. Install. There you go. So first it will uninstall, and once that is done, then we can go ahead and paste our new command for the GPU. So what this will allow us to do is to run the GPU version of PyTorch. So now the installation of PyTorch is complete for the GPU version. The only thing we need now is the ONX GPU. So we will write here, if you go to the requirements, you will see we had ONX runtime, but what we need is ONX runtime dash GPU, and yeah, we will write pip install GPU. So now it's downloading, and once it installs, then we should be able to run our GPU as well with Face Fusion. And there we have it. Now the installations are complete, and all we have to do is we have to go to our Face Fusion, right click, open in terminal, and we simply have to write python run.py. So while that is downloading, I will just show you what happens once it downloads and installs everything. So once both of these things are done, you can simply go to the terminal. So here I have a different project where I have installed everything the way I have explained. So you can right click, open in terminal. Now everything is running with the GPU. So all you have to do is you have to write python run.py, and that should start with the GPU. So here you can see we have the link. We will click on it and that will bring us to our face fusion. So it is pretty much the same, and you can see we have the face swapper, face enhancer. We can select that as well. But the main difference here is that we now have CUDA. So CUDA is for our GPU, NVIDIA's GPU that we can use. So now what we can do is we can simply use our face swapper with GPU. So if I bring in my source, and let's say I bring in the Will Smith video, then I can move around and we can find the reference face and see how well it performs. So it is detecting or not. Yeah, it is detecting this, and it is quite blur at this point because the video itself is quite blur. You can see it's actually swapping, and because it's not a good quality video, it's not very clear. So let's change that. Let's change it to the movie trailer that we did earlier. So if we move around the frames, you will be able to see how fast now it responds. So here you can see it responds really fast. Here it's weird, but it still works. And when it's in a lot of frames, it's not very clear. Even if it's not very clear, it will still look like it's you. So then you can simply press start, and this will start the processing. And if you go back to your project, it will give you the estimated time of how long it will take. So here you can see it's saying that it has taken 10 seconds and it will take another 4 to 5 seconds to complete this task. So I would say around 20 seconds to complete one of these. This one was for the face swapping, and then it will do the enhancing. So we had selected two of these. So it will swap the face first and then it will enhance it. So that's the main idea. So this is for swapping, and now this is enhancing. So again, if I'm using a GPU, you can see here it's CUDA. That's why it's running really fast. If I were to use a CPU, this will take maybe 10 times longer than this. But if you don't have the option, of course, you can just do that. And if we play this, so if we play this, there you go. You can see it's not bad at all. There you go. So that's the main idea behind this project. So you can play around with different swappers, different enhancer models, and you can select different faces, and you can do lots of different things with this. That's why I have shown you this, because it's so much fun to play around with. And once you start playing around with this, it can get a little bit harder to do something else. It's so much fun to actually play around with these. So when we create an app, we actually have two different components in that. The first one is the front end and the second one is the back end. The front end is what the user is seeing, is what the user is interfacing with, and the back end is all the heavy lifting or the coding that the programmer has done to make it functional. So if you think about the restaurant example, then the back end is the kitchen where you cook the recipe and you have all the secret sauce there. But at the front end, you have a very nice, clean, and cozy environment, which is seen by the user. So this is the difference between front end and back end. So we need both of these things to create a good app. Now, when we are talking about AI, what exactly are we referring to? Are we creating front end or are we creating back end? Now, you could run AI models in front end as well, and you can run it at back end as well. The problem is that if you run AI model in the front end, it's like giving away your secret recipe. So for example, you went to a restaurant to eat a burger, and with the burger, they bring you a receipt and the recipe as well. There you go. Next time you can make it at your home. So that's not how restaurant works, right? So the idea is you will have your kitchen where you will have your secret recipe, and then you will create that recipe, you will create the burger and serve it to the user. The same way, the front end is only for the user to see and interact with, but the actual coding or AI models are stored at the back end. So this is the main important part, that our focus in this course is related to back end, where we are creating the actual recipe for that AI model. But the problem is we need both things to actually run it. We could actually just say, okay, in the command line, write a horse jumping on the grass, and it will generate an image and it will save it in my documents or something like that. So there is no user interface, but the functionality is there. But we don't want that. We want an actual app that I can relate to, I can use, I can share with my company, with my friends, and even on a website. So how can we do this? We can do this using the front end development. Now, front end development is a little bit complicated in a sense that it requires three things for you to understand. So this is the standard way of creating front end apps, which is using HTML, CSS, and JavaScript. Now, this is the standard way. Now, this provides you full customization, but the problem is the learning curve. Because it's three different things, three different languages you have to learn, and then you have to operate them, so it becomes a little bit difficult to handle. But that's not our focus for this course. Our focus is the back end, but we do need the front end. So the answer is using Python. So we can create front end using Python as well. And we have very good two SDKs for that. One of them is Streamlit and the other one is Gradio. Now, both of these can work. For this course, we are going to use Streamlit. There are other apps that we already use like Face Fusion or Focus. They actually use Gradio to run their front end. The idea of this is that we can quickly get up and running with our AI model that is running at the back end, and in the front end, we will have our Python. So that will be very easy for us to create apps and deploy them very quickly as well. So this is the basic idea. We will go ahead and now start with Streamlit, and we will see how exactly can we install it and run it. We will look at how we can create some graphical interfaces with buttons, radio switches, and sliders, and a lot more text, titles, subheaders, progress bars, and all of this good stuff. So let's go ahead and start with that. So now we are going to go ahead and start with the basics of Streamlit. First of all, we are going to create our project and we will call it AI course. And we will hit enter, and there we have our new project. So now in order to run this, we are going to right click and create a new folder. And we are going to create this folder by the name chapter. What is the chapter name is 5. And this will be our GUI graphical interface. So we are going to go ahead and add everything related to the graphics over here. So you can also call this the front end part. Now the idea is that first of all, we have to install our package. So we will go to File and Settings, and in the project AI course Python interpreter, we are going to go ahead and install Streamlit, and we will hit enter, install. So now that the installation is complete, we can right click here and we will go to Python file. We'll create a new Python file and we will call it streamlit_intro. So we will add all the basics of Streamlit over here so that it's easy for us to follow. Now, the first thing is that we are going to add a comment, and we will add the Streamlit, add the Streamlit library to the project. There you go. Okay, then how do you do that? You will simply write import Streamlit as st. The reason we are writing it as st is because whenever you want to call it st dot something, it will be easier than writing the whole thing, which is streamlit dot something, right? So it is a little bit easier if we write st. Okay, so that's the first thing. Very good. Now, the second thing, as the AI is mentioning us, add the title of the app. Okay, so we are going to add a title. To add the title, it's very easy. You write st.title, and you can write, for example, my awesome Streamlit app. So these are the two things that you have to do in order to make sure that everything is working. And I recommend that you do it every time. And the third thing is actually running the app. So here is running the app. And how do you actually do that? you will open the local terminal. Now, the reason it's giving me these suggestions is because I actually tried, wrote all of this before. That's why it's repeating that. But anyways, the idea is that you have to open up your local terminal and then you have to run it. So if my file is in this folder, I need to right click this folder and open it in terminal. And this will give me the virtual environment. Now, what I can do is I can write streamlit run, and then we will write streamlit underscore intro.py. So initially we will write streamlit, then we will write run, and then we will write the name of our file. So in this case, it is streamlit underscore intro.py. And then we will hit enter. This will give us a local and a network address. So we can click on the local and there we have it. My awesome Streamlit app. It's already running, and that is a very good sign that we have started right away and we do not face any errors. That is a blessing as well if you don't face any errors. So let me just write it down here. Open the local terminal and then cd into the directory where the file is located. So this is chapter 5, and run the following command: streamlit run streamlit intro.py. So that's the basic idea. This is the third one. Then we can learn to add a header. So we will write here number 4 is a header. And how exactly do we do that? We simply write st.header, and this is a header. So now the good thing is right now there is no header, right? If I save this and I come back and I refresh this, it will show me this is a header. So I did not have to rerun the app. So it will automatically keep running. So I don't have to do that again and again. So what we can do to check if everything is working, we can put this on one side and we can put our app on the other side. So this way it will be easy for us to see what exactly is happening in our app, and we can minimize this over here. So then we will go to the next part, and our number 5 is adding a subheader. So number 5 is adding a subheader. So st.subheader, this is a subheader. So if I go and refresh this, there you go. This is a subheader. So the idea is that we can have a bigger heading, then a smaller, and then even a smaller. This is the title, then smaller, and then even smaller. So again, this helps in categorizing and writing stuff, making it a bit more elegant, beautiful, stuff like that. Okay, so then the next part is even going smaller than this, which is adding plain text. So you can write simply text and that should be fine. So if we go here and refresh, this is some text. So by default, you should use something like this. So for example, ChatGPT is sending you the reply. You should display it like this most oftenly. So that will be your default text. Then we have Markdown. Now, Markdown is basically the same thing that you can use on GitHub as well. These are some of the parameters that are similar to HTML as well. So let me actually explain a little bit what happens here. The first thing you do when you want to create a Markdown, you can write simply, this is a Markdown, right? Now, if you refresh this, there is not much of a difference here. The only thing is the font style is different. So this is raw. Markdown basically means raw. Everything is raw, and now you can make changes to it, right? So that's the idea. So for example, if you wanted to create a header using a Markdown, you will write 2 of these hash, right? So if I go here and refresh this, this is now a header. Now, I don't want to get too much into the details of this because Markdown is something that is a bit more advanced, I would say. And we are already getting the functionality of header, subheader, and text. So we don't really need this as much. So we are going to skip it a little bit and we will move on to the next one, which is now the fancy one, and that is our button. So how do you add a button? So we can write st.button, and this will create our button. So if we refresh that, there you go, this is a button. And if we click, nothing happens, right? So how do you make it work? That is a different story. But That's how you can create a button. And later on, when we go to our apps, we will see how exactly when we press this, something happens, right? Okay, then we have a radio button. We can have different options. Let's say you wanted different styles, or we have checkbox. We have checkbox first. Okay, so for checkbox, so pretty much everything we are referring to just goes by st dot whatever it is, st dot button, st dot text, st dot header, st dot checkbox. So that's the basic idea. A checkbox, this is a checkbox, and then you can have options based on this checkbox. But how do you actually use it? Again, we will look at that later on, but here you can see we have a checkbox now. Then we have a radio. Let's go to radio, and again we are going to write st dot radio, and then we can have multiple options, because within the radio buttons you should select only one. So you can have multiple options here. If we refresh this, and there you go, option 1, option 2, option 3. So that's the main idea. You can select any of these. Then number 11 is our select box. So it is like a checkbox plus a radio. So then we can simply write st.select box. Then we have, again, we have the option 1, option 2, option 3. So if we run that, there you go. So here we will have 1, 2, and 3. So again, you can select only one, but it's a different layout that you can use. Okay, then we have number 12, we have multi-select. So what exactly is multi-select? It's the same thing, but you will be able to select multiple options rather than just one. So here you can see, let me just make this bigger. There you go. So if we refresh that, by the way, you can see it's responsive as well. This becomes bigger and this becomes smaller when we do that. So it works in terms of responsiveness. The next one is file uploader. Let's go down first. 12 dot file uploader. So this is very useful, and we'll be using this a lot because we will be uploading different file types like images, like audio files and stuff like that. So we need to have an option of uploading. So if we go back and refresh, there is our file uploader. If I click on it, it will take me to this folder, the default picker for our files, and we will be able to pick files. For example, if I click on this, it will load this file, and I can press close and it will close the file, and so on. So it is very useful. And of course you can define the types, what type of things you want to add and what type of things you want to avoid, because here right now it's just saying limit is 200 MB per file, but it's not mentioning what type of files do we add. So here you can write type, for example, PNG and JPG. And if I refresh this, now it will tell us that only PNG, JPG, JPEG are allowed, and it will show only those that can be selected. So that's the basic idea of our uploader. Then we have a color picker. Number 13 is color picker, and we write st color picker. We refresh this, and there you go. You can select the color that you want. You can move it around, and that's pretty good. And then we have number 14 is a date input. So all of these things that we are learning right now, I want to give you the flavor of them rather than actually using them in an app. So because right now you can see creating something like this from scratch will be very difficult, but right now you already have this functionality that you can pick a date, and we can simply get the date from this value and do some processing on it. So it makes this very easy for us to use. Then we also have time input. So let's run that, time underscore input, and there you go. You can select different times, and of course you can give the increment level as well. Right now it's 15 minutes, so you can change that based on your requirement. Then we also have text input. So this is very useful because later on, pretty much every other case, we might have to use this text input, and then we ask the user to input the text. So if we go here, you can write something here, whatever you want to write. So that's the basic idea. And you can also have a default value for this. You can write here, enter your name. And if you refresh that, there you go, enter your name, and then when you write it, it will have that. By the way, this is the value. You can also have placeholder. Placeholder will give you that option. There you go, enter your name. There you go. So that's the basic idea. And then we have number 17. Then at number 17, we are going to look at number input. So what if we only wanted numbers? So we have a minimum and a maximum value, and we have a default value. So if we save that, this is what we get. So we can add and reduce based on these buttons. And then of course we can write whatever value we want here. Now you cannot write 200 because it will give you an error that it should be less than that. So you can write, for example, 50, and it will accept it. So that's very good. And then we also have the option of text area. Now this is something that you should be able to edit later on as well. So for example, if ChatGPT or any other model generates some data for us and we paste it in a text area, then we can edit that text as well. So this will be text area and st text area, and we refresh this, and there you go. So you can type in here, you can increase the size of this as well if it becomes bigger, so it will accommodate for that as well. Okay, that was 18. Then what do we have? The slider. This is one of my favorite ones. Sliders. 19 is sliders. So st.slider, you have a minimum value, maximum value, and the actual value it starts with. So let's run that, and there you go. So you can move it around. You can disable it as well. You can give different increment values as well. So that is up to you. Then we have something which is very useful, and that is our progress bar. So it's always good to know when something is loading, how much of the progress is done, because we as humans, we are very impatient. So we want to look at what exactly is happening. So we will, to simulate the progress bar, we will import time, and then we will create a progress bar by simply writing st.progressBar is 0, and then we will give it a small delay, very small delay, time.sleep, or actually, yeah, let's use this for percentage complete in range 100, sleep 0.1. So it will stop for 100 milliseconds, and then it will update the progress bar 1% each time. So let's run that, refresh, and there you go. So now you can see the progress bar going, and that actually looks good, and you feel confident that something is happening at the back end, something is working, so we should be good to go. So that's the idea of our progress bar. And do we have anything else? Yeah, we have a spinner. A spinner is also when you don't really know how much time is left, you can add a spinner. So you can write with st.spinner waiting, and then you give it a time, how much it needs to wait. For example, we will give 2, and if we refresh this, so it will first finish this, and then it will go to this part. So let's wait for it. I should have stopped the previous one, but there you go. So here it says waiting, and then it's done. So when you are running processes, you can use that within this so that the user can be notified that what exactly is happening. So let's remove these two because they will keep interrupting. So the next thing is adding columns. So now, right now, whatever we have done is in a single line. So what we want to do is we want to split it into 2 columns. So what we can do is we can write here columns, adding columns. To add this, it's very simple. All you have to do is you have to write column 1, column 2, and then st.columns, and how many columns do you want. So if it was 3, then you would put another one here, column 3, something like that. So for now, we will do it with 2. So let's do that. But if we do that, nothing actually happens because you need to put something in these columns using the with example. So nothing will happen right now because we didn't add anything to it. So we can write with column 1, we will write column 1 and some text in column 1, and then with column 2 we are going to again add some other text. So if we run this now, there you go. This is column 1 and this is column 2, and that is an epic fail because it didn't work. So if we move it, it will work. So you have to be patient. So it actually works. So you can see it's 2 columns, and yeah, that's the basic idea. That's how you can use this. Do we have anything else? Okay, let's do one more. We are going to add image from file uploader and display it. There you go. So here we first of all we will need PIL, which is the library for dealing with images, Python imaging library. So in order to do this, we can simply write st.fileuploader, and we were uploading a file before and it was a image file, and then we will store the image in that image equals this, and then we are going to display our image. So we will write here st.image, and we will give in our image, and then we will give in the caption and the column width and all that, so the parameters. So here it will give us an error because there is no file. So what we can do is we can write here if image then display. Otherwise, don't try to display because it will give us an error. So we can do that. And if we refresh, now it will not give us an error. When we upload an image, let's say we upload this image, and there you go. So the image is displayed. So that's how you can display the image using Streamlit. So I believe this should be good enough for us to get started with our web apps. So congratulations on learning the basics. Now we will go ahead and build some apps. So now we are going to go ahead and start with our coding basics. So we will go ahead and right click on our folder, and so we will go ahead and right click and we will create a new directory, and here we are going to write chapter 6, which is code basics. So what we will do is we will create a new folder within this, and we will call it, let's say, installations, because there's always more installations. So here we are going to bring in all the requirements and the instructions. So let me just paste them here. By the way, if you haven't downloaded the code, you can get it free from our website. Just make sure you register and you can download the code. So there you go. We have our installations. First of all, we have the instructions. Let's open that up. So you do have to install PyTorch for CPU. So that will be Torch. If you want to do for GPU, then you will have to install PyTorch locally. And for example, this is the example of 11.8, CUDA 11.8. Now, if you haven't seen the installations that we did for GPU earlier, you should go ahead and check that out. And if you have done one of the projects that we did earlier, which was including PyTorch, we installed PyTorch, but that was for that particular project, and that was for that particular virtual environment. So this new environment will need the PyTorch installation again. So that's why if you want to do CPU, just install Torch. You can simply go to File, Settings, and in the Python interpreter, you can add, and here you can write Torch. And this will give you the package. So you can write here Torch, and that will give you the package. And you can simply hit Install Package. That is pretty much it. Otherwise, you can download the latest one for the GPU by typing PyTorch local in your browser. So here you go. I have written PyTorch locally, and we will click on that, and let's go to start locally, and there you have stable Windows pip Python CUDA 11.8, and then we will copy this command. So once we copy it, we are going to go ahead and go to our terminal, and we will make sure we are in the virtual environment. make sure you are in virtual environment, and then you can simply paste and run. So what this will do is it will download the GPU version. Now I already did that in the previous projects. So that's why it has cached that version, and it is using that directly to install. So this should not take long, and it says it's already satisfied, and now it's collecting everything, and then it will start with the installation. Now, once that is done, we do have to install the remaining things to our Python project. So the thing is, earlier we installed a few things, but they were globally, for example, CUDA and cuDNN, all of that, the drivers, they were globally installed. But now we are talking about this specific project, which is called AI course. So whatever is installed now will be installed within this project. As soon as you create a new PyCharm project or new Python project, it will not have all those installations. That is the beauty of this, because you don't want to mix and match different projects that require different versions. So that's why we have this requirements.txt file. This is a very standard way of installing different packages. Now, what you can do is you can go to File and Settings, and you can add one by one. You can type in the, for example, this is transformers. So you can write transformers, and when it comes, you can click on that and hit install. Then you will go to diffusers, you will check the version number, then pillow, you will check the version number, and so on. Now, the thing is, the better way of doing this is writing all of them in one file and then running the file itself, and it will install everything. So here you can see it's already installed our PyTorch. So now what we can do is we can write this pip install r requirements.txt. This argument basically means that we are giving a requirements file. That's what it means. Now, the important thing to note here is that you cannot just type this in. If I do, nothing will happen because there is nothing to do. Now, what you have to make sure is that you are in this directory and then you are running this command. So you will right click and go to open in terminal. Now you are in the installation directory, chapter 6 installation, and in this folder you have the requirements file. Then you can paste this and hit enter. Now it will start collecting all the packages, and then it will start installing all of these. So now that the installations are complete, what we can do is we can just make sure that everything is running, and especially the GPU is working. So that's why we have a script by the name check torch GPU. Now all this does is that it runs the command CUDA get device name. Now if the GPU is available, it will give you the exact value, how much VRAM do you have, and if it's available or not. So if we right click and run this, and there we have it. So we have NVIDIA GeForce 3080 Ti with 12 GBs of VRAM. And this is CUDA version 11.8. So these are the two things that it tells you. But by the way, the command that we are running at the backend is simply this torch.cuda.getDeviceName. And from that, we are extracting all the information, and then we are displaying. If there was no GPU available, or if the installations were not properly done, then it will print no GPU available. So right now we can make sure, we can assure that we are done with the installations, and now we can simply go ahead and start running our apps. 3 years ago, I found a loophole in YouTube. When I looked for videos teaching how to program drones, I did not find any course that covered the basics along with some projects. So I decided to make my own course and put it on YouTube. Now, to my surprise, it became the most popular drone programming course on YouTube. And with time, it became the top search result on Google as well. Seeing how much people liked the first course, I made a more advanced version of this. This new course taught more up-to-date topics like making drones recognize faces, understanding hand gestures, and following body movements. People from all around the world loved it, and this became my top-selling course on CVZone platform, reaching people in over 80 different countries. Now, you might think that the smart move here would be to make another drone course to earn more money, but I did not want to make a new course just for that reason. So for the next 2 years, I did not make any new drone courses. But now things are changing. With all the new advancements happening in artificial intelligence, I realized it was time for another advanced course dedicated to this topic. So I'm making a brand new course about drone programming with artificial intelligence. This means I will teach you how to make drones smarter, like being able to spot different objects, fly through obstacles, and do real-world tasks, and even fly in groups with other drones. This course will include exciting projects that focus on practical challenges such as navigating through an obstacle course to test precision and control, developing solutions to quickly detect fire in a simulated city environment, employing AI to accurately count the number of cars crossing a road, and programming multiple drones to create a drone show. These projects are designed to provide hands-on experience with real-world applications, enhancing your skills in drone programming and AI technology. Since conceptual learning is becoming more popular in many high schools and universities, these institutes are now adding drone programming into their curriculum. This is done to improve the learning process. This trend has gained so much attention that it has been featured on different news channels. There are even specialized institutes dedicated solely to teaching drone programming. Whether you are learning on your own or you are part of an educational institute, I will teach you everything you need to get started with AI drone programming. There are 3 versions of this course. The first version is the AI Drone Basics. Here you will learn to build your own AI models and deploy them to the drone using the correct programming techniques. The second version, the AI Drone Advanced, takes you deeper into the subject with more complex projects. It focuses on real-world applications and navigating obstacle courses with drones. The third version is the AI Drone Educator. This package comes with a teaching license and written material to support the learning process as well, making it easier to integrate this into any existing curriculum. Each version of this course is tailored to meet different needs and levels of expertise, ensuring that everyone from learners to educational institutes can find the perfect fit for their drone programming education journey. With all the AI courses, you will get the free version of the YouTube drone programming course without any ads. If you are starting from the very basics, we recommend to go for the full pack that includes previous YouTube course and the paid advanced course and the complete AI course at a big discounted price. I'm very thankful to all the backers of my previous Kickstarter campaign, Computer Vision Web Development, that raised $36,000 last year. I hope you will support this campaign to help it come to life. All the packages are offered at a 50% off exclusively for Kickstarter. So if you are interested in this topic of the future, then this is the right time to get on board. If you'd like to support the project without any backing, then please do consider sharing it with your projects to help spread the word. Thank you for your support, and I will see you in the course. So now we are going to go ahead and start learning the basics of our coding so that we can create some amazing AI apps. Now, the first thing we will look at are the online samples. So what exactly can we do with online AI that is accessible using an API call? Which basically what we discussed in online and offline examples. So online is where you will call the restaurant and they will bring you the burger at home. The same thing, we will call our API and it will give us some results. So if we wanted a burger, it will give us a burger. If it wanted a pizza, it will send us a pizza. So how do you call the restaurant and get the stuff? That is what we are going to learn in the online part. In the offline part, we will learn some cooking as well when we go there. So what we will do is we will go and create a new directory, and here we are going to call this online_basics. So here we are going to learn the basics of how we can use the online API. Now the API that we will be using is provided by OpenAI, which is basically ChatGPT. So we will be able to access different models of ChatGPTs, and we will look at which ones are available and how we can use them. Now, in order to do that, we have to first of all create 2 files. The first file will be API key, and the second file is going to be your online_basics. text.py. So in order to run this, we need an API key. So what exactly is the API key? Is the secret code that allows you to connect your program to their center, to their server. So that they can charge you based on what data you have used or how much tokens did you utilize. So in order to do that, you have to go to, of course, you have to register to OpenAI website. And I'm pretty sure you have already done that with ChatGPT. Then instead of going to the chat part, you have to go to the API part. So here the URL is platform.open.ai.com/API keys. So this is the API keys part. And here you will generate a secret API key. And remember, they do not display your secret key after you generate them. So even if I wanted to, I cannot copy this again. So you have to copy it and save it somewhere else. It cannot be generated again. So make sure you know that. Okay, so how can you generate? You will click on create new and you will type in the name of whatever your key is. For example, we will write here AI course and we will create our secret key, and this will allow us to copy this key and then we can paste it in our code. So now we will open up our API key file, and here we are going to simply write a simple function where it will just pass, and if it runs, it will pass this main function. That's it. But the main thing that we do have to add is our API key. So we are going to write here API key equals, and we will pass in a string, and we are going to paste our API key. There you go. So this will allow us to paste our API key, and then we can go back and start working on it. So the reason we are putting it in a different file is because we are going to use this model later on in many different projects. So in every project, we should not copy and paste the file, especially if it's visible. If the string is visible, it should not be that case. So we have a secret API key, it's stored here. Now, whatever code we write, we will write in our online text file. Okay, so what exactly do we start off with? First of all, we are going to import OpenAI. OpenAI framework or library, you want to call it, it will allow us to run our API calls. So we will say from OpenAI import OpenAI, right? So that will allow us to send the commands. Then we will also need our API key. So we will write here from API key import API key. So this is that file called API key. In that we had a string called API. So it will be copied. So once that is done, we also have to import OS. Now, what all of this will do is we are basically trying to link our API key with our OpenAI. So we will add an environment variable that open API key is equals to our existing API key. Now you will see that we could have just copied the whole thing and pasted it here, but that is not an efficient way, and that is a very insecure way to do it. That's why we are adding it one place, then adding it to another, then referring it here so that it is a secure channel, right? Don't worry, we only have to do this once. Once that is done, later on, we don't have to worry about this. So now that this is done, the first thing we have to do is we have to create our client. Now here you can see we have our client equals OpenAI. And then what we can do is we can use this client to send different commands. So how can we do that? So we will write our prompt. So whatever the prompt is. So in this case, we are going to use which is the largest city in the world. Okay, so we want to check that. And how can we get the response from this? We can write client dot. Now we have multiple options. If you are generating an image, it will be different. If you are generating audio, it will be different. If you are generating text, it will be different. Now within text, you have different options. So one of the most useful options is the chat completion. which allows us to talk to the AI as if we are chatting with it, rather than just giving a text and it will complete. For example, sometimes instead of writing like this, which city is the largest in the world, you might have to write the largest city in the world is, and then you give that to the AI, and the AI will complete the rest of the words. So that is another way of calling the AI. But we are not using that because that's not a very intuitive way to do this. So we are going to use the chat completion. So here we will write chat dot completions and dot create, and then we are going to give in our model and all the parameters that we want to give. So here, first of all, we are going to give in the model GPT 3.5 Turbo, and this is the format it accepts. So you have to write messages, role the user is sending this, the content is your actual prompt that you have written here. So that's the basic idea of this. And then when the result is given, we will need the response back like this. So response is equals to this basically. And then what we can do is we can print the response. We can write here print response. There you go. So let's go ahead and run this and see if it works. So online tests, there you go. So there you go, chat completion, blah, 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 choices, finish, stop, index. Now you can see there's a lot of attributes that were given to us. So it's ID, choices, index, message. So if we look at the message, we can see there is a content within the message. And that is giving us the actual value. The largest city in the world by population is Tokyo, Japan. And that's it. And then we have the rest of the parameters. Which model did we use? The fingerprint and blah, blah, blah. Number of tokens and so on. So total number of tokens were 29. So that's the basic idea. Now, you might be wondering, wait, what is this token? And what exactly is the ChatGPT 3.5 Turbo? How did you get that? So in order to understand this, we will go to the ChatGPT website and we are going to look at their models. So we are going to write models, OpenAI in our browser, and that will take us to the models page. There you go. This is the documentation, and here you can see the models. And if we go down, you can see up till now, we have ChatGPT 4 0125 preview. This is the ChatGPT 4 Turbo, which allows 1 to 8,000 tokens, and it is trained up to 2023 December. We have Vision, ChatGPT 4, ChatGPT 32. So we were using the Turbo version, which is here. You can also use this one, which has more updated stuff, I believe. Yeah, it has 6,000 tokens. Now, you might be saying, okay, what exactly is a token? We have discussed this a little bit before, but let me remind you, tokens are basically the numeric way of sending data to your AI model. One word can be and cannot be a token. It depends. So normally 1,000 tokens are roughly equivalent to 750 words. I will repeat, 1,000 words are equivalent to 750 words back and forth. So that's the main idea. So here you can check how many tokens are accepted. The context window is 16,000. It means it can input 16,000, and how much it can output is a different story. So this is the context window. So if we talk about this 128,000, this is almost equivalent to a book, right? So you can completely send in a complete book as an input and get its summary or something like that. And here you can see returns a maximum of 4,096 output tokens, which means again, we have around 3,000, 3,500 words, something in between that. Their pricing is also given if you go to their pricing page, and it will tell you how much does it cost for each of these. So here is the pricing model for ChatGPT 4, 0.01 per 1,000 tokens. This is for the input and this is for the output. Then we have ChatGPT 4, ChatGPT 3.5 Turbo, then Assistance API and all that. So let's look at 3.5. So 3.5 is 0.0005 per 1000 tokens input. So if I were to give in a YouTube video that had 5,000 tokens or 5,000 words, it might be, let's say, 8,000 tokens. And that will be multiplied by, let's say, 5, 6, 7, 8 times, whatever the number is. And then the output token, again, it will be depending on how much can it output. So here you can see it is telling you the input token, but it's not telling you the output. Output is most probably 4,000 tokens as well. So based on your requirement, you can pick which one do you prefer. And these are very cheap. If you are running it for yourself or for a small organization, it doesn't cost a lot. You can actually run it very easily. But if you're providing it as a service, an AI as a service, then it's a different story. Then you might have to cut cost and think about different models. So here we have the 3.5 Turbo. You can basically, if you wanted to change, for example, here we are using 3.5 Turbo. If you wanted to change to the latest one, let's just copy this and we will paste it here. And we will run this. And now it will give us the answer based on this newer version. There you go. So now if you go down here, you can see, where is it? Yeah, there, the model is ChatGPT 4. So that's the basic idea. For testing purposes, I think 3.5 Turbo is really good. It has a very big context window. You can input a lot of text and it gives the answers very fast. Now, that being said, we didn't actually get the answer yet. So we need to get the answer. How exactly can we get that? We need to get the message. So if you remember here, here is the message. And inside the message, we have our content. We need to get this content. So how can we do that? We can write here print message content, and then we can write print. Now, if you look here, this is our response. Inside the response, we have choices, right? These are the choices. Inside the choices, we are picking the first choice, and then we are saying we are picking the message, and of that message, we need the content. Again, it's a little bit lengthy, but you just have to do it once. Once you understand this, it will be all good. So that's the basic idea. And if we run this now, it will give us the direct message rather than giving us the complete response. So the message content is Tokyo, Japan is currently the largest city in the world by population, with over 37 million people living in the metropolitan area. So that's the idea of how you can get text from OpenAI, from ChatGPT, using different models, using different pricing points. And this is basically for chat completion. Now, one thing you might have noticed here, if I were to write, let's say, write an essay on computer vision, right? And then if I hit enter, now it will sleep, right? It's taking too long to respond. No, it's not actually taking too long. It's writing the complete thing, but it's not showing you right away. So what we need to do, you can see it wrote a lot of stuff, but it didn't show us line by line or word by word. It's showing us after it completed the whole thing. So that something is very problematic, because nowadays people are always in a hurry and they don't want to wait for something to happen. If there is nothing moving around, no progress bar, no nothing, they will simply assume that it's hanged and they will close the window. So we will learn how to do that. That is, by the way, called streaming. So when you have text coming word by word, that is called streaming. We will learn how to stream data as well later when we are going to create a module out of this. Now, what exactly is this module? What this will do is, right now, this code is only for this file, online text. But later on, we are going to use this in many different projects. So we don't want to write all of this again and again and again. So we don't want to initialize every time client OpenAI do this, then copy the API key and do this. No, we will write it once and then we will just call one line of code and it will run all of this. So that is modularity. We will learn about that later on as well. But for now, this is how you can run your online text. Now we are going to go ahead and move on to images, and let's see how that works. So now we are going to go ahead and learn how to generate images using our OpenAI, or you can call it ChatGPT. How can we access it online? So earlier we did text. Now we are going to copy and paste, and we are going to write image. Online image basics, that's what we are learning. Now the good thing is that we have already learned how to run OpenAI, and we already know how to create a client. So all of that part is the same. So all of this is the same. We don't need to do anything else. Now after that, we have a prompt. Earlier we wrote a different prompt. Now let's say we write a prompt: a cute cat jumping over a fence, cartoon and colorful. So that's our prompt. That is the image that we want to generate. Okay, now that's good. Now, but right now we are using chat completion within our client to get the data. But that's not what we want now. What we want is now an image. So in order to do that, we can first of all write generating image so that there is some feedback. Okay, we are about to do something. Otherwise, people get very anxious that something has stuck, nothing is happening, and so on. So we will write that. Then we are going to use client.images.generate, and then inside that we will give in all the parameters. Now before we gave in the parameters like the model, the message, and so on, same way we are going to give in all the parameters. So in our case, we will have a model dolly 3, and we will send in the prompt as prompt, and then we have the option of size and the option of number of images. So how many images do you want as the output? So we will keep it as 1, and then we are going to say that this is the response equals this, and that is pretty much it. And then we can simply print the response to see what exactly do we get. Now before we go there, I want to show you these models again. It was in the pricing. There you go. So if you look at the models here, you have ChatGPT 4 Turbo, or do we go down? Yeah, image models. There you go. We have Dolly, and it has standard quality, and then it has resolution of this, and this, and this is how much it will cost you to generate one image. You can use Dolly 2 as well, and it will cost you this much. And then if you use the quality as HD, then you can use this. By the way, you can define the quality as well. You can define the quality in your parameters as well over here, so that it will give you the correct standard. So here, if you look at that, you can write quality equals standard, and that will give you the standard quality. Or if you wanted HD, you can write HD quality. So that's the basic idea. So now let's go ahead and run this and see what exactly are we getting. So right now it's saying generating image. So we know that it has already started to do something. So we are in peace. We will wait for it to finish. And there we have it. So we have the image response. So this is the print of the response. It's not the actual image, right? So here we will look at this revised prompt. So first what it does is it takes this prompt and it revises it so that it can better produce an image. And then after that, it gives you the output as a URL. And if we click on that URL, it will take you to the actual image that it has generated. There you go. So, and it is quite HD, standard HD, and it is quite detailed, looks really good. So how can we access this and actually display it here or save it here? How can we do that? Now, there is a library by the name PIL, which is Python Imaging Library. So we will import that from PIL, import image, and this will allow us to get that image and display it. So how can we do that? First of all, we need to get the response. Now, the problem is that it's already in a URL. So we need to have two more libraries that will allow us to convert that URL to an actual image. Now, don't worry too much about this. These are standard libraries. So we are going to import requests, and we are also going to import from IO import bytes IO. So what we will do is after we get the response, we are going to write image URL is response.data at 0.url. This is pretty much the same thing that we did here, response.choice0 at message content. Instead of message, now we have URL. So that's why we are writing this URL. Now we have the actual URL, we have the data. Now we need to convert it using request. So what we can do is we can simply write image equals request dot get, and then we are going to give in our image URL. Now we need to convert it into a format that will be usable by our PIL library. So that's what we are going to write, that our image equals image open bytes IO image dot content, and then we can simply write image dot show. So that will show us the image. Now we are doing all of this because we want to display the image, but later on when we use Streamlit, we don't have to do all of that. It will be easier to work with. If you are using an image online or offline, it will be a bit easier. So don't worry about that. So let's go ahead and run this. Now it's generating image. We will go ahead and wait. And there you go, the image response. And now we should get the image anytime now. There you go. So as soon as it's done, it opens up that image. So that's the idea. And if you wanted to save it, you can simply write here, save the image to a file. And then you can simply write image.save generated image.png, and that it will save that image. So let's rerun it and see what we do we get. So there we have it. The image has been generated, and let's go back, and there you go. This is the generated image that has been saved as well. So that's the main idea behind creating our own images using OpenAI. So if you wanted to change, you can of course change the prompt here, and it will create a different image. So now we are going to learn how to convert our audio and convert it into text. So that is an option that is also available in the OpenAI framework. So we are going to go ahead and learn how to do that. So in order to do this, we are going to right click and create, or we can just copy the text one, copy and paste. And here we are going to write audio. Now we do need a sample audio. So what I will do is I will create a new directory. Resources is the name that we will add, and I will copy the MP3 file over here. Now this MP3 file will be available to you to download from our website. So make sure you go ahead and download everything one by one so that you understand this. Now, once we have this, the idea is we are again going to use the same principles. We are going to use OpenAI. We are going to use our API key. We are going to initiate our API key. We are going to create the client. And then for the prompt, we are going to actually send in our file, and that will convert the audio into your text. So how can we do that? Let's remove all of this. And once we have our client, the first thing we do is we open our file. So we are going to write here our audio underscore file equals, we will use the open method, and we will go back to spaces. Let me actually show you this. So if we write it like this, we go back one space, it will go back to AI course. Sorry, not here. So we are in this directory, right? So we go back one space, we will go to chapter 6. If we go back another space, we will go to AI course. So once we are in AI course, then we will be able to find resources. You see, it detects that. If it's not detecting it, it means you did not put this correctly. So here we will write resources, and in the resources, we have our test.mp3. So that's the basic idea of how you can open it. And then we can start with writing, transcribing audio so that the person knows, okay, it has started doing something, no need to panic. And then we are going to use the client dot. Now, if you remember, we had chat, we had the image one, now we have for audio. So dot audio dot transcriptions dot create, and then we will give in all the model parameters. So in our case, the audio model is basically Whisper. So that's the name of the audio model that OpenAI provides. So it's called Whisper. We will give in our audio file, and we want the response to be in text format. It can be other formats. So we want in text format. So here we will write response equals this, and then we can simply print the response. So like we have done so far, and let's go ahead and run that. So right now it's transcribing audio. Now it will take a while if it is very long. So you will have to be patient. There you go. In this project, we are going to look at face tracking. So we'll look at how we can make our drone to track a particular object or a face. So this was one of our drone tutorials. By the way, our Kickstarter is online. If you haven't checked it out, make sure to check out the Kickstarter page for the AI drone course, which is the latest one so far. We are embedding drone programming and AI together, and it will be an amazing mix. So yeah, so this is the test.mp3. Let me check if I can play this. In this project, we are going to look at face tracking. So we will look at how we can make our drone to track a particular object or a face. We need two different things. We need yaw and forward and backward. And this red area is where it is too close, and this red area is where it is too far. So both of them, the drone has to move. Let's have a look at the yaw angle. The idea here is that so yeah, as you can see, it works and it is transcribing correctly. So this is how you can use the online version of OpenAI to actually transcribe audio and convert it into text. And as you can see, it's direct text. We did not have to add any dot response dot get dot blah blah blah, nothing like that. We are simply getting the text right away. So now we are going to go ahead and learn how to create an online module so that we don't have to write this code again and again that we studied just yet. So we had image generation, audio, we have a video, not video, text, and all that. So instead of writing or copying this code again and again in different projects, what we will do is we will create a module, we will create a file which we can call and create maybe 10 different projects using the same file. We will just have to give the reference of that file. So we will call this here in chapter 6, we are going to create, not in the online basics, we are going to create it outside so that we can easily access it later on as well. So we will call it online underscore module, and we will create another module for offline later on when we learn about offline. Now we will go one by one and we will generate using Streamlit as well, because we want to see the output. So what we can do is we can simply copy our code and we will convert it into Streamlit, and we will convert it into sections so that it is easily manageable. So the idea is converting it into functions. So we will copy that and we will paste it here in our online module. First of all, it will say the API key is not there. So this is the only time we have to copy this API key. Later on, we will not have to ever copy this. So now the API key is copied and this is ready. So what we have to do now is we have to create sections. So let's say the first thing to create it as a module, we are going to write that if name equals main, then run main. What does this mean? It means that this script can be accessible by other scripts, right? So let's say I'm creating a caption generator, and I can access this online module using this, right? But what if I run this online module? What will happen then? That will run the main function. So we will define a main function, def main, and inside that, for now, we can simply write pass. Don't do anything, just run. Okay. And then what we will do is we are going to generate our audio. We are going to convert our audio to text in this example. So we are doing for audio first, then we will do for image, then we will do for text, because audio is the most simple one. So that's why we are starting with audio. Now, we need to convert it into functions. So as I mentioned before, we need to convert this into functions so that it's easier to manage. Now, one thing you might have noticed in online audio and in online image and in online text, all of them have these 3 lines of code same, right? These 3 lines of code, they are same. You can see. So that is what we will do. We will first put that into a function. Okay, so we will call this function setup underscore open API. And what do we need? The only thing we need is this API key, which is different. So because I'm using right now, the API key is for me, you will use, it will be for you. And for every project, there might be a different API key. So we have to give in a different input key if we are using a different project. So we will put all of this in this function. Now this function will create a client and then it will give us the client back. So return client. Now this is a function, right? Earlier it was just random code. Now it has become a function, a modular function that we can use later on as well. So here we can write open API, and we can write here, let's say setup. Yeah. So this is the open API setup. And then this part here is for audio, right? This whole part is for audio. Now, if let's say I have the client, what do I need to run to get the output? Only this part, right? If I have the audio. So what we will do, we will create a function. We will write here, let me keep the name same because I will forget later on. Generate text from audio, audio underscore open AI. And inside that, we will need our client. We will need the client, and we will also need the audio file, of course. So these are the 2 things that we need. Now what we can do is we can remove this. We can remove all of that. We can remove this part as well. And now we can simply write that our response is basically this. Response is based on the client. We are using the audio file, and then it will give us the output. So here our return value is basically our response. So that's how simple it is. Now it's a modular function, and you can use it later on in different projects as well. So here we can write OpenAI audio to text. That's the idea. And normally these parameters, you should put them as input parameters here. So here you can write model is whisper1, and then response format is text. So by default, they will be whisper1 and response text. But later, if you wanted to change, you can do that. So let me just remove this here. There you go. And then we can simply copy and paste this here. Instead of writing model, the actual name, we will write this. So now whatever you put here will come here. Whatever you put here will come here. So now it's modular and we can access it. So let's see where we can access this. How exactly are we accessing it? Right? So let's go here. When we go into the main, we are going to write a code to run our Streamlit app. So we are going to write import Streamlit as st. So Streamlit basically will allow us to create this title. We are going to first of all add in a title, st.title, and that will be audio transcription using Open API. And then we will add a file, we will upload a file using the file uploader. And in that type, we are going to write MP3 or WAV. So if you remember in our chapter 5 in Streamlit app, we had the file uploader in which we uploaded PNG and JPG. Similarly, now we are saying upload the file and save it in audio file, right? Once we save it, then we can simply send it. Now, in order to send it, we should not send it directly. We should wait for the user to accept, yes, I want to send it. In order to do that, we can create a button, right? So, but we need to check whether they uploaded something or not. So if audio file, this means if there is something in the audio file, then if st.button, let me remove that. Okay, let's put it. So if we press the transcribe button, then it should do something. Let's say we pass for now. We are not doing anything. Now, but before we do that, we didn't actually initialize our Open API key. Okay, so we need to initialize Open AI. So how can we do that? That's very simple. We will simply write client equals setup Open API, and we will send in the API key. That's it. So we will send it here. It will send us the client back. And now this client we can send to our function, which is generate text from audio OpenAI. So here we can simply write generate text from audio, and we will send in the client and the audio file. So once it converts the text, it will return us the response, right? So we can write here that our result, let's say, is this. And then what we can do is we can simply write st.write result, or we can write .text result. So it will output the result for us. But the problem is, let me show you the problem first. So let's run this first. It's almost ready. So we can go to chapter 6, right click, open in terminal, and then we can write Streamlit run, what is the name, online underscore module.py, because we cannot run it directly by clicking this button. So we have to do it this way. There you go, audio transcription using Open API. So we can go ahead and browse the files. So let me actually open this up in the resources so we can get the exact location of that. So when we browse the file, there you go, resources, and then we can click on test.mp3. And then if I click on transcribe, now it's running and we are waiting for it to run. And there you go, we have the output. So all of that is good, but the only thing that is left is that we can add loading bar so that the person knows that, okay, something is happening. It's not just stuck, right? So we can write, and yes, we can also do this, which is basically showing the audio file so that you can play it. So you can write here st.audio, and you can play this audio file before you actually send it. If you want it before, you have to write it outside, but after you press the button, it will send the command and you can play that audio as well. And then we can write here with st spinner transcribing audio. And now what it will do is it will keep rotating until it finishes with the processing. So if I click on it again and I click on test, so if I click on transcribe, you can see it will give me the audio, and then I can play it and move it around, increase and decrease the volume, and I can download playback speed and so on. And there you go, it gave us this. Let me do it again. If we click on this test.mp3 transcribe, and now it's saying transcribing audio. So it is giving you that loading bar, so that the spinner, so that you know something is happening. So this is how we have done it for audio. Now we will do the same thing for images. So we have already set up Open API key. We already have the client. Now we need to do for the image. So we can go here. In order to generate the image, we only need this part, right? So we will copy this part and we will convert that into a module, into a function. So here we will call it generates. Let me check the name again because I don't want to mix that up. By the way, you can write any name. This is what I have written previously. That's why I'm writing it now. Generate underscore image underscore open AI. And inside that, what do we need? Forget about it. Let's not discuss what do we need. It will automatically come to you. What do you need? There you go. We have pasted it and we will remove this. I don't know why it pastes it twice. So now whatever is highlighted is what we need. So that's how simple it is. So we need the client and we need the prompt. That's it. And then the rest of the two things, as I mentioned before, you can make them. Model is dolly and size is this and n is 1. So now we can replace it here with model, size with size, and n with n. So whatever you put here will come here. Whatever you put here will come here. Whatever you put here will come here. And then what we can do is we can simply return the response, but we want to return the image itself. So what we can do is we can do all of this processing and send the data back. So let's copy that and paste it here. And we will need requests and the bytes IO. So we need to add that as well. So if we go to online image, we can copy these three and then we can paste them in our online. So that will work here, and then we can simply return the image. So I believe that should be fine. Now what we can do is we can, so all of this, so this part is common for all three: text, audio, and image. This one is only for audio. So we are going to write audio transcription, and now we are going to do image generation. So image generation, once we have the client, first of all, we will add a title, st.title image generation using open API key. Then what we will do is we are going to get our prompt from the user. So for that, if you go to Streamlit intro, if you remember, we have text input. That is what we are going to use. So here we will write st.text underscore input and enter your prompt, and the value is, let's say, the same that we did earlier. And once we have that text, then we can send it as a prompt. So we can write here prompt equals this. Then we can use our button to actually generate this. So let's copy all of this. We can write if st.button generate image, then with spinner generating image, it will say generate image open API client and prompt. It will send in this prompt, and then it will show us this image in a new Streamlit image. Very good. So that's how simple it is. So let's remove the audio part. Let's remove the audio transcription. By the way, this is control / and it will comment everything. And then let's run this. If we go to our code, there you go, image generation using open API, and a cute cat jumping over a fence, cartoon, colorful. So if we click on generate image, now it's saying generating image. And as soon as it's done, it should send us the image back and it should show us the image. So there we have it. Our image is generated and we can see it's shown here. We can even increase the size of this to see in full screen, and we can click back to go to previous one again. And here we can write anything we want. For example, a kid playing in the park, and let's generate that. So whatever you write here is now basically an app that you have created. So the main idea is that now we can write only this part of code, and we can create multiple apps from anywhere. We don't have to worry about the API key or all of this code. Maybe in the later parts, we will have bigger code that might need to be added to run this. So we don't have to worry about that because it's modular. We can simply write one line of code. All of this is for graphical interface. The rest of this generate image is the only one that will generate the image, and just show us the image. If we only write these two, it will also work. So that's the beauty of this, that it makes it so simple for us to do this. And you will see, especially in the text part, when we are going to do the text with the streaming, then it is a more difficult code rather than just copy pasting this. That's why I have kept the text at the end, so you can see what exactly does that mean. So there you go. We have our image generated. There's a kid playing in the park. Looks pretty good. And yeah, that's the basic idea. So now what we will do is we will create the text part for our module. So right now we have Open API audio to text. Then we have image generation. Now we need to add text generation. Now that is the difficult part, and I will explain why. Now, if we look at the text, as I mentioned before, we can just copy this and paste it and we can be done. But the problem is it will wait for a long time. For example, if we write an essay on computer vision, and then we will have to wait and see what's going on, and we are thinking, oh, what will happen, and then we get stuck, right? It's not very intuitive. Sometimes it might take 20 seconds, 30 seconds, 1 minute, and it will be very frustrating to actually see that happening. So in order to fix that, we will add the method of using streaming function. So we are going to stream our data rather than just generating. So here we will go to Open API text generation. In the online module, this is audio to text, then image generation, and now we will do for the text generation. Now, if we start from the very basic, right? So it should be the same. So if we start from very basic, it should be exactly the same, that we have generate text Open API Streamlit. We have a client and we have a prompt. Very easy, right? So if I go to my text, I can simply copy this part, the response, and I can simply send this back, and I can return the response.choices message.content, and that is it. That's basically done. But it does not have the streaming function. So we need to add the streaming part. So how do we do that? First of all, we need to add a few more variables so that if we wanted to, we could change them. So for example, we have the temperature. We have the maximum number of tokens that should be allowed. So for example, if I'm asking simple questions like which is the biggest country in the world, I should not allow 1000 tokens. It might start writing an essay. So I can say, give the answer in 10 tokens, right? So you can make it simpler. So all of these different parameters we have to add in case someone wants to use it. The main one that we are going to use is basically stream. So for stream, we are going to make it true. Now, it's not as easy as just making it true and it will work. We have to add something else as well. But before we do that, we do need to add the model. We do need to add the prompt. We need the temperature, max tokens, top, and all that. So what we will do is I will copy all of these and I will paste them here. So now you can see, first of all, client, we have prompt, then we have text area placeholder. I will explain later on what that is. For now, let's look at the model, temperature, maximum tokens, top P, frequency penalty, presence penalty, stream, and then HTML. HTML, again, I will explain later as well. Okay, so that's the basic idea, that we are running this, and now the stream is true. Now, in order to run the stream and actually give the responses, instead of getting message.content, we are going to get something else. We are going to get chunks of it. So how does it work? Let me show you. So it works like this. So this is our complete response that we will send at the very end, but we will loop through our chunks. For chunk in response, which we are getting from here, instead of going to the message content, we will go to chunk.choices.delta.content. So the difference of the content, right? Whatever is new, it's generating that part. Then we will add to our complete response complete response dot append. This is basically a list. We are adding the words one by one, chunk by chunk, and then we are using and converting it into a string without any additional spaces. So that's the basic idea, that we are joining it into a string. We are basically, this is a list of words. We don't want a list. We want a paragraph, right? So we need to convert the list into a string. So that's how we are doing that. And then we need to update it, right? We cannot just return it here and keep calling the function again and again. The function is called once. So what do we need to do? We need to update it in a text area, right? So that text area we are going to keep updating. So we will say that if there is a text area available, if the text area is available, if there is something there, then we will write it like this. Text area dot placeholder, that is our placeholder, dot text area, we are going to give it a name, generated text. The value will be the result string, the complete string of words that we have up till now, because it is updating continuously. And then we have a total height. We will skip that for now. Okay, I will explain that later on. So by the way, this needs to be inside this. So it's within the chunks when it's updating. So it needs to be within the loop. So now what we will do is we will go ahead and try it out before we do any changes, because it might get more complicated. So what we will do is we will go ahead and run it first. So far what we have done, we are going to remove this, and here we are going to write text generation, and we will give it a title, and then we will get the prompt from the user, what do you need, and then we will add a button and it will start generating. But we need a placeholder. If you remember, we need a placeholder, text area placeholder. So how can we define that? We can simply define it by creating an empty space. So here after the prompt we will write text area placeholder equals empty Streamlit. So here we will copy this and we will paste it here. So that's the basic idea, and let's see if it works. We don't need to write st.write because it will automatically update in the text area. So let's run that and see if it works. So we need to change this. Write an essay on computer vision. Yeah, why didn't it change? Let's refresh. Let's run it again and see. It is still showing image generation. Okay, what we can do is we can close this, terminate, and we can run it again, terminal, and then we can write Streamlit run online module.py, and yeah, there you go. Now it's updated. Text generation using OpenAI API, and write an essay on computer vision, and when we generate text, there you go. So now it's generating the text one by one. You can see it's going, but then it's not going down, right? So this is a problem. If we go down, we can see, but it's not updating the height of it. So that's why we need an attribute to actually get the height. And it's also giving us an error that it cannot return the response choices message.content. That is true because if you are using stream, if you are using stream equals true, you cannot use message content. You can use delta content. Okay, so we cannot return this. Instead, we don't want to actually return this. What we want to return is the actual complete, the essay or the text. So how can we return that? We will simply write result string at the end, join complete response, just to make sure everything is in one simple string. And then we will simply return this result string. That's it. And one more thing I like to do is I like to show how many words are there, how many, so you can estimate how much did it cost, or you can do other calculations as well. So what I like to do is I like to check how many words are there. So words are basically the length of this string. So if we split it up and then we check the length of this, it will give us the words. And then using our Streamlit text, we can simply write total words generated and basically the number of words. So if we go back now So if we go back now and if we run this time around, it should not give us an error. And at the end, it should give us the total number of words generated. There you go. Total words generated 373. So that's the basic idea. Now, one last thing we have to do is we have to keep updating the height of this so that it keeps going down as it generates, because that will look better, because otherwise we don't know if it's going down or what's going on, right? So in order to do that, we have an auto scroll method that we have to write right after this. So this is our auto scroll. It basically estimates the total lines, and it has given an expected length of that line, and using that average characters per line, it assumes a height, and using that height, it generates a total height. So it is a little it's a little hard coded, I would say, but given that you have 80 characters per line, you will assume this is how many lines we have. Based on the word count, then we can adjust the height. So this is a workaround for this. And here, as I mentioned earlier, we have the option of height, and we can write here total height. So if we go back and run this now, it will update the height as it goes along. There you go. So it keeps going down, as you can see. So now it looks more like ChatGPT, and it actually gives us the good results. One last thing we have to do is, if in some cases, we want an HTML response, an HTML output. For example, write an essay on computer vision and output the essay in HTML format with headings and subheadings and lists, right? So let's say this is the case. If I run this now, if I generate this text, what will happen is that it will actually give me the code, the HTML code, right? I don't want this. I want it to display as an HTML element, not to write the actual code. So how can we do that? We can add a parameter by the name HTML. So here HTML is false. And over here in the text placeholder, we can write that if it's HTML, then don't use text area, use markdown. If you remember, in our Streamlit, we had markdown. Yeah, over here, where we can use HTML code, right? So here, and we will say that unsafe allow HTML. So we will make it true so that it can run HTML code with it, right? So that's the basic idea. And we will write else this is the case. And here in our generation part, we will say HTML is true. So now it should give us the actual HTML. Where is it? So if we refresh this, let's copy this first, refresh it, and we paste it, and we generate text. Now we should have the heading. There you go. Now we have the heading, we have the subheading, we have the paragraph, we have the list, we can even have links, and all of this is generated and given to us in a good format. Now, if we turn that off, if we go down here and where is it? We make it false, then none of this will happen, right? And that's not what we want. In some cases, right? Not in all cases. There you go. So again, it's giving us raw. We don't want that. We want it to be true. Especially, for example, if you were writing a blog, then you don't want to go and check the blog like this. It should be in a proper format. Let it generate first. Generate, and let's paste that. And there you go. So now it's giving us the actual format. So this is very useful, and it will come in very handy when we are creating some projects later on, when we are building some apps. So that's the basic idea of how you can create this online module. And now I can go and access this online module in my apps, and it will make it easy for me to create more apps using all these features. Now, one thing you might want to do when you are actually going to run it is that, first of all, let's close this. When you are done testing, remove this part. Don't remove it, comment it, and then comment all of this. Don't run any of this. So just write pass. So this was only for testing. We are done with testing, and now these functions are ready. We have checked everything is working, and remove this as well because it will conflict later on. So keep it, and then now we can move on to the next part, which is the offline part. So now we are going to learn how to use AI models using your own local machine. So in order to do this, first of all, we have to download the AI model and then use our coding to actually create some apps with that. So how can we do this? First of all, we need to find the models. Now, finding the models is very easy nowadays thanks to Hugging Face, which is kind of like a YouTube of AI models. You can simply go ahead and search for whatever AI model you want, and if it's free and available to download, you will be able to download it here. So you can go to Hugging Face, and this is their interface. You can go to models, and here you are going to find a lot of models that you can use. And the good thing is you can classify them based on their tasks. So whether it is depth estimation, image classification, text to image, image to text, text classification, token classification, text generation. So this is the most common one in natural language processing. We have this text generation. We also have computer vision examples. So these are all the ones related to computer vision, mass generation, image to 3D, and all that. And this is multi-model. So which means that it can do multiple things: text, images, audio, mixture of things. So in order to download this, it's very simple. All you have to do is you have to select any one of these, and you can simply go ahead and go to files, versions, and you can see, first of all, some of them, they might want you to accept their agreement. So for example, if we acknowledge their license, then they will allow you to get the files. So one more thing that you can do is you can find based on different filters. You can find your AI model. So here, for example, we are talking about task. So let's say I wanted text generation task, right? So that will give me all the text generators. And then I want to specify any libraries that it is compatible with. So Hugging Face provides this library transformers that allows us to download these models and use them. So that is what we are going to use later on. So it is good to know that this is compatible with transformers. So if we click on that, then it will show us only the models that will run with transformers. And it's pretty much most of the models, they actually run with transformers. Then you can filter by language. You can filter exactly by license. What kind of license? Maybe you want to use it for commercial use or for research. You can check here which, for example, you want MIT license only. So you will find all these models, and you can see we have a total of 4,000 models that we can use for this specific parameters. So if I remove all the parameters, and if we remove the task parameter as well, then you can see without any filters, we have almost 500,000 models over here. And if we just go to libraries and click on transformers, then and diffusers, it is going to give us pretty much more than half of the models that will be available for us. So using transformers and diffusers, we are going to learn how to create these different models. Diffusers will be for image tasks, and transformers will be for text tasks. And at the back end, these libraries, they basically use PyTorch or TensorFlow. So we will be using PyTorch, and it will be very easy to install and run all of this. So don't worry about that. Now, the main thing again is to check which model do you want. And for example, what we will be doing, for example, for text is we will be using the open source AI models that are available. So for example, one of them is Mixtral, which is very popular nowadays, and the other one is from Facebook, which is Meta. So we will be able to directly download these and use them very easily. Now, before we actually go to the coding part, we need to understand how exactly do these models download and run. So using our library transformers that we discussed earlier, we can simply download these models, but then how do we run them? They have provided the code, transformer library, they have provided code to actually run these. But every AI model has its own specifications, has its own pipeline, which actually works in a different way. For example, as we discussed earlier, any raw data, for example, it's in text, when you send it to an AI model, there is a conversion first. The text is converted into tokens. The tokens are sent to the AI, then the AI converts it back into tokens and then sends the output to the user so that we can understand what is the output. So there's a lot of processing happening at the back end, and it can be quite difficult to understand which model requires which transformation, which conversions, and it can get very messy. So the solution to that is provided by transformers. What they do is they make it very easy for us to automate this process. And they do this by something called the pipelines. So if we go to their documentation, you can see they have this method called pipeline. And using this, it will automatically detect all of the different requirements, the conversions that need to be done at the backend. And all you have to do is you have to provide the model name, it will download it, it will run it, and it will help you find the output very easily. So what we will do is, first of all, but there are some issues with the pipeline as well. When it comes to flexibility, you don't have that much flexibility. So we will be looking at the other side of pipeline as well, where we have more flexibility. For example, when we are talking about text generation, we want to stream the text rather than one continuous output. So when we want to do that, we will not use pipeline, we will use something else. But again, we need to first understand the basics, and then we will go to a little bit more advanced stuff. Now, in order to understand pipeline, we are going to get the example of text classification because it's very simple and very easy. So we will take the example of that, and using this, we will download everything, run it, and see how the pipeline works. So here in our project, we are going to go to our chapter 8, and then we are going to open up a new directory, and we are going to call it offline basics. So first of all, we will create a new file and we will call it pipeline example text, or let's say text example. So here we are going to look at how we can classify our text. So the first thing we have to do is we have to import our transformers library. Now we have done this part in the installations. So if you go to installation in the requirements, you will see there is a transformers library. So we should already have the transformers and the diffusers library. So we should be simply able to write from transformers import pipeline. So that is what we will write. Now, if you did not have this, you can of course go to file, settings, and in the Python interpreter, you can add and you can write transformers. And here you can find that library and you can hit install to install that. So that's the idea of loading. And then what we have to do is once we import our pipeline, we need to download our model. So downloading is a little bit tricky here. I tried to find different ways around this, but some of them they work, some of them they don't work. So I will teach you a little bit weird method of downloading, but it will work every time. So the idea is that we are going to get the default model first. We want to do a text classification. So we will write that our classifier classifier equals pipeline, and then our task is text classification. So we want to classify text, and that's pretty much it. That's only that's only what you have to write. And now what you can do is you can say that classifier, and we will give in the text, you are the best. Let's remove the get lost for now. Let's just keep it professional. Okay, so this is the text that we are giving in, and we want it to classify. So we will write here print, and we want to classify you are the best. Okay, now the question you will ask, wait, you are just saying text classification, this is the task, but where is the model? Where did it download? How are you getting it? So all of the answers, they are basically here. If you write it like this, pipeline text classification, that will give you a default model, right? Each one of these, what do you call, tasks has a default model. So for example, there are a lot of different tasks. So if you go to task summary, it will give you the list of tasks. So you have audio classification. You can write audio classification like this. Then you have automatic speech recognition. Then you have image classification and object detection. So each one of these has one particular default model. So for now, it will download that default model. Later on, I will show you how you can specify that, how you can download your own specific model. So if we run this now, the first time it runs, it is going to download. So here it says no model was supplied. So default was this. So what we can do is, and it also gives us the link to that model. We can click on that and it will take us to that model. So this is the model, and you can see all the description, developed by, model type, and how to run it as well. Now, this is a good thing whenever you are using a new model and you're not sure how to use it, you can simply click on use in transformers. If you click on that, it will tell you two different ways to do this. You can use it using pipeline, the high level architecture, you can say, from transformers import pipeline, and pipeline is this, and that's pretty much it. And then the other way that we will look at later on is the direct method, which is using auto tokenizer and auto model for sequence classification. So we will look at that later on. Even this is just 2 lines of code. It's not very complicated. The one we are doing right now is the pipeline. So if we go back, now it has downloaded that model. The model was, how big was the model? It was 268 MBs. It downloaded that, and now it is label positive. Score is almost 100%. It is sure that it is positive. Now, if I wanted to check more of these, I can write, for example, here, get lost is one of the, let's say these are comments that somebody put on a YouTube video, right? So next time I run it, it will not take as long and it will give me the answer. The first label is positive, the second label is negative, and it is almost 100% sure that that is a negative sentiment. So this is how easy it is to download and run this. But the question is, look at this problem. If I go and create a new project and I copy this code and paste it there, then it will start the download again for this model. But why does that happen? Because this model currently is placed in the cache. So what we can do is we can take that model out of cache and we can place it in our own directory. And whenever we want to create a new project, we can refer to that directory, right? Because cache you might clean later on, so it might be problematic. Or you might want to directly download from Hugging Face and then you want to run it. Then how can you do that? You can do that by defining the model parameter here. So here you can write model, and then you can give the name of that model. So right now, if you go here, you can copy this part. They have given this button specifically for this purpose. You can click on this, it will copy, and you can simply go and paste it here. Of course, in a string, not like this. There you go. So it needs to be in a string. So if you do this, then it will get this specific model, this specific model. Let's say we go to text classification and we pick another model, right? So let's say this is the model we pick, and we copy that and we come here and we paste it. So there you go. We paste it. Now, if I run download, if I run it again, it will now start downloading that model again. Okay. So there you go. It's 541 MBs. So now it's downloading that. So we don't want to download it for now, but that's another way to download a specific model you want to download. Okay. I hope that one is clear. If it's not, rewind, check it again, and try to understand before you go any further. Okay. So now this is the second type. First type was you are getting the default model. You don't care about which model it is. The second was you define the specific model by the name of the Hugging Face model. The third type is you get it from your local directory. You don't give the name, you give the path to that model. How can you do that? That's the most important one. So instead of giving default model, what we will write here, we will write here model underscore path equals our path. Okay, forget about what the path is right now. So in order to get the path, first of all, we need to get the model. So where exactly is this model stored? So if you go to your C, and then over here you go to users, you select the current user you are at, then you select cache, and then over here you have Hugging Face, then hub, and then there are your models. So these are the temporary files. So the ones that we stopped actually, so it was downloading and it stopped, but the one that downloaded was this one. So this one we canceled halfway, so we can delete these. This is the model that we have downloaded properly. So you can see here, these are the files, and this is the model.safe tensors, which is 261 MB. So now what do we do? How can we copy this? We copy this folder directly from here, and then in our course, we go and create a new directory and we call it models. Now it's up to you, where do you want to save them? If you have a different directory, for example, if you want to do it in D or C or F, M, G, H, whatever, you can go ahead and do that. I like to do it here because it's easier to explain. If you wanted to do in a different folder, you can do that. So I will open this in Explorer and I will go and paste the model. So now the model is here. Now, how do you refer it? To refer it, what you can do is you can simply go to models, and here you can see this is our model. You will not copy this path. You will copy the path of snapshots. Inside that, you have this weird folder name. Unfortunately, you have to copy this. So we will right click and copy path reference, and then path from current content root. Now, if you were to use from, let's say, a different project, then you can do absolute path as well, and you can paste it there. But when you do absolute path, then it gives you the slashes in the wrong direction. Then you have to put it like this, and you have to change for all of them. So that's why I don't prefer this. So right click, copy, and path from current root, and then we simply paste it. So it's a long URL. I like to press enter right before the snapshots, so it becomes 2 lines. So now this is our model file. But remember one thing, we are in pipeline text example, right? So where is this folder in reference to this? It's not at this point. So we need to go back 2 spaces or 2 folders. So if we go back 1 folder, we will go to installation, not installation, code. And if we go back 1 folder, we will go to AI course. So that's what we need to do. Go back 2 times, and that's it. Now I can give the model path over here as it is, and it should do the same exact thing. So if we run it, now it will not show anything regarding loading or anything, and there you go. So here it says label positive, score is this, label negative, score is this. So this is how you can download a model and you can store it in your local directory. You can refer to it through your local directory, and then you can run the pipeline. So that's the basic idea of running text sentiment analysis. So now we are going to go ahead and learn how we can use the text generation offline. So there are many models that are available for free for you to download and run the inference on your local PC. So which one do you pick? Now, the idea is that if you pick a very small one, for example, we can write here GPT-2, and that will be a very small model. For example, it is, if you go to files and versions, you will see it's around 500 MBs. But the result and the quality of the content you will get will not be very good. So it will be fast. You might be able to run it very fast, but the quality of the content will not be great. But still, you can see there's around 17 million downloads last month for this model. Anyways, so if you wanted to pick, you have to pick the right balance between accuracy and the size. Now, if you want to run without any quantization, without any reduction, we are going to try out the example of Mistral. Mistral is a company that provides their models for free. These are large language models, and they are quite capable, similar to what you will find in ChatGPT 3, 3.5, or even 4. So there are lots of comparison, and these comparisons, they keep changing. So I don't want to show you different comparisons of currently what's going on right now, but they will keep changing, and sometimes one will be better than the other, but you want to get overall idea of how to use them. Now, the other one that is very famous is the Llama model, which is provided by Facebook. They have this ideology of making it open source, and I highly appreciate that, and that is something that more companies should look towards. So they are training large models, and they're providing it for free. So they have a 70 billion parameter, they have 7 billion parameter, 3 billion, and so on. So you can actually download those models based on your requirements, and you can run those. So the one we will be using without any quantization, without any reduction, will be Mistral. And the one we will be using with reduction, so that you can easily run with your local GPU, will be our Llama model. The one that we did earlier in our no code example. So we will download the same one and run it and see how it responds. So in order to run this, all you have to do is you have to go to transformers, and here you can see this is the code to actually run this. Now, again, you will first download it, and then you are going to run it. Now, to download this, you will simply write this line of code, or you can even write this, and it should download the model for you. And once you download, you are going to copy and paste it in your directory so you can run it easily. So once we go to our course, we are going to right click and create a new file, and we are going to call it offline_text. So this will be our file that we will be using. The first thing we will be needing is our transformers library, and we need the auto tokenizer and the auto model for casual LM models. So these are the two things that we will be needing. So you might be asking, earlier we were using pipeline. What is the difference between this and this? Now, as I mentioned earlier, when you are converting your raw text into tokens, then these tokens are sent to AI model, then the AI model converts them back to tokens, and the tokens are converted back to text. So that's the whole process. So in order to automate that process, every tokenizer will be different for different models. So we don't know which one to use. So we can use auto tokenizer. Based on the model it gets, it will automatically find which one to use, and it will use it for us. So it makes it very easy for us to do. The big difference between pipeline and this method is that pipeline is very high level. You don't have a lot of customization. This auto tokenizer, it will give you some form of customization that we will look into, which will be useful for us. And the reason we are doing this is so that we can use the streaming function later on, so that instead of giving the answer at the very end, it will give word by word, and it will generate like ChatGPT. So that's very useful. Okay, so how do you download? You will go here and you will copy the code, and you will simply paste it. And what you can do is we will be using the torch version. So here we can define which version to download. So here we can say we want the, okay, so here we will have torch float 16. We will be using that version, and here we can also write imports torch. So let me bring that down because it's not visible at this point. So there you go. And then to make sure it goes to the GPU, we will define our GPU, right? So what we will do is we are going to simply write device equals CUDA if torch.CUDA is available, else CPU. So we have a variable called device and we will store that. And once we create the model, we will write .to and we will give it to the device. So if it's CPU, it will go to CPU. If it's GPU, it will go to CUDA. By the way, with CPU, it's not going to run very well. So make sure you have a GPU if you're trying this. If you have only a CPU, then you might want to try the next part, which is faster text generation using the quantized methods. So then we are going to add our prompt. What is the prompt? Which is the largest country in the world? So that's the basic idea. That is the question we will be asking our model. And then you have to give in the message and the role. So the messages will be that the role is user, and the content will be our prompt that we are sending in. That's the basic idea. And now what we can do is we can convert it into tokens, and then we can send it to our AI model. So we will convert that encoded input. So we will use the tokenizer to convert for chat completion. We will use our messages to convert them into tokens. And we want to return PT is the format for a PyTorch. So that's what we want to return as. And then what we will do is we will add it to the device. So we will encode the tokens and then we will add it to our device, which is CUDA in our case. And once all of that is done, then we can run the inference. So in order to run the inference, you simply write output model. So this is the model dot generate. Now in here, we can add a lot of more parameters. Maximum tokens, for example, we want 100, don't exceed more than 100, do sample is true, top P, top K, temperature, pad token, and all of that good stuff, you can add it here. Okay, so once you generate all of this with customization, then you can simply output your result, print tokenizer dot decode, and then that will give you the output. And you want to skip the special tokens because we want raw answer. We don't want any special characters here and there that the AI uses. So that's the basic idea. Now, the thing is, if you run it like this, it will download the model first, right? Then once you download it, you have to go to your cache like we mentioned earlier. So this will be your cache in user cache Hugging Face hub, and it will give you this file, this folder. You will copy this folder and you will paste in your models. So this will be your models, and you can see this is our file. And then we can go to snapshot and folder and right click and copy path from the content root. And here, instead of downloading it or getting it from the cache, we can write here model underscore path equals our model path. There you go. And as I mentioned before, right now we are in offline basics. We need to go back to the parent folder, which is code basics, and then go back again, which is AI course. So we will go back twice. And from there, we can go to models, and then inside models, this, then this, then this, and so on. And then instead of giving the name here, we are going to give in our model path. There you go. So that's the basic idea of how you can run this. Now, the thing is, the reason I'm writing all of this code and not running one by one is because it is going to take a long time to go to the GPU. The model itself is 15 GB. it will take some time to go to the GPU, and from there it will start running the inferences. So it will take around, maybe in my case, it will take about 15 to 20 minutes just to load the model. It might take less for you, it might take more. Now, in order to avoid this, what we can do is we can put it in a Streamlit application, and then we can load the model once, and then we can keep running the inference again and again. So it will cache that model and it will keep running. So that's the better way to do this, because if we run this now, it will load the model, it will take 20 minutes, and then it will give you the answer, and next time you will have to repeat that again. So only for testing, that's why I've written all the code, and we will run it only once. Once everything works, later on when we convert this into a module, I will show you how to cache it and then how to run the inference again and again. But I would recommend you use the other version, the faster version, if you don't have a lot of GPU space. Anyways, so moving on, what we can do is we can simply run this and it should give us the output, which is the largest country in the world. So let's go ahead and run this. And by the way, it will not stream it. It will give you the direct answer once it has the complete answer. How to stream it? Again, we are going to look it in more detail when we do the offline module. So right now it's going to load the checkpoints or the shards. What are shards? These are the file. These are the weights of your model. So they split it up into different shards so that it's not one big file. So you can download them separately, you can load them separately, so it becomes easier to do that. And we have 3 of these here. So each of them is 5 GBs. So it will load those, and once it's loaded, then we will come back and we will continue and we will see the response. What do we get? So now we can see we have the result. It took about 30 minutes to actually load the model, and then a few seconds to give the answer, which is the largest country in the world. The largest country in the world by total area is Russia, with a total area of approximately 17 million square kilometers, blah blah blah, and that's the answer. So as you can see, it takes a long time. It will take around 30 minutes just to load it and then run it. But later on, I will show you how to load it only once and keep repeating the questions again and again. So you can ask different questions after that. So that is for our offline text. Next, we are going to look at how we can do this faster. So now we are going to go ahead and learn how we can run our text generation faster on our local hardware, our local GPU. So the idea is that we are going to use the quantized version of our models that will allow us to run the inference faster. Now, I have explained this earlier in the no-code examples where we did text generation. So we will use the same concept. In fact, we are going to use the same model as well that we ran on our PC before. So this is the Block Llama 2 7B GGUF. GGUF is the newer quantized version that we are going to use. It's a file format that is using quantization. So here you can see we have different models that we can download and use. So we are going to learn how exactly can we use this. If we go down, you will see that if you want to install, you have to first install C transformers. Now, the thing is, earlier we were using transformers. Now we have to use C transformers. I know there's a lot of installations that we have to do, but this we have already done in our installations. If you look at the requirements, we have already done C transformers using the CUDA parameter. So make sure you have added that, otherwise it will not work with GPU. And then you also have the option here with the GPU acceleration or with GPU acceleration for Mac OS systems. So you have other options that how you can do if you are using a different system. And then in order to run this, all you have to do is write these 3 lines of code, and that's pretty much it. So let's go ahead and try that out. The first thing we will do is we are going to right click in offline basics, and we are going to write offline _text _ faster. So This is text generation, but faster. So we will use C transformers. We are going to import our auto model for casual LLM. The good thing is these are different libraries, but they have the same convention and the same naming, so we can use them easily. Then what we have to do is we have to set up our LLM model. So again, we will use auto model for casual LLM from pre-trained. This is the name of that, what do you call, model. So if you go there, this is the name of this model, Llama 2 7B GGUF. But within that, we have multiple versions. So we are going to use this version, for instance, when we are running this. And then we have the model type. This is the model type Llama, and we have the number of GPU layers. Now, if you run this and we can write, for example, we can write for the inference as well. If you want to run the inference, you simply write, what happened there? Yeah, if you want to run the inference, you write prompt, which is the largest country in the world, the same question we asked earlier. And then we will write question, and then the prompt, and then the answer. Because this LLM model, basically, it will give you text completion. So for example, if you write AI is going to, then it will complete take over the world, you know. So that's the basic idea. In order to get a question and answer type of scenario, you have to write it like this. So question, then prompt, and the answer, and then it will give you the answer. Now, if you run this for the first time, again, it is going to download this model and it will save it in the cache. But we have already done that. So probably you didn't do it. So you have to run this. You can see it's fetching the files. Once you do this, it will download it in the hub, in the cache, which is in local C, user, cache, Hugging Face hub. And what I will do is I will copy this, the block llama, and I will paste it in over here. So as you can see, it's already done. I have pasted it here. And now we can give the path to this. So we can write here model underscore path, and we can remove all of that. And in between, we have to go into snapshots, and this is the folder. We will right click and we are going to copy and path from content root, and then we are going to paste it here. And here we are going to enter right before the snapshots. Okay, so that is pretty good. And then we will simply give in the model path. There you go. And we are good to go. So if we right click and run this now, we should, oh, okay, I forgot something. That's why this is giving us an error. You have to go back. So don't forget that. Because we are in the offline basics, we have to go back to code basics and then go back to AI course. So we are going back the folders. It couldn't find the file. That's why it was saying that. So right now, if we open up our GPU performance, Control Shift Escape, you have to press, and right away you can see there is a bump on the GPU. It's trying to load the model, and there you go. Now you have the answer. So do you see the difference of how fast this is? So here it's giving the answer Russia, but then it starts asking question again, and it keeps repeating it because it doesn't know when to stop. So if you had something like this and you had a question and answer scenario, what you can do is you can give in the value of stop, and you can give in that stop if it's a new line, or if it's a question, or it's a queue in the answer, then stop. Don't go any further, right? So you can do that. Am I missing another bracket? Yes. So let's rerun this. Not the debugging. Let's run the code. And there you go. Again, it is starting to bump up. It went down again. Why did it go down? Oh, it gave the answer. That's so quick. That's why now we are getting the actual answer, Russia. So that's good. Which is the largest country in the world? It says Russia in the world by population. And if we run that again, and that's China. So you can see the inference is so much faster than before, and we can actually stream this as well. So instead of giving the complete answer, it will give us one by one the answers. So again, that part we are going to look at when we start with our offline module, when we create that offline module so that we can use this code in different projects. So for that, we will move on to the next part. And one more thing, here you have the GPU layers. So depending on how good your GPU is, you can start from a smaller value like 10, and then you can keep bumping it up to check how much can your GPU handle. If it's able to handle without crashing, you can keep increasing the value until it uses the complete layers and gives you a very fast response. By the way, it's already quite fast, especially when we are going to go ahead and create the Streamlit app. You will see how fast the response are. It's very fast compared to a local machine, right? So it will be similar to ChatGPT, hopefully. So for now, we will continue, and we are going to go ahead later on, see how we can create images and audio, and then we will go ahead and create the offline module so we can put all of that in one place like we did in our online module. So now we are going to go ahead and learn how to generate images using our local hardware, our computer. So in order to do this, we are going to go to Hugging Face and we will go to models. And here we are going to find lots of models that do these tasks. They actually generate good images. So if we go to computer vision and we go to image, text to image, this is what we are looking for. We want to enter a prompt and it will give us an output as an image. So some of the most popular ones are listed here. We have Stable Diffusion, we have Stable Diffusion XL, Stable Diffusion XL Turbo, and we have Adapter Face ID, Inset ID. There's a lot of them that are available here. If we go to most liked, then we will find here it's the Stable Diffusion version 1.5 and 1.4, and then we have the XL Base 1.0. If we talk about the best one that we have so far, it's basically the Stable Diffusion. And within Stable Diffusion, we had a lot of versions. So if we click on Stable Diffusion XL 1.0, if we go down, we had Stable Diffusion, then we had Stable Diffusion 1, 1.5, and then after 1.5, we had Stable Diffusion XL. So that is the advanced version. So this is SD, Stable Diffusion. This is SD 2.1. Even after that, you have SDXL, which is better than the previous version. So even though there are more downloads or more likes on the Stable Diffusion 1.5, because it's a little bit more flexible and creative, but the XL provides the best results when it comes to image generation. So here you can see we have around 4 million downloads of these. And there's also a refiner model. So there is a base model, plus there is a refiner model of the SDXL. And what that does is that first you generate the image, then you send it to the refiner, and the refiner refines the image and produces even more high quality images. So that's the basic idea. And what we can do now is we can go ahead and run this on our computer, and it's very simple. They have this library by the name diffusers. Like we had transformers, the same way we have diffusers for the images. So what we will do is we will copy this part and we are simply going to paste it. Or actually, let me go ahead and create a new file first. So offline basics, we are going to right click and create a Python file, offline underscore images. So here what we can do is we can paste this. So from diffusers, import diffusion pipeline. So earlier we had different pipelines that we had to auto find which pipeline are we using. But this time around we are using diffusion because it is pretty much the best one so far. So that's why we are directly moving on to the diffusion pipeline. And we are loading from the pre-trained model. Now again, for the first time when you run it, you will right click and run this, and then it will start the download of this Stable Diffusion files. And what it will do is it will store it in the cache. Here you can see Stable Diffusion XL Base 1.0. So what you will do is you will copy this and then you will paste it in the models over here. So that's what I've done. I have pasted it here, so it's easier for us to work around with. And then we can simply go ahead and use this. Now to use this, first of all, what we will do is we will write the model path. So model underscore path underscore SDXL. equals, we are going to go here inside the snapshots, and this long name we are going to copy and path from content, and there you go. So then before the snapshots, we are going to hit enter. And again, we will go back 2 spaces just to make sure that we are in the right directory. Now, this is something that we have done so many times. That's why I'm not repeating it. So we can simply go ahead and paste it here. So now we have our diffusion pipeline from pre-trained model. And instead of pipeline, this time around, we are going to call it base, because this will be the base model, and we can have a refiner model on top of that. Then we also have low adaptation models known as LoRAs that we can add on top of that. So there's a lot of variations. That's why we will name it base. And later on, when we add stuff to it, we are going to change the names of that. Okay, so we will use the same prompt that we used earlier, a cute cat jumping over a fence. Now we will also give a few parameters here that will be regarding torch. So we will make sure that we are using the torch version, PyTorch version, and it is the F16 variant, and we are using the safe tensor as true. Now, did I explain safe tensor? I forgot actually if I explained tensor or not. Anyways, let's import torch. Safe tensor is basically a file format that does not allow viruses. So called, it is safer than the other method. Which is the other method? When you have weights, you have a checkpoint file. So in that checkpoint file, you can have some viruses, some malwares you can add, and when people download it, it can get installed in their computer. So in order to avoid that, there's a new format by the name safe tensors. So if you use that, it's preferable that you work with that. Okay, so that being said, we do not need to do the device part, and that is fine. And once that is done, we will make sure that it goes to the GPU. So in order to do that, we are going to write base.enable model CPU offload. This will allow it to go to the GPU for the inference. And then simply after we have the prompt, we are going to write image equals base, and we will give in the prompt, we will give the number of inference steps. This is very important. And then we have the guidance scale, and then we have the image, the actual image we will get by writing a 0 here. Okay, so once we have that, we can write image dot show, and that will give us the actual image to display, IMAGE. Okay, so let's save that and let's go ahead and run this. Let me open up the performance, and there you go. The GPU is started to bump up a little bit, and let's see what happens. There you go. Loading pipeline. So if you remember earlier, the pipeline loading time was a lot. Right now, it will take a little bit more than it should, because I'm recording and there's a lot of cameras installed, and there's a lot of background work being done as well. So it will take a little bit slower than it should. And of course, this pipeline components, we are going to load to the GPU one time, and then later we can keep generating images without loading it again and again. And as I mentioned before, I will show you that in the offline module when we create that. So I believe it's almost ready. We should have given a loading part and a generating image part. So there you go, it has started to generate the image. And as we saw earlier, we gave the number of inference steps as 20. So that's why it will use 20 steps to actually run this. And there we have it. Now it has started. And as you can see, it quite fast. When it starts, it generates the image quite fast. And hopefully now it's converting somewhere, and then it will show us the image. And there we have it. So as you can see, it is a very good image. And of course, it's not the best quality. And there is some variation here as well while jumping. But it is quite realistic. And I would say it's better than Dolly, especially when you ask it to do realistic images. It doesn't really provide you realistic images. So I would say that is a good one. Now, what if you wanted to be colorful and cartoonic? So you can write cartoonic and colorful. There you go. So what happened there? Okay, so let's rerun it and see what happens. So again, as I mentioned, while running again and again, it will load the pipeline again and again. So it's not very efficient. But when we do it in Streamlit, it will cache the actual model, and then we will be able to run the inferences quicker than we are able to do it now. So now the inference is complete, and as you can see, this is the image that it was able to generate. It's not as good as the Dolly now, but of course we can add refiners and we can add the LoRa's to actually improve this later on. So I will discuss how exactly can we do that later on. But for now, this is the base, the very basics of running an image or creating an image using your Stable Diffusion model locally on your computer. So now we are going to go ahead and learn how to convert audio to text. So we are going to use the OpenAI Whisper model. They have provided that you can download the Whisper medium, which is fairly good in terms of its accuracy and its size. So the model itself, as you can see, we have a safe tensor model here, which is around 3 GBs. So we can use this to actually run inferences on our local hardware. So there are a lot of details about how you can use this. And then of course, we can use our transformers library to run this. And this time around, what we will do is we'll make it simple, and we will use simply our pipeline module to actually run this. So all you have to do is you have to copy this, and you will go to your offline basics, right click and create a new, and we will write offline underscore audio. So that will create our offline module. And what we can do is we can right click and run this, and this will download the model itself. So once it downloads, it will go to your cache. This will be your cache. And once it is downloaded over here, you will copy that and paste it in your models. So here you can see we have our Whisper medium. So that will be the model that we will be using. So make sure you copy and paste. I'm not repeating again because I've done this so many times now that I think it's a bit redundant by now. Okay, so once we have the transformer, we are going to add our path. So our path will be Whisper. We will open that up, snapshots, and this will be our path. Copy path content, and here we are going to write model underscore path equals, we are going to give in our path, and we will hit enter before snapshots, and we will go back 2 spaces so that we can access it properly. And then in the model path, we are going to give in this as the actual path. So that is good. And then we also can add a chunk length. So this is basically to allow long form transcription so that it can divide it into chunks. And then we also have the option to add the device. So the device, as we did earlier, we are going to say that the device is going to be CUDA. If torch, we will have to import torch. There you go. So if torch is available, it will be CUDA. If it's not, it will be CPU. And then here we can just write device. So that will allow us to run with GPU. Okay, do we have anything else? Not really. So what we can do now is we can simply write that we want to run the inference. So your output is basically pipe, and then within the resources folder, we have test.mp3. So if we go here, so in the resources, we have test.mp3. So that is what we are referring to. And then what do we need? We need the text out of that. So that's the only thing that we need. And that is pretty much it. So if we go ahead and run this, let's look at our GPU stats. So right now it is loading the model. Here you can see, and there you go. It has loaded probably, and that's it. So when it ran the inference, it went back. So here you can see in this project, we are going to look at face tracking. So we will look at how to make drone track a particular object, blah, 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 and all of that till here. So you can see the transcription is actually good. And of course, if you wanted more accuracy, you can go to the large version, or if you wanted more freedom in terms of size, you could go to the smaller version. So it's up to you which model do you want to pick. But this is the basics of how you can convert audio to text using your own local PC. In the next part is the main part where we are going to convert all of this text, audio, images, and put it all in one place, which will be our offline module. And that offline module we will use in pretty much every other project that we will be creating using our Streamlit apps. So let's go ahead and move on to that. So now we are going to go ahead and create our offline module. This will be similar to what we have done in our online module. The only difference is that when we will be running the code, it will be running through our local PC. So here in the online basics, you can see we have all these basic code, and then we created a module out of this, the same way we are going to do for our offline module. So here we are going to right click and we will create a new Python file and we will call it offline module. Now, the reason I'm actually going through the process of creating this module rather than just giving you the code is so that later on, when some other library you are using or some new technology comes in, you have the basics of running these code in modularity. So you can easily adapt to the new code. Otherwise, for me, it's easier to actually write all of this in a single file and then just give it to you and say, okay, refer to that file and copy paste and do stuff like that. But we are going through all the steps so that you understand, and later on, when you have to do it by yourself, you can do it easily. Okay, so that being said, if we go to our online module, you can see we have the imports and then we have the main function and all of that good stuff. So what we will do is we will copy this part, and we will also copy the main. So we have if, and then we have main, and what else do we have? We have all these libraries. The libraries we will copy separately. So we are going to start with audio first because that's the easiest one, similar to what we did earlier in our online module. So we will copy the requirements and we will paste them, and then we will start with our audio part. So I want to keep the conventions same, so that's why I'm copying this. All of this we can copy, and this is in the online module. We will copy that and we are going to paste it in the main, and then in the online module we will go back again, and here in the audio parts, this is OpenAI audio to text. We are simply going to copy this and write it down over here somewhere. So here, instead of OpenAI, we are going to write local audio to text, and you can write in brackets whisper, which is again using OpenAI, but it's not online. That's the difference. So we can push this on the side and we can use our offline audio now. So let's copy all of this code and we will bring it into our function. We will call this generate. No, before we generate, we have to see, that's a good thing. Sometimes you forget, before you generate, you actually have to initialize. Did we initialize this? No, it seems we didn't actually initialize. Let me check here. Yeah, because we do need to initialize first. We didn't initialize because we are setting OpenAI over here. So we need to initialize here. So here we can say load model underscore audio, and we can just drop it here. So here, what do we need? If we look at this, this is the part for loading, and this is the part for running the inference. So we can separate that out, and we can write here generate text from audio local, or you can write whisper if you want. Again, it's up to you which convention you are using. And yeah, that's the basic idea. So now what we will do is we will look at the model path first. So that is what we have to give here. So that should be our input parameter. Let's paste that here. Then the second thing is the chunk length, and we will paste that, and we will give it a default value of 30, and the device is CUDA, or you can select CPU if you want it. So we can remove this part, and we have the device already here, and the chunk size we are going to give it here, and the model path is already there. So we can remove this part, and this will give us the pipeline, or we can call it a model as well, but let's just return the pipe. And over here we are going to write or let's call it model and return the model. And here we have the model and the audio file. So yeah, now the audio file we do have to add. So like we did before, we are going to bring in our audio file. So here st is not available because we are not doing we didn't import Streamlit yet. So we are going to write import Streamlit as st, and then here we are uploading our file. And then once we have the file, we are pressing the transcribe button. Once we press the transcribe button, it will show us the audio, and then it will start spinning the spinner, and it will say transcribing audio, and then it will go to the generate text. So till this point it's fine. So here we will send in our model and the audio file. So that audio file, I believe we can send in directly, or do we have to save it? Oh, we do have to save it. So this here is a link, but what we have here is something else. It's basically the actual file. Now the issue is that it doesn't really understand that. It has to collect it from there. So that's why we have to add a little bit of maneuverability to actually make it compatible. So in order to do that, we can bring in a new function, and we will call it save. We will call it save uploaded audio file. So the idea is that once the file is uploaded, first it is going to go ahead and save it in our local directory, and from there we will get the link and we will run it. So kind of a turnaround, a weird way to do this, but yes, it will work. So what we can do is we can right click and create a new directory, and we can call it, what did we call it? Temporary directory. So here it will check whether it's there or not, and for that we need OS. So we will write import OS. So we will try to create that directory. If it already exists, we will not give an error. That is what this means. Then we are going to join the file name with the path, and then we are going to open and copy it. And that is pretty much it. And then we will return. So then we can go ahead and get the path over here using the logic that we have applied here. Okay, so this loading the model path is done. Once that is done, we can send it back. And here, before we generate now, what we have to do is we have to save the file path. So here, audio file. So when we send in the audio file, it will give us the path of that file, and we can copy that, and then we can paste it here. So that's the basic idea, and the model will be over here, and this will give us the result, and we can return the result. There you go. So, and this is for handling the exceptions. So that's the basic idea. And yeah, so here what we can do now is generate text from audio local, and we will give in the audio file, and we will also give in the model. So we didn't actually define the model because we didn't load the model. So what we will do is we will write here after the title, and before this we are going to write here model. Yeah, we need the model path as well, and then we will need that our model equals load model audio using the model path. Do we need to give anything else? No, for now that should be fine. And the model path is, we will go to model and whisper medium and snapshots and right click and copy path, and there you go. And we will go back 2 spaces, and that will be our path. So or is it 2 spaces or 1 space? 1 space, I believe, because now our file is here, offline module is here. So once we go back 1 space, it will automatically go outside, and then we can access this. So that's the basic idea. Then we have the model itself, and we can simply send in the model and the audio file. And once we get the result, we can simply we can write here result equals this, and then we can remove this and remove this. There you go. So now it should display. Now, one very important thing that we have to do that we didn't do earlier is caching. Now, when you load the model, you don't want to load it again and again on the GPU. So it will go to the GPU, then it will offload, and then it goes back, then it offloads. That's not a good way to do it. So what you need to do is you need to cache it so that every time you run the inference, it doesn't have to load up again and again. So in order to do that, we will simply write at, this is a decorator, st.cache resource, cache underscore resource, and that's it. So that's the only thing you have to write, only for the loading part. The inference part, of course, no caching required there. So what we will do now is we are going to right click and open in terminal. So here we will write Streamlit run offline underscore module.py. So if we click on that, now it should start loading pipeline from transformers. We have a from transformers import pipeline. Cannot import name pipeline. Why is that? From transformers import pipeline. So I just refreshed it and it started working. So as you can see here, it is right now loading the model. So if we go to our GPU, we should see a bump soon. So now once it loads, then we will be able to run our inferences. So there we have it. There is the bump that it started. And now if we open it up, there you go. Now our file is ready. Our software or program is ready. So what we can do is we can go to resources, we can right click, open in Explorer, and over here we can go to test.mp3. I will copy this path so that it's easier for me to locate. So here we are browsing the files, and if I click on this and open that up, you can see that the audio is now here, and I can click on transcribe and it starts transcribing the audio. And of course I can play it here as well. You can see it's playing, but I don't want to turn on the audio, so that's why. Okay, so it's transcribing now, and hopefully when it's done, you can see a little bit of peaks, a little bit of jumps. You can see that are coming here. It's doing something. So let's see, and there you go. So there we have it. This is what it has done. So that's the basic idea. Now, if I wanted to do another file, I can browse, select the file and transcribe again, and it will not take the time to load because it's already there. And you can see now it's so much faster than earlier because it does not take time to load the actual model. It just starts transcribing right away. The model is already loaded and it starts running the inference. So that is exactly what we are going to do with the rest of these as well. We have already done with audio. Now let's move on to the images. So here, if we close this, we have our offline basics. Here we have images. So we are going to copy all of that and we will paste it in our offline module. I know it will be a bit confusing at first, but then we will paste it in the right positions. So first of all, we are going to cancel cut from here and paste our libraries. So we will have diffusers and diffusion pipeline. We will also have torch. This will be the path. So this we can comment, audio transcription we can comment, and we can go to our online module and we can copy the image part from there, image generation. There you go. We can copy that. And if we go to our offline module, we can paste it here and we can move it forward. There you go. So now we can check which parts do we need and which parts we want to remove. So this is the file path. We have to have this. So we will put it here, model path. Now, as you know, we are going one step in the previous folder. That's why we don't need to go back twice. We just need to go back once. This part here is for loading, and then we have this part here for inference. So we will put this in the loading part. So we will go here. This is audio is done. Then here we are going to write image generation STXL model, and then we will write generate image local SDXL. So it's not generate, load image, load model SDXL. So local SDXL. Yeah. So, or should we write local or not? It's up to you. Did we write local before? Load model audio. We didn't write. We wrote it here. Generate text from audio local. Okay. Load model local STXL. Okay, let's write. That's fine. It's up to you. Whatever you want to name it. Sometimes it gets a bit confusing. So yeah, that's the idea. And then over here, we were talking about, yeah, loading the model. So this is the part for loading. So we are going to go ahead and paste it here. So right away, we will need the model path, and then we will need the torch type. We can keep this same, or should we change it? We can give the user an option to actually change it. But right now, because we are using a very specific version of SDXL, that's why it might not be that necessary. Because if we wanted to create for another model, we might create a new, what do you call, file, function. So that's the idea. That's how you can load this. And once it is loaded, we will simply return the base. That's the idea. And yeah, once you return the base, then you have to generate. So here we are going to write for generation, generate underscore image underscore SDXL, or did we write local first? Local underscore SDXL. So that's the idea, and then of course we can paste it here. So what do we need? We need the prompt, and then we need the model itself. So first we should get the model, so the base model and then the prompt. I will tell you why we are not using the word model now, and later on I will explain why is that, but bear with me, just later I will explain. Okay, the number of inference and guidance scale, the number of inference we'll put 20, and guidance scale we will put it here. Now, instead of showing the image, we will return the image because it's up to the user what they want to do with the image. So whether they want to show it, save it, whatever they want, they can do with that. Okay, this is the loading part. So we have to load first. And of course, we have to write at cache source resource so that it loads the model. And this is very useful because these are the bigger models, and once they load, it will generate the images faster. So we will write here load model xtxl, and we will give in the path, and this will give us the base, and then using this base we can generate our image. So generate image local SDXL, and we have to give in our base and we have to give in our prompt. So I believe that is pretty much it. You have the model, you are loading, you are getting the prompt from the user, generate image, spin it, generate and show. I think that should be enough. So if we just refresh it and go back, so right now it's running load model local SDXL. Now, this is the bad thing that I just did. Don't do this, because we had loaded an audio model before and now it's adding on top of that. So it's that's not a good thing. So you should not add multiple models on top of each other, because earlier we were loading this and we were caching it. So that will really hurt your performance. So it says offline module because we are in the wrong directory. We have to go to the terminal, and there you go. Now if we open that up, it should be without any issues. If we refresh this, loading, and there you go, the model has been loaded. And if I click on generate image, then it is starting to generate the image. Let's see what it does. So a cute cat jumping over a fence, cartoon, colorful, and so on. So there you go, it has started, and now it's generating the image. And there you go, 20 out of 20 iterations have been completed. And now we should be almost there, and it should show us the image. There you go. So let's remove cartoon and let's remove colorful and see what does it generate. See, the second time around, you can see how much faster that is. Earlier it took 52 seconds to generate that image, and now it took around 9 seconds to generate the image, because our model is already loaded. You can see here it's already loaded and it's ready to go. So here you can see it's very realistic. A cute cat jumping over a fence, a dragon, a fire breathing dragon like we did earlier. Let's see what it does. So now again, if you wanted to, you can increase the number of iterations. That will give you more clarity, but it will be with the trade-off of time. So you will have to wait longer to get the response. So there you go. We have a fire breathing dragon, and we can write realistic. Let's see what does it give. Okay, so this is good, but as you know, running one simple model is not the answer. A lot of times you have to run multiple models. For example, there is a refiner model for the SDXL that actually allows to enhance the image once it has generated. So you will not get good results right away. What you can do is you can send it to the refiner model and it will refine that model and generate some good images. The same thing goes for something known as LoRA. LoRA is basically low rank adaptation models. What they do is they allow you to enhance the output in a specific style or in a specific manner. For example, if I wanted to generate my own images, instead of giving it an image as a reference and saying do something similar, what I can do is I can train a LoRA and I can give that back to and I can run it with the diffusion model, and that will generate very clear images of me. So that is something that you can do without actually training the whole diffusion model. So diffusion models, they take a long time, of course, and a lot of hardware to train. So not everyone can do that, but everyone can actually train LoRa's. And for specific types, for example, if I wanted to a style of, let's say, logos, I wanted to generate logos. So if I write that we need a logo here, logo of a car or flower shop. So if I write that, it will try to give me images of flowers and maybe some related to logo, but not actual logo, because it did not train well with logos. So instead of training the whole diffusion model, what I can do, you can see this is not something that I would use as a logo. So what I can do is I can take lots of images, not lots, some images of logos, and I can train the model, retrain it, or we call it fine tune the model so that it produces similar output. So that's the basic idea of LoRa's. And we also have some models on top of each other that will generate better results. And for example, we have the refiner model for SDXL. So as you can see, this you cannot use as a logo. So we will do something that will actually generate logos later on, and coloring books and stickers and stuff like that. So we can fine tune it to specify that we want this as the output. Anyways, why am I telling you all of this right now? We are just creating offline modules. Now, the reason we are telling this now is so that we have to add this to our offline module. So we have the option of loading the model with SDXL. We should have an option within this to load a refiner model and to load a LoRa as well. Later on, we will look at how can we train our own LoRa's, how can we use LoRa's from other people that have trained it, where can we find these, all of these questions we will answer later on. But for now, what we need is the actual functionality of it. So how can we do this? Let me actually show you. Now, in order to run, we need the path of our refiner model, first of all. So we need to add stuff to this. So the first thing we will add is the refiner model path. So here we will write refiner model path equals none. So we might have the case where we did not provide the model, or we might have the case where we did provide the model. So if we did not provide it, it should not give an error. It should consider it gone, like we don't have it, right? So then what we can do is we can check if the idea is very similar to this. The idea is very similar to running the base model. The similar way we are going to run the refiner model. And this is the idea of that. So we are saying that if the model path SDXL refiner, if that is available, if something is inside that, then our refiner, earlier we had a base, now we have a refiner, equals diffusion pipeline dot from pre-trained. And then we will give in the model path SDXL refiner. We will give the text encoder. This will come from the base. Then we will also give the VAE. That will also come from the base. Then we have the torch type. And I believe we have already defined that. Yeah, torch type we have already defined. And the use of tensors, the variant we have already defined. And then the cache directory, we don't need the cache directory. Okay, so that is pretty much it. And then the refiner dot enable model CPU offload, similar to what we did with the base. That's it. So if this will run whatever you give, it has to run to give you the proper functionality. All of this for the base, right? Let me actually write it down here. Base model, right? And here it is going to write refiner model. So this, all of this is for the base model. All of this is for the refiner model. So now let's say we want to use a refiner model. How can we do that? So we will go to Hugging Face models, and you will see that one of the most common ones for computer vision is actually the refiner model. So where is computer vision? We have image to image and text to image, and there you go. So image to image, basically we are getting the image from the base model and then we are refining it to create another image. So that is why it's image to image. And here you can see we have 1.4 million downloads of this in the last month. So this is the Stable Diffusion XL Refiner. It will refine your models to a great extent. You can see how well they look after refining. So that's the basic idea. And if you remember, when we were discussing SDXL, we actually mentioned the refiner part, because earlier we were using just the base. Now we will be using base plus the refiner so that we get some better results. So it's pretty much the same thing that we have done so far. Now all we have to do is we have to download this and copy it. So you can copy it from here. You can go to diffusers, copy this code, run it in a different script and download the files. Once it is cached, you will go to your models and you will paste it here. So this is the refiner XL. Then we will right click and copy path reference, and we will copy path from content root. So what that will do is we will write here model underscore path underscore STXL underscore refiner. So we will give that in, and then we will put it in a string, and we will hit enter before the snapshot, and then we will go back one space. So and then we will give in the refiner model path as well. So now that we have given this, it will assume that you are going to use the refiner model. So that is good for loading part. It will take a while to load now because we are loading two models. But then after that, when we are generating, then we have also two options. One is with the refiner and one is without the refiner. So what we have to do is we have to make sure that first of all, we know if the refiner is there or not. So we have to write here, refiner equals none. So that is the default state. If the refiner is there, then we will do something. So here we are going to write that if refiner, then we will write this code, else if there is no refiner, then we are going to run this code. So that's the basic idea of this. And what exactly do we do when we are running the refiner? So let me actually show you. So here we are going to copy, I will copy the part of the base and then the refiner, and I will explain what exactly is happening. So now that we have copied this part, what exactly is happening is that we have a few of new parameters. So first of all, the number of inference, instead of n steps, we can simply put number of inference, and then we have to, what else do we have? Guidance scale is already there. Then we have the output type. So let me just hit enter here, and hopefully it will add all of those. So noise fraction, there we go, high scale, and yeah. So what exactly are these? Now the number of inference, we all know it's 20 right now, so it will run 20 iterations. Now high noise frequency, we are going to keep it at 0.8. So at 0.8, it is going to switch to the refiner model, and which means in our case at 16, it will switch, and the rest of the 4 iterations will be out of 20. The last 4 iterations will be of the refiner. So the output type, we are going to give latent, and we have verbose, false, and temperature. Temperature means the creativity. Do you want a lot of creativity, or do you want less creativity? So 0 is less, 1 is more. So you can put something in between, let's say 0.7. And the guidance scale is basically how much do you want to follow the input prompt. So I would put it at, let's say, 15. Now, again, these are very different values for very different scenarios, so you have to test them out. So if we run this now, we should be able to run with the refiner. And here, the idea is that once you actually give in the refiner part, it should return us with the refiner model. So we should have a refiner here. And that refiner we are going to send in here. But we didn't add that here. When we are loading, if that is the case, if that is true, then we will return base and refiner. Otherwise, we will return base. Else, we will return the base. So that's the idea. If we close this now, we terminate this, and because we are loading a new model, I just want to make sure that there's nothing wrong there. We can open it up in our terminal, and then we can start. So right now it's loading the models. So hopefully once it loads, then we can generate. So if we generate the image now, it says generating image. So here you can see earlier we were only loading the pipeline for our base SDXL model. So it was 7 out of 7. And then after that, we loaded the refiner model as well, which is 5 out of 5. These are the iterations it took to actually load the model. So now we have given the command of generating the image. And as you know, the first time it will take some time to load and then run. But after that, it will be much faster. So as you can see, it first loaded a little bit, and now it's going to the GPU. Once it is loaded completely, then it will run. So if you remember, I mentioned earlier that it is going to run 16 iterations with the base model, and then 4 iterations with the refiner model. So here, that is exactly what is happening. So if you go up, this is 0.8, and we have 20. That's why we have a total of 16 that we will be running with the base model, and then the last 4 will be with the refiner model. So now you can see the first part is complete, and now it's going to the next 4 steps or the iterations. Oh, by the way, the name is wrong. We should change the name here because it's local. But that's okay. We'll change it. So hopefully now it took a long time to actually generate this, but hopefully now we will get a better result. And next time around, we should be able to get faster response. And there you go. So right away, you can see the quality of the image is much better when you are using a refiner model with it. So the big difference you can see when you actually use it with humans. So one thing I want to do, first of all, let's remove that image generation. using local SDXL model. Okay. One thing I want to do is, sometimes what happens is that if we are not using the base, then we will have to remove, we are not using the refiner, then we will have to remove this. Every time it might give you different output. So if you are not using it, you can simply write it like this and you can ignore that part, because otherwise it will give error if you have some dynamic functionality there. So I believe it is better that we always return the base and the refiner. Now, again, it's up to you. If you want to change it in a different way, you can. And what we can do is, if the refiner is not there, we can say that the refiner, because we didn't define refiner if it did not go here, right? Because it's defined here. So if this is the case, else refiner is none. Let's put it this way. Okay. So that's the idea. So if it's none, it will give us none, and it will send none over here as well. So no big deal, right? So now if I wanted to ignore this, I can simply remove this part and everything has to stay the same. And now it will run without the refiner model. So if I save this now, if we refresh this, it is going to load model locally. And now we will try to run some very specific examples so that we can see the difference between the refiner and without the refiner. So here we can write man portrait. So we will generate an image of a man, and then we will generate an image of a woman. We will save these, and then we will do the same with the refiner model, and then we will compare what is the difference between these. So there we have it. This is the image of the man generated. And then we are going to do the same thing with a woman. There you go. So we are going to right click and save this again. And this time around, we will call it woman and base. And then we are going to go ahead and go back. And this time around, we are going to give in the refiner model as well. And what we can do is we can give the same parameters. 0.8 is our switching part. So we are going to go back. So here we are going to refresh this. And now it is going to load the models again. And there we have it. This is the image generated. We can save this for now. And then we will go back and do for a woman, and then generate image again. So as you can see, this is the image after the refiner, and we can save this as well. Now let's go back and review these. So if we open up the image of the man, this is with the refiner and this is without the refiner. So as you can see, the details in the refined model are much better than the base model. So definitely just with 4 iteration difference, you can see there is quite a bit of difference. And one thing to note here is that we didn't actually add any iterations. We just changed the iterations to refiner model. So both of them have 20 iterations. Another way to do this would be to have 20 iterations of the base plus 5 iterations of the refiner model. So that will give you even better results. So again, here you can see, so this is the portrait of the woman. And here you can see we have a lot more detail and a lot more clarity. This looks a little bit more fantasy, and this looks a little bit more realistic. So definitely there is a significant difference when you're using the refiner model. So that's why I added this part of the refiner model, so that you can make use of this, because it does make a big difference. So that's why we had to add this. So one more thing that I mentioned regarding the images was LoRA, low adaptation ranking. So here is an example of a LoRA, which basically allows you to create coloring images. Now, what you can do is you can go ahead and to your base model or the refiner model combined, you can say make a coloring book page, right? You can do that, but the result will not be that great. So in fact, let me actually show you if it's already open. If I write it here, create a coloring book page of a lion, right? If I generate that, the result will not be as good as if we were to train with some images of coloring books, create a LoRA out of that, and then use it with our existing SDXL model. So it's a little bit more intuitive and it gives a lot of direction. What exactly do you want? Now, the same thing you can do with faces, you can do with so many things. You can create LoRAs and you can use them. So Civit AI is one of the places where you can find lots of LoRAs and you can use them. For example, here we have featured models. You can see LoRA XL. These are the ones that we can actually use. Checkpoint is the actual model, but LoRA is the what do you call, the file that goes on top of the model and we can use to do that. So for example, here Eastern Dragon. So if you wanted good images of that, you can do this. Here somebody did for Valentine Tech World. Then you have art styles. You have lots of different things that you can try out here. You have the option of filtering as well, I believe. If you go to models, and within models you have the option to filter, and then you have instead of checkpoints you can write LoRAs, and it will give you the highest ranked ones and the most utilized ones, and there you go. So that's the basic idea of creating LoRAs for specific tasks. So for example, this is Arcane. If you have watched Arcane, if you wanted that style of images, you can use this LoRA to actually generate that. Let's go back, and here you can see this is the image of a coloring book page with the lion. It is actually not bad at all. It is good. Sometimes it gives very bad results, but in this instance, it's not so bad. But the idea is, again, if you wanted very specific result, if you are giving it as a service, then you want to make sure that every time it generates a very specific output. So that is exactly what we are going to look at, how we can do this. You can go to the website and download the LoRAs. Here you have one of the ones that we will be using is the coloring book Redmond version 2. It has 8,000 downloads. You can see here it is provided by Artificial Guy BR. Thanks to him to giving us that. And you can even try it out here. And every LoRA basically has a trigger word. So this is the trigger word for that LoRA. They actually mention that here. The information, it's based on SDXL version 1, fine-tuned on a large dataset. LoRA is high capacity to generate coloring book images. This is the tag. So tag is that word, the keyword that will trigger this LoRA to generate something. So that is coloring book or coloring book AF. So that is what you have to use in your prompt to generate this. So you can code it in the backend to have this always in the prompt, and then you can just ask the user, what coloring book do you want? So something like that. So how can you use this? Again, you can download the files. If you look at the diffusers, you can download it from here. For example, you can download it like this, or I will tell you the different method. You can go to files and versions. You can directly download it from here. And once you have this, then again, you are going to go ahead and put it in the models. So here you can see we have this. So I downloaded it with the code as well. So if you go to diffusers, you can copy this code and it will download in the cache. As I mentioned, you can copy it from the cache and bring it here. And this is your file. You go to snapshots, and here inside this is your model. So this is the safe tensor file. So I can right click and copy path reference and copy from content root. And here down below, I can give the option of not model. We can write LoRA underscore path equals this. And then we are going to enter over here and we will go back one space. So now LoRA path is there, but how exactly do we load it? It's very, very simple. If you go to your generate image, local SDXL and your load model, what you have to do is you have to check if you have the LoRA, you will attach it to the base. So if model path LoRA is available equals none, if that is available, then base.load LoRA weights and you give in the model path of the LoRA. That's pretty much it. And the good thing is that once you are done with this, that is it. That's pretty much it. You don't have to do anything else. The only thing you need to add it to the prompt, the tag words. So what you can do is, for example, you can write here LoRA underscore trigger equals coloring book, right? So that was the one that the author mentioned. And there was another one. Let's put both of those. So if we go back to the model card and coloring book, AF and coloring book. So we will put it here. And then what we can do is we can write that our prompt is basically our LoRA trigger plus whatever this is. So here prompt plus our LoRA trigger. So that's the idea. So now whatever we write, so for example, we can write here lion and it will generate automatically the coloring book of a lion. So now all you have to do in order to run this, you have to go to the LoRA path and you have to paste it here. So the third one, is it LoRA path or not? Yeah, the third one is LoRA. So yeah, now once we add this in, now it will use the LoRA as well. So if we refresh this, then you have load model local SDXL. Now it is running and it will load all the models and then it will run our inference. So now we can simply generate image and let's see what it generates. So there we have it. This is the image that was generating using our LoRA, and it is also using the refiner model at the backend. So this is the idea that if you want consistent results of very specific idea, then you can use LoRa's to actually generate that. For example, if I wanted to train my own face so that whenever I write a man or whenever I write my name, it shows me my face, and in different scenarios, then I can use different LoRa's to actually, I can use my own LoRa to train, and then I can use that to run the inference, and then it will give me images that look similar to me. So the LoRa training and all that we are going to discuss later on as well. But let me show you some of the images I have generated with my own LoRa that I created. So this is one of them. This is another one. And let me actually show you. Yeah. So here, this is an example that this was the bad example when I trained multiple models and one of them was giving results like this. So how exactly can you go from this to actually generating something like this? So we will discuss that later on in the training part. But for now, you can find many LoRa's online and you can download them simply to use them. They are on Civit AI and they are also available on Hugging Face. So we will be using some of these in our upcoming projects. So now we will go ahead and create our text part. So far we have created our offline module with our images and audio transcription. So we can generate images and audio, but we did not do the text yet. And in terms of text, we have two options. We have the offline text and we have the offline text faster. So we will add both of these in case you have a very good PC, you want to run using Mixtral without any quantization. You can do that, or you can run Llama with quantization. That will be much faster, but it will not be as good as the Mixtral version. So that's the basic idea of how we can do this. It's text and text faster. So the idea is that we are using C transformers, and then we are loading in our path. Then we have the initialization part. We are loading the model, and then we are running the inference. So let's go ahead and do that. Here we are going to copy this, and here we are going to paste it. Now, one thing that will be different will be our streaming. So earlier we are not streaming, we are just sending the data directly. So the user has to wait and think what exactly is happening. Oh, when will it come? But what we are doing now is streaming, which will allow us to generate the words and send them one by one to the user so that they are at peace and they can enjoy copying essays and stuff like that. Anyway, so the idea will be that we will first initialize. So let's copy that part. So first of all, we are using Streamlit to cache the resource. Of course, you have to cache it, otherwise you will have to load it again and again. Then we are creating a function load model text llama2 gguf. Here we are giving in the model path. So basically the idea is very similar to what we have done here. We just copy pasted this over here. And then using the C transformers, we are defining all of these parameters. And that's pretty much it. Now, the reason we are using C transformers here is because there is another method, auto model for casual LLM, that is going to be in the offline text. So in offline text, there is a library transformers that has this functionality. And then there is another one, probably this is a class. Let me check. Yeah, it's a class. So this class is also present in transformers, and it's also present in C transformers. So we cannot have that both ways. So what we have to do is we have to add it like this, import C transformers. And over here, when we are loading it, we will write C transformers class this, and then we will load the model. So once that is loaded, then we are going to generate the text. So here we are writing generate text llama2 gguf, and we are giving in the model that we created. We are giving in the prompt. And if you remember, in the online module, we added the text area placeholder. We are going to add that as well so that we can stream the text out using that. And then we also have an optional parameter of stop, because as we saw earlier, Llama keeps repeating the stuff. It keeps creating questions and other things. So if you want to stop it, you have to give it when do you want to stop it. So here we have our generated text. Initially, it will be empty. Then we will loop through. We are basically running the inference here. And we are saying that we want to stream. And these are the stop parameters. While that is happening, we will send in the text, and it will keep updating in the text area placeholder. And we are using Markdown because we will allow HTML as well. So if you want to, you can ignore that and just write text. If you wanted more flexibility, then you can write Markdown so that it can input HTML as well. And then once everything is done, it will send us back the generated text. So that's how simple it is. So what we will do is we will copy from the online module. Where is the online module? From the online module, we are going to copy the text part. the text generation, and we will paste it in the offline module. Let's remove this and let's paste it here. There you go. By the way, if you want to go forward, you have to press tab. If you want to go backwards, you have to press shift tab. So let's remove the comments from here, and then we are going to load first. So let's load what is the load model text llama gguf, and we are going to give in the parameter the model path, and what else, the model file. Yeah, we do need to give the model file as well. And once that is done, then we can generate. So before we do that, let's actually give in the model, and it will return us the model equals this, and we need the model path. Let me write it here, model underscore path, and then we will need the model underscore file. So if we go to our offline text faster, this is our model path, and we will paste it here. What happened? Okay, and okay. There you go. And we can remove this. And then model file is basically our llama name. So the particular file that we want to refer to. So that's the idea. Now we have our model created. No, we don't. We have to add it here. So model path and model file. Now it's ready. Now we can use this model to send it to our generate text llama, and along with the prompt. So this is our model, and this is our prompt. This is the text area holder, and HTML equals true. We don't need to put that. Okay, so yes, that is pretty much it. Result, we don't need to see the result because it's already putting it in the text place area holder. And what we can do now is we can right click, open in terminal, and we can write Streamlit run offline underscore module dot py. So there you go. Now it will start loading the model. So now it's loading the model. It's going to cache it. And here you can see our memory going up and up. 4.1, 4.2, 4.3, 4.5, 4.6. Okay, so our model is now loaded, and we have the prompt write an essay on computer vision, or we can say which is the largest country in the world. I'll copy it and generate text, and the answer is Russia. There you go. So it is quite fast. And what if we don't write this? What if we write an essay on computer vision? Or we can ask it, what is computer vision? Because it's kind of question answer thing. There you go. It's the ability to see and understand what you are looking at. I guess the reason with computers do things blah 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 blah. So that's the idea, and you can see how fast this is. But again, there's a trade-off between fast, which is speed, and accuracy. So you have to pick which one do you want, because the next one we are going to do is going to be mixtural, and it is not using the quantized method, so it will be a bit slower, but it will give you better responses. So in order to do this, we are going to keep this as here text generation faster, and then we will copy this and we will write here text generation. There you go. So the title is again text generation using OpenAI. keep forgetting to actually change it. Text generation using Llama GGUF model. That's a good idea. And here text generation using Mixtral AI model. So yeah, that's the idea. And then what we can do is we can go and load the model first. So if we remove this offline text, modeling, auto, offline text. So this is the one that we want, offline text. And here you can see we are importing transformer, auto tokenizer, and auto model for casual LLM. So we can copy that and we can come to our module. What happened? Wait, did I change it here? No. Offline module. I'm getting confused with the modules. So many things going around at the same time. Okay, so we are back on track. Transformers, import this and this. Let's remove the online module. It's confusing me. Let's go to the offline text. So do we have torch? No, we need to add torch. No, we have. Okay, then we need the model path and the device, the tokenizer, and the prompt. No, the prompt we don't need. We need it till here. So all of this is basically your loading part. So we will create load model text, and we will go down over here. This was for text generation. We will write here load model text underscore local, and then using this we are simply creating our model and we are adding the tokenizer, and we are making sure that our device is GPU by default. So or we can add it here. We can add it here as an automated thing, that device, if torch is available, then device is this. If it's not, then it's not, it's CPU. Anyways, so that being said, now what we can do is we can give it a name here. Text generation using Mixtral AI model. So now that we have loaded this, the next step is to run the inference. So to run the inference, what we are doing is we are first converting the tokens to tokens, and then we are sending it, and then we are getting back our tokens, and we are, you can say, decoding it. So that's a long process. That's why it's a little bit complicated when you go to the streaming part. In order to do the streaming part, we will need another one here, which is text iterator. So this is the class text iterator streamer. That is what we need to actually do this. It's a little bit complicated, but once you do it, it's like you have to use it without any problems. You can use it just by calling this offline module. So here I'm going to paste the function, which is generate text streamlet. Text local streamlet, and this is without any quantization. So here we will need the model, then we will need the tokenizer, then we need the prompt, we also need the device. Okay, so we need device again. So either we can, yeah, we can put this here as well, why not? So we need the device, we can put it here. So now we can remove this. Then we need the text area placeholder and the maximum number of tokens. If you want to restrict how many tokens you want, you can do that. So the idea is very similar. You have the message like we had before, message, then the tokenizer encoding, and then we have the input encoding. We are sending it to the device. So these are the three things that we are doing earlier. The same way we will be doing this right now. That's it. Then we have to create the streamer. That streamer will have the function of timeout. So if nothing happens in 10 seconds, timeout, leave, skip. Then the second thing is skip the prompt. Usually when you are getting the final answer, it will add the question as well in the prompt. So in the answer. So that's not what we want. We want to skip the prompt. And then it will also have some special tokens or special characters here and there. So we want to remove those as well. We just want the pure answer. That's why we are adding these. Otherwise, we will have to manually check what does it add, and then we'll have to manually remove it. That is a very tedious process. It's good to have these flags so that you can use this. Then we will create the arguments. So we have to create the generation arguments. This will include all the parameters, and then we will start the streaming process. So here, the ones that we had earlier, we have input IDs, maximum new tokens, the streamer, the actual streamer, and whether we are streaming or not. Then do we sample or not, the top P, the top K, all these parameters that we have discussed earlier, all of them are here. Some of them I have removed as well. If you wanted to add further, you can do that as well, and so on. So of course, all of these, they need to be over here because these should be optional, right? So we need to write input, not input IDs. What is the one? So we need to start from do sample, do underscore sample, and then all of them should be here. Yeah. So we have do sample, top K, temperature, stop. We don't have a stop here. So we can copy this part, paste it here, copy this part, paste it here, copy this part and paste it here, copy this and paste it here. So yeah, so all of these should be optional. Again, you can put these optional as well, but I would not recommend that. Timeout, yes, timeout should be optional. Should be able to give in the timeout. Timeout is this, and we can add it here. Okay, that being said, then we will use threading because we need to stream the output. That's why we will have to use threading. You don't have to go into the detail of how threading works. It's just think of it as you are running two things parallel. So you can have other things. It will not wait for the words to come in before it can do some other processing. So for example, if you had text generation and image generation running at the same time, it can run parallel with threading. Of course, if you have the capacity. If you don't have the capacity, you cannot run it in parallel. You will have to do it one at a time. So we have the option. So here we are creating that thread and we are giving all the generation parameters. And then we are starting the thread that, okay, start generating. And this is similar to what we did in our text generator here. When we want to stream, it's pretty much the same thing. We have a generate text, then we start the streamer, we copy each word and we add to the main text, and then we give it to the placeholder, which is your markdown. So that's the basic idea. So now let's go ahead and run this. We have been talking for a while and we didn't actually run anything. So let's go ahead and try to run it. So here, this is for text generation and we have the model path. So let's remove that. And this will be load model text local, and we will give in the model path. What else do we need to give in? That's pretty much it. And we don't need to give this. The model path we can copy from offline text. This is the model path like that. And we can remove one of these like we have been doing for a while. And load model text local, yeah, and then this is the input text placeholder, and here we have to generate. So we will generate local, we will give in the model, we will give in the prompt. Was there anything before the prompt? Model, tokenizer, then prompt. So we are getting the tokenizer here. So model and tokenizer. Okay, so we are getting the model and the tokenizer, and we will copy that, we'll paste it here, and then we are getting the prompt and the text area. So now it should automatically do everything for us. If we go back here and we refresh, it is going to load model text local. And now if you remember, it takes a while to load these shards. And once they load, we will come back and then we will be able to run multiple inferences of this model, and we will be able to ask it a lot of questions, whatever we need. But wait, did we write it like that? No, the prompt is wrong. The prompt is wrong. We need to stop it. Let's stop this. Oh, we'll refresh it later. So we can go to offline text, and here, this is the prompt. And it goes to, no, I think it's right. So if we have the prompt here, it goes over here, and then it goes here. Yeah, that's fine. That's fine. We are heading in the right direction. Let's wait. Oh, I already stopped it. My bad. Okay, let's close it again. And we will go to terminal and run the offline module. So now let's wait for the shards to open up, to load, and then we will come back and continue. Now the model has been loaded and we can ask it anything. For example, we can say, what is the largest country in the world? So generate text. So I ran it again. It gave an error in the beginning. Not sure what that empty is, but now it's working. And the largest country in the world by area is Russia. It covers approximately 17.1 million square. So we can say, actually it should be which is the largest country in the world by population. So let's generate that. Now you can see it will generate without loading the model. But as you can see, it's very slow compared to what we had earlier. But of course, it will give better results because it is a bigger model and it knows more. So if we were to ask it something open-ended, it might take a long time to actually compute. So for example, we can say, write an essay on computer vision. So if I do that, it will take a while, but the thing is we have limited the token numbers. So if we go down, or we go up, the token numbers, by the way, the error was repeating, so I had to try out different things. This timeout should be here. I was trying out different things, and one thing that I noticed is that you do have to define CUDA before you start. So you have to define the device before you actually start, because when it's running the resources, it tries, and if you check after running the resources whether it's available or not, so sometimes CUDA will not be available. It will say only CPU is available. So you have to check it before, and then you send it to the device. You send it to the load model text, and you also send it to local Streamlit. So here you can see I have added device equals device, and here is device as well. So device is basically plain text by CUDA. By default, it will be CUDA. You can see here, and over here as well, by default, it will be CUDA. If it's not available, it will go to CPU. Now, if it's not CPU, if it's not CUDA, then you should not actually run it because this will not run properly on CPU. Anyways, so the idea is that it actually works. Now this has been cached, it has been loaded, so even if I refresh this, it should work. There should not be any issues. Here you go, you can refresh and you can keep running it, and you can see the memory being used is almost 11.6, so it's using the complete memory to actually run this. And as I was mentioning, here is the maximum number of tokens. So if I even write an essay on computer vision and I tell it to generate the text, it will only write almost 25 tokens and then it will stop. So if I added more, it would actually give what do you call, more tokens. So for example, here, if we add, let's say 100, I don't want to add a lot because the computer is going to get slow and I'm recording at the same time, so it might get problematic. So there you go. Now it will start introduction, computer vision, a subfield of artificial intelligence and machine learning is the ability of computers to interpret and understand the visual world, and so on. So as you can see, it works. you can run it on your GPU, but it's not as fast as what we had before. So if you wanted to stream, then it's better to use the other one. But if you want the full functionality, then the online is the best bet when it comes to large language models, because they are very stable and they have very good accuracy and time as well, because they are running on very good GPUs. So now that we have understood and created the online and offline module, we need to go ahead and learn how to import them so that we can use them in different projects. Now, normally, if you were to create a project, a single project, what you would do is you would create a folder. Let's say we will call it recipe, and then you will add your main file, let's say main.py, and then any modules that you have, online module.py, for example, and then any resources that you have. So everything is in one single folder, and you can basically run it very easily. But in our case, we are not going to do this because our online module is going to be used in many different projects. So instead of copying that online module and pasting it in this folder and doing that repeatedly for, let's say, 10 different projects, that will be very problematic if we wanted to change anything in the online module. So if we were to change one thing, we will have to go back and change in every 10 of the other files. So what can we do? Instead of doing that, what we will do is we will have our folders for each of these apps. And within these folders, we will have only the files that are associated with the main code. So we will have main.py for each one of these. And then we are going to refer the online module from outside. Now, this is not a very good method of creating your projects, but this is sufficient if you are learning. So it's only for learning. So if you were to create an actual project, you would copy this and paste it in your folder and make any changes or whatever you require within that. But because we will be doing that for many different projects, we will keep it outside and we will write a few lines of code, 2-3 lines of code that will allow us access to this file from outside. So that is the basic idea, that we need to import our online module, offline module, or even resources that are outside, because we want to access the resources and these files in many different projects. That's why we keep it outside, so we only have to change it once. Now, in reality, you would only make one project at a time, so you would not have to do this. So now that the concept of this modularity is clear, so we will go ahead and start building our apps. So now we are going to go ahead and create our first app. We have come a long way before we have done so many installations, so many modules, so many things, so many models to download. Now, finally, we are at a stage where we are going to start with our project. So here we are going to right click and create a new directory. We are going to call it chapter 9 underscore apps. So here we are going to build all the apps, and then we are going to go ahead and create a new directory, and we will call this recipe generator. So this will be a simple project that will generate a recipe, but it will have a specific format that every single time it will have XYZ. For example, it can have a fun title, then it can have ingredients, then it will give you the country of origin of that recipe, and so on. So there is a specific flavor we are adding, rather than just going to ChatGPT and saying, give me a recipe. We are adding a flavor that every time it gives us the correct format. So how can you do that? We will go ahead and create a new file, and we will call it recipe generator. The first thing we have to do here is we need to decide whether we are using online or offline method. So in this case, when you want to generate something long, I would recommend that you use online module using ChatGPT, because that will be much faster than what you are using locally. So for this project, we are going to use the online method, and if you wanted to, you could switch to offline with just one line of code and it should work as well. But for now, we are going to start with the online. So now we are going to write our code. And as I mentioned earlier, we need to import our online module. So how can we do that? We can simply refer to our chapter code basics, and then from there we can import. So we can write from chapter 8 code basics dot online module import everything. If you wanted to import specific things, you can do that too. But in this case, we are importing everything because we're going to use it later. So once we have that, the first thing we will do is we will add our title. So here we will call it AI recipe generator. That's well and good. Then the second thing is that we need to generate an output format. Now we will discuss this output format later on, but for now, let's just keep it here that there will be an output format that we have to add. Then we need an input from the user to give us what recipe do you want. So here, for example, recipe is enter your prompt. We have chicken biryani. So the user will define the value. By default, it will be this, but you can define your own. So once we get the user input, then we can basically set up our client. Actually, we should do that before. We should do that right after the title. So we will set up our client to have the API key from chapter code basics.api key, import API key. So here you can see this is our API key over here. So that's what we are importing, and we are sending it to our OpenAI setup. So now once that is done, we need to add a button so that the user actually starts. So we can write if st.button create recipe, and then with spinning of the recipe, with spinning of the spinner, we can generate an image first. Now it's up to you if you wanted to generate an image or not. Initially, I will generate an image and show you how it's done, but then later on I will pause it because we don't want to generate again and again the images. So what we will do is we will simply write down that with spinner generating image, we are going to generate image OpenAI. The reason we are able to use this is because we imported everything over here. So if you go to the online module, if you press Control and click on this, it will take you to this module that we created earlier. So you have set up OpenAPI, and then you also have generate text from audio and generate text OpenAI image. There you go. Generate image OpenAI. So that is what we are using, generate image OpenAI. We are sending in the client and we are sending in the recipe name. So that's the basic idea. And then we are generating an image and showing that. And this here is the caption of the image. Here it will expand to the complete width. If you make it false, it will be whatever size you want. You can, for example, specify 200, 300 if you want it different. So that's the basic idea. Let's go ahead and run it and see if it works so far. Open in terminal, and then we will write Streamlit, run, and then we will write recipe dot underscore generator dot py. So now it has opened it up, and there you go. Now we have an issue which says no module named chapter 8 code basics found. See, this is the issue that I was referring to earlier. So in order to fix this, we have to write a few lines of code, and that's it. So how do you do that? Right now, it's not able to find this as a module. Now, this is an internal issue. Again, if you are creating an actual project, you should put the files over here and you should not face this issue. You can simply say online module, import everything, and you should be fine. But right now we will face this issue. So in order to solve this, we will write import system, and then we will also import from pathlib import path. And then we are going to include into our system path a new variable or a new string. What does that mean? When you actually run this script, it has a list of places it's going to find and check whether you are getting the stuff from there or not. So what we are doing, that list is basically system path. If I write here system.path, and if I print this, let's run that. It will not run, but it will give you the output. So this here, this is your path, the list. So what we need to do is we need to say include AI course as the path as well, so that when we say chapter 8 code basics, it knows where to find it. So path, this path with file is basically the link or the path of recipe generator. So we are taking that recipe generator and we are saying go back to your parent twice. So go back 2 spaces. So that's what we are saying, and that will append this main course page, and it will allow us to link to our code basics and app 9 and whatever we need. We can even access resources and everything. So if we run this now, if we save this and come here and refresh this, we should not get this error. That error should be resolved. There you go. So right now it's saying AI recipe generator. We can create a recipe, and now it's saying generating image. Let's see, what does it say here? Nothing. No, terminal. So yeah, here nothing so far. This is the previous one, that the error we were getting. Not a big deal. Now it's generating an image. It may take a while. There you go. So chicken biryani. There you go. We have the is that a pencil? Looks like a pencil. Anyway, so yeah, you are getting the image. You can of course add some prompts like realistic, cinematic, something like that. So what you can do is you can write here my recipe, or you can write it here plus, let's say realistic, and or what else, realistic and cinematic. There you go. So yeah, and let's try maybe pasta this time. Pasta. So let's refresh this. And by the way, this is the default value. You can change it if you wanted to. So that's not an issue. So there we have it. Now it has generated the image of pasta. It is a bit more realistic. But again, you can keep changing the prompts to get better results. So that's the basic idea of generating the image. Now what we will do is we will comment this out, because now we are moving on to the next part, and I don't want to keep repeating this every time, and it will slow us down. So the next part is basically where you actually generate the recipe. So how do you generate the recipe? You basically write with the spinner that generating recipe, and within that you simply create a placeholder like we used to do before, an empty placeholder. And then what we will do is we are going to call our function. In the online module we have generate, where is it? Generate text open AI Streamlit. So basically we are going to send that. And what exactly do we need to send? So here we have to give in the client, the recipe, the client we already have, the recipe we already have, and the text placeholder, and the HTML is true, because we wanted to give us an HTML format so that it's like a blog. We don't have to worry about heading, subheading, list. It will automatically generate that and send us the values. So that is a good thing that will be available to us. Now, let's say I want to generate the recipe for this. So right now, it just says that this is the recipe that we want of pasta realistic cinematic. This is for the image. So we should actually separate them. Image underscore prompt equals the recipe plus this, right? So this is our prompt for the image. So instead of doing that, we can send it like this, image prompt. Now we need to create the prompt for our recipe. So what we will do, we will write a simple prompt. That is our prompt over here. And this should be after, the generation should be after. So here our prompt is create a detailed cooking recipe for the dish named recipe. So whatever we added, let's say pasta, it will create a recipe for that. Include preparation steps and cooking tips. Follow the following format. Now, this is the most important part. Here, we are going to define our output format. If we were to just give this, it will give random values, random answers every time. Every time it will have a different format. So we need to specify this output format in HTML format. What is HTML format? If you are not familiar, it's very simple. All you do is you add tags. So H1 basically means it's a heading. So here, this is the format that we are going to give. We will say that our first thing should be H1 tag with a title, some fun title of the recipe, right? Then we will need a table of content, again in heading 1, but it should contain a list. Li means list of all the links of the contents. So next we have introduction, country of origin. So all of those should be linked so that when I click it, it goes down, right? So that's the second thing. Then we will have an introduction. So this is our introduction. Why is it like this? It should be like this. So if we add triple quotes in Python, then we don't have to worry about adding these one by one. So here we need to remove these 3, and here we don't need to add these. There you go. We don't need to add these. Instead, we just need that. So now we can keep writing as we want. So then we will have the introduction. So introduction of the dish. So whatever, this will be the title, and whatever we want, we are basically explaining here, dish introduction. So if you wanted more details or specific details or specific links, you can add it here. Then we will add the country of origin. This is something I just added, like where was this found first, and who actually eats them most, things like that. Then we will get a list of ingredients. So again, we are using the heading, but we need a list. Li is the list of those ingredients. And then we need the cooking steps. How do you actually cook it? Again, we will need a list. And then we will need an FAQ, that if there are any problems, where can users find the answers to these problems? So this is a format that I have created randomly, right? By the way, P means paragraph. So we are defining paragraph here. So this is a format I have created randomly. If you wanted, you could change whatever type you want. You can add FAQ at the very first. You can mix them around. You can change their titles, whatever you want. So now it will give us with this output format. And is there anything else do we need? Okay, so now we are done. And what we can do is we can save this and we can go back to our pasta and we can refresh it. This time around, it will not generate the recipe. So here, pasta is a type of Italian dish made with dough that is typically made from drum wheat water. Okay. So something is wrong because it didn't actually pick any of what we said. And the reason is, that's the main reason, we forgot to add the prompt. So we need to add the prompt instead of the recipe. So you see how big of a difference that makes? So let's refresh this and create the recipe. There you go. Creamy garlic, parchment pasta, table of contents, introduction, country of origin, introduction, country of origin, ingredients, cooking steps, and FAQ. So that's how good this is, that you are getting a format. Now, if I were to write here, chicken biryani, then it should give me the exact same format. Now, the title might be different because we said make a fun title, but the table of contents is there, the introduction is there, country of origin is there, ingredients is there, cooking steps are there, FAQ are there. So everything else is there. And it is referring that it is a Pakistani, Bangladeshi, Sri Lankan, Indian cuisine, something like that. So it's referring to where it was started as well. So let's say cheese burger, and we create the recipe, ultimate cheeseburger recipe. So it's a fun title. And now we have the links as well. Yeah, there you go, FAQ. Now, one thing I would like you to try out for yourself, try to split it down into tasks and then give each task one at a time so that it creates bigger introductions. It creates bigger story, bigger ingredients, bigger cooking steps, you know. So that's a task for you. We will discuss this later on as well when we are doing other projects. But for this project, if you do that, that will be amazing. Now, the only thing left is we open this up because we are generating an image as well. So what we can do is here, for example, cheeseburger, we will create the recipe. First of all, it is going to generate an image. And once it generates the image, then it will move on to creating the actual recipe. And you can see all of this is already formatted. So the heading is there, the titles are there, then you have the lists, and then these are the point list, bullet points, and all that. So that's the good stuff. And the image is actually very good. Now I want to eat a burger. Okay, so that's the idea. So you can basically create any recipe that you like. Let's try pasta again. Let's see what kind of image do we get with pasta. So there we have our image generated, and it looks very good. And yeah, so the best thing about this is it's actually streaming. So we are at peace that something is happening. Otherwise, if we were to wait, then it might be a little problematic. So that is basically the idea of our app. I hope you like this. And next on, we will continue with making some more apps. So now we are going to go ahead and create a new project by the name AI Meal Planner. Now, the idea behind this project is very interesting because we are going to add on something on our previous project. In the previous project, we created a recipe generator. And the idea of this was that we needed an output format exactly like this, right? But what if I don't want to place in this order? What if I want the answer and I want to pick and place things in different place? For example, I want a summary of how much weight should I lose, but I want the answer of how much I should lose, for example, 5 kgs in a separate area. So I will write in big title, lose weight, and below that I will write 5 kgs. So how exactly can I pick data from the chat GPT or whatever AI you are using? How can I pick the data from there and then place it on my website in different places or in your app? So that's the basic concept behind this. So we are going to right click and create a new Python file, and we will also call it AI Meal Planner. Okay, so now what we will do is the first thing we will copy and paste our previous code because that is the best thing ever, copy and pasting. So the idea is similar to what we have done before. We are going to make use of the online module, and we are going to create an AI meal planner. And in this meal planner, we are going to have our chat GPT give us the answer, but we will take specific parts of it and display it based on our requirement. So first of all, like we did before, we have to set up our client. So client equals setup open API, and we will use the API key to set that up. So now the online part is ready. So that's how simple it is when you have your own module to get up and running. So this is our app created. And now what we need is we need separate input requirements from the user. So this is something I've created myself. If you want to change it, you can do that. What I will do is I will create 2 input columns. So we will have column 1 and column 2. And here we are defining that there will be 2 columns. Now in column 1, I will ask the person to give their gender and their weight. So the first one will be gender. This will be a select box where you will have 3 options of selection. And then the second one will be a number input where you will have a minimum value of 1 and the maximum of, let's say, 80. So we should not have a minimum value of 1. Let's put, let's say, I don't know, 30. So that's the idea. So you are also referring to the units so that the other person knows what they're inputting. So what you can do is, in order to run this and make sure everything is working, we can right click and open in terminal, and then we can write Streamlit run, and we can write AI underscore meal underscore planner dot py. So that should open up our app. So there we have it. Now it's opening up the app. So if it doesn't work for the first time, just refresh it and it should work. So there you go, AI meal planner. We have the gender, you can select, and then you have the weight. You can increase or decrease, or you can simply type in the value. If you type in, for example, 20, it will tell you that it should be greater than 30. So that's the good part of creating graphical interfaces with Streamlit, that it handles some of the logics at the back end that you don't have to worry about. So you can type in the value here. And the second thing, the next thing that we will add in our columns are the age and the height. So we are getting the data of the user, and then based on that, we want to generate a meal plan for them. So here we have the age. Basically, it will be a input number, a number input like we had in the weight. And again, we will have a minimum and a maximum value. Minimum value, let's say it should be 18, only 18 plus people should use this. And then the step is 1, and the initial value, let's say, is 30. Then we have the height. Again, it's an input number. We are giving it a name, and the minimum value, the maximum value, step, and the value itself. So this is in centimeters. So again, depending on your requirement, you can change. So if we go and refresh this, then now we have 2 columns. And if we move it around, you can see they are responsive. So it means it will work on a mobile phone as well. So now this is done. Now what we can do is, getting this information, we can send that to our ChatGPT. Or do we need something else? I think we have one more thing. Yeah, the aim. Yes, I forgot the aim. So the aim should be defined whether you are losing weight or gaining weight, or you want to maintain the weight. So that is your aim. You can select that as well. So if you refresh that, there you go. You have the aim, lose, gain, or maintain the weight. So now all of this is done. We have used select box and number input, and that's pretty much it. Now, the next step is to get all of this in a prompt, and then we can send it to ChatGPT to give us the answer. So first of all, we are going to add our user data. So we are going to write here that our user data is basically, we don't need this. What we can do, instead of writing F strings, you can simply write 3 times. This is also called doc string, like that. So in this case, you don't have to put the F strings. There you go. Let me remove that. Okay. So now whatever you want to write, you can basically write in here, and it makes it easy to read as well what's going on and make some changes. So here it is saying that I am a gender. So I am a male or female or other, whatever the person selected will be selected here. My weight is, you give in the weight. So that's the value. I am dash years old. So we are getting the age and we are putting it here. My height is whatever the height the person has given. My aim is to dash weight, lose weight, gain weight, maintain weight, right? So this is our user data that we are getting, and we will add this to our final prompt, but the prompt is not ready yet. So what exactly will be our prompt? Our prompt will be that this is our user data, and we will say, given the information, this will be the first thing, the information. And then we will say, given the information Follow the output format as follows. Give only JSON format, nothing else. And we are giving the output format. Now, we discussed two things here, output format and the JSON format. What exactly is that? Now, don't get confused. JSON is a big word to use, but it's very simple. JSON format makes it very easy to deal with things. For example, if you are writing age, just write age, colon, and the answer. That's it. That is what JSON format is. So JSON format basically means, for example, if I were to write age, I will write it like this. Age is 30. This is JSON format. That's it. Whatever you want to write, write it like this. So let's say my height is 170, let's say. So this is JSON format. Nothing fancy, nothing difficult. So what we are saying, give us the output like this, so that when I want to know the age, I can just say age and then I can take its value. I can say height, then I can take its value. So if you have worked with Python, then this is basically a dictionary. In Python, it's similar to what a dictionary is. That is what is your JSON format. So now we need to give in this format. So I have written down the format here, output format. So here our output format is like this. So we will have a range. This is what I want the ChatGPT to give me. Range, and the answer of the range will be range of the ideal weight. Then target, target weight. Difference, weight I need to lose or gain. BMI, my BMI. Meal plan for 7 days. Total days to reach the target weight. Weight per week, weight to lose or gain per week. So all of these are the values I need, and this is what ChatGPT will give me. So for example, in the answer, it will be like this. It will give me the answer like this, that my, let's say, range of ideal weight is, let's say 65 to 75 kgs. So that will be the output of ChatGPT, right? Then what I can do, I can say, okay, find me the range, and then it will give me this value. I will explain this further on if it's a little bit difficult now. So this is my output format. If you wanted something else, you can do that. If we were doing the recipe generator, we would do we can do a similar thing. We can write title, and then we can write give me a good title. Then I can write ingredients, give me the list of ingredients. So you can do that as well. So if you were to create the recipe part. Okay, so now that our prompt is ready, this is the user data, this is the output format, and this is our main prompt that we are going to send. What exactly do we do next? We use our button to send the data, and we create a spinner so that the person knows that something is happening at the backend. So don't worry, something is working at the backend. Then we will add our placeholder, and we will send the value to the ChatGPT. So here, did we add a placeholder before? Yeah. So here we added a placeholder, and then we sent the prompt to ChatGPT. So that is exactly what we will be doing. We will create a text placeholder, and then we will write here meal plan, or we can, yeah, let's keep it meal plan. Generate text, OpenAI Streamlit is the same name. Yes, is the same name. Okay, so we have the client, we have the prompt, and the model we are using is ChatGPT 4, so that it gives us good output, right? ChatGPT 3.5 will give you good output, but it will not be as good as ChatGPT 4. So we are trying our best to get the best results. Again, it's a trade-off between price and what do you call accuracy and speed and all that. So you can play around with different values. Okay, so now what I want to see what exactly is ChatGPT giving me, because that will tell you the real story. If I refresh this, there you go. This is all the values, and I can simply press generate meal plan. If you wanted to change, of course, you can change the values. But let's see what it gives us. Creating a meal plan. Why is it taking so long? generated 215 words, but it didn't show anything. Why is it not showing anything? Because we did not give the placeholder. My bad. We need to give the text placeholder. So like this. And that's why I was wondering, why is it taking so long? It should not take that long. Anyway, so let's generate meal plan, and right away it will start writing all this stuff. There you go. So as you can see, it is giving us the JSON format. It is saying range is this, target is this, difference is this, BMI is this, and then day 1 plan, day 2 plan, day 3 plan, and blah, blah, blah. But there is a problem. The problem is that it's not giving direct JSON format. It is basically giving a string. It's not actual JSON. It's a string which has this character in the start and this at the end. So that's a bad thing. First, we need to remove this. Once we remove it, then we can process this as JSON format, and then we can convert. Now, how do you remove this? It's very simple. What I like to do, if I have something like this, I will simply go to ChatGPT and I will give it the input, and I will say, this is my problem. Write a simple few lines of code to remove this, right? So let me actually show you, if I were to do this, how would I do this? So I would go and copy this, and I would paste it here, and I would write, this is the format I am getting as the output. I want outputs. This is a string in Python. It has initial dash dash dash. Is it dash dash dash? What is it? This format. So it has this. It has this at the start and this at the end that I want to remove so that I can convert it into JSON format and not string. So a little bit of context is enough, because it's not a complicated thing to do. So it should be able to tell us. So it is saying to load it into JSON format, you have to include this. And before it does, it is giving us the original string, and it will write the whole code so that we know what exactly to do. So there is the answer from ChatGPT. It is giving us the string. It is telling us how to strip it. And I believe it's just stripping the first one for now. But that's the idea. If you keep asking it again and again, oh, it didn't do this, it did this. Okay, try to do it yourself. Did it remove? Doing all of that will land you to the correct answer. So this is exactly what I did. I don't want to show you the whole process because it might take a while. So how it does it, it's very simple. To remove the first one, we can write like this. If meal plan dot starts with this, if it starts with this, then we simply replace this with empty. That's it. That's all we need to do. And then we are saying if it ends with this, then we will remove this part as well. So that's the basic idea. This is how simple it is. You can remove the top part and the bottom part. And now what we should get is the final result. So if we write here that st.write, and we give in the meal plan, then this time around in the answer, if we generate our meal plan, this is not the final answer. This is what we generate by default. After generating this, it will clear the data and then give us the final result. So we are waiting. There you go. And then there you go. So now you can see this is the actual data we are getting. So the front and the back has been removed. And now we can simply convert this into JSON format, because right now it's just string, it's text. So, and everything is cleared. So we can simply convert it into JSON And to do that, we are going to load our JSON. This is available by default, so you don't have to worry. It's very common. Import JSON. And now what we can do is we can convert it into JSON. So meal plan JSON equals JSON.load, and we just send in our string, and that's it. It will convert it into JSON. Now comes the best part. The best part is that now I can say range and it will give me the value of range. I can say meal plan, it will give me the meal plan. That is the best part, and that's how you can split your data. So in order to make it beautiful, what I will do, I will make it in 3 columns. So we will write, first of all, we will write meal plan, and this will be the title. And then we will have 3 columns. We will split it up. And then each one of them, we are going to add something. So for example, if I wanted to add, let's say in column 1, I want to add a header range. And below that range, I want to give in the actual value of the range, nothing else, no text, no nothing, just the actual value. So what I can do, I can say meal plan JSON, give me the range value. That's it. That's how simple it is, right? So I can write st_write meal plan, and this will give me the range. Similarly, I can get the targets. So anything that I have here, I can write here. By the way, you cannot write R capital because this is the actual value we are referring to. If we said range with R small, then it has to be R small, like this. Here, this is just a title. Title, you can write anything you want, but here we are getting the actual value, so we cannot write it like that. So then we will do it for the other 2 columns. This is column 2. We are going to add our BMI and the days, total days. This is what we wrote here, total days. Then the difference and the weight per week, how much I need to lose. And at the end, I will give in the complete meal plan. Now, there is a task I want you to do to try it out. But for now, let's just run this and see. So this is the meal plan, the 7-day meal plan. It will give at the end. So if we go back and refresh this, then it will generate the meal plan. Now, the thing is, you don't want the user to see this because this is something happening at the back end. So you can remove the text holder part and you can just say creating meal plan, and you can even give a progress bar that shows any arbitrary value that it's running or doing something, right? So you can just take an average value, how long it takes, and so on. Something bad happened. Oh, okay. So it waited a little bit. That's okay. So this is our answer. But when we format it, this is what we get. See how beautiful that looks. If you give that to a person, they will be like, are you serious? Did I pay you for this? But if you give that, yeah, that makes more sense. So here we have the range is from 53 to 72 kgs. My BMI is 27. I have to lose 10 kgs. So target weight is 70. And days, you should do it in 140 days. And per week, you should lose 0.5 kgs. Now, this is where I want you to jump in. This is in JSON format, and it's displaying in JSON format because we are simply taking this part, which is meal plan, which is a JSON inside a JSON, right? So what I want you to do, go ahead and break this down into columns and put them one by one. Write a title, day 1, then breakfast, lunch, dinner, and give the actual values. Then day 2, breakfast, lunch. So you can do this in a loop, or you can do this in columns. Because we already know it will be 7, you can hard code it, but that's not a good way to do it. So try to do it with a for loop 7 times, and then take each value one at a time, and then write the breakfast value, write the title, then write the lunch, then the breakfast, the lunch value, and so on. So this is a task for you. I'm pretty sure you can do this because it is so clear, because we have done exactly the same thing here. You have to do this, just put it in a loop and get the values from, instead of getting from meal plan, get the values from meal plan JSON meal plan. Okay, so you can write it like this: my 7-day meal plan equals meal plan equals this. And then from there, you can say my 7-day meal plan at, let's say, day day 1. And then you can say, for example, breakfast. So that will give you the exact value of the breakfast that it was showing. And then you can do the same for the lunch, same for dinner, and then you will put that in a loop to do 7 times, so it will display everything in detail. So that's basically the idea of our project. I hope you like this. It is very interesting to get what you want when you are referring to AI. Then it's like a superpower you get, and you can create so many amazing apps just using this formula. So now we are going to go ahead and create a coloring book app. So what it will do is it will give you different forms of coloring pages. You can define how many pages you want, and it will give you a very good style of coloring pages, as you can see here. So if we move around, you can see these are some of the outputs that people have gotten. And if you wanted to check what was the prompt, you can even click on it and it will tell you the exact prompt that was used to actually create this. Now, right now we are at Civit AI. So on this website, you can find lots of different LoRas that people have trained and fine-tuned to do very specific tasks. For example, in this case, we are doing it for coloring book. Now, you can also find similar things on Hugging Face. Now, this is the same person who has provided Artificial Guy BR, and I believe it's the same name here. Where is the name of the person? There you go, Artificial Guy BR. So it's the same person who has provided this on both platforms. But in case you didn't have, you can download from Hugging Face. You will find some there. But with Civit AI, you can see some examples as well, like what people are making, and you can look at the prompt as well. What exactly did they use to generate that? And it is a little bit more detailed when it comes to Civit AI. So I will show you both ways how you can download and use them. And the good thing is it will tell you what is the base model. So we are using SDXL as our base model. So in order to run this LoRa, it will be very easy and efficient for us to use it with our SDXL base model. So the idea, again, if you are not familiar with why we are using LoRa's, I explained this earlier. You have a base model that can do variety of good things, but it's not specified to do something. For example, if you ask it to create a logo, it will not generate good logos that you can use at the very end. What you can do is you can give it lots of different images of logos. You can train a LoRa, and then using that, you can get very specific kinds of results. So similarly, you can ask your AI model to give you coloring book examples, but if you ask it, it might give you something similar to contours. So if you just say, the other day I was talking to a person and they said, why don't you just tell the AI to draw lines or to highlight the edges? So if we do that, let me show you what happens. So that is called contours. So if we do edge detection or contour detection, this is what we get, right? So this is the image. This kind of image is what the result will be. So that's not what we want. That's not what a coloring book looks like. So in order to get a good coloring book, there needs to be very specific examples of what coloring books are. So that's what this person did. They collected the data of these coloring books, trained a LoRa, and then using that, now if we use this LoRa and we tell it to create any kind of coloring book page, it should be able to do that. So two methods. How can you do this? You can go ahead and copy the diffuser part, and you can copy this and paste it in your Python code, and it will automatically download in the cache. Then from cache, you can copy and paste in your model like we did before so many times. The second, or the more easier way to do this, is you go to Civit AI and you download from here. So this is the safe tensor file. It's only 162 MBs. So you click on that and it will start the download. And once it is downloaded, you can see here, this is the download file. What we can do is we can go to our models. We can right click, open in Explorer. And over here, we can create a new folder called LoRa's. It's up to you. We are doing this so that it is a little bit different and easy to differentiate. So then what we can do is we can simply drag and drop our LoRa here. And remember, it's just one file, safe tensor file. That's it. So once we have it here, then we can directly access it from here. So here we have our LoRa ready. So that's the second part. So the first part is here. If you download it directly from GitHub, not GitHub, Hugging Face, then this is what you will get, and you will link it over here. It's the same thing, right? It's the same safe tensor file, and that's pretty much it. But it's a little bit more folders. That's the main idea. Okay, now to create this, we are going to go ahead and create a new directory. We are going to call it coloring_page. And we are going to right click, create a Python file, coloring_page. And now we are going to use our offline module. So earlier we did recipe generator and AI meal planner. We were referring to our online module. Now we will refer to our offline module. So I will copy this code and it will add this path to the system, and it will make it easier for us to access our modules. So here we will write offline module. So now we have the access to the offline module. The next thing is we define the path. So if we go to code basics, we go to offline basics, and if we go to offline images, there you go. This is the code that we need. So no, actually not. Let's not go to offline images. We'll go to offline module. So if we go down, if we go to our image generation, we can simply look here. What exactly are we getting? And we can copy all of that. Image generation. So we can copy and we can paste here. We can uncomment this. So this is for image generation. We can say, first of all, coloring page. And then we have the SDXL path. So this will be, this path is going to be, yeah, it's going to be here. It's the same path. Then we have the definer. Now this is up to you if you want to use the definer or not. For now, we can skip the definer. You might get better results with the definer, by the way. So it's up to you if you want to do that. Then we will put none here. And then we have the LoRa path. LoRa path, we can simply now copy from here. We can right click and copy reference, and we can paste this here. There you go, models, LoRa's, and then safe tensor file. Then we will get the base and the definer, and then we have the input prompt. What exactly is the prompt that we are going to give? But here we have to add the trigger as well, like we said earlier. So the LoRa trigger is coloring book and coloring book. So if you're not familiar with the trigger word, then you can go to the Civit AI, and here you can see these are the trigger words. You can see here coloring book and coloring book AF. So that's the basic idea. And then we have the button to generate the image. We have a spinner that will generate the image. And then we are basically sending and receiving the image, that we are sending the prompt and we are receiving the image. And yeah, that's the basic idea. We can skip the definer because we don't have the definer, and it will display the image. So this is for when you just want one image, but later I will show you how to add a slider so you can have multiple images. But first, we are going to go ahead and test it if everything works. So we will right click over here and we will open in terminal and we will say Streamlit run, and we are going to say coloring_page.py. So there we have it. It is loading. So here we are having a problem. The provided pre-trained model or path for stable diffusion is not correct or invalid. Why did that happen? So we are in coloring page. We need to go back. We need to go back. Oh, we need to go back twice. So that's the problem. So I believe we have to do that here as well. So we have to go back twice. If we refresh this, yeah, now it's loading. So it will take a while to load. You can see here it will start loading, and the very first image that you generate is going to take a while, but after that the generations will be very fast. So here you can see right now the GPU is not completely loaded. So if, for example, we generate the first image, we say lion, now it will start bumping up and it will start sending the model to the GPU, and then once it is loaded it will stay there, and then we can keep making changes here, and it should not affect as long as we do not make any change in this part, load model. If we change something here, then it will have to reload again, but if we don't make any changes there, then it should be fine. So let's wait for it to finish. The first image is going to take a while. As you can see here, it will start the iterations once the complete model is loaded, and then it will generate the image. So now I believe it has been loaded completely and it is generating the image. So 20 out of 20 iterations have been done, and after the iterations it takes a little bit time to load up, and it should show us the image here. There you go. So that is the image of lion. It looks really good. Now, one thing I'm noticing here is that it always gives a lot of details. So what we can do is we can actually add here that give lower details. So we have LoRA trigger, we have the prompt. By the way, it's not a good idea to do it like this. We should have, we can call this user input. This is the LoRA trigger, and then we can say prompt. So the prompt should be ready before you actually send the whole thing. So user input plus LoRA trigger plus we can say low details and simple. That's what I was referring to. So I think it can read my mind as well. Yeah, there you go. So we are writing the prompt here. So now if we refresh this and we generate the image again, then it should not take as long as it did before. So here you can see it took 1 minute, 2 seconds to generate previously, but now it's only taking 11 seconds because the GPU is already loaded with our model. So it takes much faster. So there you go. The details are pretty much same like before, but as you can see, sometimes it gives too much detail, and then that could be problematic. So here you can write anything. You can even write a person. So we saw the images of Emma Watson. So we can write that. Emma Watson. Let's try if it gives us the image. So here you have 1, 2. There you go. And of course, you can use the definer as well if you wanted more detail. So there we have the image of Emma Watson. That's not Emma Watson, is it? Maybe if we remove the low and simple, let's try that again, because that's not Emma Watson for sure. Emma Watson. Yeah, there you go. Much better. But this is again, you can see now it's too much detail. It's not looking like a coloring book. So you will have to add probably low detail or something like that. Let's remove simple and just keep low details, something like that. Anyway, so you can keep experimenting, but the idea here now, what I want to add is the option to have a slider so that you can select how many images do you want. Because I can see this happening in a school environment where a high school teacher, for example, she wants to create 10 images for different images for every children to color and have an interactive session. So what you can do is you can just move the slider, 10 students, it will generate the images and print them out. So that's a useful scenario. So here what we can do is we can copy and paste. This is the slider. So what you can do is number of images equal slider dot st.slider, select number of images to generate. It can be from 1 to 10 and the default value will be 2. So that's what it is saying. And then what we can do after that is, instead of generating one image, we are going to generate based on how many images are coming from here. What is the number of images? So how can we do that? First of all, we are going to introduce a progress bar so that the user knows what exactly is happening. Otherwise, it might be a little bit difficult for the user to be patient, right? So we are introducing a progress bar. Then what we will do is we will adjust the generation based on columns. Now, I don't want to generate, if you wanted to generate on top of each other, then it's simple. You just generate all of them and it will line up very easily. But I don't like that. I want to do it in different columns. So column 1, column 2, column 3, column 4, not column 4, column 1, column 2, then column 1, column 2, column 1, column 2. So we should have 2 columns. That's what I want to try out. So how can you do that? It's very simple. We will remove that. And here we are going to write that we want to adjust for image generation. So what we are doing is we are looping through all the images depending on how many did we say. So if we said 1 image, it will do this 1 time. If we said 2, it will do this 2 times. So that is what this is doing. Now, the second thing it is doing, it is checking, do we need to create a second column or not? Because when it displays the first image, it needs to generate 2 columns. Then when it's doing the second image, it should not generate a new column. It should generate when it goes down and then it starts, right? So generation of columns should happen every second time. 0, it should generate. 1, it should not generate. 2, it should generate, and so on. So that's why we are checking if it's divisible by 2, then generate the column. Otherwise, don't generate the column. So this means that when you divide it, either it will give you 0 or 1. If it's divisible by 2, it will give you 0. If it's not divisible by 2, it will give you 1. So that's the basic idea. It gives you the remainder. So then we can say that generate the image. Okay. Now where to place is a different story, but we are going to go ahead and generate our image. What was the exact name? Wait. So offline module. This is how you generate the image. Let's copy that and paste it here. Okay, so we remove the trigger and refine it. So that's how you generate the image. Now, once you generate the image, then you need to display it. Where do you display it? Again, it is based on this value, the value of I. If the value of I is 0, it should be here. If the value of I is 1, it should be here. If the value of I is 2, it should be down, below this. And then third one like this. So 1, 2, 3, 1, 2, 3 like this. So based on that, we are going to put it, no, what is happening? Okay, so with columns, again, we are checking whether it's 0 or 1. It will toggle between 0 and 1. And then what we do is we simply add our generated image. That's it. And we give it the column width true so that it completely takes over the column, whatever size is available. Okay, so that's the basic idea. And then we need to update our progress bar. Updating the progress bar is very simple. You take the total number of images, because right now it will start from 0. I will start from 0. So we don't want that. We will start from 1. So 1 divided by the total number of images. And then it will give us the percentage. So we just multiply it by 100 to give us the percentage, and we convert it into integer. So we don't have a floating point. And we will put that in our progress bar. So that's the basic idea. And if we go ahead and run this now, if we refresh this, now we have the option of adding as many images as we want. So let's say we add 4 images and we say of, let's say a car, and then we generate the images. So here, once it produces 1 image, the progress bar will go forward. then the next it will go forward, and so on. So this way it will be easy to look at the progress. So right now you can see the GPU is really working hard. There you go. This is your first column generated, and then the next image should be generated in front, and then the image after that should be generated down, and so on. So, and yeah, one more thing you can do, which we will do in the next projects as well. You can basically add checkpoints here, checkboxes. For example, you want simple quality. For example, you want detailed, or you want a car inside that, no humans. You can put checkboxes, and whenever you click one of the checkboxes, it is going to add something to the prompt, and it will make it easier. So here you can see all of the cars, they are very similar, and you can see the theme is similar. So that's a good idea if you were giving it to, as a coloring book, as a complete coloring book. So there are some similarities in that. So there you go. We have generated 4 images, one by one, each in a different column. So that's the basic idea of our coloring page project. Next up, we are going to look at more details of how we can create other projects and enhance them. So now we are going to go ahead and create a sticker generator. So it might seem very simple, but when you are actually asking your default model to create some stickers, this is not what it will generate. So these are some really good examples of how you can create not just stickers, you can even create a sticker sheet which has different types of fruits maybe, or vegetables, or cars, or stuff like that. So that's the basic idea. And here you can see we are at Civit AI, and I've just written sticker and searched for them. And you can see all of these are LoRa's basically, but the one that we can use right now are with XL. So this is the base model XL. You can filter from here. So for example, you can write, this is the SDA XL 1.0 we are using. So it will only show the ones that are compatible with this. So for example, we can use this. Now, if you wanted to use the other ones, for example, this one, if you wanted to use, or this one, then you can check their base model. So for example, if I click on this one, and the base model of this is 1.5, so stable diffusion 1.5, and I can go to my models in Hugging Face, and here in computer vision I can write text to image, and here I will see all the base models, right? So different base models. So we have here stable diffusion 1.5. So we are using diffusion XL base 1.0. If you wanted to, you could use this as well. It's up to you, but this is a previous version. So that's why we are using XL, and you can copy this and paste this, and then download the base model, and then create a function for this, for running this base model as the base model. So, or you can embed to our own existing function. So it's up to you which one do you want to use. We are going to stick with our base 1.0 for XL because that's the newer version. So again, you can use this as the sticker, or even this. Actually, I like both. So I'm going to try out both of these. So this sticker sheet is a very good one because you can generate a complete sticker sheet with robots, and it looks really good. So all you have to do is you have to click on download. It's just 27 MBs. And here again, this is, by the way, from the same guy, I believe. Yeah, Artificial Guy BR. Is it the same guy? No, Rude 78. So thanks to all of them who are providing this for free for us to try out. And what we can do is we can download this one. Did I download this one? I think I did this. Now I have to download this. Yeah. So you will download these, and then you will take them to your, what do you call, LoRa folder over here in the models. We will open this up, right click, open in Explorer. And inside this, we can simply paste our new models. So this is the one for sticker sheet, and this is the one for just the sticker. So what we can do is we can go back to our coloring page, because coloring page and this project is pretty much the same. So we can write here sticker underscore generator. And when we open that up, we can change the name of this. You can double click it, right click here and rename file. So we can write here sticker underscore generator. And again, here we are going to change this to sticker generator. And this is going to be the same path. For the LoRA, we are going to change. So let's pick the one for the normal sticker, let's say first. Models, LoRa's, and sticker. Why is it not showing up? STIC. Stickers, no, it's not showing up. So we can just copy the path of that file name and we can paste it here. So yeah, that should be good. And then the rest of it, what you have to do, you have to make sure that you are using the correct trigger words. So here for this one, the trigger words are stickers and sticker. So here we can write sticker in our sticker. I think that should be enough. Sticker. STICKER. I never learned spellings. I need to learn more. Okay, so the idea now is that we have pretty much the same thing. We can remove the low details and yeah, number of images and this and that. The rest of it should be pretty much the same. So we can right click on the sticker generator, open in terminal, and then we can simply write Streamlit run sticker underscore generator dot rate generator dot py. So now it should load up. So our sticker generator is now loading up. So here we can write, let's say, cute lion, and let's see what it gives us. So there we have it. As you can see, these are very good stickers. Now imagine without using the LoRA, this would be very hard to generate. So sticker like these, they are very high quality and very realistic. Not very realistic, very cartoonic, and the kind that children actually want to interact and work with. So this is very fancy. So let's try another one. Let's say we add car and let's see, actually let's write cute car and let's see what do we get. Okay, this is funny because it generated cats instead of car. I guess it got confused with the word cute. So let's try again with a car. Okay, so that looks more like cars. So this one has a background as well, which looks like it's an interior of a car, but this one is a good sticker with a car and some flowers and some cuteness with it as well. So what we can do now is we can try the other sticker, which actually generates the complete sticker sheet. And that will be interesting to see how that works. So we can go ahead and terminate this, or you can press Control C and it will stop. So here what we can do is we can remove this and we can copy the name of this path file name, and then we can simply paste here. So now what this will do is it will allow us to create sheets, but we don't know the trigger word. So let's go ahead and check the trigger word. So this is the one, and the trigger word is sticker sheets. So here we are going to replace this with sticker sheet. So let's rerun this. So let's create of fruits. So there we have it. Sticker sheets, 2 sticker sheets of fruits. So they look very good. They are not bad at all. So now let's try out some other ones. So let's say we will add cute sparkle rainbow unicorn. So let's try that out. So there we have the results, and I would say not bad at all. They are looking really good. A lot of fun for the kids. There you go. So that's the idea of how you can create stickers. You can basically use your own model. You can create your own LoRa's as well, or you can find some online to create your own sticker styles. So now we are going to go ahead and create a logo generator, which will allow us to create different types of logos. And the addition that we are going to do for this project will be the types of logos that you can generate. So you can click on a checkbox and it will generate a minimalistic or black and white or something like that. So the idea is, again, we will be using our base model, Stable Diffusion, XL, and then we are going to add onto that a LoRA. And we have a lot of options here that we can select from. So again, we are at Civit AI, and all we have to do is you have to type logo and it will give you the LoRa's for logos. And again, we will have to filter by SDXL because those are the ones that we can use with our model. So that's the basic idea. Here, for example, this is the most popular one with 30,000 downloads. So we can click on that and we can simply download it, which is only 160 MBs. So let's have a look at some of the results. You can see they are pretty good. And well, that's not a logo, but okay. So some of them, they are not logos, but that's okay. Some of them are really good. What is that for? I want to see the prompt. So it's skeleton with bottle of water logo. Okay, that's interesting. So now that it has been downloaded, I just copied and pasted it here. This is the logo Redmond. So what we can do is we can copy our sticker generator, and it will be similar to that. So we will write here logo generator, and we will close this, open up the generator, open this up, right click and rename file. So we will write here logo instead of sticker. So logo generator. So we will have the slider to select how many do we need, but we will add on our checkboxes that will allow us to generate very specific kind of logos. So again, we are using the offline module. We have the logo generator this time around. We are loading our base model, and then we have to load our LoRa, and we can type in here the name of that. So this one is logo, right click and copy and file name. So we can simply paste that here. So now it should work. And then what do we have? Then we have entered the prompt. So whatever prompt that you want, for example, we can say car. So design a logo of a car. For the trigger, we can check it over here. So it is logo. We can simply copy that and we can paste it here. And then it will add to our prompt. And yeah, that should give us our sticker. So for now, let's go ahead and try it out. If we are getting the correct stickers and everything is working, then we will add the checkbox part and we will see how that works out. So we will go to our logo generator, right click, open in terminal, and we will write Streamlit run and logo underscore generator dot py. So there we have it, our logo generator. So let's go ahead and generate some logos. So there we have it. These are the logos that were generated. So what we can do next is we can define what kind of criteria do we want. So in order to do that, it's actually fairly simple. So what we will do is we will go back to our model, and here we are going to, after the slider, we are going to add some columns, and these columns will have the additional checkboxes. So let me show you here. So we are adding up 5 columns. That's what we are doing in the first line. And with each column, we are adding a checkbox. So here we are saying checkbox 1 is for colorful, checkbox 2 is for black and white, checkbox 3 is for minimalistic, and so on. So if we go back and we refresh this, we should be able to get these checkboxes. Now, what happens when we click on any of these checkboxes? We didn't actually define that yet. So in order to define that, what we will do is we will put an if condition for each one of these. So we will say that if our check 1 becomes true, it means there is something inside it. Then whatever prompt we have, we will add to that. So that's the basic idea. So here we have user input, and then we have the LoRA trigger, then we have the prompt. So what we can do is here, instead of user prompt, we can write prompt. So it will add to that prompt whatever we have added. So if it was checkbox 1, it will add colorful. If it was checkbox 2, it will add black and white. So we are just putting a comma and then we are adding to that. So you can have multiple checkboxes as well. So for example, you can say black and white and minimalistic, right? You can say colorful and circle. So that's the basic idea. And what else can we do? So once that is done, it is going to go into the prompt and it will get sent. But I think we should add for the user input, we should add here, instead of logo, we can say logo of a, and then we can add the user input. So this way, I think it will be better, logo of a whatever car or design and whatever you like over there. So the rest of it should remain the same. So if we go here and we refresh this, so now we have the option. So here, let's say we put it circle and we put it black and white and minimalistic. So 3 of these we are selecting, and let's go ahead and run that and see if it's any different than before. So there we have it. The first logo has been generated. And as you can see, it is minimalistic, it is black and white, and it is circle. So you can see it is actually checking all of these parameters and making sure that they are met. So if we were to do the same thing with colorful, then that would be different. So there you go. It is black and white, as you can see, and it is of a car. So you can say that. So next, let's try out of a flower shop, and we will add 4 of these. We want 4, and we want it to be circle, we want it to be colorful and minimalistic at the same time. So let's see what it generates. So there we have it. We have generated 4 of the logos, and as you can see, they are quite good, and especially the first one looks really good. It is colorful, it is minimalistic, and it is of flowers. So I would say definitely a win-win. So that's the idea of how you can create different logos using our new logo generator. So next, you should actually go to Civit AI, or you can try out other different LoRa's to see what kind of results do you get, what kind of logos can you generate. So if you want any specific style as well, for example, black and white like this, you could try this model, or something similar to that, you can try that. So again, depending on what kind of designs do you want, you can generate your own types of logos and a logo generator. So now we are going to go ahead and learn how to get semantics of a photo. So you might ask, what exactly is semantics? So if you look at an image, for example, this is the image, and let's say I said that there is a cat in this image, and that's it. So that would be object detection or object classification. So in object classification, it will classify, is there a cat or is there no cat? So that is object classification, yes or no. Then this next step of that is object detection, where it will specify, okay, there is a cat present at this region. Now, if there were multiple cats, it will define, okay, there's a cat here as well, there's a cat here as well, there's a cat here as well, okay? So, but still, the only thing that it provides is the very specific object that we are trying to find. So it will say one cat, that's it. Now, what is the cat doing? Where is it? There is not much information other than the cat itself. So there comes the semantics. So semantics basically tells us, in this case, for example, it will be a cat jumping over a fence, or it might even say a kitten jumping over a fence or a wooden fence, something like that. And it could say it is cinematic shot, bokeh at the back, something like this. So it's about extracting the meaningful information from an image so that you can understand more about it. So what we can do is we can get this information and we can use this in captioning an image, or we can use this in storing images so that we can filter them later on very easily. And that is exactly what Google does. They actually get all the information from an image, they store it, and then later on when you search on Google Photos for something, it actually pops up and it shows you all the ID cards or all the cats, all the cars that are in your Google Photos. It will show you that. So basically, we will be building something like this as well. But for now, we want to look at the semantics, how we can get that. So to get it, this is a classification from image to text. So this is the task that we need to find. So here in Hugging Face, we can go to computer vision. And here we have image to text. We can click on that. And here are some of the models that can do this for us. So this is the one that is most popular so far. And this is the one that we are going to use. So the idea is that it is going to convert our image to text. And if we go to files, you can see it is almost 2 GBs, which is not bad at all. So if we go back and what we can do is we can click on use in transformer. And here you can see we have it in the form of pipeline. So we will be using it with pipelines, and we will add a new thing. I will mention exactly what that will be. But for now, let's just copy this and we will go back to our chapter 9. And here we are going to create a new directory and we will call this photo semantics. So we will create a new file, photo underscore semantics, and we are going to paste this. Why are we pasting this? So that it downloads that, what do you call, AI model. So if we run that, it will check whether it is available in your cache or not. If it's not available, it will start the download process. So there you go. It is starting that 1.88 GB file. So I've already done that. It went into my cache. I copied it and pasted it here. So where is it? Where is it? Where is it? There is the file. So you can see here is our model, which is 1.8 GBs. So that's the idea. Again, you can find it in your cache. If you don't know how to do that, make sure to go ahead and check the previous videos on offline module so that you understand where all of this is stored and how you can access it. Okay, so now in order to run this, we have to use the pipeline. Now, what we can do is we can simply use pipeline like this and it should be fine. But the problem will be that it will not cache it and it will not store the AI model in the GPU so that we can run multiple inferences. So it will load up again and again. So in order to counter that, we will add this part of using a pipeline in our offline module. So we created an offline module earlier. If you haven't checked that out, make sure you go ahead and complete all the videos before you understand this. So this is our offline module and it has a lot of things here, but it does not have anything specific to pipeline. We have specific for image generation with SDXL. We have for text using Llama. We have text using Mistral, but we don't have anything related only to pipeline. So that is what we are going to add here. We will copy this and we will just write here pipeline pipeline. There you go. So that's the basic idea, and we will put it in a function. So we will say load model pipeline, yes, and then model equals pipeline. The task and then the model path and the device. So we will be using CUDA for the device by default. If there is a CPU, you can define that, okay, that is for the CPU. And that is pretty much what we need. And we can simply write at st cache resource so that whenever we run this, it will store it. So now what we can do is we can load our model and then we can run using the model itself within our environment. So let's go back and let's copy one of the codes that has, let's say, we will copy sticker generator. We'll copy all of that and we'll put it into photo semantics. And we will keep this part. We need the offline module. We will need the title. So we will change it to photo semantics finder. And then we do not need the base module because we are not generating an image. Instead, we will be loading our own from load underscore model pipeline, and we need image to text, and we will give in the model path. So what exactly is our model path? Model underscore path equals, we have the model path over here. We will copy this snapshots and this folder. We will copy path reference, path from content root, and we are going to paste it here. And we will enter with snapshot and we will go back to spaces so that we get the access to the model. So that's the idea. And then it will be stored here. We can call it model equals this. And then we don't have any LoRa's and we can remove that. And then we will ask the user to input something. No, we don't need user input. We don't need any of the prompts. We don't need the slider. What do we need? We need the button, and that button should say generate semantics. And then it will say generating semantics, and then it will generate that. Let's remove all of the rest. Now we do need to load an image once the model has been loaded. So we are going to have a loader. So we will say uploaded image equals st.fileuploader, choose a photo, and it can be of any of these. And we do need to convert it so that we can, we do need to convert it, but okay, let's convert it afterwards. So here, first of all, we will show the image st.image, and we will show it with the width of, let's say, 300. And then we are going to go ahead and find the semantics. So we can create a function to do that, or should we just write it here? We can just write it here. Let me check what exactly is it. So how you can do this is simply by writing model, and then you have to give in the image that you have uploaded. And the result of that will be your caption, and you will get the 0 value of that, and then you will get the generated underscore text. So here, if you go to CPU or you go to expand, so all of the code examples and this stuff is given here. So I'm just summarizing it and explaining you how you can get it from here. So the model will have an output. We will get the 0 element of that, and from there we will get the generated text, and that's it. So this will be our let's say semantics equals this, and then we can write st.subheader semantics. So it will show us in big words what the semantics are. But one thing, as I was mentioning, it does not accept the direct uploaded file. The model itself, the pipeline does not accept direct model file. So we have to convert it into a pillow format. So import pillow, PIL as, no, from PIL import image. And here we are going to convert. So we will write PIL underscore image equals image open uploaded image. So once we convert the image into PIL format, then we can send it and get the response. So if we run this now, we should pretty much have the semantics. If we want to change a few things here and there, we can change it later on. But let's go ahead and try it out, and let's see if it works. So photo semantics, right click, open in terminal, Streamlit run photo underscore semantics dot py. And there we have it. So now it will load, and now we can choose, for example, let's say we wanted to check for the cat and generate semantics, and we have an error. Image to text pipeline missing one argument, images. Okay, so probably the argument here is not image, it's something else. Let's check here. It's images or what? Okay, image to text. Where does it say? Semantics model image PIL image. Okay, let's not put this here. Is it images? It said. Yeah, images. It says it should be images. There you go. Hopefully this time around it should work. So generating, and there you go. There is a cat that is jumping over a fence. Exactly what it sounds like, or exactly what it is. So one more thing we can do. I like to format this side by side. It's up to you if you wanted to do that. So here, for example, we can show the image on one side. So column 1 and column 2 equals st.columns2, and we can say with column 1 we will have our image displayed, and with column 2 we will have the rest. So this way I think it looks a little bit better. So let's try that out, and let's do the cat again. Yeah, there is a cat that is jumping over a fence. Let's try something else. Let's say this image, generate a close-up of a person holding a cell phone with a fake picture on it. I mean, come on, that's really good. And then let's say this one, and you can see how fast it is, by the way. Man in white shirt and sunglasses standing in a parking lot. Yeah, sounds good. As soon as I click it, it's there. Image of a woman running on a field with a green line. That's not really a woman, but that's okay. Sometimes it will not get the right answer, but it is close. 3 sheep standing in a field of grass with one eating. That's very good, I would say. And what else? What else? This one is the funny one. Woman riding a bike with a child in the seat. Oh my God. That is a good one. Okay. There was a man over here. Oh, there's this one with for loop. Let's check that. Stop using I in for loops. A man holding a sign that says stop using it in for e loops. Okay, close enough. I mean, with the text, it might be a little bit more challenging. But yeah, you get the idea of it. I wanted to show another one. Oh, let's see if it finds the dinosaur. Man taking a picture with the dinosaur with a cell phone. Nice. Very, very nice. There was something I wanted to check. There was a man with a pizza in front of him with a no, it's not here anymore. Anyways, so that's the basic idea of how you can actually get the semantics. Let's see how many monitors it finds here. Close-up of a microphone and a computer monitor on a desk. Not bad at all. So that's the idea, that once you get this information, then later on you can use it in different projects, and that is exactly what we are going to do in our next one. Do you want to implement your computer vision ideas to solve real-world problems, or upgrade your resume by enhancing your computer vision skills? Then the computervision.zone is the perfect platform for you. CVZone is a one-stop computer vision platform with over 100,000 users with courses sold in over 80 different countries. If you want to commercialize your computer vision ideas, then the Computer Vision Web Development course is the perfect course for you. Here you will learn the basics of web development and computer vision, as well as how to integrate them to solve real-world problems like customer engagement, car counter, face attendance, shirt size measurement, and a lot more. Advanced Drone Programming is another great course that focuses on the practical implementation. Here you will learn the basics of drone programming as well as advanced concepts like face following, body following, gesture control, and a lot more. If developing mobile apps is your thing, then check out our Computer Vision Mobile Apps course. Here you will learn the basics and create several apps including object detection, augmented reality, face detection, document scanner, and a lot more. The best part is that you will create a single app that will work both on iOS and Android. If you are passionate about integrating hardware with software, then check out our Computer Vision Arduino course. Here you will learn the basics along with amazing projects such as conveyor belt assembly, face tracking, lamp gesture control, face door lock, and a lot more. The Computer Vision Game Development is another great course where fun meets programming. Here you will learn to create games such as Fruit Ninja, Balloon Pop, Squid Game, Cookie Cutter, all using the latest computer vision techniques. Not only that, you will learn to compile your awesome game to an exe file to make it accessible to all. You can also learn to implement computer vision on embedded devices with our Computer Vision with Jetson Nano course. Here you will learn the basics of Jetson Nano and computer vision along with creating exciting projects like lane following robot, eye tracking, object following, and a lot more. All these courses have a clear path from basics to advanced with maximum knowledge in a short amount of time. So check out the links in the description to get started with your computer vision journey today. So in our previous project, we created this photo semantic finder, and while it works very well, we will add on to this to create an actual project. And this project will be caption generator. So you can add an image and then it will tell you, for example, the caption of Instagram, what you should add. And then we can also have options whether you want to add emojis, whether you want to add hashtags, whether you want to add anything specific that you would like. So what we can do is we can close this for now, and we will actually terminate our previous session that we were running. And I will close all of these and open up the photo semantics. I will copy and paste that, and I will call it caption underscore generator. And I will copy this because we have to paste it several times. Where did it go? Caption generator. We will open that up, right click and rename the file caption generator. And we will also change it here, caption generator. Okay, so now we have pretty much the same thing that we did earlier, but with the title of caption generator. So how exactly can we generate captions with this? This is the best part. Now we learned how to use offline module. We created our offline module, then we created online module. Now we can simply mix and match and we can play around with it. I can integrate the online module here and ask ChatGPT to generate the caption, or I could use one of the offline modules to ask it to generate captions. But because ChatGPT does it so much better, we are going to use online module for this. If you wanted to, with few lines of code, you can flip it and try it out. In fact, that is what I want you to do. Try it out after this, convert it into offline module as well, use the GGUF and try the Mistral as well, see how do they respond. Now to get the online module, we can go to the recipe generator because that uses the online module, and we can copy that part for loading. There you go, and we will paste it here. So we are getting the online module and we are getting the API key. Then we will simply get our client. We will initialize our client. Let's do it after we load our pipeline. So then we will have our client ready. And after that, we only need, we don't need any prompt from the user. What we need is to generate the text. There you go. So this is generate text, OpenAI Streamlit. We can copy that, and in the caption generator, we can go here, and instead of semantics, we can keep semantics as well. We'll keep it smaller. We'll put as a text, or we can write, and we can add a subheader that will say semantics. Subheader that will say semantics, and then after the semantics, it will give us the actual what do you call caption. Not here, come on. caption. There you go. So now we have to give in the prompt, and we have to give in the text area placeholder so that we can actually put it on. The text area is basically our markdown. Do we need markdown? Not really. We can get away with the other one as well. So here we need to put it after the heading, and we can put it as empty. There you go. So, and we don't need HTML, so we can close that. Okay, so now the only thing we need is the actual prompt, which will be our semantics, but we need to add some stuff to it. So what we will do is we will add our prompt. We will create our prompt after this, let's say here. So our prompt is basically based on the image description generate based on the image description generate captions. Okay, add emojis and hashtags right for Instagram, Facebook, YouTube. Here is the description. Now what we will do is we will remove these two. I don't want emojis and hashtags for now. Later on we will look into that. So this is our prompt, and now we can simply send this prompt here, and it will generate it and show us the result. So we will only want it for Instagram. Based on the image description, generate captions for Instagram. Or should we generate 1 or 2 or 3? It's up to you. Based on the image description, generate 3 captions for Instagram. There you go. Here is the description, and plus you give the semantics. So let's run this and see if it works. Right click, open in terminal. We will write Streamlit, run, and what is the name? Caption underscore generator dot py. So let's wait for it to load. So let's open that up. Let's bring in the cat, generate semantics, generating semantics. There is a cat that is jumping over a fence. Generated text, leaping into the weekend like cat of Instagram. No fence can hold me back. Jumping cat, freedom. Just a perfectly timed. Oh, that one is very intuitive. Just a perfectly timed jump over the fence. Wow, that is very, very good. So yeah, that's the idea of how you can generate these captions. And of course, you can ask it to generate more or less. But before we end it, I wanted to add something as well. The option of adding or removing the emojis and hashtags. But here you can see by default, it's doing that. So we might not have to add that. But here you can give checkboxes that if you did want to add it, you can add that as well. But because Instagram, they require these hashtags, I think it might be a bit redundant. So maybe we can skip that. We can simply write it like this, like I did before. Add emojis and hashtags, at least 3. Yeah. And you can generate for Facebook, Insta, and stuff like that separately if you wanted to. Anyways, so let's go back and run it with other files. Let's say this. What does it say? Caught red-handed trying to fake the perfect selfie. And it gave emojis, and it gave these hashtags as well. Just a friendly reminder, not everything you see on social media is real. I am amazed, I'm shocked with how good this caption generator is. So you can have all of this. If you wanted to, you can add the caption down, because maybe it's not looking good this way. So in order to do that, you can simply do it outside. So once you write the semantics, you can basically do all of this outside. So let's try that. Let's try which one. Okay, I'm having a difficult time deciding. uh, let's try this one. So here, a woman riding a bike with a child at its seat, enjoying a bike ride with my little sidekick. Mom life, outdoor adventures. It's for sure an adventure for the kid as well. We can see she's enjoying a lot. I think the earlier design was better when you had it here. I think that was better. And we can remove the semantics completely if we wanted to. So you can remove this and you can push this in front, and now it will only generate. Why is there a underscore here? Remove the underscore, please. Caption generator. Let's refresh that. There you go. Caption generator, and then we can generate for the cat. Caption. Yeah, leaping into the weekend and so on, and that's good. So that's the basic idea. What if we do HTML? Let's see, what if we do HTML? Will it expand by itself? Maybe. Because right now it's not expanding. So if we put this as an HTML true, why is it capitalized? HTML equals true. Let's see, how does that work? Let's pick any image. Yeah, that looks much better. Yeah, I like this more. So that's the idea. So you have the caption, now you can generate these, and you could even do, maybe make this a title, or make this a header, and header, and make this a subheader. Can we make this a subheader? No, it will be difficult. Anyways, so that's the idea. Let's refresh it and try it one more time. Again, I'm going into the details of design, which is not a good thing at this point. We are just doing a simple caption generator. Just grazing with my squad. Sheep life. One of these things is not like the others. Oh, because one of them is eating. This is really good. Living my best woolly life in the great outdoors. Sheep goals, grass is greener, nature photography. I mean, you can see how good that is. Anyways, so next up, we will add more functionality to this. Using semantics, we can do much more. So we will have a look at that in the upcoming projects. So in this project, we are going to create a Google Photos replicator. So the idea is that when you go to Google Photos and when you upload your photos, what happens is that it saves the meaning of those photos as well. So next time around, when you search for a car, for example, or for a person, then it will list down all the images that have that category. So it is very convenient this way to find different images of the past, and it makes the organization very simple. So what if you wanted to create this for yourself, or for a company, or for your organization? What can you do? So this is the basic idea of how we can do this. The first thing we will do, we have an image, for example, we will upload it. Now, once the image is uploaded, we will not save it. We will first get its semantics. Once we get the semantics, for example, in this case, man wearing glasses, then we will save the image in our directory. So somebody uploaded it, but we are saving it in our database, and we will give it the name with a unique number so that it's not copy and paste. You know, two images can have same semantics, but they cannot have the same unique number. So we will give it a unique number, and then we will give it the semantics. So man wearing glasses. So next time around, when we want to filter it, we will just search for the images that have the name man, for example, in it. And then it will list down all the images of man. Or let's say in this case, we have a cat jumping a fence. We will save it. And here you can see, if I move around, there you can go. Or is it hard? There you go, jumping a fence. So that's the idea. So we will get the image, we will get the semantics, we will save, or we will rename the image and save it. And then from that, we are going to load up our filters. So here we are in our project. And what we will do is we will copy photo semantics, because this is very similar to that. And what we will do is we will write Google Photos replica. So that's what we are trying to do. We will open this up. We will open the file, right click and rename file. And we will write Google Photos underscore replica. So the idea is very simple. Google Photos replica. Now the idea is very simple. We have a lot of things that are actually more towards the graphical interface rather than the actual AI part. So we are going to quickly go through this. And I will be honest with you, a lot of this code that is available for this project, I have written using ChatGPT. So, and you can do the same thing. The only thing I recommend is that you break it down into functions and then ask ChatGPT to actually write the functions for you. So in that way, it's a little bit easier to work around with instead of just saying, okay, I want this functionality. So it becomes easier to actually write the code. So I've written down a bunch of functions with the help of ChatGPT, and we will add it here to get our results, the desired results. So first of all, we are loading our offline module, and then we are loading our pipeline where we will get the semantics from. And then we are using a file uploader to upload all the files. And then we are simply displaying the semantics and the the image. Now that's not what we want for this instance. So what we can do is we can comment this out for now. And what we will do is instead of upload image, we will say uploaded images. And over here, we are going to give in the value that accepts multiple files equal true, because we can have multiple files uploaded at the same time. That's why we have to write it like this. Now we are almost ready to begin. So what we want to do is we want to load our model so that we don't have to load it again and again. And later on, we can keep adding the code. So let's go ahead and run this. So right click, open in terminal, and we are going to write Streamlit run Google underscore photos underscore replica dot py. So let's wait for it to open up. So there we have it, Google Photos replica, and now it's loading the pipeline. And once it has been loaded, next time around, we don't have to load that. We can just keep writing the code and we can keep testing. Now, one more thing I wanted to share is that in the resources, I have some test images for this. So you can add your own test images and you can try it out. So just go to your pictures, copy paste a few things, and that's it. So we will be using these images as a reference. That's why I was sharing that information. So let's actually check what's going on with the GPU right now. Yeah, it is kind of loading. Let's wait for it to load completely. And there we have it. So now it has been loaded and we can browse files and we can select, and that's it. So once we select, what's the next step? The next step is that we make sure that we have an uploading directory. So in order to do that, we are going to right here, right after this, we are going to ensure the directory for upload images exist. So what is the directory name? Uploaded images. And os.make directories upload directory. This is the name. And then if it's available, it will not give an error. If it's there, it's fine. If it's not there, it will create it. So that's the idea of this. So if we refresh this, then it should upload, it should create this. As you can see, it created this folder, uploaded images. So once that is done, now what we have to do is we have to give a key for our uploading session. Now, this is a little bit tricky because what happens is that once you upload a few images, 1, 2, 3, 4, let's say I upload these images. Now these are in the states. So there is a state in which these 4 images have been loaded. Now, next time around, when I add more images, those images are also there. The previous ones are also there and the new ones are also there. So that's problematic because if I keep uploading, it will keep uploading multiple times. So let me explain it one more time, that if I upload, let's say 1 and 2 images, then I upload 3 and 4, then all 4 images will be uploaded and I will have a total of 6 images, 2 from before and 4 from now. So that will be quite messy. So we have something to reset the uploader once we want to upload again. So to do that, we have a unique ID that we have to define. So we will check if file uploader key not in st session state. So this is the state in which we will check if there is a file uploader key. We assigned it a file uploader key. If it's not there, initially we are going to assign a key. Now, how you can do that? You can simply write session state file uploader key equals this. This can be any number, any unique number. And to find unique numbers, there is a library that we can import that will help us create this unique ID. Otherwise, you can have multiple IDs similar, which will make it difficult. So that's what we are saying, that give it a unique number. Every time you upload, let's say give it the number 5. Then next time it upload, give the number 1020. Next time 600. I'm making it simpler than it is, but that's the basic concept. So that every time it knows it's a new upload. So it will reset the upload instead of using the previous images. Okay, so then we have to load our pipeline. We have done that. Everything is good. Now we need to check, did we upload any files? We will check if is there something in this. If that is the case, then we need to start the saving process. So I will paste it here. I will paste it here. If there are files in our uploaded images, then we need to send these uploaded images to a function called save and process files. We did not write this function till now, but that's the idea. That once we have our files, we will take the files and we will take the upload directory, which is basically uploaded images, and we will send it to process. Now comes the fun part with the functions, the ones that ChatGPT wrote for us. So the first function is the big function, which will, have other functions in it. It's the save and process files. So what happens is that it will send us all the files and then we will loop through all the files. Each file we are going to open as an image. We will convert it into an image, right? Because it is an image. And then we will get the semantics of it. So to get the semantics, we will create a new function called get image semantics. So we will create a new function here, get image semantics, right? Actually, that should be above this. Get image semantics. Now, what this function does is it only does this part, this model equals this, and that's pretty much it. So we can remove all of that and we can simply send in our image and we can get the semantics. By the way, we need to convert the image as well, or is it already converted? Yeah, it's converted because we are writing here image.open. It's already converted to PIL format. And then we are sending the image. Once we send the image, we get the generated text and we send it back. That's it. That's how simple it is. So we will say, instead of saying detected classes, let's say semantics. Okay, so this is our semantics. And now we will send the semantics to save the image, right? Earlier we said we will upload the image, that's done. Then we will get the semantics, that's done. Now we will save the image. Before we save the image, we need to create a name for that image, right? Using the semantics, using the unique number, and using the extension of that file. So we need to process all of that. In order to do that, we will create a function called rename and save file. So I will copy that and I will paste it here. So this is rename and save file. So what this will do is it will have the image that we want to save. It will have the upload directory where we want to save it, and it will have the semantics because that will be the name of our image. So what we will do is, this is our new file name. How are we creating this? We are using the same UUID library to actually give us a unique ID. And then we are giving our semantics. Then we are giving our semantics, and then we are writing .jpg. So we are saving it as JPG. And then we are joining it with our directory where we want to save it. So this is the file name. This is the file name plus the directory path. And then we simply write image.save, and that will save our image in our uploaded images. So if we run this now, it should save, but it should not filter, right? It should save the file, it should have the name and everything, but it will not filter. So let's go ahead and try it out. So if I refresh this now, and if I go and upload 2 files, open it up, and now it is running. So if I go here, it will show me something probably here, or not yet. Is something happening? Is it loading? Yeah, I think because it's running for the first time, so it is loading it. Once it is loaded, then we should be able to run it without any issues. So I think it has been loaded. And let's open uploaded images. Right click, open in Explorer, and there we have it. So there you go. Now if you look at this, it has the name, image of a man wearing sunglasses on a computer screen.jpg, a pizza with cheese and basil on it on a cutting board. There you go. So now you can see our files are saved with the semantics. Now that's all good, but we are not able to display it. We are not seeing the images, and that's the main point of it, that we want to see the actual images. So how can we do that? To do that, we will go down, and by the way, one more thing we have to do. If you remember, I mentioned that you have to update. So if I go here and browse, and if I upload, you will see that once it uploads, it will upload the previous ones as well. So you will see multiple uploads of the same image. You can see now there are 2 pieces, there are 2 people, 3 actually, 3 of my images, 2 cars. So it's this is the thing I was mentioning earlier, that it will, if it's not reset the state, then it will keep uploading the old images as well. So in order to fix that, we initiated this as the key, but we never changed it. So we need to change it after uploading each time. So session.state file uploader key equals this, so that it can generate a new key every time. So what I will do is I will delete all of these in the upload images. And now if I go back, if I refresh this, This time around, let's say I upload pizza and the person. Now 2 images will be uploaded. Now if I upload again, let's say the car and the mic, then it should only upload car and mic. And that's not the case. So it should be like that, but it didn't happen. So we will have to check why. So as you can see, the problem is there, but it's not fixed. We just need to check why it's not fixed. So session state is file uploader key is this. This is this. This is this. After it uploads, it should saved files. Actually, we don't need this because we are not sending anything back. We are just processing the files and that's it. We don't even need to write that. So yeah, save and process files, rename and save file. Yeah, it seems fine, but it's not resetting the states. Session state, it's not resetting. Session state file upload, is it the same spelling? File uploader key, file uploader key, file uploader key. So it should give a unique ID each time. What if we put this right after rename and save image, save and process files? Right after this, let's put it here. And we will put it outside the for loop. Let's try that out. Refresh. I will delete all the images. Now if we upload the first one is uploaded. Then if I upload the second one, the second and first both are uploaded. So that is the issue. I'm still facing this issue. The state, it seems it's not updating the state. So the session state. Why is that? Oh, okay. Yes. My bad. So when you are giving the file uploader, you have to define a session state key here. So we can say that our key is this session state file uploader key. So we didn't actually assign it to the uploader and we were assuming that it will work. So that's bad. That is my bad. Okay, so let me delete those and let's try it again. So if I upload image one is uploaded. If I upload image two, image two is uploaded. There you go. All good. So now there's no replication. So if we refresh and upload the third one, there you go. The third one is uploaded and we don't have a repeat. So that's all well and good. And yeah, we can bring that back, by the way. Where is it? This session state file uploader key, we can bring it back here because here it's a little bit more easier to read. Okay, now we need to filter. So to filter it, we are going to add a query. So we will call it the search query, and this will be the input from the user. So we will go back and we will refresh this. So here it will say search images. What do you want to search for? Okay, so that's the basic idea. Now what we will do is we will filter our images and display only the ones that are filtered by this search query. In the beginning, the search query will be empty. So it will by default show everything. When we put a query, then it will show only the ones that are present in that name. So that's the basic idea. So here we will have filter and display images based on search query. I will remove this part. So here we will have filter images, that's new function. And then we will have display images in the grid. That's a different function. So let's go ahead and I will show you again. Both of these were written by ChatGPT. I will show you what they mean and how they work. So let's go up here. And here we have filter images. So first we are going to filter the images. We will send in the query and we will send in the upload directory, because whatever is saved is the one we want to filter from. It doesn't matter what you are trying to upload or what will you upload. No, what has already been saved is the one where we filter it from. So that is our upload directory. So we will send in the upload directory and we will send in the query. Initially, the query will be empty. Now, right now, it is not getting all the files. It needs to get the file names. Now, you could write it in a different function, or you could actually write, because it's just 2-3 lines of code. Now, ChatGPT actually wrote it in different lines, in a different function. So, okay, we will keep it in different. So get image files. So basically what it's doing is it's only getting the files that are images. It's basically getting all the names of those, right? So it is using os.path.join, the upload directory and the file name, and then it's returning all the files using the os list directory method. So if you have used Python OS before, then it's very easy. You know that you can query based on all the different file names, and here we are getting the names based on the ones that end with PNG and JPG. So these are external filtrations that you can add when you are really pushing out the project, and you are creating something really functional. Then you can add these conditional operators that if that is available, somebody might try to upload an MP3 file or something else, then you should be aware of, things like that. Anyways, so what happens is that here we are just getting all the names of the images, and then we will check if there is a query. Then we will do this. Then we are going to go ahead and we will search. First of all, we will put it in lower characters and we will split it up into words. And then we will filter out all the keywords to check if that is present or not. So this line of code, it is just checking that whether that name or the search query is present in that name or not. And then it will return the filtered images, or it will return the image files as it is, like it was before, if there is no search query. So if there is no search query, it will not filter, it will just return the image files. If there is a filter query, it will first filter and then send it back. And once that is done, now we have all the new updated list. And now all we have to do is we have to display. So we can display images in a grid. It's a very simple function, again, written by ChatGPT. So here, display images in a grid. So we will say that if there are any images to display, then select how many columns you need. So in this case, we are putting 3 columns. First, it will create all these 3 columns. If you remember, that's how we do it, st.columns and the number of columns. And then for each column, it will filter that out and display the image, and it will take the width of the actual column. That's how simple it is. So we are displaying based on the image names that we are getting, whether they are with the search or without the search. That is done in the filter part. This is only for displaying part. So if we go back and we refresh this, now you can see we have 3 images in our uploaded file, and we are getting 3 images over here. So if I browse and if I add, let's say 2 more, then it added these 2 more. And then if I filter it, let's say, let me refresh this. If I filter it, let's say I write man, then it will show me images that only have man. If I remove the search, there you go, everything will come up. If I write car, it will show me only the images of car. And if I write, let's say glasses, then it will show me the images with glasses. Now, one more thing you can do is when you are uploading, for example, if you upload, let's say 4 files, 1, 2, 3, 4. Now, it can take a while to load, and it can get annoying for the user to just wait and watch. So what you can do is you can actually add a few lines of code for the progress bar. So if you go to save and process files, so while it is saving and processing these files, you can count how many did it do. So in order to count, we can write here I, that will give us the index value, and we can write here enumerate. So it will give us the loop number. So once we have this loop number, we can simply display it. Now, we don't want to keep adding new text every time it saves the image. So what we can do is we can assign it here. We can create it here and assign it below here. So here we can write, for example, progress bar underscore bar equals, yeah. So initially our progress bar will be 0. And we can also write count equals st.empty. Yeah. So create a placeholder for the display count. And here we can write progress bar dot progress, and based on the I value, I plus 1, because I starts from 0, we want to start from 1. So that's why 1 divided by the total number of files we have, that will give us the progress, but it will not be an integer. So let's make it an integer. But wait, it should multiply by 100 first. Yeah, we need to multiply it by 100, and then we make it an integer. And then we can do for the count as well. Count.text, we will have the value, and then this out of this image is processed. So that's the basic idea. If I go here, refresh this, and now I browse files, for example, I browse 5, 6 of them, and there you go, 6, 7 images processed. And then here, now I can write here, let's say car, and it will show me all the images of cars. So when you have a lot of files, then it will be useful. For example, if we go to browse files, select all and open, then it will show 6, 7, 54, it's showing me 22 out of 54, this out of that. So yeah, this is something that you will have to fix. Now, sometimes the image format is different. Sometimes it's not acceptable. I believe one of the images has a different format, JPEG instead of JPG or something like that. So all these conditions you have to put in later on so that it counters all these issues. So here we have all these images. Now, if I write cats, it will show me the images of cats. Now, we have double duplicates of cats because I uploaded it twice. It's not because of the previous error. That's not the case. I know that. And then let's say fake. You remember that? It had that semantic of fake. And then if we write man, there you go, all the images of man. And so yeah, that's the idea. If you enter apply, then it will show all the images despite any filtration. So that's the idea of how you can create this Google Photos replica. The reason I did not write all of that code is because I wanted to show you that you can take help of ChatGPT, and that's the whole point of using AI technology, that it helps you write the code as well. So all I did was I broke it down into pieces in my mind that, okay, saving is one part, uploading is one part, displaying the images is one part. So I gave it the commands that, okay, write that function, write this function, and then made it compatible with each other. And that is what I want you to do later on in this, for example, projects that try to use AI for coding as well, not just for creating these apps. Well, you are writing code, use AI as well. I hope you like this project. It was quite fun to actually create this, and you can see it is quite useful for many different applications. So now we are going to go ahead and create a PDF sorter. The idea is very simple. What we have is a few papers. And what happens sometimes is that these papers, they are not given any name when you download them, especially from different websites, then they don't really have an organized pattern. So if you had a lot of documentation and you wanted to organize it, then this is one of the ways you can use AI to actually do this. Now, this project was actually suggested by one of the subscribers. Unfortunately, I couldn't find their name. I was trying to find the comment where they suggested this. But if I do, I will add it in the description, or probably if it's before the release, I will add it somewhere on the screen. So it's a great idea that if you have, let's say, a lot of papers, what you can do is you can skim through the paper and you can basically add some keywords to it, a title to it, and so on. So for this instance, we have research papers, and what we will do is we will add the title of the paper, and we will add the author names, and we will add 3 keywords. So again, it depends on you, because there is a limit of how long the name can be of a file. So it's up to you if you wanted to sort it based on the name of the authors, or you wanted keywords, or you wanted the title in it. So you will have the flexibility to do this. So it could be any document that you want, and then you will be able to sort them based on your requirement. So it's a very fun project. Let's go ahead and start with it. So here you have, I've created the PDF sorter, what do you call, folder. And then inside that we have a papers folder. And here I'm going to go ahead and create a file, and we will call it PDF_sorter. So this PDF sorter, first of all, we need the ability to actually read the PDF file using Python. So in order to do that, we have many libraries. You can go to File Settings and Add. Make sure you are in Python interpreter. Here you can write PDF, and the name of the package was PyPDF. So this is the package. If you haven't installed it already, you can go ahead and click on install. By default, it should be installed because it is also available in the requirements file. So it's there, so you should be able to run it without the installation as well, because it has already been installed. Anyways, so once that is done, let's first understand how to read the PDF files, and then we will create an app around it. So the first thing we will do, we are going to import. So we will write from PyPDF imports PDF reader. So this will allow us to read our PDF files. Now, let's say I wanted to read this particular file. So what I can do is I can refer to this file_path equals, let's say, papers slash 24. We can pick any one of these. So this is the PDF file that we want to read. So once we have that, all we have to do is we have to write reader equals PDF reader using this class we are giving in the file path. And then what we can do is we can actually check the number of pages, for example. So in order to do that, we can simply write reader.pages, and we will get the length of it. So let's go ahead and print this out for now to see if everything is working before we move on to the next part. So if we run that, there you go. It says you have 12 pages within this. So that's pretty good. And now if you wanted to read any of the particular pages, then you can simply write page equals reader.pages at whatever the index. So if I wanted page 1, I would write it like this. If I want page 0, I would write it like this. So for now, we just need the page 0. And what we can do is we can actually print the page to see what exactly are we getting. So if we run that, we are getting type page annotates, indirect object, blah, 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 and we have lots of them. So how exactly can we extract the text? We can do it by writing dot extract text. So that is what we actually want. We want the text of the PDF. There you go. So this is all the text that was extracted from our PDF file. So that's the basic idea. Now, once we have this, what we can do is we can send this to our model to actually extract the relevant information. So that's where the AI comes in. It extracts all the relevant information and then gives us keywords, names, title, whatever you want, we can get it from there. So that's the basic idea. In order to get the actual text, we can say raw text equals this. So now this is the code for creating or getting the data. So we have a couple of steps. Let's just put this one as getting the, or let's say reading the first page of the document. Yeah, that sounds better. So let's say this is one of the tasks. Now, the task that comes before this is actually loading. So what we need to do is we need to load the files. So you can have multiple files. It's not like we will give one file at a time. You can have 1,000 files. You can drag them in and it will sort them out all and save it in a different folder, right? So we will load the files. Then we will read the first page of the document. Then we will get the title and the keywords. And then we will save the file in a different folder. So these are the 4 steps you can say we are going to follow to actually complete this. Okay, now in order to do this, we will be needing the online module because we will be using ChatGPT to actually sort these out, get the title and keywords. But if you don't want to do that, you can of course use one of the offline modules as well. So if I go to the recipe generator, and what we can do is we can copy all of this, even the title and even the clients we can copy, and we can go here and we can paste. So let me bring this down over here. Okay, so here instead of recipe generator, we are going to call it PDF sorter or organizer, whatever you want to call it. And then we are going to set up our client for this. So we need to upload our files. We need an uploader. So we will write st.file underscore uploader, and then we need to choose a file, and the file type will be PDF, and we will accept multiple files that we will make it as true. So once we have that, we will put it in files and we will save it, files, there you go. And once we have that, then we can actually add a button for the user to get started. So we can write if st.button button, let's say organize PDFs, and we can say that with st.spinner, and we can write working on PDFs, right? So then we will go through all the files. We will loop through the files. So this part is actually correct. So for I and file, I is just for the index so that we can update the progress. How many files did we finish? That's why we are writing. Whenever you write I here and you write enumerate, then it will save the count over here. So loop 0, loop 1, loop 2, loop 3, and so on. And the actual file coming from here will be stored in file here. So we are reading each of these files, we are extracting the document, but then we need the actual data from ChatGPT. We need the answer of the keywords and all that. So we can remove this part because we have it here now. So get the title and the keywords. So right now we have the raw text. So what we can do is, first of all, just to make sure we are headed in the right direction, we can write st.write and we can give in the raw text. So this will display us the raw text for each one of these. So which is not a very good idea, but still we want to see if it's working or not. So what we can do is instead of giving, okay, let's test it first. Where is it? PDF sorter, right click, open in terminal, and then we will write Streamlit run. And what is the name? PDF sorter.py. So there we have it. Now let's go ahead and upload. So here you can see I have the papers. I can select, let's say I will select 2 papers for now, and I will click open, and there are 2 files here, and I will click on organize. So here you can see this is for the first one and this is for the second one. So we have the text for both of them, which is good. And what we can do is we can remove this for now. And the next part is getting the keywords from ChatGPT. So how exactly can we get it? So for that, I have written a prompt and a format. So here I'm going to write, let's call it output format. Output format. There you go. So what happens is that we are basically giving an output format that I need the title, keyword, and so on. And in between, I need these dashes. That's how the name will be. So here we will say that our prompt is basically, below is the text of a research paper. I want you to generate a name of the paper that has the full name of the paper as well as 3 keywords that will allow me to find it later, right? If there are any special characters in the text like colon, slashes, or other, remove them from the title. Now, this is a problem because ChatGPT doesn't always understand this. So what we will do is we will adjust this later on. But for the sake of it, we are adding it here as well in case it is able to remove, it should remove. Give raw text as the output. Use the following format. So we are giving the format, and this is the actual text that we will give, the raw text that it has to summarize to give the title and the keywords. So once that is done, now we can simply write this stwrite, and what we will do is we will actually, oh no, we didn't actually send it yet. I forgot. We need to first generate the text. So we will write generated text equals generate text OpenAI Streamlit. So this is coming from our online module that we have written before. We will give in our client, we will give in the prompt, and we will give a maximum tokens. Now this is important because your file name cannot be unlimited. So it has a limit of characters. So how many you want, you can write here. So tokens 40 probably means 30 to 35 words, and that's it. So it's up to you how many do you want to add. So you can adjust here. So then what we will do is we are going to go ahead and see what exactly are we getting in the generated text output. So let's open this up again and we will refresh it. We will select one of the files and we will organize. So it says working on PDF, total words generated 18. So this is the name that it has generated. And then you can see preference optimization, DPO positive, large language models. So these are the keywords that it found, and this is the name. Now, this is the problem. You can see here there's a colon, and even though we specifically asked GPT to remove it, it was not able to remove it. So in order to remove this, we need to add some extra lines of code. And again, I took help of ChatGPT to actually write this. What I did, I just gave it this command and I said that I want to remove the colon because I cannot have it as a name for a file. So remove everything that is not acceptable as a file. So it gave a good suggestion. It said that instead of removing everything that you cannot have, just mention the things that you can have. So we will optimize it based on that. And in one line of code, it was able to do that. So how did it do it? It's very simple. Let me actually show you. So this is the line that ChatGPT wrote. It said that it will loop through the generated text. So this is a for loop. It will loop through the generated text, and every time it will take one character. The C stands for character. And every character it will check. So we are talking about character, not word. So S is a character, M is a character, A is a character, and so on. So it is checking each character. If it is alphanumeric means whether it's an alphabet or it's a digit. So either of two, maybe 9, maybe 5, maybe 3, or maybe A, maybe B, maybe C, something like that. Nothing else than that. So it is checking if it's alphanumeric or any of these characters. So these characters are allowed, which means space is allowed, underscore is allowed, and this dash is allowed. So these three are allowed and alphanumeric is allowed. Rest of them, if that is the case, it will not accept it, right? So that's how it is looping through all the characters, checking for alphanumeric and checking for this. And then at the end, it joins them together without any spaces. So that's how clean and efficient code ChatGPT can write. So that's very intuitive. So once it cleans this text, what we can do, we can print this, and then we can print this to see the difference. And we will do it for the same file so that we get the same result. So working on PDF. So here you can see this is without cleaning and this is with cleaning. So you can see smog, fixing, failure modes of preference, blah, 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 and this, all of that. So now our text is ready to be saved as a file name. So now we can proceed to the next part, which is save the files. We can remove this as well. And here we can say save the files. Or should we add it? We can put this, and we can actually write here st dot. Okay, let's do the GUI part later on. Let's save it first. So now we need to define where do we want to save it. So here we are going to save it in a folder by the name organized. So we will write here output folder equals organized. So this is the name of that folder. So we can even put it outside here because we don't need to define it again and again. So we have the organized, and now what we can make sure is that this directory is available. So to do that, you can write os make directory. If it's already there, it will not give an error. It will keep on moving. So we can actually change the name over here to output folder. So then we will simply create the name of the new file. So new file path will be our output folder plus the clean text that we have. So, and we will write it as .pdf. Now the only thing left is to actually copy the file. And in order to copy this, we will simply write it with open new file path as f. We will write f.write file.get buffer. So this is basically simply to copy from one place to another. That's it. So that's pretty much it. And do we need anything else? Let's just run it for now and let's see if it works. Then we will see what else do we need to do. So let's say we select one of them for now, just to test, working on PDF. And there you go. This is the result. And if we go back, we should have organized here, and there you go. So if we open that up in Explorer, organized, there you go. We have the file name with the keywords as well. So here you can see these are the papers and these are the organized ones. So now what we can do, the last thing we can do is we can create a progress bar, or we can write, for example, over here, we can write that st dot, let's say subheader, st dot subheader, and we will give in the PDF number. So here we are getting I, so we will give in the number of the PDF that we are processing. Where is it? Where did it go? There. So we can write here f string, and we can write I, I plus 1, yes, and then we can write PDF title is this, or we can write PDF 1, and then we can write title is this, or title we should write below, I guess. So I'm getting confused here which one to pick, but anyways, so let's write it down like this and let's see how it works. So let's refresh this, and we will open up all our PDF files and organize PDFs. Working on PDF, PDF1 title is this, PDF2 title is this, PDF3 title is this, PDF4 title is this. There you go. So now it has completed the task, and if we go to organized, you will see that we have our files. So here you can see we have all of these saved. So that's basically the idea of how you can sort your PDFs, and you can do it for other documents as well. And it can be very useful and very efficient if you have lots and lots of data, and it will help you out organizing them. So now we are going to go ahead and learn how to do background removal. So for this instance, the model that we are going to use is trained to do segmentation where there is a person, there's a background. It can tell the difference between a shirt and a pant and so on. So this model is segformer B2 clothes. If you go down, you will see all the categories that it has, and it will tell you the percentage, the confidence level, and it will also tell you the labels of these. So for example, the red one here is the background, the green is the hair, then we have upper cloth, pants, left shoe, right shoe, and so on. So here are all the labels that we can use. And the best part is that the model is very small. If you go to files, you will see that the safe tensor file is around 100 MB. So that's pretty good. So to run this, all you have to do is you have to go to use in transformers. We can copy this part and we can paste it in our PyCharm, and we can download the model like we have done for so many models. And then when it uploads in your cache or downloads in your cache, you can copy that and paste it in models. So here I have pasted it. This, is it this? No, it is this one. There you go, segformer B2 clothes. We go to snapshots, and this is the actual file. So that's the idea, and let's go ahead and start creating the project. Here we will right click and create a new directory, and we will call it background remover. And then we are going to create a new Python file, and we will call it again background remover. There you go. So now in order to remove the background, it's very simple. What we have done earlier is that we created a offline module with the pipeline part. So here you can see we have the pipeline configuration already ready. So what we can do is we can use this to actually load this model. So in one of the projects, we did that already. So let me remember which one was it, where we loaded the model. Was it photo semantics? I believe yes. So if we open up photo semantics, then yeah, this is pretty much what we have to do. So and we are going to upload an image as well. So what we can do is we can copy all of it and we can paste it in background remover. So first we are going to change the name of this. We will write here background remover, and then we have to specify the path, the model path. So this will be models and seg former, and right click, copy path reference, path to root content, and we can paste it here. There you go. So make sure you have these two. So that's good. And then we have the type. So the type is basically image. If we go here, if you don't know the type, you can see here, it's image segmentation. So we will copy that and we will paste it here, that it is image segmentation. Once that is done, then we are uploading a file, which is good. That is what we want. Then it says generate semantics, or we can say here remove background, and here it can say removing background, removing background. And then we have two columns, in which one we have is the image and the other one is the semantics. So yeah, we could do that. We can have one, the actual image, and the other one we can have as the mask, and later on we can keep adding to that. So let's just, for now, let's just run the model and see what it gives us. So in order to run this, all you have to do is you have to write, you have to give in the model, which is our model, and you have to give in the image. And once you get the image, we want to see what exactly are we getting. So here, instead of the subheader, I'm going to print the results, let's say. So the result we are going to print, and let's see what do we get. So let's go to our background remover, right click, open in terminal, and here we are going to write Streamlit run background remover.py. So there we have it. So it loaded. Now I can go back to AI course, resources, test images, and let's pick a portrait. Click on remove background. So it's saying removing background. Is it? Okay, it's loading for the first time, I believe. So it might take a while. So something is happening. Yes. It's loading. Okay, so that's done because we have some answer here. So this is the print that we are getting. So what exactly are we getting? So here, if you look at this, first of all, it's a list because we have a bracket like this, and then we have a curly bracket, which probably means it's a dictionary after that. So here we have a score, and inside that we have none. Then we have a label, then we have a background, then we have the mask. So this is a dictionary that basically has a score, none, label, background, mask, which is the actual image. And then we have another dictionary. So basically it's a list of dictionaries, and each dictionary is one of the labels. So for background, we have a dictionary. For hat, we have a dictionary. For hair. So what we can do is we can simply check which one do we want, or we could simply display all of them. So right now, let's say we want the background. So for background, we need ID number 0. So that's the basic idea. So here you can see label, the first one is background. So what we can do is, if we wanted the actual mask, what we can do is we can write here that, first of all, within the result, get, let's say this is the background equals the result at 0, and inside that we need the mask. So we are getting the mask within that. So that's how you will get this. And then we can write st dot image background width and this and that. There you go. So now we can simply run it again, and let's pick this image again, remove background, and there you go. So as you can see, directly we are able to get the image, and the background as well. So if I wanted to, I could actually, let's just remove the columns. We don't want the columns. Let's go back. And what we can do is we can display whatever images we have. So let's say this is the result, and here we are displaying background. Now, if I wanted to display, let's say, what is the next one? Let's say here. So for here, what exactly do we have? We have a hat and then we have a hair. So it's ID number 2. So for ID number 2, I can copy this part. I can paste it here and I can write here and here. And instead of 0, I'm going to give in the value of 2. So that's the idea. And I can write here. I can write here. Okay, that rhymes. Let's refresh this and we will select remove background. There you go. Oh, it's not here. It's something else. Okay, so probably they have different index on the website and different here. So we can check it from here, by the way. So here, the first one is background. The second one is here. The third one is sunglasses. Oh, that's why we are getting sunglasses. So it's sunglasses. Probably they need to update it here because sunglasses is 3 over here. Anyway, so they don't have a hat, or maybe if there is no hat, it might not give you the hat. Maybe that's the case. So yeah, maybe that is the case. In that case, you will have to directly loop through all the labels and then check the label itself rather than giving this value, right? So you will have to go through and find the labels. You can do that too. Later on, I will show you how to do that too. But for now, we want to keep it simple and we want to do this. So let's do this as 1 and we will refresh this. And this time around, we should get the hair. So yeah, you can see. So basically it's the white part. Whatever is the white part is basically the mask that it has detected. So this is how we are getting. And if you wanted to do more, you could do upper clothes and pants and left arm and right arm. So you can do all of these if you want. You can keep pasting these. And in fact, maybe that's your task. You have to try it out. So let me remove the width because we want it to display as a whole. So, I mean, why not, right? If it's one column, why not display all of it? There you go. Yeah. So now you can see. Let's try it with a different image. Let's try it with this. Yeah, you can see there's the hair. Yeah, we have a little bit of beard as well. Is that it? Yeah, kind of a reflection though. But yeah, the main idea works. If you look at this, there you go, the hair and the background. So what do you do after this is a different story, but the idea is that we are able to get the background and we are able to get the person, the hair, the sunglasses, and so much more using this method. There you go. So that's the idea behind background removal. And later on, we will put this to test and create some more apps with this. So now we are going to go ahead and create a background blur app. So the idea will be that we will get our background and we will apply an amount of blur as we require. So this is the example of the blur app. So if we have our original image, first of all, we will get the mask. So this we have done in our background remover app. So we should be able to get that mask. Once we have that, then we will apply or we will create all these images from which we will be able to create our last image, which will have some extra blur in it. And we will have a slider through which we can increase or decrease the amount of blur that we want to add. So this is a very good example of how you can use these AI models to your benefit. So the thing is, we will go to our background remover and we will copy this code and we will paste it and we will say background blur. So this will open up our background blur, and we have till here we have the actual background image. So we will take a step further and move it in the right direction. So before we do that, we are going to run this, open in terminal. We will write stream let's run background background underscore blur dot py. So this will open up our app. So it says background remover. So let's fix that first. Background blur. And this will remain the same. We need an image, yes. Then we have remove background, or we will say, do we need a button? We don't really need a button, or should we add a button? I don't think we need a button for this instance. We can simply say adding blur, and that should be good. If we come here and refresh this, background blur, and now we have an error because it's trying to do all of this. So we should not do this if we don't have an image. So if uploaded image, then do all of this. So that's the idea. If we refresh this, and there you go, we don't have an error. So now what we will do is we will go step by step and create our images. Now here we can see once we add the blur, once we start the spinner, then it will get the image and it will extract the background from it. So once we have the background, then we can apply the second step. So first of all, let's look at the background if we are getting it or not. So if we click on this, adding blur, and there you go. So it's gone from here, and there you go. We have our image. This is the mask. So we will call this image as the mask. So this is what we are getting. The background is white and the forefront is black. So this is our mask image. Now we have to do all these conversions so that we can get to our main image. Now the first conversion that we are going to do is we are going to convert it into this. So how can we do this? We can add our original and mask image. Once we add this, we will get an image like this. So let's go ahead and do that. So in order to do this, we can simply say that our background equals image.composite. This we are getting from our image library, the Python image library. So what we are saying is that we want to get our original image. So let's call this instead of PIL image, let's call it the original. And here we will put the original image. And then here we will have our mask. So this is our background. We will call it mask. And we will call this mask as well. So this will be our original and this will be the mask. And then basically what it's doing is it's creating this based on this, it's creating a new image. So we are saying it should be RGB, and this is the size of the same image that we already have. So this will be our original image, and that's pretty much it. So here we can say, what should we call it? So this is mask plus original. So we can write here mask and original. So let's go ahead and view this. So we will comment this out, and instead of original, spellings were wrong. So here we can say mask original. So let's go ahead and rerun this. And there you go. So now we are getting the same image as we discussed. So if we look at that, this is our mask plus original. So once we have that, then we can add some blur to this. So we need the second image, mask plus original plus blur. So how can we add blur to this? There is a Gaussian function to actually add blur. We will not go into the maths of that, but the Gaussian function basically adds blur. That's all you need to know. So here we can write that our mask underscore original underscore blur equals, we will take our mask original and we are going to apply the filter. So how can we apply the filter? Using our image filter, which we did not import. So we need to import here, image filter. So this library, it has some filtration functions. So we can use that, and we will use the Gaussian blur to actually do that. And the blur level is basically, let's say we will put, not 50, 50 is too much. Let's say 20. So we'll put the blur level as 20 for now. Later on, we will add a slider to actually move this around. So let's go ahead and look at this image. So if we paste this here, we can check our mask original blur. And if we go here, refresh this, load our image, and there you go. So now the original image has some blur added to it. So that will give us the mask original blur. So we have done this part, and this part. Now we need to add the mask inverted. So we need to invert it and then we will add to it. So how can we do the inversion? Again, we are going to use our image operations. So here we will add image ops. Yeah. So we will add image operations, and what it will do is it has the option to invert. So image ops dot invert, and we give in whatever you want to invert. So in this case, we want to invert our mask. So this is our mask. We want to invert it. Inversion basically means make black white and white black. So it will do the opposite. So here we have the mask inverted. So we will write here mask underscore inverted. And then once we have this, let's go ahead and check it out first. So mask inverted and mask inverted. We can comment this and we will go and refresh this, try out this, and there we have it. So the front part now becomes white and the background becomes black. Now, once we have this, what's the next step? We need to create this image, mask inverted plus the original. So mask inverted plus the original is simply, we will add this image to the original image that we have. So we have done the addition before, and it's pretty much the same thing that we did earlier, which is this. This was the adding part. So we will copy that and paste here. So this time around, what do we need? We need mask inverted plus original. So mask inverted underscore original. So that will be our new image. So we will give in our original image, and this time around, instead of mask, we will give in mask inverted. So that's the main difference, and that should be good. So here we can copy this and paste it, and now we can check mask inverted original, and let's see if it gives us the correct answer. Let's refresh. And if we go down, there you go. So now this is the image that we wanted, mask inverted plus the original. This is what we get. So what's the final step? The final step is actually adding these two together. So mask inverted plus original plus mask plus original plus blur. So we just need to add these two together, and that's pretty much it. So how can you add that? We have done the addition before as well. So it's again image composite, and what we will do is we will give in our subject, which is the mask inverted original. Then we will give in our blurred background, which is mask original blur. And then we will give in our inverted mask, which is mask inverted. So now if we look at that, we should have our final image over here and final image over here. So if we save that and we come back, refresh, and we select the image, and there we have it. So you can see now the blur has been added and all of that works pretty well. So as you can see in a few lines of code, we actually were able to create a simple app. How many lines are there? 40 lines of code, and we were able to create an AI app that does something that is actually useful. Now, one more thing we can do is we can add a slider for the blur level. And what we can do is we can show it if the person has uploaded the image, and we should show it before we actually show. Are we showing the image here? The main image, yes, we are showing somewhere. Original ST shouldn't show the image itself. Yeah, it's showing here. So we should remove that. And above this, we can add the blur level. So blur level is basically we are adding a slider and we are saying adjust blur level. Minimum value is 0. Let's put it at 1. Or yeah, let's put it at 0. The maximum is 30. The default is 15 and the step is 1. And what we will do is instead of putting a fixed value of 20 here, we will put a blur level, and that's it. So if we go and refresh this, now if we pick any image, we get this, and if I move it around, you can see the blur level changes. So we have added a blur effect. There you go. Looks pretty good. So now you might see that there is a black line that appears when we do the separation. Now, if you want to avoid that, you can try different types of blurs. So you can research on it, what type of blurs are there. One of them is the Gaussian blur, but there are different types which you can add and have different effects. So you can research on that. Let's try another image. There you go. Not a very big difference because the background is already quite blur. So it's not a lot of difference there. There you go. Here we can see a lot of difference. Yeah. So that's the basic idea of our background blur app. In this project, we are going to go ahead and create something that we have already learned, and we will build on top of that. What exactly are we building? We will be building the cloth changer. So the idea is that we have been getting our background removal before. So we are able to get the upper body and the lower body. And what we can do is we can take that part, send it to our AI model, and tell it to convert it into something else. So how does that work? So if we look at this example, we have our main image and then we have our mask. So this is what we got from our background removal AI. And then what we do is we add a prompt to that and we say blue hoodie. So what we are saying basically is change this white part to a blue hoodie. And this is what it generates. Similarly, we have for a formal shirt, you can see this is the input image. This is the clothing area that we get. We have some mistakes here and there, that's fine. But then you see the result and it's amazing. So it looks really good. Now, of course, you can change the parameters and get better results. And as the AI gets better, it will get better as well. But for now, how exactly can we do this? So earlier we saw that we gave a command and it generated an image for us. That is our basic image generation. We can say text to image. But what exactly is happening here? We are also inputting a text. We are also inputting an image. In fact, we are inputting two images. So what model are we using? So there are multiple models that you can use for this, and this is known as in paint. So if we go to Hugging Face and we type out in paint, these are some of the models that we will get. We have focus in paint, we have stable diffusion in painting, stable diffusion XL 1.0 in painting. So there's lots of them. The one I found quite useful is the Kandinsky 2.2 decoder in paint. So we will be using this. Now, if you wanted to try a different one, you can try the stable diffusion XL or the 1.5, whichever one you prefer. And here, for example, they have an image of a cat and the prompt was a hat. So they gave the region, the upper region of the cat as the mask, and they said that convert it into a hat. So this is the basic idea. So what we can do is we can simply use it in diffusers. We can copy this part and we can paste it in our program. And what this will do is it will download the model and then it will go into the cache. We will copy it from the cache and we will paste it in the models directory. So here you can see Kandinsky 2.2 decoder in paint. So this is the model that we will be using. Now, the idea is very simple. We are going to go ahead and copy one of our background, let's say remover, and we will paste it here. And instead of background remover, we are going to rename this to clothes changer. So here again, we will write clothes changer. We are going to use this model to actually get the mask, but we do need the different model of in paint. So we will look into that, but before we do that, let's write it here. So we can write here changing clothes. That is weird to say, but anyways, change clothes. Or we can just write generate. And here we can write generating. Okay, so once that is done, we will get our background. So do we need the background? No. What we need is the front part, the top part. So if we go to the model card, we can see that they have upper clothes. That's the ID for that. And if you remember, there was an issue with these IDs. So it's probably 3 instead of 4. So let me check again if it's 3 or 4. Yeah, it's 3. So we need to add here 3, and that will give us the upper mask, or we can just write mask. So that will give us the mask, and we can remove that. We don't want to see it. Instead, we are going to apply something to it. So in order to check if everything is working, I believe it will be working, but the new part here that we need to add is the pipeline for in-paint. Now, this is different than what we have been using before. Initially, we were using, if we go to our offline module, we were using either load pipeline, but for diffusion models, we were using the local SDXL model, right? So this was the function we were using. But now we are going to introduce a new one, and we are going to call it in paint. So let's copy that. Where should we paste? Let's paste it at the top. And then we are going to copy this and paste it here. And we will write here that this is for in paint. Now for in paint, we do need, earlier we were using the diffusion pipeline, but for that in paint, we need the auto pipeline for in painting. So we are going to load that. So what it's doing is it's simply writing auto pipeline for in painting from pre-trained, and we are giving in the model path, and we are telling that use the float 16 which will give you less precision but faster response. And we will enable the GPU. That's pretty much it. We are offloading the CPU. So that will give us the actual model. Once we have that model, then we can go ahead and run it. So actually we can write this as model instead of pipe. So we can write it like that. And we are also caching it. So it will be useful for us when we are running it. Okay, so once that is done, now we already have the offline module. We are importing everything, which means this will be imported by default. So we don't have to worry about importing that. But now we do need to add our path. So here, like we have our model path for the background remover, now we need the model underscore path underscore in paint equals this. And then we are going to give in the path. We will go to models and we will copy the folder name, copy path reference from root and paste. There you go. So we will go back to spaces, to folders, so that we can access it. So once we have the path, then we need to load it. We need to run this function, load model in paint. And we can simply write here the model path in paint. So we can write here model underscore in paint equals this. And now we can actually run our in paint model and see what the response is. So how can you do this? It's very simple. So this is how you can generate the image. So let me just make sure it is okay. So first of all, what we are doing is we are using our model in paint, and then we are giving in some parameters. So we need three things. So the first one is the prompt. So we need to define the prompt here, that our prompt is basically text from the user. So we are getting the user input. So for example, we can write blue hoodie or formal shirt, something like that. And then we will send it here. Then the second thing is we need the actual image. So in this case, it's the PIL image. And the last thing we need is the mask, which is basically our upper clothes. So we can write here upper clothes mask. So this is the idea. And then the rest of these are the parameters that you can change. Now the height and the width are basically defined. This was defined somewhere here. I believe they mentioned it somewhere here to be of that specific size. Yeah, there you go. So this is the width and the height they mentioned. That's why I added it here. If they didn't mention it, you can change it. You can try different methods if that works well for you. But for this model, I believe you do have to add these two parameters of height and width. Anyways, then you have the strength, the number of inference steps, and then the guidance scale. So all of these parameters, you can play around with these. Again, the guidance scale is the one that actually tells you how much to follow the input prompt. And the same goes for the strength. It's similar to that. So again, it should not be more than one. And the number of inference steps, they are the number of iterations. So again, you can play around with these values and see what gives you the best results. For now, we will keep it like this and we will move on. And once we get the output, we will simply get images at 0, and that will give us the actual image. Now, what we can do is we can basically upload our image. Now, one thing that I was facing an issue with was that when the output is coming from this model, the image size was changing. So that was not good. So what I did, I simply changed it back to the actual size, so of the original image. So PIL image.size equals our new size. and we resize the image, this new image, to this old size that we had. So that's the basic idea. And now what we can do is we can display it side by side. So to display it side by side, we can, this one, we can put it in column 1. So we can write here column 1 and column 2 equals this. And we can write with column 1, we will do all of this. Let's say this. And with column 2, we will do all of this. And we will show our image, resized image. And we will write here that it is modified image, and we will give in the width of, did we give a width before? No, we didn't. So let's not give the width at all. Okay, so that being said, that all looks good. Let's go ahead and try it out and see if it works. So we will go to our cloth changer, right click, open in terminal, and we will write Streamlit run clothes changer.py. Now we will wait for it to load. The first time around, it might take a while to load, but after that, it should work smoothly and it should work quite fast. So now that the cloth changer has loaded, we can simply go ahead and click on file, and we can pick, for example, this one, and we can generate. So here the prompt is formal shirt. So let's see what it does. So if you go back, you will see how long it takes. So here is the result that we got. This is the modified image. Actually, the label doesn't look that good, so we can skip that. We can remove, where is it? Here, modified image, we can save that. Yeah, so that's the idea. And if we wanted to write, for example, we could write formal shirt with red tie. Let's see what it generates this time around. So if you go back here, you will see the number of iterations it takes and the time it takes to actually do this. So 30 iterations, they are quite fast. It's 3 iterations per second. So there you go. It mixed up the formal tie and the shirt part, but it's giving us the hint of that. So that's the basic idea. As the AI keeps getting better, these results will keep getting better. Plus, you can also play with the parameters to check how much do you want the prompt to actually affect this. And one more thing you can do, if you actually go to their page, you will see that you have all these different options. So you can play around with the hairs, you can make a hair changer or a background changer or a dress or pants or whatever it is. You can get the mask of it and you can change that specific part. Now, one more fun thing you can do actually here is that instead of writing 3 here, if you put 0, that will give you the actual background, right? So using that background, you can create a background changer as well. So if we go back now and we refresh this, so now instead of a cloth changer, it's a background changer. So if I select, for example, this image and I write, let's say, beach at the back, then it should generate an image with me at the front and beach at the back. So this way it's a nice background or background changer as well. The same thing you can do with hair, the same thing you can do with other aspects of this. So let's see if it's generating. It's almost done. Took 11 seconds. And now it should upload anytime. There you go. So it does work. Uh, doesn't look very real, but yeah, it does work. So let's try it with a different image. Let's pick this one. And here we are going to write the same thing, that our background is going to be a beach. And let's see what it does. And there we have it. it looks quite weird, and my ear for some reason has gotten bigger. But yeah, that's the idea. So of course you need to fine tune and you need to add a lot more functionality before you can actually use it. But as you can see, only a few lines of code and you are able to do this. And just by typing 1 or 0 or 2 or 3 here, you are able to completely change the outcome. So that's pretty amazing. So that's the basic idea of this project, and I will see you in the next one. So now we are going to go ahead and create a detector that will detect whether the content that is provided is appropriate or not. Or you can call it not suitable for work or adult content, whatever you want to call it, whether it is of that category or not. So the idea is that, let's say you were to build a social media website and you don't want people to upload inappropriate content on that. So one way to do this would be every time someone uploads something, you have somebody look at the image, look at the video, and manually select, okay, this is appropriate, this is inappropriate. So imagine every time you upload something on the website, you have to wait for like 1 day for it to get approved. So that's not very a convenient way to do this. The other method is you simply create an AI model that can differentiate between these two classes. One is, let's say, appropriate and one is inappropriate. So in that case, if you get a particular percentage of inappropriate material, you can say, we will ban this content, we will not allow it to upload. So that's the basic idea of this project. Here we are going to use the NSFW image detection model. This is available on Hugging Face by Falcon AI. So what we will do is we will simply go ahead and download this, and it will give us the percentage of how much does it think that it is not suitable for work. So in order to download this, you can simply go to files and you can see here are all the files. You can download it from here, or you can simply click on use in transformers and you can copy this part. And as you can see, they are using the pipeline method, and we will be using the pipeline method as well. We already have that in our modules. So all we have to do is we have to define that this is an image classification problem. And the model we will download initially, and then we will take it out from our cache and put it in our models. And there we have it. This is the models directory. And as you can see, we have it. Where is it? Where is it? I just copied it. There you go. NSFW image detection model. So if we click on that, we click on the snapshots, and there you go. This is our model. So we have it here now. What we can do is we can simply access it using the pipeline method. So here we have our project adult content. So, and inside that I have an images folder in which 3 of the images are inappropriate and 3 of the images are appropriate. So we are going to test these out. Now I'm not going to open it up. So what I will do is I will just link the image instead of dragging and dropping, so that it is not visible, but it will give you the percentage of whether it's appropriate or not. So, and what we will do is we will create it in a way that it will only show the image if it is appropriate. So that's the basic idea. So we can right click and create a new file, and we will call it adult underscore content detector, or let's just keep it like that. Now, what we will do is we are going to use our offline module to actually detect, and we will be using the pipeline. So we have done that in previous projects. For example, we did it with the background blur or the background remover. So we can go ahead and copy that part completely, and we can bring it in here. So we will paste that. And what we will do is we will remove the specifics of the background remover, and until we get the image, and we are not going to show the image as I mentioned, and we are in fact going to have the link to that. So here we will have image underscore path equals this instead of uploading the file. So we will have that, and here we are going to give in, for example, images, A1, A is for adult. So we will first use R. Let's see. Sometimes R is for R rated, so it's weird, but R, by R we mean regular. So anyways, so our task is not image segmentation, it's classification. And the model path we have to define is over here. We will open that up, snapshots, right click, open in, not open in terminal, copy and copy from root content. Then we are simply going to paste it here. And we will hit enter here so that we can see it. So now we have our image, we have our model. Here we can write adult content detector. So we have that, and then we have the model path. We are loading the pipeline, that's all good. And then we are adding our image. And after we add the image, then we will have the option of the button. Do we need the button in this instance? Not really, because we are already defining the path to our image, so it will be there. So we don't need that. And here we can say checking content. Checking content, and then we will first upload the image using the image path. And then once we have the image, then we will get the result of the model, right? So we will get the result from the model. So what we can do is we can write here print for now, or we can actually show it there, st.write, and we can print the result to see what exactly does it give us. So what we can do is we can remove this, and now we can simply go to our folder and we can right click and open in terminal. And here we can write Streamlit run adult underscore content dot py. So there we go. When we run it, this is what we get. So this is our detector, and this is the print that we are getting. So we have a label in which we have normal, and then the score is this, and then NSFW, and the score is this. Now, one thing is that if we actually use another image, for example, we use one of the other ones, a1.jpeg. Actually, let me copy that so that we don't have to do that again and again. So I can write here A, for example, this, and I can comment this out. So if I do this and I come here and refresh this, now NSFW is at 0.8. So 87% or 88%, it's sure that this is NSFW, and the normal is 0.12. The thing to note here is that it doesn't have a fixed index. So NSFW will be higher, or it will be first if that is the case. If it's normal, then the normal will be first. So we cannot just say get the first element of whatever the result is, because it might not be normal, it might not be NSFW. So we need to check specifically for that name so that we can get it. So the way we can do it is very simple. All we have to do is we have to write that our NSFW score is basically, we are looping through our items and we are checking their score. So if you remember, this is the score that we want. We are looping through those and we are checking if the label is equal to NSFW. If that is the case, then it will return. Otherwise, it will not return us anything. So at the end of the day, what we will get here will be the NSFW score, whether it's in the beginning or it's secondary, right? So it doesn't matter, it's element 1 or 2, it will get the score and it will display us. So if I copy this and paste it here, now if I refresh this, so this is the value that we are getting. So if I change the image now, let's say I use the other image, and I refresh this, then you can see the value is much lower. So again, we are not getting the normal value, we are getting the value of NSFW. And now what we can do is we can simply say if the score is above something, don't display and say it's inappropriate, otherwise display the image. So here, first of all, we can write the probability. So we are giving a subheader and we are saying adult content probability, and then we are multiplying the score by 100 and we are rounding it off 2 decimal places. And we are writing a percentage in front to give us the value. So if I refresh this, so it says adult content probability 0.03%. So that's the idea. And then we can also add a slider if you want to add, showing how much red it is, something like that. So you can write it like this, ST slider, and it's from 0 to 100, and this is the score. So if I save this and refresh, this is the score, it's 0. But if, let's say, we change the image, then we refresh, and there you go, 87% is red. So it's not appropriate, so you should avoid. So now in order to check it further, what we will do is we will go back to our normal image, and what we will do is we will add the option of displaying. So we will say that if the NSFW score is greater than even 10%, so even 10% of the image is not appropriate, then we will say the content is not safe, cannot display the image. Otherwise, your content is safe and we will simply display the image. Our image is basically PIL image. So we are going to go ahead and display that. So if we go back and I refresh this, then there you go. So the probability is 0.03%. So that's why it was able to display this image, because it is safe. What if we put the other image? So if we remove that and we refresh this, then it's saying it's 87.353% cannot display the image. Your content is not safe. So then we can try for others. So for example, we will comment this and let's try the other one, which is appropriate. Let's save that and refresh. Your content is safe. So there you go. It is saying that it is safe. There is 0.19%. This is 0.19%, which means this value. It's not 10%. And then we will try number 3. And if we go here and refresh, your content is safe, probability is 0.14%. And there you go. This is a regular image and there are no issues. But if we go back and we try a different image, let's say image number 2. And if we refresh it, it will say 95% it's sure that it's not appropriate. And then if we try number 3 and we refresh this, there is no 3. Oh, there's 1. Okay, anyways, so there's no 3. There is 1.jpeg. Okay, so if we refresh that, and there you go, 89%, it's sure that it's not safe. So we should not display that. So that's the idea of our project, Adult Content Detector. You can basically detect whether the images given are appropriate or not, and whether you should consider them safe or not. Now we are going to go ahead and create a storybook generator. The idea is very simple, that we give in a prompt, for example, a princess that saved the village from a dragon, and then it will generate these 5 images which will have the story on top of it. So each page will have a sentence on top of the image, and all of that will be generated and combined together in one place. So let me actually give you a little bit of background how I came up with this idea. My niece actually started reading books and she was obsessed with it. So one day I suggested that let's go ahead and create our own storybook. And what I did, I went to Canva and I added some images, some graphics. And when we created the book, the process itself was a lot of fun, but the end result was amazing. It wasn't of the highest quality, but she loved the book. I actually have that still with me. So here you can see this is the Canva template or the book that we used. And you can see I just copied and pasted some graphics and overlaid her image on top of that. And this story, I actually asked ChatGPT to generate, and I asked ChatGPT that there will be 5 books, so 5 pages. So make sure to write one line for each page, and there will be an image and so on. So that's the basic idea of how I came up with this. And looking at her reaction, that got me thinking that what if we automate this process? So all you do is you write the name or the story character, and then it generates the story by itself. So that's what we are going to do. Now, we are not going to overlay the images on top of the actual character, but this you can do very easily. You can use a face detector and overlay the images on top of that. And the good thing is it doesn't have to be perfect. As you can see, it's just a random image on top of another image and it still works. So there's a lot of room for error when it comes to generating something like this. So it can be actually quite useful. But nevertheless, let's go ahead and look at how we will generate our book and how exactly can we run this. So the idea is that first of all, whenever you are creating a story, you need a storyboard. So before you actually go and start shooting a video or something like that, you need a script for that. So that's what we are going to do first. We will ask our AI model, the large language model, to generate a story which will have an X amount of pages. Let's say we will keep it fixed. We will say that we will have always, let's say 5 pages. So whenever we have those 5 pages, then we will say for each page, generate a line of the story. So for example, on page 1, it says, once upon a time in a land far away, a princess discovered her village was in danger. So this is the actual story that will be overlaid on the image. The second thing we will need from our large language model, from our text generator, is the description of the image that will go along with this, what do you call, storyline. So what we will do is we will also add an image description. So for example, a princess with long flowing hair stands on a hill overlooking a small village. Her expression is one of determination. So that's the basic idea. We will have a page, text, and then we will have a description for that. And this we will keep repeating for X amount of pages. In our case, it will be 5 pages. Now, one thing that we will face an issue with is consistent characters. So the problem is that the AI model that is generating the images does not know the characters, right? So there is not a fixed character. So how you can counter this is by adding character features. So for example, in this instance, we can say long hair, white skin, blonde hair, blue dress, something of that sort. So then it will generate images that are relevant to each other. Now, it might not be perfect still, but it will be consistent in some ways. So we can do this in 2 ways. One is that we ask the user to input the character features. And these character features we are going to add in every image description so that it remains consistent. The other way is we let the AI model decide on the features and tell it to add it to every image description. So you can try both methods. We are going to let the AI decide and add those features. And if some of the features are not consistent, then at the back end, we will give it some hard-coded values that, okay, try to keep that consistent. So then once we have our image generated and we have our text generated, the last part will be to combine these two together. That's a very simple process. In fact, we are going to ask ChatGPT to write that function that does this. And we will simply copy and paste that function, and we will input the image, we will input the text, and we will tell whether you want to put it up or you want to put it down. So you will have different options. Again, this kind of code is very simple and very specific to the application. So we want to focus more on the AI part, and that is what we are going to look at. So let's go ahead and look at how exactly we will be doing this. Now, in order to create the actual story-like images, we need to get a LoRA, which actually generates coloring book images, not the coloring book, the storybook images. So here I have written story in Civit AI, and these are some of the LoRAs that are available. You can see here it's very bookish, kids style, images. That is exactly what we are looking for. So here you can see this one is quite popular, 1.6K downloads. This is storybook sketching. We don't want that, but maybe this or this. This one is not for Excel. This one is for Excel, the one we are using. We will be using the SDXL as the base model. So here you can see these are some of the results. So these seem pretty good. And as you can see, the base model is SDXL, and kids book is the trigger word that we will be using. So this is what we can do. We can simply go ahead and download this. Once we download it, we are going to go ahead and copy this in our LoRAs, and then we are going to start off with creating our project. So there we have our storybook, what do you call, LoRA. And what we will do now is we are going to create a folder by the name Storybook. And I've added these images. If anyone wanted to use these as a reference, I have added these here. You will find it in the course page. So here in the Storybook, what we will do is we will copy one of the projects which will be the closest to this. So which one was the closest? Let's say we have sticker generator. I believe we had the LoRA, and yeah, so I believe sticker generator is quite similar to the storybook. So we will write here story underscore book dot py, and here we have our file. So what we can do is we can open this up. Now here it's up to you if you want to add a refiner as well or not. So we can actually add the refiner to make it a little bit better. Underscore refiner. And for the refiner model, we have, where is the refiner? There you go. We will copy the path and we will paste it here. So this will be our refiner model, and then we will also need the LoRA. So here, okay, let's put it back. Okay, and then we will also need the LoRA. So for the LoRA, we are using Storybook, right click, copy, and copy file name, and we can simply paste it here. So now we will have our main model, the base model, we will have the refiner, then we will have the LoRA, and all we have to do is we have to make sure we add our refiner path here so that it uses the refiner. So now it should use the refiner and it should use the base, and here generate image local. Are we giving in the refiner? So refiner is none here, so we need to give in the refiner. So we will say refiner equals our refiner, and the LoRA is already there, so we don't have to worry about that. So that's the basic idea, the initialization, I would say. So storybook generator. So now once we load the model, then we are going to add a few things here and there. So it will take a while to load the model. So let's go ahead and do that before we actually continue. But wait 1 second, we are going to remove the progress. Let's remove the progress. The spinner is there, generating generate story, generating story book. And yeah, for now we will generate just one image and we will display, and we don't need the columns. we will keep it plain and simple. So we are generating the image and then we are displaying the image, and that's pretty much it. So here, instead of the sticker sheet, we should have the trigger storybook. And here we will write a princess that saved the village from a dragon, let's say. Again, you can write whatever you want as a initial input. The slider, we don't need the slider. We will remove that. And I believe we are good to go. And let's go ahead and run this. Right click, open in terminal. And then we are going to write Streamlit run story underscore book.py. So now it has loaded, and what we can do is we can click on generate story to see what kind of image does it generate by default. Oh, I just realized something. The trigger was kids book and not storybook. So let's paste that. So there we have it. This is the image that was generated. So now what we can do is we can go ahead and here we can start making some changes. So what are the changes that we need? First of all, we need to get the answer from our ChatGPT. So we need a story from ChatGPT. Then we are going to go ahead and add it to our images. Now, if you wanted to get the story from Mistral or even Llama, you can do that offline. But I think the best one is ChatGPT still, because it is much more trained and it is a much bigger model to give a much better story. So in order to do that, we will go to, let's say, recipe generator. We will open it up. And here we are going to copy this part because we are lazy. And then we are going to initialize our client. And this client initialization should be done only after you have done the loading of the offline client. So then after that, then we can simply ask it to generate the response. So to generate the response, what I've done is I have written down the prompt. So here I'm going to copy that prompt and paste it here. Of course, you can download this prompt from the resources on our website. So let me actually read it out. So the prompt is write a 5-page story for children with a character. For each page, give a description that will be used to generate an image for that page. Don't use names in the description of the image. Describe the appearance of the character in each image description as the AI does not have a memory. Don't use words like same character because the AI does not have any memory. Now, these things I kept repeating and checking what exactly is wrong with the prompt. And these are some of the things that it kept repeating. That's why I have added these part. So again, if you keep checking what exactly is wrong, you can keep adding more stuff to this. Use white skin color for the character and mention it in each image description. Now, the reason I've mentioned this is because it was getting it all wrong. So every image, it was generating a different color for the skin. So you can specify you want black, brown, white, whatever skin color you want. You can specify it here so that it's a little hard coded this way. But again, you can use these as the input from the user as well. So based on what exactly is your requirement. Then we will give in the format. So this is the output format. You can put it in a separate output format as well, like we were doing before, or you can keep it in the same. So here it will be JSON format. So it will be page 1, and then it will give us the page 1 line, page 2 line, 3, 4, and 5. So here it will be 3, here it will be 4, and here it will be 5. Then page 1 description image. Then it will give the description of page 1, page 2, page 3, page 4, page 5. So that is what we will get exactly as the output. And then we will say, here are the details. So what exactly are the details? The details will be whatever we are getting as the input from the user. So this is user input, prompt, or we can say user prompt, user input, and then we can actually have our prompt, this, all of this, our prompt equals our prompt plus prompt user input. So that will be our main idea. So once we have that, then we can send it to ChatGPT and see what exactly does it send us back. So if we go to recipe generator and if we look at how can we generate, this is the idea. We have to generate a text placeholder. We can remove the image for now and we can simply write it here that this is the text area placeholder. Right now it will be empty, and then we will generate the text using ChatGPT. Generate text OpenAI Streamlit. We will send in our client, we will send in the prompt, and this is the placeholder. And it will be HTML is true. It's up to you if you want to do that, but it will work without that as well. Anyway, so let's go back and here, let's generate the story. So this time around, you can see this is the output that we are getting. So here we have page 1, once upon a time, this. Page 2, she heard a loud roar. Then page 3, page 4, page 5. And then this is the page 1 description, image description, a young princess with white skin wearing a golden crown and blah, 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 and so forth. So now the next step would be to actually parse this. Parsing means extracting information from it. So how can we do that? We have done this before. It's very simple. We can use the .load method from JSON. So we can write here import JSON. And then what we will do is that our story underscore JSON equals JSON.loads, and we will give in our, so we did not generated, or we can say story equals this, and then we can give in our story. So this will convert it as a whole. And now what we can do is we can write story JSON, and then whatever we need, we can write in here. So for example, if we wanted, let's say page 1, it has to be exactly the same, page 1. So if we write page 1, then it will give us only the value of page 1. So we can write it in a for loop for I in range of 1 to 6. Yes, we are going to write page, whatever the page number is. Then we are going to write the page number, the actual page story, and then we will write the description of that. So this way it will tell us that we are able to parse it and we are able to display it as well. So it's up to you if you want to keep this on or not. Let's keep it on for now so that we know it's working. So let's generate the story. It's generating. And now you can see page 1. This is the story and this is the description. This is the story, this is the description. So we are effectively able to get the story, parse it, and now what we can do is the next step, which is to generate images using these. So we are already in the loop. We have all the information. Now we can create a image from this. So we can write here, generate image. And for each image, we are going to give in our prompt. The prompt is going to be page underscore prompt equals story JSON page at I image description. So that is what our page prompt will be, and we will send it like that. So that's the basic idea. And now instead of doing from 1 to 6, let's do 1 to 2 so that it only generates one image. Because we don't want to wait for the whole thing to finish up. So let's go ahead and refresh this, and we can remove this part here where it's generating and showing as well. So we can remove the showing part and we can remove all of this. There you go. and then we can refresh it and we can generate story. So now it will generate the story first. It will not show you anything. Then it will show you that, okay, this is, let's say, page 1. This is the story for that. And this is the image description. So now based on that, it will generate an image. So let's see what it's doing right now. There you go. It's generating the image. So I'm recording at the same time, doing lots of different things. That's why it might take a while to actually generate. Okay, two things. The first thing is I forgot to add to show the image, and it is not showing the image. And the second thing is you might see that my image is glitching. So I'm using the refiner and the actual model. So I think it's too much for the PC to handle all of that, plus do the recording. So what I will do is I will remove the refiner, but you can do it at your own PC to try it out. So here is the image that we have created, or it has generated, and then you can see this is the text. So what I will do is I will copy this, and it will be easy for us to repeat this rather than generating the image again and again. So I'm going to terminate this process because it is GPU heavy and we are recording at the same time. So what I will do is I will bring in this image. So this is the image that was generated. I will bring it in Storybook and refactor and right click and rename, and we will say img.jpg. So this will be our image, and then we will have our text. So what was the text? The text was page 1. Let's say page 1 underscore text equals this. So that's the idea. This will be our text, and then this will be our image. So in order to upload this, we can simply write page 1 underscore image equals image.open, and we give in the image name. So what's the name of the image? Image.jpg. So now we can use these two as our dummy inputs, because we know that we are able to generate the images. We know that we are able to generate the text, but now we need to add these two together. If we keep generating and adding and testing, it will take forever to test it. So that's why we will create some dummy data, and then using that, we will make sure that they work together properly, and then we can open it up and see the whole thing in process. So what we will do is we will comment all of this out. So as soon as we press the button, it should add these two together. So that is what we are trying to do. So what I did was I asked ChatGPT to write some code, and what it did was it created two functions for us. One function is to overlay the text on the image. The other function is to warp the text. So what happens is that instead of writing the complete text in one line, if it's long text, it should write one line, then second line. So that is called warping. So let me put all of that at the top here. There you go. So this is the code to have text on image, and this is the code to warp the text. So that's the main idea, and it does need a few functions here and there, so we need to add those. So they are from our library, which will help us work with the images, PIL. So we are going to import image draw, and image font. And the good thing is it also has the option of adding your own font. So if you have a font that you want to add, and the reason we added this is so that you can have a cartoonic font which will actually look good. Otherwise, if you do it without that, it will look very weird. Actually, let's go ahead and try it out, and I will show you what I mean by that. So here what we will do is once we turn on the spinner, once we click on the button, then it should add these two together. How we can do that is very simple. So what we will do is we will write image, our new image, equals text on image, which is our function. Where is it? Text on image, that's our function. And what it does is that it gets in the image the story and the font and the position. So do you want it at top or do you want it at the bottom? So here we will give in our page one text. Here we will give in page one image, and we will give in a font. Actually, let's remove the font so you can see what I'm talking about. And yeah, so once that is done, we can write st image and we can display this image. So let's go ahead and run this again because I stopped it earlier. So open in terminal and we will write our storybook. So will it load? Oh yes, it will load. So we need to stop that. So we need to stop the loading of this specifically. And now we can go back and refresh, and there you go. So generate story, font reference before assignment. So where is that? So do we have a specific font reference before assignment? Verb text, text font. So I believe you have to give in the font because I think ChatGPT did not account for not having the font. So, okay, so we will add the font because it's trying to get the default font from the library and it's not getting it into this function, I believe, the verb. So that's why. So let's add the font to avoid the confusion, because if you face issues like this, you have to ask ChatGPT to write the code again and to fix this part. So if we refresh this and generate story, there you go. So now it works. Once upon a time in a fairy kingdom, there lived a brave princess. So it has merged these two together. So this kind of programming is very simple. That's why ChatGPT is very good for this. You can do it very easily without any issues. So for example, right now you can see the offset here is almost close to none. So you should have some offset. So all of these things are based on the personal preferences. So you can add these. So here you can see there's a padding at the top. There's an option for padding. So of course you can ask ChatGPT to add the padding at the sides as well. So all of these things, you can keep playing with them using ChatGPT or any other AI model that you prefer. But that's the basic idea of how you can put them together. So this works. Now all you have to do is you have to put this in the loop and then you have to run it. So what we will do is, first of all, we will open this up. Here it will generate the images. Or do we? No, we don't want to generate the image. In fact, we will remove this part completely, and we will remove this part as well. So now what happens is that when we loop through all of them, and then for each one of these, we will have an image description and the image itself. And then we add those together. How do we add those? Using this method. So once the image is generated, instead of displaying that, we will pass it through this. Generated image will go here, and the generated text will be, or you can say page prompt, no, page underscore text equals your story page string text, and we can add it here. And then the font is this, the position is this, and this is your image that it will display. So this we need to open up so that we can load. There you go, load model local. I think because I saved it, it might have removed it. Let me check why it's giving an error. load model local SDXL JSON generated image. I think that's the issue. So here, when you save it, it will remove a few things that are not being used. So that's the problem. So what we can do is we can go back to our sticker generator, for example. We can copy the offline part and we can paste it in the Storybook. There you go. And then we can also add import the JSON. So I believe now it should not give any errors. Yeah, no errors so far. So now it should go ahead and generate the story, generate the images, put them together and show us the image one by one. So we will loop it 6 times because we have a total of 5 pages. Because it will start with 1, 1, 2, 3, 4, 5, 6, and it should be good. So now let's go ahead and run this. I'm going to pause it now because again, we have recording issues while it's running. So once it's done with all of that, I will come back and show you the result. So here is the result. As you can see, it has generated, and let me show you. So it took around 10 seconds, 10, 10, 10. So, and then 47 to begin with, 57, 67, 77, 87. So 87 seconds, almost 1.5 minutes to create a single story. So if we open this up, you can see this is the story that it generated. Once upon a time, in a fairy kingdom, there lived a brave princess, not a fairy, fairway, far away. So far away combined together. Anyways, so you can see the images here. The consistency is a little bit off. Here we have white hairs, here we have brown. But here it's good. You can see the images there. It's working well. Here it's fine as well. And there you go. Here it's a little bit off. So again, one way to fix this would be to ask the user to input the exact characteristics, and then you can add it manually to each of the image descriptions. I believe that will work much better than this. But here the idea was to understand the basic concept behind how you can generate something, how you can automate something, and fine tuning is a different parameter. If it's a different game ball, you can try different parameters, you can try different techniques to actually fine tune, or you can even try different models to fine tune and give you specific results. So I highly encourage you to emphasize on fine tuning this and creating it to a point where you can have a very good story right away. And then the next step of this would be to actually get a face detector and replace the face of a kid that you have as an input image, and then it will replace all the princess images with that actual kid images. So that will be a very fun thing to see how well that works. So this is the idea of this project, and now we will move on to our next one. So now we are going to go ahead and create a YouTube to blog converter. So the idea is very simple. We want to input a YouTube URL and it should generate a blog based on whatever the transcript has and whatever text is available within the YouTube video. Based on that, it can create a summary, it can create a blog, it can create some links, it can even create some images and some GIFs as well, and you can make it very interactive. So we will start off with the basics, and what I want you to do is to carry on this project and make it really amazing so that it is actually useful to YouTubers. So what we will do first of all is we are going to get the YouTube transcript. Now, what you can do is you can ask the user to upload the document or upload the video file, and then from that video you can extract the audio and then send the audio to Whisper to convert it. You can do it locally as well and transcribe the audio and then get it. Or because we are doing YouTube to video, then we can directly get it from here because YouTube already transcribes all the videos. So we can access that using this simple API. So here we have the YouTube transcript API. This is the Python package that will allow us to do this. And it's very simple to get it up and running. And it's very simple to get the response. So how exactly can we do this? First of all, we have to install. You can write pip install YouTube transcript API, or you can go to File, Settings. You will go to Add, and here you will write YouTube dash transcript dash API. So this is the one. You can go ahead and install this. So now it's installed. Here we are going to create a new folder. We are going to call it YouTube to blog converter. So within that, we are going to create a Python file, YouTube to blog. And inside this, we are first of all going to learn how exactly can we get the transcript. So once we have the transcript, then it will be easy for us to send it to the AI model. So in order to get it, all you have to do is you have to import the transcript module. So we will write from YouTube transcript API, import YouTube transcript API. And then all you have to do is you have to write YouTube transcript API, and then you write dot get underscore transcript, and then you give in the video ID. Now, what exactly is the video ID? Now, this video ID can be any video that you want to convert or get the transcript of. So in our case, what I'm doing is I'm copying one of my videos here. So here I have pasted one of my videos, face blur, easy face blur using OpenCV. And what we can do is we can get the ID from here. So if I look at this part, this is basically your ID till the and. So and is basically to give the exact time, but that's the idea here. This is your ID. So if I copy this ID and if I paste it here and I run this, or before we run it, let's print out the transcript itself. Script equals this. So let's print that out and see what do we get. So there we have it. So it says, hey everyone, welcome to my channel. And then there is starting time, duration, and then the text. So basically we are not just getting the text, we are also getting the toggle duration. So the toggle times, you can click on description and you can go to show transcripts. And here you can see these are the timestamps. So you are basically getting these timestamps as well. So what if we don't want that? What if you just want the transcript by itself? Then you can simply write one line that says our transcript text is whatever is in the entry text, whatever it is, we are going to join it. So let's call this list. So we are going to join it based on an empty space. So that's the idea. We are going to join that. And then if we print this out and run it, there you go. Hey everyone, welcome to my channel. This. Now it's raw transcript that we are getting. So what we can do is we can put this as a function. So we can write here, get underscore transcript, and we give in the URL. Okay. Now the problem is we are not actually giving the URL, we are giving the ID. This is the ID. So we need a function to convert this URL to ID. Now you might think that it's quite easy and you can just simply get the last part of the, the URL, but it's not that simple. Every time we might have a different, if I click on share now, you can see here the link is different and here the link is different. So different YouTube URLs can be different. So we need to get the ID from each of these YouTube URLs. So how can we do that? What we can do is we can go to ChatGPT or any other AI model you want to go to. And here I can simply ask it to write me a function to do this. So it becomes very easy for us to work around with these problems. So I can say, I want you to create a function. I want it in a function, not just random code. I want you to create a function that converts a YouTube URL to YouTube video ID. So that's the basic idea. And we will use Python as the language. So let's see what happens. To convert a YouTube URL, its video ID using Python, you can use a function that extracts. So it is using get YouTube YouTube video ID. And there you go. It's using regular expressions to actually extract. And as you can see, it's not very simple to get this up and running. You can see there's a lot of variations to that. Now, if you wanted to if you wanted ChatGPT to explain it to you, you can ask it to explain every single part of this, and it will very easily. But we are not going to do that. We will simply copy this and we are going to paste it. And we need to import RE, and RE stands for regular expressions. And then what we can do is we can remove all of that. And so let's go ahead and test it. So what we will do is we will copy different types. So I will copy this. So this will be my URL one, or let's not put URL one. Let's just put print, and we will print get YouTube video ID URL, and we will give in the URL. So this is one type of URL. Then we will print, we will copy from here, and we will paste that over here. Now this will be a different type of URL, but it should have the same result. And then we can even add a start at, and we can give, let's say, 5 seconds. And then we can copy it and then try another one, so that we make sure that it works. There you go. So yeah, that's the idea. If all of them give you the same answer, then it means we are headed in the right direction. So let's run this. And there you go. So each one of them is giving you the same answer. It means we are getting the ID properly. So now what we can do is, instead of adding it here, we can say video ID is basically this part here, like that, and we give in the URL over here. There you go. So we give in the URL, and it will get the video ID first, and then it will give the give it to the get transcript, and then it will run that. So we do need this as the output. So we are going to return both transcript list and transcript text, because maybe later on when you are creating this app again and you are improvising and enhancing it, you might need the timestamps. So for different timestamps, you might want to take screenshots of the video and upload it somewhere, or some sort of other algorithm that you might want to add based on timestamps. So that's why we want to have the option of using those or the transcript text as it is. So that's the basic idea. Now what we can do is we can now move on to our Streamlit part, and we can create a Streamlit app here. We will be using our online module. So let's go to recipe generator, and let's copy the few lines of code that we have here along with the title and all that. And we can go to YouTube to blog, paste it there, and now we already have a title. We can call it YouTube to blog posts. So that is good. And then we have set it up. Then we actually need the API, not the API, the URL. We need the URL from the user. So in order to get the URL from the user, we can use text input. So here we can write that our URL is this, and by default we are going to add a URL so that we don't have to do it again and again when we are testing it out. Later on we can of course change it. So this is the default URL that we will give, and then we can have a button to generate the blog, and then with the spinner we can write, for example, we are getting the transcript first. So we will send in get transcript. We'll use this function. We'll give in the URL and it will give us the transcript text. And then we can simply write st.write the transcript. And we can also write the word count for it using the split method. So that is good. And actually, let's display it first as well. And later on, we can remove it just to make sure we are headed in the right direction. We can display the transcript text as well. So that being said, let's go ahead and run it. Right click on the YouTube video blog, and we will write Streamlit run YouTube _to _blog.py. So there we have it. And now you can see YouTube to blog post. This is the link, generate blog, getting transcript, and there you go. So it got 3,144 words, and you can see this is the complete transcript. So that's pretty good. Now, if you wanted to try another video, you can of course go ahead and do that and see how many words we are getting for each one of these. So for example, one of my longest videos is the OpenCV course. So let's see if it gets that. So this is that YouTube video. Let me copy the URL from here. Let's paste it here, generate blog. And there you go, 23,557 words. That's a mouthful. You can see how much did I talk. Oh my God. Okay, anyways, so the idea is there, the concept is there, it's working. Now we can move on to the second step. Now the next part is basically creating your own recipe. So the term recipe is important here because you are the one cooking it up. So whether you want to get a summary of this and then create some titles, then create some content, links, it's up to you what method do you follow. So you can have your recipe and you can add it here. So in my case, what I will do is I will generate a summary so that we don't work with a lot of words. We have, let's say, 500 words or 1,000 words. And after that summary, I will ask it to generate a blog, and I will ask it to generate an ending with the FAQ and some links. And I will add my video, and I will also add the thumbnail of my YouTube blog. Now I will do all of that, but that's not really the best case for a YouTube blog. So what I want you to do, follow this along, create it, but after that, make it longer, make it better, add screenshots, add images, add more things that will make it an actual usable blog, right? But before we do that, let's start with the summary. So how can you create a summary? It's very simple. You can add a spinner, or you can ignore if you don't want that. But I will add a spinner, and what I will do is I will generate the summary, and I will create a prompt for that. I will say you are a YouTuber and you want to write a blog post about your video. So we are giving the persona before we actually give the text. Using the below transcript of the video, create a summary that will be later used to generate the blog, right? And then we give the transcript text. So that's the idea. And then we have the placeholder, and then we generate the text. So using ChatGPT, we are generating the text like we did before. So it's up to you which version do you want to use for ChatGPT. I'm using 4 because that will give us better answers when it comes to the summary. So if we go and refresh this and we generate the blog, so there we have it. It is generating and it has generated almost 500 words. So now if we wanted to put it into more text, or if we wanted to add another AI model on top of it, then 500 words is still manageable rather than thousands of words, right? Now, once you create this, what we want to do is we want to hide this. We don't want to display it. By the way, we can remove this part because we don't want to see the transcript. And I will remove the default model because ChatGPT 3 will be faster. And right now we are just testing, so I want it faster. And what we can do after it, we can make this empty so that once it generates, the only reason we want the person to see that it's generating is so that they don't get impatient. They know something is happening. Once the summary is generated, we don't want the user to see the summary. So we can empty the summary and then we can move on to writing the actual blog. So we can write generating blog. And for the blog, first of all, what we will do is we are going to add our prompt. So our prompt will be, this is the blog prompt. Create a blog post from the following summary using the following format. That's how simple it is. So we give in the format, we give in the summary. Now, what exactly is the format? Let's go ahead and define that. So like we did before, we have lots of different formats you can apply. For this, we are applying, this is the output format for the blog. You will have a title, table of contents, link of contents, introduction, then you have introduction. This is not dish introduction, just introduction. And then heading of section, then the content, heading of section, then the content, any code if required, we added that. And then we have the conclusion. And then we also have, we separated two things. We also have an output format. So we will send in one query to generate all of this. Then we will send in another query to generate this. This way it will create a bigger response. But later on, what I want you to do is tell it to generate a list of contents. Once it has all the content, generate each content with every single query. So for the introduction, one query. For the heading of section, one query. Or if you wanted to make it a little bit shorter, you can do 3 titles in one query. So you do table of content, introduction, and heading in one, then another 3 heading in one query, then another 3 in one. So that will give you much longer response. That is what I want you to do after this. But for now, this is our output format blog. This is our output format ending. So we will use both of these. So this one will generate the output format. I will remove this so it's a little bit faster. And then after this, we are going to generate the output. So the ending prompt, and that will be this. So our ending prompt is write the ending of the blog from the following summary using the following format. So that's what we're giving. Now, if you wanted to give in what you have previously written over here, the blog itself, you can do that too. So again, that is part of your recipe. You need to create a recipe that generates the best output, the best results. So that is what I encourage you to do to test these things out. So yeah, once that is done, I will remove this as well so that it's faster. And what else? Then at the end, we can basically write how many words was the blog, the complete blog of. There you go, blogs generated, word count. We can split and generate the blog. Now, if you wanted to add blog plus the ending, you can do that too. Again, try it out. Try to do it yourself. Okay, let's open this up and we will refresh, generate blog, and let's see what happens. So transcript received. Now it's generating the summary. Summary is done. Now it's generating the actual blog. You can see generating blog, how to create real-time face blur using filter, blah, 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 and FAQ and links and conclusion and all that. So as you can see, total 386 words were generated. Now, of course, you can keep adding to that. And one more thing you can do is you can add the thumbnail and the actual video. You can embed it. Embedding is very easy. You can write st.video and you simply give in the URL. that we received from the user, this URL. That's it. So it will actually generate the actual video. It will show the actual video. We can remove this for now. And if you wanted to show the thumbnail, for the thumbnail, it's very easy. There is a link that provides you with the thumbnail. So if you have, let me actually show you. So we can put it in the transcript part so that while it's getting the transcript, it gets the image as well. So once we have the video ID, there is a URL. This is a fixed URL provided by YouTube that will allow you to get the resolution. So given that you put your video ID here, whatever video ID you can put here, it will give you the actual URL of the image. So once we have that, then we can use this to our advantage and display the result. So here we can add a image URL as well. So now it will output the image URL as well. So if we go to get transcript, here will be image URL. Now, in order to display this, it's very simple. All you have to do is you have to write st.image and you give in the URL. That's it. So that's the basic idea. So if we go back, now we should have the video and the URL as well. So if we run it again, there you go. This is the image. And now it's generating the summary. After generating the summary, it will start writing the blog. And there you go. We have the video embedded as well. And there you have the complete blog. Now, as you can see, the blog is not very good. It's very short. Again, this is all based on your recipe. You need to have your own recipe. Now, I will give you a hint. What you can do is what we did in our Storybook part, where we gave it output format, where it gives you a JSON format, and using that JSON format, you can get the summary or you can get the table of content, and then you can pick 3 of these and tell it to write it. Then the next 3, tell it to write it. Next 3, tell it to write it. This way, it will be a much longer and a much richer blog than this. And then, of course, you can add, this is something that I would like to do as well, to get the screenshots from the actual video and place it based on the timestamps. That will be very useful. And then again, you can create some graphical interface around it, which allows you to select a frame next to the screenshot, a frame before the screenshot, GIF images. You can do lots of things with this once you get up and running and get cooking with your own secret recipe. So that's the idea of this project. I hope you have learned something new and you will continue this, because if you have reached this far, that you are doing the 15th project of this course, then I know you can do this. So go ahead and continue this project, and I'm pretty sure you will be able to create something amazing. So far what we have done is we have understood how exactly can we run our models, AI models, and how we can use LoRa's along with them to have a specific output. But what if we want our own custom LoRa, or if we wanted our own custom model? Now, when it comes to model, it requires a lot of computational power to actually retrain these models to have a specific outcome. So that is not very feasible for a local hardware PC or something you have at home. But if you have a graphic card, a good graphic card like a 3080, like a 30 series or 40 series or even 20 series, then you will be able to generate a LoRa or train a LoRa at home as well. So you will need a few images, and from there you can create or you can fine tune your existing base model. So how can we do that? So these are some of the LoRa's that you have seen on Simit AI. We are going to go ahead and create something similar. Now to do this, we are going to go ahead and download a software by the name Koya SS. This will allow us to train a model, train a LoRa based on a base model. So what you have to do is you have to download it, and then we can simply use our setup.bat file to set it up. So what you can do is you can simply go ahead to the code and click on download zip. So once the download is complete, you will simply open it up and drag and drop your folder, and then you will open it up. Now, for the very first time, you are going to open up the setup. So setup.bat file, it will first of all create the virtual environment, and then it will give you the option of the actual install. So here, what we will do is we will install Koya SS. We will click on we'll press on the first, and we will hit enter. So now it is going to go ahead and install everything. So it is right now installing Torch, Python, and everything it requires to get this up and running. So now it has done installing some of the packages. So as you can see here, there's a long list of these. And then it will ask us some questions. So we have to answer these. In which compute environment are you running? Please select a choice. So we will say this machine instead of AWS. So we will simply hit enter. And then it will ask which type of machine are you using. So we will say no distributed training. And then it will ask, do you want to run training on CPU only? So the answer is a big no. Then do you wish to optimize your script with Torch Dynamo? So we will write no. And do you want to use deep speed? We will say no. What GPUs should be used for training for this machine? We will write all. Do you wish to use so this is the thing, that if you are using 20 series graphic card or lower, then you should use FP16. Now if you are using a 30 series or above, for example 3080 or 4090, then you should use BF16. So we will select that. One more thing while using the precision is that if you are having more than 8 or let's say 12 GBs of RAM, then for example, if you're using the 90 series, then you can also skip the precision part. You can say no instead of using any one of these precisions. So you can say you don't need to cut it into half or anything like that. You can simply use without this. So now once all of that is done, it will ask you again what you need to do. So you can simply quit this, and then we can go back to our file, and here we are going to go and open up our GUI.bat. So this will first check for the CUDA toolkits, the NVIDIA, and then once that is done, it will open up our GUI. So here you can see this is the link. So we have to simply copy this and we are going to paste it in our browser, and this will finally open up our Koya SS graphical interface. So now we are going to go ahead and look at what exactly do we need to start the training. So here, first of all, we are going to go to LoRA, and here we will do everything within this. So we have training, we have tools, we have guides. Now, one thing we do have to do is in the utilities, but for the rest of it, everything needs to be done in the LoRA. The first thing we have to select is what kind of model we are using as the base. So we will be using Diffusion XL base 1.0. So if you were using something else, you can select it here. So we will be using XL base 1.0, and then we will define the safe tensor. Now, if you were to use a specific model, then you can go ahead and use your custom model and link it here. Otherwise, when you select this, it will download it first and then start training. So this is more likely to give you less errors than if you were to add your own model. The second thing we have to do is we have to prepare our data. So here we have the dataset preparation. You can see here, first of all, we have to write our instance prompt. Now, the idea is that we are going to do it for a person. Now, if you were to do it for a person, then it's better that you pick someone who is similar to your face. So in order to find that person, if you already know who do you look like, you can go ahead and do that. You can write the name of the person here. So the idea is that it should be similar to what you actually look like. So, and the AI should know that person. So probably a famous actor, so that it resembles your face and it's easy for the AI to detect that person. So what you can do if you don't have that, you can go to starbyface.com, and here you can select your image by uploading an image here, and it will give you the name of the people that it thinks that your face looks like. So the issue is that all of these people, none of them, they are from the same culture. So I would say that's not a good fit. I myself, I found that the AI knows a person by the name Karan Soni, who is an Indian actor, I believe. And because he's brown and he kind of has similar features when I'm wearing glasses, so that is a good resemblance, and the AI actually knows this person. So that's why I have chosen this. You can choose whatever person you want, and then here, because it's a person, you will write person here. Now then we will need the training images and the regularization images. Regularization images are what you are trying to generate, so whatever is similar to that you will generate of this class. So if it's a person, you add a lot of images of people, and for training images, of course, you will add your own training images. So I have created a new folder by the name train on the desktop, and here I have my training images. So I'm going to go ahead and select that folder, and then I will select the regularization images that I have here. Now you might ask, what exactly are regularization images and what are the training images? So let me actually show you. So here, if I go to my training images, you will see these are the training images. I have one, two, three, how many? 10 images. So it's good to have between 10 to 20 images so that it trains well. Now, if you were to train a style, then you would need about 100 images of that style. But these are of person. So the most important thing when you're training is the quality of the images. So the quality should be good. When you zoom in, it should have a good amount of zoom in it. You can see here, I can zoom it really far. So these are good quality images. And you can see these are of different clothing and different styles. So this is a good example. Then in regularization images, you will need lots of images of man. Uh, Here I have around 5,000 images of man. Now, where do I get these? You can get these from online resources, or you can generate your own. If you Google regularization images for stable diffusion, this is one of the repositories that you will get, and you can see it has SD 1.5, 2.1, and SDXL. The difference is in the size of the images. So SDXL has 1,000 pixels. So what you can do is you can go ahead and click on SDXL, and you can basically download it from here if you're using for a man or a woman. So here I have downloaded these. Now the other way to do it, which is a better way to do this, because some of the images, they are not that great. If you look at, for example, the first one, the face is not that great. Some of them you can see here deformed. So these are not the best images, I would say. So what you can do is you already know how to generate images. So you can go to, for example, focus, and you can generate all these images of people. But you might say you will have to click again and again to run it. That's not the case. So let me actually show you how you can do this without repeating it by clicking again and again manually. So if you were to generate an image of a man, you can simply write man, and this will generate the image. So there you go. It is generating an image of a man, and it is taking 30 frames, 30 iterations to generate this. There you go. Now you have a very clear and good quality image of a man, and then it's generating a second image. Now, how can you generate lots of images, for example, 1,000 images or 5,000 images for your training? How you can do that is very simple. You will go to advanced, and here, instead of two, you can put the number of images you want to generate. So here it's 32. You cannot go above 32. So here you will keep it 32. But then what you can do is if you right click on generate, there is an option of generate forever. So what you can do is you can write man here, right click and generate forever. And now it will keep generating 32 images every time it finishes. Now what you could do is generate, for example, 2 images and then generate it again, then 2 images, generate again. But you see, it first prepares the text, it moves the model to GPU, and then it generates. So if you do 32 at a time, then it will be a bit faster than doing 2 or 3 at a time. So what it will do is it will generate these images. And if you're not familiar with where these images go, if you open up the focus folder, let me open that up. This is the folder for focus. You can go to outputs, and here in the outputs you can see the dates. So you can go to the last one and you can see the generation. So here, for example, I did this earlier, and now it's starting to generate these new images. So here you can see the new images are being generated, and it will save all of these images here. So there you go. Now it will keep generating because we have said generate forever. So now that you have those regularization images, again, it's up to you which one do you want to use. I have 5,000 images, the ones that were downloaded. You can access it from there as well. Then how much you want it to repeat, we'll add the value of 20. Now again, these parameters, they can be different for different instances. You have to experiment with these. So here we will write the training directory, the output folder. So here we are going to go ahead and create a new output folder. We will write here output, and we will select that. And then what we will do is prepare training data. And then we will copy info to folders tab. So here you can see when it's done, then we will go ahead and copy info to tabs, folders tab. And if we go back to our folders, you can see it's already filled. So that is what we wanted to do. Now here we have the model output name. So what we will do is we will write here Murtaza underscore, or we can write dash, and we can write Karan Sony, and let's say this image size is going to be 1024. We are going to have that big size image. So that's the idea. One more thing that we have to do before we start training is to adding captions. So for each image, we are going to add some captions so that it explains that image as well. So we will go to blip captioning. So here in utilities, we'll go to captioning, and here we are going to select our training images folder. And then here we are going to add an optional text, Karan Sony, so that for every image, it knows that this person is Karan Sony. So that's the basic idea. And then what we can do is we can click on caption images. Now what this will do is, first of all, it will download the model. So I've already downloaded it, so it will not take that much, but first it is going to download that model. It will be a few GBs to download. That will allow you to generate these captions. And you can see here, this is the link of that model, largecaption.pth. And once that is done, then we will be able to see all of the captions generated with that. So here you can see right now it's showing that there are 10 images detected. So for each image, it's going to go ahead and create a caption file. And once it starts the progress, it will show us how much it has completed. So that's done. If we go to our folder training images, so now you will see that we have .text files along with it. So if we open it up, it says Karan Sony, a man wearing glasses and a vest. Then Karan Sony, a man sitting on a table with a box of donuts. So that's basically the idea. So it will generate these captions. So now we can go ahead and close this. And what we will do is, don't close this, by the way, keep this open. Then we will go ahead to our parameters. Now in the parameters, it depends on what kind of model or what kind of GPU do you have. Now, most of the cases, if you have a 30 series or a 40 series, then you can use BF16. Otherwise, use FP16. So I have a 30 series, so I'm going to use that. Then no need to change the rest of this. You can click on cache latents to disk. And here we are going to go ahead and use the constant. And here, all of these things we are doing is so that we can optimize the GPU. Because we are using a local machine, we are trying to get the optimizer and all the schedulers and everything that are the least amount of heavy on our GPU. So if you want to read more about these, you can read it on Hugging Face. They have all the details on optimizers. So we are going to use the ADA factor. So here you can see on Hugging Face, we have the optimization part. So I believe this one is the least heavy on the GPU. And they do mention that use these parameters. And they also mention the learning rate, which is 0003. So we can use those parameters. So here what we will do is in our prompts, so arguments, we are going to write here the prompts that they gave. And for the learning rate, we are going to give in the value of 3 instead of 1. And we will do the same over here and here. Now here we are going to use the resolution of 1024 and 1024. Then in terms of what else do we have here? Epochs. Now it depends on you. How many models do you want? If you want a lot of models, so a lot of LoRa's that you want to pick from, then you can put, for example, 10 of these, 10 epochs, and each epoch you are going to save one file. So each epoch can take around 1 to 2 to 3 hours to generate a model. So this can take, for example, 10 hours, 20 hours, 30 hours, and so on. So I recommend that you start with one and see how long it takes. And the next time around, you can select, for example, I want to generate 5 models. So write 5 epochs. And that's the idea. And then we will go down. And now the important part, you will keep enable buckets. And then the important part here is the network rank and the network alpha. Now here we are going to use the value of 32. And here we are going to use the value of 16. Now these parameters will allow you to run on a local GPU. If you have a very good GPU, or if you have a 4090, then you can go ahead and experiment with even bigger values like 256. You can even go as high as that. So these parameters, they depend on how good of a GPU you have. So again, I recommend the values of 32 and 16. If you want to play around with these, you can go ahead and read about all these values and you can play around with those as well. So once that all of that is done, then you can simply go ahead and go back to your source model, check everything is good, and then you can simply click on start training. And here, if you will go back, then it will first of all start checking all the things. Once it is done, it will start the training process. So now, as you can see, the training has started, and you can see here they are showing the steps. There are a total of 400 steps. And the reason I'm not adding my video here as well, because the GPU has been used heavily, so it will not work properly. So what we will do is when it finishes, we are going to go ahead and look at the final outcome. So now you can see the steps are complete, and we will go to train. We will open up our output, and here we will go to the model. So here in the model, you can see this is the file that we are going to copy and paste, and we will take it over to Focus, and then we are going to run it. So here we are in the Focus folder, and as you can see, we have the models. We'll click on that, and in the models, we can go to LoRa's. There. So here you can see we have the Murtaza Karan 1024. you can add your all LoRa's over here, and then this will allow us to generate our images. Now, of course, if you wanted to use it with programming, then you can import it like we have done before, the safe tensors, and that should work. Otherwise, if you want to run it with focus, then this is how you will do it. So let's go ahead and open up focus. So here we have opened up focus, and if we go to advanced and we go to model, and over here you can see we already have one LoRa. Now this is the great thing, you can have multiple LoRa's and it should still work. So here we can add our new LoRa, and this time around we select a weight. So here it's 0.1, so it's very little effect. So here we will put 0.9 or 0.92, something like that. So you can actually go above 1 as well, but again you have to play around with the parameters to get the good results. Here I've added a newer model, version 9. So let's go ahead and test this out. So I will write current Sony. So this is going to generate my images. Now it won't be perfect, but let's see what exactly does it give us. And there you go, it has started generating these images. And now we will wait for it to finish. So right now you can see this is the image it has generated, and it is not bad, it is okay-ish, I would say. And this is another image. So if you don't say anything by default, it is going to put me in one of the wedding dresses, because I believe I had something similar in the training images. So that's the idea. This is how you can get your image. But the thing is, this doesn't look very realistic. One way to make this more realistic is to go to input image, drag your image, and then upscale it without the fast 2x. So upscale it to 2x and click on generate. And this will give you better results than before. So this is the result. As you can see, it's a little bit better than before. This was the previous image that we had, and this is the one that it has generated after upscaling it. So upscaling definitely improves the image and it makes it much more believable. So now you can pretty much write anything you want here. So you can write, for example, current Sony in a plane cockpit. So let's see what it generates. So there you go. This is one of the images that was generated. It's not bad. The lighting definitely is different than the previous model. Earlier I was using version 6. Now this is version 9 with photo to lighting. So it has a little bit of different lighting, I would say. It is not bad. So definitely there is more realism in this. And again, if you wanted to, you can upscale this and make it even better. Now, one thing to give you inspiration is to go to Civit AI, and what you can do is you can go to images, and over here you can simply sort for man. So right now we are looking at the images of man, so we need some inspiration, so we can basically get some hints from here. So based on this, you can actually generate some pretty different and unique images. So for example, if you click on this one, you can look at what exactly was the prompt. So you can copy that prompt and you can even paste. So keep the name and the rest of it we will keep the same. And then we will check for negative prompts if there are any. Crossed eyes and long neck. So those are the negative prompts. We'll go to settings and here we will add the negative prompt. And here we will read it out. Current Sony cinematic dock photo of a leprechaun. What is that? I don't know. Protecting his blah blah blah, shining gold. This is this. So you can write as a cinematic dark photo of something like that. So let's see what do we get. Now it's not compulsory that we will get something similar to this, because as you can see they are using different LoRa's here. So if you wanted very similar to this, then you can go ahead and download these LoRa's. You can see there are two LoRa's that are in effect here. But as you can see, it did generate something. Now, the neck, I think because of the negative prompt for the long neck, maybe it's giving something very weird here. But as you can see here, the second one seems a little bit better. So if we were to upscale this, I think that would be better. Yeah, this with upscaling would look much better. And one more thing you can do is you can of course click on the quality button, which will have 60 iterations to run, and that will give you better results overall. So let's try something else. You can look here for further inspiration. So for example, this one looks like a warrior. So we can copy that and paste it here. And we can also copy the negative prompts and we can paste these here. And handsome, soft hair, muscular, blah, 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 blah. The only thing you have to check for is the names that it doesn't specifically say. For example, it might say Will Smith doing something, this, then it will generate Will Smith instead. So instead of Will Smith, you can write, for example, current Sony, and that will generate your image. Or in this case, it will generate my image. So let's see what this generates. So, and we can try out other ideas as well. It is generating, so you can see something similar to warrior. Yeah, definitely there is something related to war and armor and stuff like that. Oh, that is good. I mean, it is artistic in a sense, but it seems painted, but overall it has captured the essence and the armor and the overall scene looks pretty good. Let's look at the other one. Yeah, the other one is also similar without the background though. But yeah, definitely there is a good improvement, and you can tell this is quite similar to me. Here we have another style. Let's try to copy that. There's a lot of negative prompts on this one. So let's copy all of those. By the way, there is a button for these to copy here. So you can copy the negative and positive prompts. So let's generate this and see. Oh, I forgot to write current Sony. Current Sony as face of poor Levitian 800 worker, rag, blah, blah, blah. So there we have one of the images. Let's click on that. It's okay. Like seems painted. For some reason, the essence is there, but the prompt itself, the image itself is not very clear, I would say. The second one, yeah, that seems a bit more real. But there is the added style of paint. Is it because we have something here? No. But there is a little bit of style of paint as well. So that's basically what you're getting. So that's the basic idea. You can basically get your LoRA working, and then for references you can try different things here, get inspiration from here and try it out for yourself, what works for you, what doesn't work. And if you really like an image, for example, you really liked this one, right? So what you can do is you can download the LoRAs for this. For example, they're using 3 of these. So you download these LoRAs, you add them to your focus. So you go here, you add these other LoRAs, and then you add this as well and say current Sony with running all of this, and yeah, that's pretty much it. So that will give you the best chance of getting something similar to this. So that's the basic idea of how you can train your own LoRA. And of course, you can try out with different images, different timings, different training processes. And it might take longer for you. It might be faster for you. It depends on your PC, your requirements. And this is something you can do on your own computer. You don't have to go somewhere fancy to actually do this. So that is a big advantage of using this method. So now that we have created our models, we have trained them, we have created so many applications, what is the next step? The next step is deployment. So you take your AI model and you give access to the public. So that is basically your deployment. So you have your AI model running on your PC, but now you want the people to access it and use it. So how can you do that? Now, this will depend on your specific use case. There is not a single answer for this question. You will have to find what method suits you the best, and based on that, you can take the appropriate actions. So, what are the different types? Let's have a look. The first type is the local method. So basically, you have trained your model, you put it in a local PC, and you run it, and anyone who has access to that can run that. Then there are managed services. So there are services, there are websites online that allow you to host their GPUs, which allow you to run your models using their GPUs, which makes it very easy for you to get up and running very fast. Then we have the cloud platforms. These are the bigger companies that allow you access to pretty much everything. So you will have lots of flexibility when it comes to preparing or deploying your models. So now let's have a look at each of these in a bit more detail so we understand which user case is for which. So first of all, we will talk about local. The local is the easiest one, and pretty much what we have done so far is using the local method. So whenever we ran our Streamlit app and it gave us a link, it gave us a local link and it gave us a network link. So basically that is your local environment. You are basically using your PC to run your AI model. Then whoever has access to your network or your Wi-Fi, they can basically use any laptop or tablet or mobile phone, and they can open it up and they can use the Streamlit app within their browsers. So anyone within your house can access it who has access to the network. Now, this can happen in offices as well. So for example, you have a model that generates something specifically for that office. So what you can do is you can give access to everyone. You will buy a PC, you will give access to everyone and they can simply use it. You can even add a password so that not everyone can use it. Only a limited number of people can use it and so on. So this is quite cost effective and it is secure. Now, an example of this would be a hospital where the employees, they are uploading patient information and getting some response, right? So the reason you could do it with the local infrastructure is so that the confidentiality of the patient remains confidential. Because if you send it to ChatGPT or if you send it to a cloud service or a managed service, then you are sending the data and there is risk of interruption, there is risk of hacking, there is risk of leaking. So if you have very confidential information, or in the case of lawyers especially, if you have a law firm and they need to access an AI model, then this is a good way to do this because their confidential information will not leak out and it will remain within the company. So it is an easy and secure method. You can buy a computer, you can buy some GPUs with it, and then you can basically run your Python modules and your Streamlit app within it, and you can keep it running as a server, and everyone in the company can access it. So it is very secure and it is cost effective because you don't have to pay every now and then to actually run the inferences. You are basically paying for the computer, which most companies they already have, and they have budgets for that, for buying stuff like this. But it is not scalable. You cannot increase it exponentially like you can with cloud. And then with maintenance, you will have an issue because you will be the one having to maintain it. If something goes down, if the server is down, you will have to maintain it. If the power goes out or something else happens, or there are new updates and the software crashes, then you will have to go and manually fix that. Then we have managed services. Now, these are GPU services that you can rent out. For example, you can do it through Hugging Face. You can do it through RunPod, and there are many other examples. Now, these are very specific companies, so I don't want to mention all the companies here. So I'm just giving two examples that these are the ones that actually provide you with a GPU, and there's tons of them that provide you with GPUs, but the problem is they are quite expensive and they are not secure, but they are ready to use. You can write the code and upload it, and within a few minutes or hours, you can have your AI model running, and you can give access to anyone in the world. So anyone, anywhere can get access to actually run this. And they are specifically tailored for AI. So a lot of these companies like the Hugging Face, they have tailored this service towards AI, so it will be much easier for you. For example, installing different Python libraries is very easy in Hugging Face. So you can simply write the name and it will automatically install it for you. And some of the libraries that are important, they are pre-installed and you can use it direct. So there's a lot of things that come by default. So that's why it's ready to use and easy to work with. You can try out Hugging Face Spaces. They have a free version, but it's only for CPU. But then when you come to the paid one, it is quite expensive because they charge you per hour. So any of these services will be expensive because they charge you per hour. These values can start from around $500, $600 per month if you run it completely all the way 24/7. So it can be expensive, and there is a security risk that you are providing someone else your code and you are also sending the data to them and they are processing it, but it is publicly available. You can give access and it's ready to use and it's very fast. Then we have the cloud services. These are the big companies like AWS, Azure, and Google Cloud. So AWS is for Amazon, Azure is for Microsoft. So these are big companies with large servers that allow you full flexibility. So they are very scalable. You can create a model, you can create a website, and then scalability is not an issue. Flexibility is not an issue. Customization is not an issue. You can pretty much do anything you want with these servers. And but the issue is that you will have to maintain it. You will have to take care of all the security measures and everything. So there is a bit of a learning curve when it comes to cloud computing. So make sure that you understand the basics before you dive into this. So these were the three basic methods of running your models, whether it's local, managed, or cloud. It depends on what kind of application do you have. Are you providing a website as a service where people, for example, can convert their YouTube videos to blog, or you are providing hospitals a service that their patient information does not have to leak. It is very confidential. So in that case, you might go for local. Then if you want to create a prototype and get it up and running very quickly, you might go for managed. And if you are giving a service to a company like lawyers or hospitals, they don't care that much about security, but they care about their branches. A lot of different branches they have to access and they want it something very quickly. Then you can go for the managed one. Maybe they can pay for the higher cost and still be able to run their models in different branches, different locations, and it can be accessed globally. So this is the idea of how you can deploy your models. Now, the specifics of these can be found online very easily, how to actually run your Python code in any of these servers. It's a quite common thing. That's why we are not diving into that. Plus, it's different for every single company. For AWS, it will be different. For Azure, it will be different. For Hugging Face, it will be different. So covering all of them is not a good idea. So what you can do is you can actually look into what exactly are the options that you want. And based on that, you can decide which one to go and look for and continue your learning journey. So this is it for our complete course. Now, I hope you have learned something new, and don't forget that there is a Facebook and Discord channel. If you have come so far and you have completed the complete course, first of all, that's amazing. You have done a lot, right? You went through, I feel like it's the Lord of the Rings, right? When Frodo is actually going all the way and dropping that ring in that lava or whatever the mountain. So basically you have dropped that ring. You have achieved your goal. Now the next part is happily ever after. So actually that's never the case. But anyways, you have to go ahead and continue your AI journey, and you have to go ahead and create these apps. Don't stop here. Create ideas and post them on our Facebook group and the Discord channel, and you will be motivated, and you will actually get motivations from other, you will get inspiration, and you will be able to create some amazing apps. The idea behind this course was not to actually just go through the course and that's it. You write it in your degree, or you write it in your CV, and that's pretty much it. The idea is you create something amazing. You create the next big thing. You create and provide this as a service. Go ahead and make some money using these applications. Ask people what exactly do they want in AI. There are companies that need lots of these services that require very specific tasks, and some of them are very easy to run and very easy to deploy or using the local method. So you can have basically AI models up and running in 2-3 days for many different companies as well. Now, if you are a company and you want our services, you can always go ahead and send us an email at hire@computervision.zone, and we will provide you, we will guide you, we will give some consultation if you want that, and we can provide full solutions as well if you want a fixed answer or a fixed solution for your company. Now, once you have done everything, make sure to upload and post this on our channels and say that I have done this, and then make sure to upload new apps and keep up and running and keep the momentum going for AI, because AI is just the beginning, right? It's starting right now. From here onwards, now you have the basics. Now you can build on top of this. This is just the start of your journey, and I hope you will create some amazing apps that will change the fate of this planet. So I hope you have enjoyed this course, and I will see you in the next one.